If you try to learn Android app development using Kotlin by watching YouTube videos, buying expensive books, wasting a tremendous amount of time searching online resources and documentation, but in the end, after all that frustrating work, still not able to make an app? Hi, I'm Paolo Dishon, an Android developer with over 12 years of app development and programming experience. I am the creator of highly rated 5-star courses in which I show students how to build mobile and web apps from scratch. The courses have received over 2,000 5-star reviews and currently have over 20,000 happy and satisfied students enrolled. I have built and published several apps in all major platforms such as the App Store, Google Play, Barnes & Noble, and Amazon. Kotlin is the new programming language that was recently officially adopted by Google for building Android apps. It's a simple, concise, and efficient language with which you'll be able to build powerful apps that will wow your users. In this Kotlin and Android developed course, you will start with the basics. I'll show you how to set up your computer for Windows PC, Mac, and Linux. You will write your first Hello World program in Kotlin. I'll share with you the fundamentals of Kotlin that will make you a strong and confident Kotlin and Android developer. You'll create several apps throughout the course, such as image filter, pet bio, chore app, weather app, and many more apps. The course will take you from no skills to being able to make any app you want. There's no prior coding knowledge required. Also get premium support and download all source code for free. If you want to learn a skill that has the potential to make you money, enroll now and start making apps today. I'll see you inside. Well, hello and welcome to this course. So I'm very excited that you're here, and I would like to take a moment to thank you really for enrolling in this course. I'm very glad that you're here and actually very honored that you chose to enroll in this course. This video, I'd like to talk to you about how this course is structured, and also keeping in mind that I will be updating and adding new content and updating things often. Okay, so as you can see, once you start this course, this is what you're going to see. There's the first section here. You probably already watched this, which is wonderful. And nice surprise, I gave you some free stuff, if you will. It's just a bonus, which contains a bundle of all sort of things for you. But you already watched that already if you're here. And then, of course, we have the mandatory, if you will, development setup. Now, I know this is not the most exciting thing in the whole world, setting things up on your machine, but it's very important because we need that in order for us to actually start learning the language and building applications. So please bear with me there. On top of that, you notice that it says here Windows PC, Mac, and Linux, Ubuntu. So if this is your first time, this does not mean that you have to do this for all of these machines, right? So if you're on Windows, what I mean here is that if you're on Windows, then you just find the PC Windows installation and follow that. If you're on Mac, of course you do the Mac, and if you're on Linux Ubuntu, then you do Ubuntu. That's what I'm trying to convey here. So you don't have to go and find, if you don't have a Windows or Linux Ubuntu, you don't have to go and get all of those different machines. It's just catering to whatever machine that you have at hand. All right, so follow these instructions and you should be good. Now, I've added, just a few days ago, again, talking about updating things. You notice that I added here watch this updated development tools. Because you know, technologies evolve, tools get updated. It's very important for us to keep track of that and go along updating our tools. So what I did here just very recently, I created this new section here. You can see we have new updates for IntelliJ and update to Kotlin 1.2. So you can go ahead and watch this video. That way you can be up to date. Okay. And then we have the fun Kotlin section. In this section, we finally start typing in and learning about Kotlin. And then, of course, we go into depth into Kotlin language, decision-making, if statements, when expression, and so forth. So now we're progressing a little bit further into our studies here. And we go to the intermediate to advanced Kotlin here, or object-oriented programming. And I've just recently also added a few new advanced concepts in Kotlin here. Okay. Very nice. We've got another advanced object-oriented programming in Kotlin as well. And then we go into data structures, arrays, and so forth. Okay, so there's a lot of content here. And then finally here, in this case in section 11, we dive into the Android Studio and development setup. So this is where we finally run our first Android Studio app. But notice I have this update to Android Studio 3.0. Again, like I said, because we are in the development realm, things get updated constantly. So it's very important that we update our tools. Okay, so notice I have these caps updated. That's just to tell you that I have added those updates. Okay, so those are important for you to watch. And then we go ahead and start looking at the Android development widgets and so forth using Kotlin. More of the interface, user interface, and so many things. As we do all of these, we are also building a lot of applications. For instance, here we have this app Animals Bio. Let's see, here we're learning about Recycler View. Again, this will make a lot of sense once you start going through all of the content in this course. And then we have storage, so learn how to store things in Android. And we have applications that we're building. You can say it says app. There's a lot of applications being built. So we learn concepts and then we apply them in a form of applications. Then we connect to the world. We learn how to use libraries and so many other things. We create apps. And then you notice here I've just added about 4 new applications this week. So this is new. As you can see, like I said, I'm constantly updating these courses so you can get more value. This is how the course is structured. Perfect. So I'll see you in the next video. All right, so I know you're eager to get started and start coding and move forward. I still have a few things that I think it's important for me to discuss with you. That way you are better situated on how to maximize your experience in this course. Now, in this video, I'd like to talk briefly about where should you start this course. So when I create these courses, I'm trying to find the middle ground, meaning that there's people who are completely beginners, right? They've never really done anything in programming, and there's people who have done some, and then there's others who have done a lot, right? So they're a little bit more experienced. In this course here, you are free to skip around in trying to find where you are more comfortable to start this with, okay? But I would always encourage to start in the beginning, the getting start section, and go from there. Now, if you already have done some development, you've done all these installations on your machine, right? So you've done all this. Obviously, this is not very helpful for you. Okay, so you can skip to the section that is going to get you going as soon as possible. So that's totally fine. I wouldn't want to put you in a situation where you feel like you have to do everything. You have to go from 0 to until the end of the course. That is not ideal. So you find what's the best for you. Best way to know whether or not you need to skip a section is to go to the last lecture of that section and see if you understand everything that I'm talking about in that lecture. Okay, if you don't, then probably a good idea to go back and start watch all of the lectures in that section. If you're a new person or somebody who really wants to get the full experience of this course, then I would obviously start from the beginning. Everybody should start from here, like I said, but I will start from the beginning and go all the way through the entire course. Now, if you already have done some programming, and so this could be, understanding what a variable is can be a little bit mundane for you. So I would skip around as necessary. Some of you would say, well, I know all of this stuff already, and you can skip to advanced stuff too, right? So going, for instance, to the object-oriented part of Kotlin, start the object-oriented advanced part of things. You can, and once we get to the Android development part of things using Kotlin, right? If you already have all of these installed, I would still recommend you to watch the update videos so you are updated, if you will. You can just go ahead and just download the source code if you wish and run it and see if you understand everything. If you do, then you're good. If you're more toward just start building the apps, I would just go scroll down and start, for instance, from here, where you can start building a little bit advanced app using storage in Android and Kotlin, okay, and move from there. So the choice is yours, but if you were to ask me, I would say just go through everything, and that way you have a fuller experience. But I also understand that most people are looking for certain sections that they want to really explore, and that's totally fine. This is your course, and you do what you find is the best for you. And the other thing that I also would like to discuss about here is if you, for some reason, I speak too slow or too fast, there's a few things you can do. So if you click on one of these, for instance, I'm in this lecture here. I'm going to pause this. So if you notice here, I can rewind, I can go forward, and if you look here, it says 1 times, you can change the speed at which the video and my voice are being rendered, right? So you can go slower, so I will talk like this next thing, what, or if you're going to 2x it, you can speed it up as well if I'm too slow for you, okay? So you can change your speed here. That way you don't feel bored or you feel like, oh, Paulo sucks. Let me give him a bad review because he's too slow or it's too fast. Or so there's things you can do that Udemy allows us to do. That way all of us are happy at the end of the day, okay? And also you notice here at the bottom, you can bookmark certain parts of the video. So click there. See, you can add comments, for instance. So you go back here, put a bookmark there, and you keep playing, and you notice, you see, there is indeed that yellow mark there. If you hover, says click to add comment. Because I didn't add comment, that's why it looks like that. A lot of good things that you can do to help you get situated in this course and get more out of it. Perfect. So I'll see you in the next video. Shortly after you start this course, Udemy will ask you for a course review. The rating represents the entire course and not just a lecture. So reviews are very important to me and other students as well, because that would also give other students the confidence to enroll in this course and learn as you are doing right now. So I would love to get a rating and a review from you, of course, but only when you're ready. So do not rate this course until you are ready to do so. You can dismiss by clicking Ask Me Later, which then it will ask you in half an hour or so. So we are going to start with the fundamentals in this course, but feel free to skip the lectures if you already know the material, or if you just want to skim through, you're also free to do so. Okay, thank you, and I'll see you in the next video. Alright, so in this video, I'm going to show you how to install the Java JDK on your Windows 10 machine. So we're going to go to Google Chrome first, and I apologize, my machine here is a little bit slower. And then what we do, we just say Java JDK, there we go, click on that. It will take us to this link here called Java SE Development Kit. So click on that. And then next thing we do, we are going to go to the bottom here where it says Windows x64. Now this is going to be Windows 64 because that is my Windows that I'm running here. If you are running Windows 32, obviously, I would recommend you to go and get Windows 32. And of course, we have to accept our license here in order for us to be able to download it. So click on this accept, and then you'll be able to say Windows 64. All right, so once you do that, click on that, and you should start the download process here. It may take a few minutes, so go get a cup of coffee or something. All right, so you can see here we have our executable file already downloaded. So what do? You just double click. Or we can say show in Finder, so it will show where we have downloaded. So go ahead and double click that. It will ask us whether we want this to be installed. We're going to say yes. And then you'll see this window here that says Java SE Development Kit 8 Update 131, or depending on when you're downloading this, these numbers may change. But we're going to go ahead and say next. So what we're doing here, we're going to be installing our Java Development Kit. Okay, so that's what we're doing. And it will take a little bit of time because you'll be validating everything. And all of a sudden, I got this message here, change to install. We don't want to change anything. We're going to say next. And then we see this window that says Java SE Development Kit 8 Update successfully installed. Okay, so we're going to go ahead and say close. And one little test to run before we do anything. So you can go here and type in command, and there you go, there's command prompt. So double click. Before we do anything, what we can do to see if perhaps your computer may already have Java, if you go and say Java C, okay, and enter, if this happens, says is not recognized as an internal or external command, that means you don't have Java installed in your machine, which is our case here, okay? Now, next thing we need to do is to add our Java into our system path. That way, whenever a program wants to run the JDK or the Java, it will know where to find it. Now, before we go any further, let's go check to see where our Java was installed. So let's open our folders here, right? So go to our folders and what I need. And then we go to our local disk, of course, and then we go to our program files. Double click and we should see our Java folder here. If you double click here, you see these two folders. One has GRE for Java Runtime Environment, and we have JDK for Java Development Kit. Okay, so if you click there, there's a lot of things inside here which you don't have to really know much about. Okay, but just know that the Java, JDK, and JRE come together, so they're all in our application, in our computer now, which is good. Next thing we need to do is to then, like I said, add the path to all of these libraries. Control panel, there we go. And you can reach control panel different ways, but I choose to search because it's the easiest. And then what we need to go, let's go to systems, like so. We go to system, and then we go to advanced system settings. And at the bottom here, you'll be able to see environment variable, and click on that as well. And this happens here, this pops up. So what we need to do first is at the bottom where it says system variable, we actually go and find where it says path, this path here where it says program data Oracle Java. This is very important. That's the path you want to click on, and you double click, another window will open. So what we need to do here is go ahead and add our path. So what we're going to do, we're going to say like that, and all of a sudden this will happen. So we'll have a place to where we can paste our Java JDK. So paste. So now we have this program file Java JDK bin, right? And then we say OK, and we say OK. And before we get out of our system properties, I'm going to go back to our Windows here. Okay, let's go back to where our Java is installed. So I'm going back to our Java folder, and now this time I'm going to click on JRE. So double click. I'm going to go inside of bin, remember, and then copy this path here as well. So we copy that, and we go back to our Windows here. Say System Advanced. We go to environment variables again. So essentially the same thing we did previously. And what I'm going to do, I'm going to click on the path again. Remember, make sure that it says Oracle Java and has this long path there. So double click and brings us back here. And we should already have this program files JDK here, which we added earlier. Now we're going to add a new one. So say new and just paste our new path, which should be JRE. Okay, so say OK, and OK, and OK. All right, so let's get rid of all of this. And what I like to do, right click inside of your desktop and say refresh. It's always a good idea to refresh everything. And then just to test to see if this actually worked, and we're going to go ahead and find our command prompt. Okay, so we're going to search, say command, and there we go, double click on that. And now is the moment of the truth. So if we are able to say, and then type in Java C, okay, and hit enter. If you were able to actually see all of this gibberish here, okay, that means that Java was installed correctly and we were able to add the path to our environment variables, which is wonderful. Also, if you type in Java -version, it should give you the version of Java that you're running, which in this case is 1.8.0131. In your case, it could be a different number, but that doesn't matter. As long as you get this information, that means we are set to go. Perfect. I'll see you in the next video. All right, so the next thing we need to do is install our IntelliJ. All right, so let's go to Windows to Google again, and we're going to say IntelliJ. There we go, download. We're going to go to IntelliJ download, the first link there. And this brings us here to this website. And then we are going to go into the community version, right? Because that's all we need. We don't need the ultimate version. Go to download. And it will take you here. And as it starts downloading, it may take a few minutes. And I'll come back once it's done. All right, it's getting close. It should be done in a second here. And there we go, it's done. So double click, should be able to then open an installer here. And of course, do you want to allow this app? Yes, indeed. And then we have a wizard here that will take through the process of setting up our IntelliJ IDE. It'll ask us where we want to install. We are just going to give it the destination folder, the default here. Say next, next, and we are a 64-bit because that's my computer. And if you are on a 32-bit computer, then of course you will choose a 32-bit. But I presume that most of you right now have a 64. So let's keep with 64-bit. And we're going to install. All right, once all is installed, we should see this window here popping up. and which says completing IntelliJ IDE Community Edition. So we need to say here, click on Run, and we're going to say Finish, which will finalize our installation. In order to complete, it's going to say complete installation. It's going to say import IntelliJ IDE settings from. If you already had IntelliJ installed on your computer before, which I doubt you had, if this is your first time programming or installing IntelliJ, we're just going to say do not import settings. Okay, so go like that. And then we have to accept some licensing there. And there we go. So now we are in this page here where we can set the user interface, the theme. Okay, as you can see to the left here, we have the IntelliJ, which has a white background. And to the right, we have the Dracula. If you click on that one, it's going to look like this. I personally like the Dracula because it's good. They say it's good for, it's easier on the eyes. But if you prefer to have this theme here, this white one, go for it. So I'll just go and choose Dracula. In this case here, I'm just going to go ahead and say skip, remain, and set defaults, like that. And you will notice the IntelliJ now is running. Give it a few seconds. And there we go. So we're going to click on the Create New Project. Because it's the first time, we need to actually set where our SDK, or in this case, our Java SDK is installed, right? Say New. And we'll need to go to where we installed our JDK. So it's under Program Files. Let's see, there's Java there and our JDK. So highlight JDK, okay, very important. And you can see here at the top, it gives us the path. So we're in the right place, say OK. Once it's there, we go say Next. In this case here, we are just going to go ahead and say Next. Allow us to create a new project. In this case, we're going to say Hello World. We say Finish, and we should have a new project popping up in a second here. Always IntelliJ has this pop-up thing that happens. They call it Tip of the Day. So if you don't want this to show up on startup, just go ahead and click there, okay, and check it and say Close. And there we go. Now we have our Hello World application. So if you go to Source, it takes a few minutes. As you can see at the bottom here, it says indexing, so give it a time. So in this case here, it created our project, and you notice here you had to click on the Hello World and go to Source for this to open. And then under Source here, this is where we're going to put all of our Java classes and all of the stuff. So for now, what we're going to do, we're going to right click, say New. We're going to add a new package. Okay, we're just going to say Hello. And inside of that package, we're going to right click, say New Java class. Okay, I'm going to say Hello World and say OK. And there we go. We have our Hello World Java class. The next thing I'm going to do, I'm going to say public static void main. I'm going to say string args, like that. Okay, you don't have to know what all this means, but I'll give it a little bit of explanation here. What this means is that we're creating an entry point to our program, which is our main static void class. Okay, and so inside of our main method, this is where we're going to say system, okay, dot out dot print ln, and inside our method here, we're going to go and say hello world, like that. This is for us to test, make sure that our application will be running. And once we have that done, we can just go ahead and click on Run at the top here and say Run, and say Run Hello World. It's parsing and doing all the builds and everything that needs to be done. And pretty soon we should see, look at that. It says here, Hello World at the bottom. Okay, let's change this to something else perhaps. Let's just say Hello Java World. And we're going to go ahead, and the moment we change that, we ran it for the first time. Notice that our green button here is there. So run again. We should see the output at the bottom here on our console to say exactly what we wrote at the top here. Hello Java World. So in this video, we were able to install our IntelliJ IDE, which will allow us to write Java code. This means that your development machine environment is now set up for some fun coding. Perfect. I'll see you in the next video. In this video, I'm going to show you how to install Android Studio. Android Studio is a tool that we'll be using to create Android apps. So needless to say, we need to have it installed and configured in our machine. That way, once we're ready, we can then start using it to build applications, Android applications. Okay, so the first thing we need to do, we're going to go to our browser and just type in download Android Studio. There we go. Click that. And we're going to go to the developer.android link there. And it brings us here. And you'll see here, this is where all the information about the features, user guide, and so forth about Android Studio, this is where you're going to find. Okay, what we're interested in right now is to download the Android Studio here. So click on download Android Studio. And of course, you have to accept a few things here. Okay. So I have read and agree with the above terms and conditions. Click that, and then this will turn color. Then click download. It will take a few minutes. It says here we're going to launch our .executable file, and we'll follow the wizard steps to install Android Studio, and of course any necessary SDK tools. And it says here that's it. If you wanted to watch this video, go ahead and play, and gives you all of that information there, which it's exactly what we are going to be doing in a second here. And there we go. We have our Android Studio executable. So double click. Please wait while setup is loading, verifying installer. There we go. We should have this now. Do you want to allow this? Yes, indeed. And we will start our installing process here. So we're going to go ahead and say next. All right. So we're going to install all of these because that's important. Next. We're going to create a shortcut as well. So install. All right. So it says completed here. Go next. And we're going to go say finish, which will start our Android Studio. Well, it seems like we need to do the same thing here. So in this case, we are just going to say, I do not have a previous version of Studio. So say OK. And now our Android Studio is booting up. All right, so we're going to just go ahead and say next. Standard is fine. Say next. And all of this looks fine. We're going to go ahead and say finish. And now it's going to go ahead and download some components that will allow us to have our Android Studio set up properly. That way we can start building applications. All right, so as you can see here, all these components were downloaded. Next thing we're going to do is just say finish. And this will pop up. We're going to say start new Android Studio project. Click on that. And there we go. Okay. So what we're going to do, we're going to give a name here, say application name. We're going to say hello Android. And for a company domain here, this is fine. And we'll talk more about this as you progress in this course. But for now, just leave as it is. And where project location, you can change where you want your projects to be saved. In this case, I'm okay with where this is. So I'm going to go ahead and say next. And for now, I'm going to just have this phone and tablet. And if you click here, you can see different versions of Android. So we're going to just keep at 4.3. In fact, let's go up a little bit, perhaps to 21. That seems to be the best. Okay, say next. And the moment you say next, it will go ahead and install a few other things that it needs in order to run that version of Android. And then I'm going to go ahead and say next again. And now here we are going to select which activity we want to add to our project. Empty activity is fine. We're going to go say next again. And this is the name of the activity. We usually leave it main activity as it is. And we are going to say, you can't quite see here, can you? There's this finish here. Let me make it a little bit bigger here. Okay, I'm going to say finish. Start creating our Android project. All right, and after a little bit, you may end up with this problem here. Windows Firewall has blocked some features of this app. What we need to do is just say allow access. Okay, say allow access, and this will continue. And again, it may take a little while, being it the first time. And what do you know? Our Android Studio is now creating our project. Okay, so there we go. It opened, and you can see at the bottom here, it says it's still working in the background to make sure all of the dependencies, all of the files are set up for us. And then we have this tip of the day. Okay, this is something that pops up every time Android Studio opens, so you can deselect it if you don't want to see this. But if otherwise, you just keep it selected. In this case, I'm just going to deselect it and say close, and give it a little bit of time for all of these processes to finish. All right, so we have now our project here, our Hello Android project, ready to run. Okay, but before we go any further, so there's a lot of files that were created for us, okay, and we'll get into them as we progress in our studies here. First thing is the main activity. This is where we're going to write our code in Java. And then we have our activity XML here, which has, you will see this window here, preview window, and you can go ahead and zoom in. Okay, let's make sure that we can have more space here. And we can zoom in. You can see here, this is the screen. Now, if you open this activity main and then it has an error, the first thing you need to do, just go ahead and drag one of these text views here to your screen, and then that error will go away. Okay, so put it like that, and you should have that error going away. Okay, so in this case, we just put a text view inside here, and it's really small. Let me make it way bigger. That way we're able to see a little bit. As you can see, it's a text view. And to the right here, we have properties. And as you can see, we have two windows now. We have this window where we can put items. In this case, we put a text view. We can put a button or whatever we want. And to the right, we have this a preview kind of window that allows us to see where things are situated on our screen. Okay, and we'll talk more about this. And remember now, we have this constraint layout. Everything goes inside of our constraint layout, which will then allow us to start to align things inside of our window. Okay, like that. So this constraint layout, it's very handy, constrains all of our widgets, widgets being text views, buttons, and checkbox, and so forth, okay, on this screen. And you can see to the right here, all of these is being rendered as well. And to the far right, we have another view here. We can change the width and the padding, and we can change certain constraints as well from here. Again, we'll take a better look at this at a later time. I just wanted to give you a little taste of the Android Studio. But now that we have all of that, at the top we see here this green play button here. So click on that. And since this is our first time running our program, our Android Studio, we need to connect a device, or in this case, we can create a virtual device. So a virtual device is an emulator that allows us to see our apps running on it. So as we develop applications, we want a way to run our applications and see how they are behaving or looking. So think of this virtual device or simulator as a device that allows us interact with the application and run it as if we were running on an actual device. So for that, we need to create a new device. So say create new device. And then we have here, what we need is a phone. And we have a few specifications here. We can say we want Nexus 5X, and we have the resolution and all of that. So what we're going to do, we're going to say next. Okay, we're going to go ahead and get the first one, Nougat. Okay, and we're going to say next. And that's fine with the name. We're going to go ahead and say finish. And now you see we have available virtual devices here. We have one. So in this case here, we're going to use the first one. Say OK. So one thing we need to do here is let's go to our SDK manager, this button at the top. Click on that. It brings us back here. Now, so in this tab here, SDK platforms, we have Android 7.1.1 Nougat, which is the latest one that I have installed. That's fine. However, if you go at the bottom here where it says show package details, click on that, you'll notice something very interesting. It turns out it installed all of that stuff that we needed, except it did not install other things or other packages that are very important for us to have, right? So what we need to do here, let's just click on all of these that are not installed, okay? And we are going to install them. We're going to say okay, and we're going to apply. So what this is going to do is it's going to go ahead and install all of those items that we don't have. They will all be installed, which is very important. Okay, so say next. And it may take a few minutes, so we're going to wait for that, and then I'll be back once all of those are installed. Now, as you can see here, for me, it failed because it says that there's not enough space on my disk. In your case, you should have enough space, and just let it install all of those packages, and once it's done, you should be able to run your emulator. Okay? The most important lesson here is that you always want to install everything, right? As I showed you here. I'm going to cancel this because it's not going to do anything. You always want to, whenever you install a certain package, in this case 7.1.1, you want to click Show Package Details, so that way you can click on all of the other ones that are very important for us to be able to run the applications, if that makes any sense. That's very important, which also means if next time you want to install the 7.0, which is a lower version, make sure you show package details. You click on this so you are able to click on all, select all of these in middle inside as well. Okay, same with other ones, always. That's very important. All right. Okay, so at least in this video, I was able to show you how to create a project. And I apologize, my Windows doesn't have enough space here, so that's the reason why I'm not able to install all of the other packages. But you should be able to do that. And if you have any questions at all, don't hesitate to ask them in the forum. All right, perfect. I'll see you in the next video. Well, hello there and welcome back. So in this video, I'll show you how to install IntelliJ IDE in your machine. In this case, I am on Mac. You could be in a different kind of machine, a different operating system, but let's start with Mac first. So you go ahead here, we open up our Google search. As you can see, I went ahead and say IntelliJ. And what you get is this. You get this site here, this link says IntelliJ, and you go click download, which will take you to this beautifully crafted website here. Now, as you can see, if you're on Linux, of course, we click here, and they have all the information you need to go ahead and do that. You can go ahead and also read up and see what it entails, what it comes with. All right. So in this case, I'm on Mac here, on a Mac. So I'll take the community version of it. So as you can see, it's for Java Virtual Machine and Android development. One thing, though, that I will say is that when we start doing deep Android development, we won't be using IntelliJ per se. Well, I should say we will still use IntelliJ, but in a different form. You see, Google, what they did, they went ahead and got IntelliJ, took the IntelliJ source code, and they create what they call Android Studio. So it's still based on IntelliJ, but it's not necessarily, we're not going to be using this IntelliJ IDE. We'll use a different IntelliJ-based IDE, which that Google built for us. Okay, so without further ado, let's go ahead and download this. Should take a little bit. As you can see here, it's downloading. It's about 382 megabytes. As you can see here, got 382 megabytes. I've got a pretty fast internet speed, so it shouldn't take that long. In your case, depending where you are and how good of an internet you have, it may take a little bit longer, but be patient and it shouldn't take that long. All right, as you can see here, it seems like the download is complete, so I double click that. It's verifying, going through the process. And there we go, drag to, just drop it there. It's copying all the files necessary to install an instance of IntelliJ IDE for us. There we go. So now, there it is. I've got our IntelliJ. So double click and see if it all goes. And of course, depending on settings you have, I will just say open. This is just what Mac does when you are installing applications not via the App Store. I'm just going to say OK, open, because I trust it. I want my settings for custom location. Let's say OK here. Got to accept a few things. All right, of course, it will give you some details, things you can do, shortcuts. Okay, in this case, let's see. We want IntelliJ white. I like this Dracula, which is kind of like a black, dark color. It's supposed to be better for your eyes. But if you prefer the white theme, go ahead and keep it here. All right, I prefer this one here. And of course, this features these themes you can actually change later as well. Okay. So next, we don't need that, so just go like that. Let's see. In this case, we're just going to go ahead and leave them all. It's all good. We don't need anything here. Just go ahead and click next. Right, so now that we have IntelliJ installed, let's go ahead and test things out here to make sure that installation went accordingly and that we are able to at least start using it. Okay, let's go ahead and here say create new project, click on that. And what we're going to do, we are going to create a Java project at this point just to test things out, to make sure things are working. And you see at the bottom here, you don't have to select anything. The only thing you have to make sure is that you have either these two Java versions here, right? So I'm just going to use one of them. Okay, and if you don't have that, that means, and you are on Mac, that means you have to install the Java SDK, so the JDK and JRE. But usually they come with Mac. But don't worry, we'll get into that next time. If that's the case, then I'll show you in the next videos how to get that. But you should have all of that already. Okay, so next thing you do, just say next. And here we can choose to create a project from template. Okay, in this case we just want a command line app, so click on that. And here it tells you exactly what you are expecting, will expect to see. Say simple Java application that includes a class with main method. Okay, if this makes no sense, no worry. We will obviously go into more detail as we progress in this course. So go ahead and say next. And of course now here we are going to have a title. Let's say Hello World app. Okay, and everything else you can of course change the location where you want your Hello World app to be. And the package, base package, you probably won't have this. You'll have something calm, that example or something. Just keep as it is. For me, I went ahead and put gohuljava.com. Okay, this is the package, base package name, which we'll get into more detail. Not to worry if you don't understand what all of this means. Okay, so go finish and look at that. Now we have a template Java class that is ready to be used. Public class main here, and we have our main method, which is the main entry point. So inside here, this is where we write our code, right? The instructions that we need to be run. Okay, so what we need to do, so right now what we need to do is just say system.out.println. There we go, that's the method we need. And inside we're going to put a text, hello world Java. Okay, save. And to the right here, you see this green play button here. If you click on that, in a few seconds we should see hello world Java. All right, so that means everything is installed. We are ready to go. We are ready to start learning about Java. Very simple, isn't it? All right, perfect. I'll see you in the next video. In this video, I'm going to show you how to install Java in your machine, in your Linux Ubuntu machine. Okay, so we're going to go to search here. I'm going to go and find terminal. So terminal like that, and you'll find terminal. Click on that. And the first thing we're going to do, now I'm going to use command line because I think it's the easiest way to do this. There's different ways to do this. Obviously, you can just go online and search, but terminal is fine. All right, so we're going to go ahead and say sudo bash first because we want to make sure that we get as an administrator. Say enter. I'm going to enter my password, so you should enter yours as well. Okay, so now we are as administrators here. And the next thing we're going to do, we are going to type the following. Say add -apt -repository space ppa : web app d8 team, like that, okay, and Java, and then press enter. Okay, and we'll see this important note here about Java. Okay, we're gonna just go ahead and say enter. Next, what we're gonna do here, what we're gonna type here, you're gonna say apt -get space update, like that, enter. So we're gonna go ahead and update everything. Okay, so everything is up to date. As you can see now, all the packages have been updated. After that, let me give it some space here by hitting enter. Well, after we have installed or updated everything, we're gonna go ahead and say apt -get install. Remember, there's a space between get and install there. Oracle, because that's the company that owns Java pretty much. Java 8, Okay, and I'm gonna call this installer. So now we're just gonna go and invoke our installer from Java, from Oracle. Say enter, and we'll go ahead and ask if we want to continue this with this. Okay, we're gonna just say yes or Y. Okay, and all will be installed. In this case here, just say enter, and move to yes here, say enter, and Java is indeed being installed. Okay, give it a few minutes. Once everything is installed, let's go ahead and see if Java indeed was installed. The way we testify that things have been installed correctly, if we go and say Java space dash version and say enter, we should see now that Java is indeed installed. It says here Java version is 1.8.0_131. And of course, depending on when you're watching this video, this could be different. But nonetheless, at least just tells us that it's all installed and says runtime environment and Java hotspot. Also, 60-bit server is also installed. Okay, that's really good news. And now let's go ahead and set up environment variables here. So I'm going to go ahead and say clear, just to clear everything up. So we start from fresh. Next thing we're going to do here, we're going to say apt-get. And remember, you have to type exactly as I am typing here. Space install, space Oracle, dash Java 8, dash set, dash default. Okay, we're just setting up our environment variables here to default. Okay, so go ahead and set enter, and this is going to happen. Oracle is already the newest version, set to manually installed. So next, to test out and see, make sure that our Java works, okay, we're gonna go ahead and compile a very simple hello world Java class here. So I just created it real quick here, and I saved it on the desktop. So what we're gonna do now, we're gonna go back to our terminal, open that, and we're going to navigate to where we saved our test.java file here. So what you can do, of course, is to create, open what I did here. I opened my search here, and I went ahead and I typed text and found this text editor. Okay, and I open it up. When I open it up, this is what happened, and then I copy and created this file here. Okay, so I say class test, just like this. Okay, and then curly braces, and I close them, and then inside I said public static void main string args, like that, just exactly like that. And I'll make sure that I have this file for you. Okay, so what we're gonna do now, I'm gonna go back here to our terminal, and we're gonna navigate to desktop here so that we can see if this runs. So the first thing we're gonna do, say ls to see what we have. I want to navigate to our desktop where our test.java is. So I'm gonna say cd d like that, and tab. I'm going to say ls to see what's in there. It says test.java, right? So I'm going to say Java C for Java compiler, and I'm going to say test.java. Enter. If all works well, this would happen, okay? So now we know Java is indeed compiled because we say Java C, which is Java compiler, and then we gave the name of the Java file that we created. In this case, test.java, okay? If you hit enter, if it compiles correctly, then this happens. Nothing happens in this case. That means compiled. But if you go now and say ls to see the list, you'll see now we have test.class created as well. So now to run that program, we can say Java test like that, and we should see hello, which is exactly what we set it to print. Okay, so now we know that Java is indeed installed on our machine, Ubuntu Linux here. All right. Now, if you had any issues, so when you say Java C test.java and it didn't compile or something, just make sure that you typed it exactly as it is right here. Okay, class test, and make sure exactly, it has to be exactly like that. If it's exactly like that and you have some sort of error that says Java wasn't installed, just go back, rewatch this video and follow exactly as we did, as I showed you, to install Java and make sure that we set up the variables and everything. All right, so perfect. So Java now is installed and we are good to go. I'll see you in the next video. All right, so the next thing what we're going to do here, we are going to install IntelliJ IDE or IDEA, which is a tool that we're going to use to start learning Java and or Kotlin, okay? So I'm going to go on internet here, open up my Chrome or any browser of your liking, and I'm going to say download IntelliJ like that. And then we have here from www.jetbrains, I'm going to click this first one. Okay. And what I need here is there's two flavors. There is the ultimate, which is we can have free trial, and then I think you have to pay later. And we have the community version. So what we want is the community version. So download. And you can see here it's downloading. It may take a few seconds depending on your internet speed. Just give it a few minutes. All right, so we have downloaded our package here. So next thing we're going to do is I'm going to go and find where when I head into my downloads, I have here the file that we just downloaded. Okay, so what I'm going to do, I'm going to double click. So the file is being read, and next thing I'm going to do once this happens here, I'm going to go ahead and say extract, and I'm going to extract it inside of my documents so it's easy for me to find it. So, okay, at the bottom I'm going to go say and extract, and it's going to be extracting all the files to our documents folder. It should say here extraction completed successfully, and then I'm going to go ahead and say show file just for me to look at the files. I'm going to delete, close all of these, and close these as well. So now you can see it's under our documents, and there is our folder there. So if you click, and you can see all of these folders. Okay, so what we're going to be doing here, we're actually going to be accessing this bin folder here, but we're going to do that using the command line. Okay, so at least now we know where things are. Okay, let me open my command line again here, and what I'm going to do, I'm going to clear, so we can have a clear terminal here. And what I'm going to do, I'm going to navigate to my documents and to this folder here and to the bin inside of it. So I'm going to say cd to documents ls. There you go. We have our idea, our folder, which is this one here. Okay, so I'm going to navigate inside of it. I'm going to cd idea, and I'm going to go tab to complete. I'm going to say ls, and you notice we have all of these folders now that are inside, folders and files. Okay, so I'm going to go, we need to go to this bin folder here, which is this one here. So I'm going to say again cd bin like that, enter. We'll see ls. You should see all of these things inside. So now we need to run this file here that says idea.sh. Since we are inside of this folder already, we can say dot / and we're going to say idea.sh like that. So this will go ahead and run this batch there. I'm going to say enter. Now this will pop up. Okay, now we're installing our idea, our IntelliJ. Since it's the first time, we're just going to make sure that we install everything from the ground up. So we say do not import settings because we don't have any. Say okay. And there we go. This agreement will pop up. Okay, I'm going to say accept. And what do you know? And we have our IntelliJ installed. Now we're setting things up. Now the next thing we'll see here is the UI theme. As you can see, we have different themes. Okay, and there's this dark color here, or there's another theme. I usually tend to like this theme dark color because it's easier on the eyes and all of that stuff. But you can choose whatever you want. Okay, I will choose this dark color theme here, and then I'm going to go next. I'm going to just go ahead and say next to also. And in this case, I'm going to just say defaults. That's fine. Okay, and we don't need this. Let's go and skip the remaining defaults there. And of course, we need to install we need to add our password to make sure we authenticate ourselves. Okay, so type in your password, and I'm going to say authenticate. And what do you know? Now everything is working. And now we can go ahead and create a new project. So if we go ahead and say create new like that, it will give us this option here. Okay, let me go ahead and get rid of all the other stuff in the background because we don't need that. Close that terminal. Close this now. Now we can actually go and find our IntelliJ. We say IntelliJ. There we go. There's our application. Click on that, and we should run our application IntelliJ IDE. So it's running again because I ended up closing the terminal, which was running IntelliJ at that moment. But that's fine. I'm going to start over. Okay. Looks like our settings have changed. It's fine. I'm going to go back here to settings. So click at the bottom, configure. Click on that. I'm going to go to settings. I'm going to change it back to dark color. Okay. So we go to editor. Actually, we go to appearance. IntelliJ theme, I'm going to go to darker like that. I'm going to say apply. There we go. Say OK. And you can change if you don't want it. Right? You can go back here, go to settings, again to appearance, and you can change to whatever you want here. Okay, not a big deal. Perfect. So we can go ahead and create a new project. So create new. And here, what are we going to do? As you can see here, we have Java installed already. So IntelliJ allows us to create applications running Java, Kotlin, and many other languages, right? So I'm going to show you first for Java. Okay, so we click on Java here and we go say next. We want to create a project from a template, command line in this case. I'm going to say next. I'm going to give it a name. This is going to be hello world. We're just going to test things out here. Say next. And it will start creating our application or project. And once that's done, we should see here. Okay. Okay. So now here inside, to make sure that things are actually going to be working, we'll take a few seconds here to scan and make sure that all of the indexes and dependencies are ready for us. All right. So as you can see now, everything is ready. Okay. So we have our project here, hello world. It has a source. It has our main entry point here for Java, which means inside here, we can go ahead and write a piece of code here. Say system.out.println like that. And we're going to say hello world. We're going to go ahead and say run. If all goes well, we should see hello world being printed in the console. And there we go, hello world. Very nicely done. You can see Java is all installed as well as IntelliJ IDE for us to start working here. Perfect. So next, I'm going to go ahead and create with Kotlin here. Okay, I'm going to delete this. So exit. Start from scratch. I'm going to go ahead and run IntelliJ again. All right. So what are we going to do? Close this. I'm going to say file, new, project, like that. I'm going to head down here to Kotlin. That's what I want. Say next. This is going to be a Kotlin project. I'm going to say here hello Kotlin, or you can give any name you want and say finish. Just say this window. So that means it's just going to open this new project inside of this window. I'll take a second here. All right, so now we have our Kotlin project here. If you click, we have resource here. Now notice the resource is empty. So what are we going to do? We're going to say right click. I'm going to say new. We want a Kotlin file. So click on that and we're going to name it hello world. Hit enter. And there we go. We have our Kotlin file. Okay, it says here new version is around. Click on that. We'll download a plugin. It's always a good idea to download plugins when prompt. And it says here we have to restart. I'm going to go ahead and restart. Apologize for that, but that's fine. And it should load our last project, which is the Hello Kotlin. Okay. And you notice always we have this tip of the day. It's just a very handy tool or window here that shows us few things that you can do with this IDE. Okay, you can either say show tips on startup or not. I don't want it to show. I'm going to just go ahead and close this. All right, so we're back here. We have our Kotlin. I usually get rid of all of this. So this is just a comment that says here was created by me and this is the date. Okay, so I'm going to go ahead and delete all of that. And I'm going to go ahead and create a main point entry here or a main function. So I'm going to say fun. It's Kotlin for function. Things are still being indexed here, so maybe we should wait a few seconds. All right, so we're going to say fun. I'm going to call this main. I'm going to say args, colon, array, and strings like that. And we finalize by putting braces there. Okay, and finalize. And you can notice right away we have this cool logo here of Kotlin. That's the Kotlin language logo. And inside here, we're going to say println like that. We can say hello Kotlin. Okay, notice we don't need to put semicolon. You can run this file here by right click, and it says here run hello world KT, which stands for Kotlin. And run, we should see hello Kotlin if all goes well. So things are being built now. Because it's the first time, it may take a little while. There we go. It says here, hello Kotlin. Very nicely done. Now we know for sure that we can write both Java and Kotlin without any problems here. Okay, perfect. I'll see you in the next video. All right, so now we are going to install Android Studio on Linux, on Ubuntu. Okay, so what we're going to do, we're going to go ahead and open our browser. You can open whichever browser you use. I use Chrome, and I'm going to go ahead and say here Android Studio, like that. And I'm going to go to developer.android. Okay, so it says here, download Android Studio. This is for Linux. Okay, easily we can go ahead and download this Android Studio here. Okay, now you notice also here, as of recording of this video, Google has also released a preview version of Canary, which is Android Studio 3.0. Now this version here is a preview, so it's not fully ready. Okay, so but you can also download this one here, Canary, in case you want to use these features. Okay, but for now, in this case here, we're just going to go ahead and download, go back to downloads here. We're just going to go ahead and get the stable version, which is 2.3.2 as of recording this video. And this may change, that doesn't matter. Okay, perfect. I'm going to go click download. And of course, we have to accept a few agreements here and download for Linux. There we go. Now it's downloading. It may take a few minutes. And it tells us here exactly what to do. Okay, we're gonna have to unzip the file to somewhere, and then to launch Android Studio, we're gonna use the terminal and navigate to the bin folder and run the studio.sh, and we can go ahead and of course import previous Android Studio settings. In our case, we won't need to do that because this, I'm assuming this is our first time. Okay, let's just wait until all of this is downloaded and it's done. All right, it's done here. I'm going to go ahead and open it, show in folder, and there it is. So I'm going to double click. Okay, and what I'm going to do, I'm going to say extract, and I'm going to extract it inside of my documents here. I'm going to go ahead and say OK, or extract like that, and it will take a few seconds here to extract all of the folders and files. All right, I'm going to go ahead and say show files. I'm going to get rid of all of that in the background there, so we have an empty, and I'm going to minimize this as well. In fact, let's see what they say. Okay, so we're going to have to find the studio.sh. So inside of our Android Studio, click on that. We have this bin, and the file that we're interested in is the studio.sh, which is this file here. Okay, so let's fire up our command line here, or terminal, I should say. And what we're going to do, I'm going to say ls to see the list. I'm going to navigate to our documents. Okay, so I'm going to cd, doc, like that, and tab. And I'm going to say ls again to see what's inside. I have Android Studio. I'm going to navigate to it. I'm going to say cd, Android Studio, like that, and ls again. And I want to go and get the bin folder. Cd again, bin, tab, and enter. ls to see what's inside, and I want the studio.sh. To run that, I just say // and I'm going to say studio.sh like that, and I'm going to say enter, and pretty soon here we should see this. Okay, you can import settings from previous version. We don't have any, so I'm just going to select the last one here. Say okay, and Android Studio will start. And notice it's also powered by IntelliJ platform. So IntelliJ and Android Studio are pretty much the same, except Android Studio was built on top of IntelliJ. Okay, so now we have this welcome, okay, wizard here. We're gonna just go ahead and say next. In this case, we're just gonna keep standard, say next. And there are a few things, obviously, as you can see, that we need to install in order for us to be able to start writing and running Android apps. So what we're going to do, we're just going to say next. Okay. I'm going to say finish. It's downloading all of those components. All right, so everything is up to date. Okay, everything installed all right. I'm going to go ahead and say finish. And Android Studio is now starting. So one of the things we can do again here, we can go back here and say configure. Go to settings. We can go to appearance and we can change here. For instance, I like dark color. You can keep as it is if you want. I'm going to say apply. Notice it's now dark, which is great. Okay. And we can go ahead and create our first project. So we're going to say here, start a new Android Studio project. I'm going to call this is fine. I'm going to go ahead and say next. I'm going to say, I'm going to use API 23 6.0. Okay, say next. And it's going to install all of those components that are needed. I'm going to go ahead and say next. And there it is, empty. I'm going to choose an empty activity. Say next again. And I'm going to go ahead and say next. And our project should be running in a second here. And there we go. Our project is starting here. We should see. I'm going to go ahead and show tips and turn that off. Okay, again, give it a few seconds here. All right, and what do you see now? We have our project working, our project starting up here. Okay, you can see now we have our bare bones project. Let's go ahead and run this project. Click on this button. And we need to actually create a new device. So we're going to say create new virtual device like that. And we're going to choose Nexus 5. That's fine. Say next. So we're going to go ahead and download. I'm going to say accept, next. So now it's downloading our system image, which will allow us to create a virtual device or an emulator. All right, let's go ahead and say finish. I'm going to go ahead and say next. I'm going to say finish. Now, the reason why I'm getting this error here is because I'm running a virtual machine on my Mac. So in your case, you probably would have some sort of different arrangement and you shouldn't have this problem, okay? So if you say okay, I'm going to say just okay. I'm going to go say install and continue. So now it's installing SDK 24. Okay, I'm going to say finish. It says here Gradle is running, so let's give it a few seconds. The next thing we need to do is to install all of other API levels and other packages that come with Android Studio so that we can start building applications here. I'm going to go to this button here, this icon at the top. This is SDK Manager. Okay, click on that. And you should see this. So we have a few tabs here. We have SDK platforms. You notice that the only one that is installed is this Android 7.1 Nougat. So we can go ahead and install others as well. So we can click on these other ones. Okay. You can click all of them. I'm just going to click on these few ones, but I encourage you to click at least up to 3.1. Okay. I'm going to say apply and say okay to install all of those. It'll take a few minutes, so go ahead and get a cup of coffee or something. Okay, so I'm going to go ahead and say finish. And the next thing I want to do is you go to SDK tools here. We're going to make sure that we have a few other tools installed here. For inside in here, where it says support repository, all of the ones that we want are installed, and we have everything done. So we can click OK. And we should be good. Again, like I said, the reason why I'm not able to run an actual virtual device is because my CPU does not support required features. So you shouldn't have this problem here. Like I said, the reason why I am having this problem is because I'm already running on top of my Mac and I'm running under a virtual machine here, Linux. So my CPU, in this case, inside of my Linux doesn't support that. But in your case, you shouldn't have any problem. If you follow these instructions, you should be able to actually run this first application here, okay? Perfect. All right, so you're all set up, and I'll see you in the next video. All right, so in this video, I'm going to show you how to download the zip file containing all of the Kotlin code that we've been typing. Okay, so as you can see here, I will provide the link to the GitHub repository where all the code will be. Once you get to my GitHub link, this is what you're going to see. Now you notice here we have this Kotlin code.zip. This is the zip file that you need. What you need to do is to click on this Kotlin there, and then you will see this page here. So what I need to do, just click on download, and you notice right away, this will be downloaded onto your computer. And if you click on that, you notice now we have our Kotlin code unzipped and everything. Now, if you are on Windows and you need to unzip it, you can right click and unzip it. But on Mac, if you double click, it will unzip for you. So once you have this Kotlin code here, in order for you to import into our IntelliJ IDE, we simply do the following. We open up our IDE, which I already have it open here. At top, you go File, you say Open, and then you'll have to go to where you have put the Kotlin code file, which was unzipped. Okay, in this case, I have this inside of our downloads, so I'm gonna just keep it there. So I'm gonna go to our downloads, and I'm gonna find our Kotlin code like that. Once you've done that, just click OK. In this case, I'm gonna go ahead and say this window so that it all opens up inside of our window. Once you do that, you will see inside of our source, we have all of these Kotlin files. Okay, you can see we have hash map here. If you double click, you can see we now have our hash map. Okay, now to run it, as we've been doing, you can right click and say run hash map. So each file will represent a different project per se, or a different lesson. Okay, so if you are interested, for instance, in functions, of course, you will click on that and go to that file. Okay, perfect. And as you can see here, we ran and we have our married, single, and married again. This is for indeed the hashmap.kt for Kotlin. All right, and that's it. I'll see you next. All right, so this video here is going to be an update video, which means I'll take you through the process of updating the software that we're going to be using in this course. Now, if this is your first time in this course, so again, thank you so much for being here, and it is my hope that you enjoy every bit of the course. Once you have installed IntelliJ as one of our IDEs, which we're going to be using to learn programming here, the first thing you'll notice right now is that in some videos that you will see in the near future, things are going to be a little bit different, right? So fear not. The differences usually are minor in a sense that it can be very cosmetic. As you can see here, you may think, well, my IDE IntelliJ doesn't look like this. Something is not right. Well, the reason why mine looks like this is because I've actually installed a theme called Material Theme. Okay, but before we go there, let's go ahead and check, which is something that you should do very often. Let's go ahead and check to see if we maybe have an update for our IntelliJ. To do that, at the top, you can't quite see. It's out of focus here, what you can see on my screen. But at the top, there's this IntelliJ. I'm going to click that, and I'm going to scroll down. I'm going to say check for updates. So I'm going to check for updates. It's going to say check for updates. I'm going to keep doing that. And once you do that, you notice that there is indeed a new IntelliJ IDE, which is 2017 2.6. And it tells you, of course, things that have been added and so forth. And if you want to go and get more information, of course, you can click here to get the release notes. But for now, we don't want anything. We're just going to go ahead and click update and restart. And this looks like I have other things to update to. You probably won't have any of this. So if you don't have anything, that's fine. You just go ahead and say update and restart. And of course, it's going to download everything. And once it's done, it will restart itself. All right, after a few minutes or a few moments, I should say, you'll see that everything has been updated and your IntelliJ will restart and everything should be good. Great. Now, going back to the way things look, like I said before, the reason why my IntelliJ looks a little bit different than yours, the original one, is because I'm using a material theme, okay, that I've installed as a plugin in our IntelliJ. So you may ask then, how do I get that theme if you are inclined to do so? Well, easily, you can, once you open your IntelliJ, you hit the Shift key twice, as such, which will prompt the Search Everywhere window. Once you have that, just type in here plugin and go to the bottom. You see, it says plugins here. Click on that, and then it will open the plugin window. So here, what are you going to do? Go to the search bar and search for material theme. So you want to click on this material theme, and it says material theme. For me, it says uninstall because I already have it. But for you, it's going to say install. And once you have that, easily just click install and follow the wizard, which should be very simple to do. Follow the wizard and everything will be installed. It may also ask you to restart. In fact, I'm very positive it will ask you to restart your IDE, the IntelliJ, so that the changes happen. So follow that and do that, and it should be good. That's how my IntelliJ looks this nice. Again, it's not a requirement. If you feel like that's not something you want to do, that is totally fine as well. The next thing you notice that also keep in mind this, what you see here, this code, don't look at it because this is actually just Java, right? So I'm just showing an example so you can see how it would all look. Again, like I said, in the next videos, you will see some videos where the IntelliJ IDE will look a little bit more similar to the original default factory state, which is totally fine. Don't worry about that, okay? As long as things are working in terms of the code that we're learning, that's all that matters. Okay, so that's one thing I wanted to let you know about so that you are not caught by surprise and thinking, what's going on? Paula didn't tell us this. Okay, so now you have that information. So the main takeaway points here is always go to IntelliJ at the top here. You can quite see my menu bar. Click there and say check for updates. And then you will check for updates. And if you are up to date, it won't give you a chance to update because you are up to date. If not, then you always go ahead and update. Perfect. So I'll see you in the next video. The other thing we need to do, and we have to keep in mind, is to always make sure that our Kotlin is also updated. Now, as of recording this video, which is February, beginning of the year, February 2018, there have been a few changes in the Kotlin language in terms of security and certain parts of the syntax, okay? But everything else, the basics at least, is still the same. Nevertheless, it's always a good idea for us to update whenever new updates come in. Well, simply you go at the top. Once you open IntelliJ, you can't quite see this, but you just go to Tools, and you will have to scroll down. You'll see here, also look at this. Since we have our material theme, we can actually change different things in our material theme. That's very nice. That is assuming that you actually install the material theme. Okay, but anyway, I digress. So we want to talk about Kotlin. So we're going to go to Kotlin here. Notice we have Kotlin. It's already included with IntelliJ now. We go to Kotlin, configure Kotlin plugin updates. So click on that, and this is what you're going to have. Now make sure that you are inside here where it says update channel. You can drop down. There's early preview, early access preview. We want stable. So you notice that now the next one is actually the one that is stable is 1.1, not 1.2, which is the latest one. So we don't need to go to earlier because now it's stable. So keep on stable and say check for updates. You notice now a new version 1.2.21 actually is available. So what we're going to do, I'm going to say install. Notice here at the bottom, we'll take a few seconds to install the plugin and set everything up. Okay, perfect. And what I'm going to do next is go to Tools. And now you notice that you have the latest version of the plugin 1.2.21. It's installed. So we are now safe. Everything is installed as we intended. So click out of this. And what I'm going to do here, I'm going to just create a new project to make actually a Kotlin project here. So now you notice once that happens, you notice that now we have this Kotlin here. Okay, so we're going to just use Kotlin JVM there at the top. You can say next. Let's say hello again of some sort. Okay, just a little test. Say finish. I'm going to say this window. And there we go. So now we have a new, I'm going to right click here just real quick. And instead of Java class, of course, we want a Kotlin class. Let's just call this hello. So just for testing, I'm going to go ahead and say fun for function main. Say args. It's going to be of type array, type strings. And here I'm going to say print ln, and I'm going to say hello there. Okay. Of course, you'll see this again. Hello there. I'm going to go ahead, and you notice to the right here, to the left, we have this play button. Click that, run hello. And there we go. We now have, it says here, hello there. The other thing you notice that here is that now I'm using the JDK 9. So if you were able to go and install Java in the previous video, you'll notice that now JDK 9 or Java 9 has been updated, has been live and well for the past 6 months or so. So you should see JDK 9. If not, you will probably see the previous versions of JDKs. Okay, that's totally fine. But you should see JDK 9. We are using the new updated Kotlin 1.2, which is the latest one. I just want to get you updated so that you are up to speed. So in this video, we were able to update our Kotlin language in our IDE here to the latest available 1.2. Perfect. I'll see you next. All right, so we're going to go ahead and start a new project here with our new installed IntelliJ. So I'm going to go ahead and say open the IntelliJ, and once you open, this should be the first thing that you see. Now, because I already have a few projects here, just go and ignore this. Yeah. In your case, this is your first project, so you probably won't be able to see any of this. Okay, so I'm going to go ahead and say create new project. And right away, this will happen. You'll see here this window says new projects. And now we have a few options here. We have the Android, Java, and so forth. But we're interested in, obviously, is the Kotlin, our new language. So we're going to click on that. And we want the Kotlin with JVM, which means runs on Java virtual machine. So we're going to say next. And here, what we're going to do, we're going to give a title to our project. I'm going to say hello world Kotlin. Okay, and as you can see here, we have this project location. This is the place where we're going to be saving our projects. I have a place where I save my project, so you can go ahead and find your own place. If you want to change the place, you can just click here. And then you can find a folder where you want to save. Okay, perfect. And then we have here project SDK. You should see at least a version here, something similar to this. These numbers don't matter so much because depending on when you're watching this video, they may change. But the idea here is that this is where we point to our Java version SDK, to our Java SDK. If you don't see this, simply go to New and go to find the folder where you have our Java installed. In this case on Mac is under Home, and that's why it's pointing. This is where we have Java SDK installed. In Windows, it's a little bit different. So what you will need to do is to go to Program Files and find where we installed our JRE and go to find the bin. Okay, the Java SDK. Perfect. And of course, we have our runtime here is Kotlin runtime. All right. And I'm going to say finish. I'm going to go ahead and say yes. All right. And there we go. It may take a few moments for you, but for me, it's really fast. So here we go. The next thing you notice here to the left, we have this folder here. So if you click on that folder, we should have this source folder. Okay. Right now is empty, which is totally fine. So we're going to right click it and I'm going to say new. And we want a Kotlin file or class. You click on that. And this one we're going to call hello Kotlin. Say OK. And there we go. Now we have a blank, empty file here. I'm going to go ahead and get rid of this. So what are we going to do here? So the first thing we're going to do here is the following. We're going to go ahead and say fun, right? And say main, parentheses, and we're going to say args, colon, and we're going to say array, and we're going to pass here a string. Of course, we're going to put curly braces there. Right away, you will notice a few things that have happened here. There's this Kotlin icon here, which signifies that this function here is a Kotlin function. Okay, and we'll talk more about what's really going on here. But for now, I just want to get you going here. All right, so next thing we're going to do, I want you to type in print ln, and inside here say hello Kotlin. Just like that. And save. And once you save, we can either click here to say run, or we can right click and say run, okay, whichever you like. I'm going to click here and say run. And we should see at the bottom saying here in our console says hello Kotlin. All right, so this is our first hello Kotlin or hello world program that we have written in Kotlin. It should be very, very exciting. Obviously, we can add a few things here. We can add another print line. We can say, I love Kotlin. And notice one thing here, since we just ran project for the first time, all of a sudden we have here this play green, run green button at the top here, which means we can just click on that and we should see the results here. Hello Kotlin, I love Kotlin. Very nicely done. And one thing I want you to do before our next lecture is I want you to go ahead and print as many lines as you possibly can. Okay, create another print line that says some sort of message and go from there. Just have a lot of fun. All right, okay, I'll see you in the next video. I hope you were able to get many other print lines to print messages to the console here. Okay, so simply we would have said print ln again and say hey there, something like that. And on Mac, if you say Control R, this will run. Okay, and you can see here it says hey there. All right, perfect. So it's pretty fun. I hope you had a lot of fun. Let's talk a little bit about commenting your code. You notice here a very important distinction here is that as you see here, it says fun, main, and we have this braces here, right? Which means whatever it's inside here, it's inside of our main function, which is the first thing that runs when we run this piece of code, all right, this project. Now, if we wanted something to be commented out, meaning that if we wanted to make sure that this line here doesn't run, or it doesn't show in our console, we would do the following. We're just going to say // You notice right away the whole line turned a different color. So now it's gray color, which signifies this line here won't be read by the compiler. Okay, we save this and say run. We shouldn't see hello Kotlin. We see I love Kotlin because this is still active. All right. So this is a very quick, fast way to omit certain lines of code that you don't want the compiler to see and run it. All right. But also, this allows us to do a lot of other things. For instance, if programs become more and more complex, we need to add certain instructions for ourselves or other developers who may be interacting with our code. So we can actually do the following. Let's say if we want to say this will print a message, right? So this is something that you and I can read as people, but the computer will just ignore it. It's not a programming command per se. Okay. Now, if we wanted to be able to comment out this whole piece of code here, so these two print lines here, what we could do the following. Say / and asterisk, okay, and then we do asterisk and then /. Now, you notice whatever we write inside here, it's all going to be grayed out, which means the compiler is not going to run it. Okay, so if we save this and let's go ahead and run real quick, you will see nothing will show because all the code print lines, these two print lines, there are now inside of this multi-line comment. All right, so these are very important things to know as we progress in our studies here. So there's this option here. If you wanted to comment out one line, you just do // and whatever comes next, it's going to be out. It's going to be a comment. If you want to use a bigger block of code that you want to comment out, you just use / asterisk and asterisk /. Okay, so anything inside here is going to be a comment. Now you know how to comment out and make comments in your code. I'll see you next. In this video, we are going to talk about variables, right? So I'm going to go ahead here and create a new Kotlin file. So say new Kotlin file. I'm going to name this variables definition. Okay, say enter. Now you notice we have a new file here. Okay, so I'm going to go ahead and get rid of all of this. That's just junk. We don't need that. All right. So again, I'm going to go ahead and say fun for function, and I'm going to say main. This is very important because each Kotlin file needs to have a main function, which is the first entry point for the program. So we're going to say here args, say array, and we're going to pass here string. Of course, we have to put our braces there to signify that we are creating a function. So anything that comes inside here will run when we run this program, this project. So we are going to be talking about variables. Okay, so variables are a very important topic in any programming language you will ever learn. Variables allow us to set spaces in memory and to say that this space is here, we are going to put certain kind of information. And whenever we want that information back, we can refer to that spot or to that variable name. Okay, so think of it as a little bucket where we can put information. Okay, so again, if you put information somewhere, you want to be able to bring it back, right? How do we create a variable? The first thing we need to do in Kotlin, we say var. That's the keyword we need to use to start a variable. So again, var, and we have to give it a name, right? Because we need to give it a name that we can then use it to get the value that we have added to it. So we're going to say, for instance, name, okay? And we're going to go say equals Paulo, like that. The other thing you may have noticed already here is that with Kotlin, you don't need semicolon, right? In many other languages, you need a semicolon to signify that this statement here is ending. Okay, so in Kotlin, no need for those. In fact, if you add one, you will have this little warning that say redundant semicolon. Okay, perfect. So now here, what we did, we created a variable. We start with a var and we name it name. So we're creating that little bucket and we name it name. And then we are assigning Paulo to name, which means now if we say print ln and we pass in name, what do you think is going to happen? All right, let's go ahead and run this. And there we go. It says Paulo. Okay. Now notice something here. This is called a string. Okay. And we'll talk more about string in the next video. So a string essentially is a text. All right. So we put double quote. Whatever is inside double quotes is considered a string. So we are putting this string inside of our name. Okay. We can go ahead and create another variable. We can say var last name, and we can say is shown. Okay, and we can go ahead and say print line, pass in last name, and you notice the moment we put LA, IntelliJ here is smart enough to say, hey, I think you meant you want this last name here variable, right? So we don't have to type it out ourselves. We can just go ahead and say enter, and voila. All right, save and run. We should see Paulo is shown. And naturally, we can keep doing. So we said var again. Let's say what else? Dog name. We can say doofus, something like that. And we can go ahead and say print line. Say dog name. There it is, right? And so enter. If you save this and go ahead and run, we should see Paulo is shown, doofus. Now you can start seeing the power of having these variables here, because now we can infer by calling the name and we get the result, or we get whatever we have put inside of those buckets, inside of the variable. As you can see here, we have Paulo in one line and is shown in the next line. So if you wanted to put all of this in one print line, we can actually concatenate things. We can say plus, and we say last name. If we save this, and let's give it a run again, we should see Paulo is shown. As you can see here, we don't have a space between Paulo and is shown. So what we can do to add a space, we can just add a string, an empty string. In fact, we can put a space there and put a plus. Now this space here will be read as a string, but since it's an empty string, it will give us a space that we need. Okay, so save this, say run, and we should see the Paulo space is shown. Obviously, we could have added a dog name as well here, so we can say copy, and we can even add other strings inside. Let's concatenate, so plus, and here we can say has a dog named. We can get in the next line here, and we can say dog name. All right. So now let's save this and run. We should see Paulo is shown has a dog named Doofus. Okay. Now we're constructing a string here, but all of this is coming from our variables. All right, so go ahead and play around with this new knowledge that you have now. So go ahead and create different variables, right, and give them different values and print them out and see if you can concatenate them or adding them together as we did here, and add text in the middle as well if you want. And just to make it look something like this, we had here at the bottom in our console. All right? I think you can manage it. Okay, perfect. So I'll see you next. All right, so we are making strides here, which is wonderful. Now, the next thing we're going to do is to continue talking about variables. Variables in Kotlin and many other languages, they do have types. Now, a type essentially means what type of a bucket am I creating and what kind of things am I supposed to put in that bucket that I created. Okay, so let's go ahead and create a new file class here. So we're going to say new Kotlin file class. I'm going to call this variable. We're going to start with string. Okay, I'm going to go and copy all of this information here because we don't need to be constantly writing the same thing, right? So I'm going to delete all of this. So we know what variables are. Now we're going to talk about types. We have strings, we have int. You've seen strings already, so this is a string type. So string, we have int, we have double, we have boolean, we have float, we have char, and a few others, but these are the main ones. Again, a type essentially tells us, because we know that a variable is a little bucket in memory that we assign to say, hey bucket, here's your name, and also we are going to add this inside of you. Okay, so when we define a variable, we need to make sure that we also define what kind of data we are going to put inside of it. We don't want to create a bucket that is supposed to hold cats, and then we decide that we want to put elephants in it. All right, it just physically wouldn't work. Okay, so let's go back here, create a var country. Okay, and we're going to say Spain. Okay, so again, we know this is a string because we have double quotes and inside we have a text. Okay, that's a string. So this is a string variable. Now this country here is a bucket that contains this Spain string. Okay, so that means also if I go here and I say country is equal to Mozambique, okay, that's also valid because now I'm changing whatever was in the country. First was Spain, and now I'm saying, oh, now it's going to be Mozambique. Now, the reason why I know this is okay, and you can see there's no problem here. In fact, we can go ahead and say print line and say country. We're going to go ahead and run. We should see Mozambique. There it is, Mozambique. That's all good. Again, we say Mozambique here because we changed to Mozambique. Now, the reason why I'm okay even to put Mozambique or any other string here is because I know the first thing I did here when I instantiated or when I first created this bucket, I said to be Spain, which is a string. Implicitly, we're saying this country bucket here will always hold strings. If we were to add, let's say, 23, which is an integer, we'll talk about next, we're going to have an error. Okay, because it says here, the integer literally does not conform to the expected type string. And you may say, well, how, again, we didn't specify it to be a string. Right? But we actually did. The moment you say equals and put a Spain here as a string, then that means this is always going to be a string. This is how you define a variable to be a string implicitly, not directly. Now, if we want this to always be a string, or to explicitly say that this country variable is a string, we can say, we'll say country like that and put colon, and we would say string, just like that. Okay, so now we were saying this country here is of type string. And then we could say here country, Spain, and that would all work. Or we could have said at the top here, just give it Spain, like that. That would also work. Okay, so those are two ways to define a variable. Wonderful. So we learned a little bit more about how to create a variable of type string. So we learned how to explicitly do that by saying country, colon, string, and then we can say equal Spain. Or if we didn't want to do that, we could have just go ahead at the bottom here, say country, and then add it to say Spain. Same difference. So it's all the same. And also we learned the implicit way of defining a variable type. We say country, and we just give it Spain like that. And so that is also another way of us telling our system that country will only accept strings. All right, perfect. So in the next video, we'll go ahead and talk about integers. Hello, my Kotlin developers. Wonderful. I'm happy to see you again. So in this video, we are going to continue and we're going to talk about the int type. To organize things a little bit, I'm going to say source new Kotlin file. I'm going to call this variable int, something like that. Okay. And because we have all that information already, I'm going to copy all of this and paste it all in here. Okay, so we did string, now we're going to do integers. Okay, let me go ahead and get rid of all of this. An integer is essentially a number. Okay, just a number. So when we say a variable is of type integer, we're just saying this variable will hold numbers, will hold integers. All right, so how do we do that? We say var, let's say age, for instance, as the name of our bucket, of our variable. And then we say equal 31, just like that. Let's print line, print age. Okay, let's go ahead and say run. And we should see 31 here. Now that means we are here. What are we doing? We are implicitly defining age to be an integer type. Now we're saying this age here is of type integer because the first thing we did is assign 31, which means now if we go here and say age is equal to Paulo, we're going to have a problem. Okay, because it says your type mismatch require int found string. So that's one of the things that you have to be very careful when it comes to your types. You can add a different type inside of, for instance, an int type. All right, so how do we then explicitly say that this age here has to be an integer, right? Right, because you say, for instance, my age, colon, and you say int, just like that. Okay, I can say it's equal to 32, for instance, and if we go here and pass my age, if you save. Now at the top here, if we go to run, let's make sure that we want to run the variable. Okay, so we go ahead and run. And we should see 32. That's perfect. So now we have integers and we have strings, which means if we have those two, we can actually add those together in our print line here so that they show a message. Okay, we'd say, for instance, we can go ahead and create here, say var name. I'm going to just make a string type is equal to Paulo. And what we can do here, we can say, I can say name, okay, plus is plus age, just like that. So it's going to say my name, which is a string type, is Paulo, plus I'm concatenating, so I am gluing these two pieces of information together here. It's going to say Paulo is age. What's age? 31. So let's see if this is true. Give it run. And Paulo is 31. Now, there is another way of actually concatenating here, okay, which is Kotlin way concatenating variables inside of a string here. So what we need to do actually is just go ahead here. We just go and say $, and we say age, like that. So now we can actually run this. It's going to say Paulo is 31. So there's really no difference here, right, in the result. But at least we know we are doing the better way, per se, the way that Kotlin allows us to do. But either way it works. But this is the Kotlin way to do things, okay? But notice we have a little thing here. So that means we need to get rid of all of this. We can just put everything inside and say this. Okay, so now everything is inside of a string because we have these quotes here. So when we put the $, and then the name of the variable, in this case is name, we're saying we want to actually display what's inside of our variable name here. Okay, so it goes ahead and runs and goes and says name, Paulo is age. So you'll see no difference again, but at least now we know we are doing it the Kotlin way. Okay, in fact, we can remove that space, run again. And there we go. Paulo is 31. Okay. There's one other thing I want to show you. Let me get rid of this. The moment we do that, we have a problem here. If you hover over instead of a name variable here being called, notice it says variable name must be initialized. What this means is when we create a variable and we say explicitly give it a type, we need to initialize it. Initializing really means that we need to give it a value. we can either go ahead and say Paulo or just empty string. So, but it needs to be initialized. Now, there are times when we don't want to initialize it. We just want to say, well, we will initialize, give it a value later, and just don't do anything for now. So the way we do that, we just put the exclamation mark like that. And then we can say is equal to null, just to give it something. Okay? We're just saying this name here could be null, and that's totally fine. Okay? So we put the exclamation mark, and then we say equal to something. In this case, equal to null. Now, this allows us to do a lot of things because now we can add whatever we want to name. Now we can go ahead here and say name is equal to James. Okay, and give it a run. You will see it says James is 31. Okay, the moment you give it something, this says, okay. Now, the moment you notice, the moment we actually give something to James, because now it's not null, which means it's not nothing, this becomes redundant. This means the moment we create this name here and we say string, could be null or something, we have to right away add something to it, right? We can say name is equal to James in order for this to work. Otherwise, you notice here is going to give it a problem. I'm going to say variable must be initialized. Now, as we start building more complex applications, you will notice that we're just going to go ahead and say var name string and give it a null. And then later, of course, we're going to be adding things to that variable. But I just wanted to show you how things are done. Okay, perfect. So in this video, we'll learn about integers, and we'll also learn how to concatenate or how to show variables data or information inside of our println string here. Okay, perfect. So go ahead and play around with this concept here, and I will see you in the next video. In this video, we'll continue and talk about double types. Okay, so I'm going to go ahead and create a new Kotlin class file here. I'm going to call variable. If I can type double, just like that. Get rid of all of that. And we're going to go ahead and steal the main method here, which is what we always need, and paste it in there. I'm going to get rid of all of this. Okay, so now we're going to talk about double type. Okay, I'm going to go ahead and get rid of all of these other tabs here. We don't need them. So a double is a bigger bucket where we can put numbers, okay? And the numbers usually have a decimal point, okay? Not a fraction, but a decimal. So if you find a number like this, 23.00, 12.89, those are doubles, okay? Perfect. So let's go ahead and create a var here. We're going to call my double. And of course, we can go ahead and say 23.0, okay? So this, if we go and say print, and we say, here's my number. And of course, we can do the new concatenation way that we've learned. In this case, we can say my double, save, control run. We should see 23.00. We have to run variable double, and you can see at the top here it says variable int, so we still are inside of our int file. Let's just go ahead here and say run this one here. Okay, here's my number 23.0. okay, it omits the next 0 because it's just a 0, but if we were to put 1 there, if you save and run again, we should see 23.01. If we had 2 zeros, the last 0 doesn't quite matter because it's 0. So this is an implicit way of defining our double number here, but the explicit way would be var new double. You can say it's going to be of type double, okay, and then we can give it and say here 43.6. We save this and change this to new double. Go ahead and run. We should see 44.6. All right. Okay, so we have the implicit way of defining a double, right, by just creating the variable and then say 23 and then give it a double number, which means is my double variable here is now of type double. Okay, or we can go this route here where we explicitly say colon type double, and we give a value. Of course, we could have done the way we just learned, which is we put exclamation mark and we say is equal to null. All right, so as it is right now, we won't have an error because we are saying, yep, it can be a null, and we give it a null. And then we pass it in. Now, if we go ahead and run this, we should get a null. Okay, number is null. So now here at bottom, we can say new double is equal to 23. Let's see what this is going to do. Well, we have an issue here because it's saying the integer literal does not conform to the expected type double. Again, this is an integer. It's not a double. That's why our compiler here is giving us some issues. So we have to say .0. Then we should be good. Perfect. So now you learn about doubles, which is another type of numbers. Now go ahead and play around with different doubles and see how all of this works. And I'll see you in the next video. All right, welcome back. So in this video, we are going to talk about booleans. Okay, so booleans, a boolean is a variable that can only hold two states, either true or false, either 1 or 0. Okay, and we'll see the power of true or false as we progress in our studies here. Now, one of the things we can do here, let me go ahead and create a new file here. I'm going to say variable bool for boolean. Okay, get rid of all of that. And as you know, I'm going to copy all of this and paste it in here. Okay, get rid of this. This just helps us with time management, I guess. All right, so now we're going to talk about boolean is either true or false. Okay. So in computing, in any programming language, we need a way to control the flow of our application or of our code, which means there are times when we need to figure out certain conditions. So if something is true, if a condition is true, then we want to do something else, we want to do something else. This is where booleans shine. Boolean variable. We'll say var again, and we can go ahead and say my bool is equal to true, just like that. Now my bool here is always going to be a boolean. We don't need a semicolon there. As you can see, again, in Kotlin, we don't need to add semicolon. It's optional. Okay. All right. So there we go. If we go say print line and say just pass my bool and run this, we should see. Oh, again, let's go ahead and change. Instead of double here, let's run from here because it's running the previous app. Okay, there we go. It says true here. All right, perfect. And we can do the same. Say var my bool. I'm going to say this is a boolean. Oh, I'm going to change the variables here. Say new bool. It's a boolean type. And we can say it's equal to null. For now, let's pass here new bool. And we should see null. There we go. Why? Well, because we instantiated or we create our variable of type boolean and we give it a null. Obviously here we can now go say new bool is equal to false. Just like that. Save and run again. By the way, I'm hitting Control R to run it. Or you can just go ahead again and just go click somewhere here, right click and say run variable bool. Just different ways to do the same thing here. Perfect. So now you can see now we have false. We added this new bool and we give it type false. It print it and says new bool is false. All right. So now you learn another type here, which is very important, and we'll see it happening over and over and over again as we progress in our studies here. Great job. So far we've learned about strings, integers, doubles, and now booleans. So next we're going to learn about floats. I'll see you next. In this video, we are going to learn about floats. So floats are another type of numbers that are fractions. If we want to represent a fraction, we would use a float. Okay, so like for instance 1.1 or 0.3 or 5.2. So a float is a fraction. Okay, so 0.6 or even 2.5 or 1.4, etc. Okay, so let's go ahead and create a new file here. Kotlin, I'm going to say variable float, and I'm going to copy all of this and put it all here. Perfect. So now we're going to again get rid of this and this as well. We like to start things from fresh. So here's how we define a float. We say var my float equals 0.5. So let's try something real quick. I'm going to say print ln, and I'm going to pass my float. As you know, this should will show 0.5 as my float. Good. Now let me go ahead and do something very interesting here. Instead of assigning 0.5, okay, I'm going to explicitly say that this float here is going to be type float, and I'm going to give it null, just like that, which means now I'm going to say my float is equal to 23.44. Okay, right away, as you should have expected, we have a problem because this is actually a double. Now, but what if I do this? Look at this. Now, this is being considered a float because we put an F at the end of that number. Okay, so if we save this and give it a run, we should see 23.4. But this is a double. How did that happen? It turns out if we put an F out, that signifies that this number is now considered a float. Now, if we get rid of this and say 0.5, we still have a problem because we need to actually have an F, okay? So this tells you that doubles and floats are essentially represented the same way. The only difference is that if you are talking about floats, you have to put an F, small f, an F like this, or a cap F, doesn't matter, okay? As you can see here, the moment we take out the F, we have an issue because you have to differentiate a double from a float by putting an F for our float. But you also noticed here when we said my float is equal to 0.5, we didn't have any problem. But you notice also when we implicitly just say my float is equal to 0.5, it's all good. Well, the reason being is because since this is implicitly, it assumes that this could be a double or could be a float. So there is my float. If you say var new float, make this an actual float, and we can give it a null. And then here we're going to say new float is equal to 0.6. Then I have to put F. Actually, something like that. If you go like this, you have an error, you have to put an F. And we're going to say new float. Save, give it a run. We should, of course, see our 0.6. All right, so I'll see you in the next video. All right, so we'll move on and we'll talk about chars. So a char is a character. So a char is equal to a character, right? So something like this, H or B or $, or the ampersand, etc. Or even just a space like that, that's also a character. How do we define a character? Well, let's go ahead and create a new file here just to get things very well organized. We're going to call variable char. And copy it all here. And delete all of this. Okay, so how do we create a character variable? Yes, there we go. So we say var, and we're going to call this my char, and we can implicitly say m, like that. Now, notice a few things here. When we talked about strings, we had double quotes. Now, characters, we have single quotes. So that's the basic distinction between a character and a string. Notice if we were to put something else here, we would have an error because it says too many characters in a character literal. Okay, that means a character, as the name implies, is just one character, one item inside of our single quotes here. Okay, so that's very important. Say print ln, like that, my char, save, and run. Should probably end up running the previous one. Yep. So we have to actually right click and say run, and we should have an M. Okay, say new char, and it's going to be of type char, and we're going to give it a null for now, and then at the bottom we can say new char is equal to B, just like that. Say new char, let's actually run it, not compile. and we should see B. Okay. And obviously you can go ahead and concatenate, say my char like that. That's an old way of concatenating, and we're having a problem. All right, because the moment you do that, it assumes you're trying to add as an addition these two characters. Okay, so we need to figure out a different way here. What we can do here is just say something like this and put my char. And get rid of that and put it all outside like that, and then we'll be able to concatenate new char. In fact, we have to say here, there we go. To save, we should have MB. Let's run this. Oh, BM, I should say, because new char is being called first. So BM. All right, perfect. So now you understand the difference between characters and strings. The main distinction here is that with strings, we have to have double quotes. With characters, we only have one single quotes, which also means for characters, we only are allowed to have one character. Okay, we can't put more than one because, again, we're talking about buckets here. So if we say this bucket only fits character, it should only fit characters. There's exceptions, but for now, I want you to think in those terms. All right, perfect. So now you've learned a lot of things here. You've learned about strings, you've learned about integer, the distinction between doubles and integer, the distinction between doubles and floats, okay, and also you learn about booleans and now characters. So with all of this information, you are able to do a lot of great things here with Kotlin. So I want you to go ahead and play around with this concept with all these variables types that we've learned here. And they are very important, as you will see in our next videos as we start building a little bit more complex programs. All right, perfect. Good job, and I will see you in the next video. All right, so in this video, we are going to learn about a different way to define variables. Up until now, we've been using var, the var keyword, to create our variables. However, there's another keyword called val, V-A-L. So let's learn about that. I'm going to go ahead and create a new Kotlin file here. I'm going to say val and var, just like that. Of course, I'm going to copy all of this, paste it in here, and get rid of all of that. And I'm going to get rid of this as well. I just leave it here. Difference between var and val. Okay. So again, we are inside of our main here. This is our entry point for our programs in Kotlin. All right, so difference between var and val. Okay, so let's go back to var. We can say my name is equal to Paulo. Okay, I'm going to go ahead and print ln, and we can say my name. I'm going to call here my name, and that's all good. Okay, now notice if I want to change my name to something else, I could go say my name again is equal to James. If we go ahead and run this, right click, and you should see James. Even though we started with Paulo, Paulo is not used anymore because we changed it to point to James or to hold James string here. Okay, and that's good. So the var allows us to change as many times as we want. So we can go ahead and say my name again and give it a different value, say Bonnie, save, give it a run. We should see here Bonnie. We can change as many times as we want. Now, there are times when we want a variable to be more of a static or a variable that is not allowed to change. Okay, that's when we use a different keyword here. Instead of var, we just say val. Notice the moment you do that, we have an error. Val cannot be reassigned, which means we can't change it because now this keyword just tells us that this variable here is a variable that cannot be changed. Okay, so those are the differences here. So if you want a variable that can be changed as you keep going in your program, then of course you're going to use your var, V-A-R. Now, if you want it to be more of a static variable that doesn't change, doesn't allow it to be reassigned, then you will say you will make it a val. Now, you may ask, in what cases will I ever want to use a variable that it's unchangeable or unreassignable? Well, there will be cases, for instance, that you have a number like such as pi 3.14, right? You're running a program, you say val, say pi, Okay, I'm going to say is equal to 3.14, like that. And you know pi doesn't change. Obviously, you don't want it to make a var because somewhere along the program, you don't want this pi to end up being 5.678, right? Because whatever else at the bottom here you'll be using this pi, if it changes, then the calculations will end up going to be wrong, right? Because pi is a static number that will never change. It's always 3.14. So naturally, you want this to be a val, because now pi can never be changed, which is exactly what you want. So you're reinforcing your programs to be a little bit secure and smarter in the way that variables are declared, right? If you want something that changes along the way, then var is just fine. Otherwise, you want a val, which means it is static, it's just written on stone, and it will never change. Okay, the only way to change it is to go back to where you define it and change the number. Perfect. So there we go. And of course, we can call this pi here. Let's say pi. There we go. Give it a run. We should see 3.14. And of course, we have problems because these are all useless now. Let's run again. This should work. Okay, 3.14. There it is. This is our pi. And we cannot change it. In other cases would be, for instance, if we just have certain variable or string, for instance, of a URL, right? Let's say website URL in our program that we are using to do something at a later time. We can say val, URL is equal to www.google.com, something like that. And of course, we can always use it somewhere else we want. So now we can say pi and URL, okay, something like that. And if you go ahead and run, should be 3.14 and www.google.com. So now you have two keywords here. You have var and you have val. So the val is, let's call it static, not meant to change, okay, or be reassigned. And we have var, meant to be reassigned. Perfect. So with those two pieces of information, now you're able to understand a little bit better the syntax and when and how we use these different types of keywords to create our variables. Okay. All right. Thank you, and I will see you in the next video. All right, welcome back. So in this video, we are going to learn how to get user input, and we get that input and we display on the screen. Okay, it's going to be really fun. So I'm going to go ahead and create a new file here. I'm going to call this read input. It's been a while. Let's go ahead and say, just write, say fun, main, say args, it's going to be array of strings, let go, like that. Okay, so again, I just created a new main function here. Perfect. So here we are going to learn about read input. All right, so what I'm going to do here, I'm going to say print ln. I'm going to give it a little welcome here. So say welcome to our store. And then I'm going to say print ln again. This one's going to say, I'm going to put a bunch of equals like that. I'm going to copy this and put it here as well. Let me prettify this. Something like that. All right, let's save this and run. Right click, run. Let's see how it's going to look in our, oh, look at that. So it looks pretty decent. So let me move that there. Yeah. Let's run this again. All right, welcome to our store. Very cool. Maybe add a little bit more equals like that. Very nicely done. All right, so welcome to our store. It's going to be this very, very interesting console application we're going to make here. So next we're going to say print ln again. We're going to say hello. What can we do? What can we do for you? And then at the bottom here, we can say var customer response is equal to read line. Okay. So this read line here, what it does is just reads whatever the customer types inside of our console here at the bottom. Okay, so let's go ahead and run this. And of course, we have hello to our store. And notice here, the next thing we need to do, we just have to say, I want to buy bread, like that. Okay, and it exits. So we're able to allow users to enter something, in this case, a text. And now this text here, I want to buy bread, is now being read and put inside of our customer response, which means we can then print line here and say customer response, like that. If we save this and run again, we should be able to say I want bread. You can enter, it says here I want bread. Okay, perfect. So we are getting what the customer responded, whatever they wrote, and we are putting into the customer response by using readLine method or function that comes with Kotlin. And of course, we're printing it out. Okay, but for now, we don't want to do that. Let's see. So what we can do now is the following. And then we can say again here, print ln, and the clerk will say, yes, indeed, we have fresh bread. We have fresh bread off the oven. It's your lucky day. Save this and run. Okay, hello, what can we do for you? I want bread. Yes, indeed, we have fresh bread off the oven. It's your lucky day. And then what we can do, var customer second response is equal to read line. We'll prompt the customer to write a response. Okay, so let's go ahead and save this and give it a run. All right, so hello, what can we do for you? We can say, I want bread. Yes, indeed, we have fresh bread off the oven. It's your lucky day. The customer can respond by saying, thank you. And there we go. And what we can do again here, we can just copy this and put it at the bottom here. This is for the clerk, and he's going to say, you are very welcome. Have a nice day. Save this, give it a run. So now we're creating this very interactive conversation here. So, hello, what can we do for you? I want bread. Yes, indeed, we have fresh bread off the oven. It's your lucky day. Great. Thank you. You are very welcome. Have a nice day. And we are done. Perfect. Now at the end here, if we want, for our sake, if we wanted to display all of the responses that we have received, we can go ahead and do the following. You can say print ln and give it a little separation there. Do the same here. And we're going to say your conversation with the clerk. Something like that. And what we can do, we can actually go ahead and copy all of these. Right. And except now, what are we going to do here? Let's say print ln, the customer response. Copy this. Say customer response like this. We're not reading any line anymore. It's just going to display the whole conversation that happened between the customer and the clerk. Okay, let's give it as 2 here. Like that. Oops. All right, let's save this and give it a run. All right, ready? Okay. Hello, what can we do for you? I want bread. Or rather, you can say, I'm looking for fresh bread. So enter. Yes, indeed, we have fresh bread off the oven. It's your lucky day. Wow. Thank you. Yep. The moment we do that, it says here, you are very welcome. Have a nice day. And all of a sudden, it says your conversation with the clerk and gives us the whole conversation with our clerk. Now the problem here, there's a very strange formatting issues here. So what we can do, in fact, is, let's see here. I'm looking for bread and then say yes indeed. Because we have to say print ln, not print. If you don't put print ln, it's not gonna print in the next line. So it's very important. Let's save this and run once again. Hello, what can we do for you? I am looking for bread. Enter. Yes, indeed, we have fresh bread off the oven. It's your lucky day. Whoa, thank you. Enter. You're very welcome. Have a nice day. And then it displays our whole conversation with our clerk. So it says here, hello, what can I do for you? I'm looking for bread. That was you. Yes, indeed, we have fresh bread. It's your lucky day. And we said, whoa, and thank you. And you're very welcome. Have a nice day. Okay. And next thing we can do here is let's do a little bit more formatting here, right? Because we noticed we can put, for instance, where the customer is saying something and where the clerk said something as well, right? That way we have a better representation of the conversation here. So what we can do here, we can just go and say clerk like that. Clerk. And we can say customer, clerk. Okay, save again. This is the last time, I promise. I hope you're having fun, because this is fun. I think it's fun. All right, so hello, what can we do? Looking for bread. We have fresh bread off the oven. It's your lucky day. Nice. Thank you. Enter. You're welcome. Have a nice day. And then you have your conversation with the clerk. Clerk said hello, what can we do? Looking for bread. Forgot to add one more here. This should be customer. Here, let me put, you probably saw this part here. I did not see it. Okay, let's see. Here is customer. Okay, once again, let's run again. Yay. Okay. All right. Say looking for bread. Yes, indeed, we have bread. It's your lucky day. Thank you. And he says, you're very welcome. Have a nice day. And then we have our whole conversation here. Clerk said, hello. What can we do? Customer said, oops. Customer response. Ha. Put something like that. My bad. And we have that response, and then clerk says, yes, we have indeed. We have fresh bread off the oven, so lucky day. And then customer said, customer response. Again, you probably saw that. We have to put the $sign to signify that we are actually wanting the variable here that we added the response, okay? And so forth. Perfect. So I'm not going to run this again because you can see with these little changes that we made, the app should work perfectly fine. Very nicely done. So we were able to do quite a lot here. We're able to create this very simple but useful, I would say, this simple, fun program here where with read lines. So we're able now to get input from the users, from the customer in this case, and have a very nice chat conversation here. All right, perfect. So I urge you to go ahead and start looking into doing this. Now you've learned about strings, you've learned about integers and floats and booleans and so forth. Instead of here, this conversation was very string based, right? It was very text based, but you can also ask for numbers, right? You can create a program just like this one here and start adding more things like, what is the quantity of bread you're wanting, and users can input numbers or any other types. Okay, so just play around with what you've learned so far and add to this simple program here. That way you can broaden your repertoire. Okay, so take this and expand it a little bit. All right, perfect. I'll see you next. In this video, we're going to learn about operations and operators. So namely, we're going to learn about adding two numbers. Okay, let's go ahead and create a new file here. I'm going to Kotlin. I'm going to say addition. And get rid of this. Let's copy all of this and put it here. And get rid of all of it. Almost all of it, not all of it. There we go. We don't need this anymore. There we go. Addition. Okay, how to add two numbers. So the first thing we're going to do is to create two variables, and these variables are going to be var because we want to change them. So we're going to say var first num. Going to make it 10. Var second num is going to be 20. Next var is going to be result. Right? We're going to go ahead and call this. Going to give it a type of int. All right. So here what we can do, we can say result is going to be equal to first num plus second num, like that. So now our result here will have the addition between first and second numbers. So as you know now, we can say print ln, and we're going to say result, or we can say, to be better, we can say this sum is, I'm going to say result, like that. So if we save and right click and run, we should see the sum is 30. All right, that's very good. So we were able to create two numbers here, first and second, and we created a variable. That is not necessary, but I did it anyway just to show you. So this variable here, we said result is of type int because it has to accept ints. Okay, and we'll make sure that say it's not going to be null. And here we're saying it can be null. That's not a big deal. And we say result then is going to first num plus second number. And then we are displaying the sum. Okay. We could have said, if we wanted, actually, we could have just said the following. We could put it inside here. We could have said first num plus second num, just like that. Now, this is a different notation that I haven't shown you here. If we wanted to display an actual expression as we have here, so we took the first num plus second num and we put it all here to make it quick, easier, you have to put inside of curly braces. Okay, so you say the $, and you open the braces, and we can put first num plus second num here. In this case, we don't need our result anymore. Okay, that's another way to do it. Okay, so if we save this, we should run, and you see nothing real has changed in terms of result. But we know that in our code here, we've changed how we are displaying it or how we're retrieving the variables. In this case, we have first num, second num. That's perfect. So we can do, of course, change all of these numbers here, something like that. If we save and run, we should have the addition of these numbers here. And the beauty also is that here we can go ahead and if we wanted to add another actual number, save this and run, we should have 330 because we added 120. So I'm going to go ahead and comment all those out. There's different ways to do the same thing here. Right? So you're able to learn how to add two numbers, and you also learn a new way of concatenating or a new way to add variables inside of your print line here, inside of a string. Okay, so you put $, curly braces, and you put, in this case, first number plus second number, and it gives you the summation of those two numbers. And you're good. So go ahead and play with this. In fact, you could take this knowledge that you have here and go back to the previous program that we wrote about the store, the customer conversation, and you can add a little bit more of interactivity to that program. All right, perfect. So I'll see you next. In this video, I'm going to show you subtraction, how to subtract numbers. Okay, so what we're going to do, I'm going to create a new folder, a new file here. So new subtraction. There we go. Going to copy all of this and paste it all in here, and we don't need that anymore. So subtraction, how do we subtract two numbers? All right, so to add, we have this add sign, and to subtract, you would imagine we have the minus sign. How do we do that? Well, we're going to say first num here and second num here. What are we going to do? Let's change this to 10. Let's keep that to 10. Let's change this to 5, okay? And right here, we can just go ahead and say minus. If we save and run, it's going to run the old one. So let's go ahead and do this. Run subtraction. And the sum is 5. Well, it shouldn't be the sum. Let's say result is 5 because 10 minus 5 is indeed 5. Now, what if we did the following here? What if we did 5 and put 15. What would result be? Run. And is minus 10, right? So it works both ways. So it gives you a negative number as you would expect. So you learn about how to subtract two numbers. Essentially just use the minus sign, right? I'm going to put it here. The minus sign, that's for subtraction. And there's the plus sign for addition. Okay, good. That's it. Good job. I'll see you next. All right, welcome back. So in this video, we're going to learn how to multiply, so multiplication, which we use the asterisk sign there. So that's what we're going to learn in this video. So what I'm going to do, I'm going to say source, right click, new Kotlin, and we're going to call this multiplication. I'm going to copy all from the previous file there, and we don't need the subtraction anymore. And we are back here. How do we multiply two numbers? Yes, you guessed it. Just change here, put the asterisk. Okay. I understand in the real world we would use the X for multiplication. Save this and right click and say run, which should see the result, which is 75. So 15 times 5 is indeed 75. So if we change this to 1, give it a quick run, you would see the result is 5. And as you know, multiplication doesn't matter the order of your variables, right? Because it's multiplication, the result is always going to be the same. So you have something else to play with here, which is the multiplication. So you can multiply two numbers and get the result as we did here. And of course, I comment this out because I want you to have it to see the other way we could have done this, which is we create a result variable, okay? And we say it's a type int, and then we assigned the operands here, first and second. Of course, you would change the operator here to whatever you wanted to get. Okay, in this case, it's multiplication, so we would add this multiplication here. And of course, here to get the result, you will just say $sign and the result. Then you will get the result. Okay, but this is another way, quicker, faster to do things. I usually prefer to put everything into variables because then it's easier to go back and refer to that variable. But you don't have to do that, obviously. All right, so now you know how to multiply in code, of course, because I know you can multiply. All right, I'll see you in the next video. Hey, welcome back. Welcome back. So in this video, we are going to proceed, and this time we're going to talk about division. So how to divide two numbers. And for division, we use the / like that for division. Okay? All right, so let's go and create a new file here. It's going to be a Kotlin file. I'm going to say division like that. And one thing I want to say, you don't have to do the way I'm doing here. I'm doing this and putting everything in one file because it's easier for me to then share all this code with you. Okay, you can create different projects, but this is much easier because we're talking about smaller lectures, as you can see here, smaller programs, because we're just getting used to programming in Kotlin. That's how I'm doing here. So I'm going to copy this, okay, and get rid of that. All right, division, we just put a /. Okay, so let's go do that. Change this / like that and save. Right click. Let's go and say run. I misspelled division. Oh well, it's okay. Should have an I there. I apologize for that, but it doesn't matter. Okay, so the result is 5. Why? Because 5 divided by 1 is indeed 5. Now, what if we did reverse? What if we put 1 here and we said 5 here and we save? Let's run. What's going to happen? Says the result is 0. So we have a problem here, folks. We have a problem indeed. All right. So what's happening here? Let me go ahead and confirm that this is wrong. I'm going to call my calculator application here. And we're going to say 1 divided by 5 is 0.2. Why is it giving us 0? Well, the reason why is because this here, right, when I say first num is 1, that's an integer, and so is 5. So what this program's saying is that, well, this is equal to 0 because 0 is an integer. 0.2, it's not an integer, right, as we've learned previously. It's a float. So that means then, in order for us to actually get the correct result, we can do the following. We can go ahead and make this a float, which means we have to put 0 and say f. Okay, make this also a float, which put 0 and f, like that. So now we know these two are float, which means the result of the division between first and second num should be also a float. So we save this and run. We should see 0.2, hopefully. There we go. Now we have 0.2. Okay. Now the other way we could have done this, I'm gonna go ahead and comment. I'll copy this. Oops. I'm gonna copy this and comment it all out. I'm going to create these ones here. Just remove this float. I'm going to show you the other way, the beauty of this wonderful programming language here. What we're going to do here is the following. So I'm back to integers, okay? It's because I didn't put inside of a result variable, so I went straight ahead and did this, put inside of our print line. What we could do here is right after the first line, we could have said dot to. Look at this. Now we have functions that convert any number to any other type number, right? So I can say to float. Now, while it's there, so now we're saying first num, it gets this first num here, and we convert it to float. Okay, that's what we're doing here, and we'll talk more in the next videos how to do this. So now we say first dot to float. That means this number first now is a float because we're converting it to a float. Now, if we save this and give it a run, we should yield the same result. Now you may say, well, okay, that makes sense. We did the first dot to float, so the first number now is float, but the second number is not a float, is an integer, because as we said here, second num is 5, is an integer. So why is it that we're still getting the correct result indeed, which is 0.2? Well, the reason why is that it's all about inferring. So what's happening here is that the compiler will look at this and say, well, if this first num is a float and you're dividing a float by an integer, the result has to be a float, okay? So we could have gone, if we wanted to be a little bit extra careful, say here to float as well. And guess what? The result will not change. It's still 0.2. Now, what happens if we get rid of the float, right? And just keep the last one, the second num, the number that we're dividing by, to be a float? What's going to happen? Are we still going to have 0.2? Well, let's see. Let's run. Yes, we do. So this means only one number has to be of type float for this to yield to an actual correct result. So you have two ways here you could have done. You could have explicitly said first num is of type float and create that number. Always add the f. Otherwise, the compiler would assume that is actually a double. So you put an f if you want a float to be a float, right? And second num, type float, and 5.0 f. And then we wouldn't need to say to float. Now, if we have integers and we want to get the correct fraction number, the correct result, in this case a float, we have then we could either use the second num and convert it to a float, or the first num to float, or both, but just one, it's sufficient, all right? So those are the small things that can throw us off as we are creating our apps, right? Just little things that can yield to very catastrophic results here, right? Because we learned if we are dividing two integer numbers, in this case, we're supposed to get 0.2, but if we didn't specify that these numbers here, either one of them or both of them are floats, we got 0, and that's not good, my friends, all right? Because 1 divided by 5 is not 0, it's 0.2. Very nicely done, folks, very nicely done. Thank you again, and I hope this lecture made sense. If it didn't make any sense, just rewatch the video and feel free to ask, and I'll be there to answer your questions. Deal. I'll see you in the next video. In this video, I'm going to show you another operator here called the remainder. The remainder, I feel like, is one of those less talked about operators, but I think it's very important to know, to understand how it works. Right? The remainder. So how do we get a remainder? We just use the percentage sign, and I'll show you what remainder is. Remainder essentially means what remains. I want you to think of what remains after dividing two numbers. That's the idea. All right, let's go ahead and copy this and create a new file here because we want to be able to organize our code. Okay, I'm gonna call remainder. Okay, I'm gonna have an error here because this is not needed. change this number here to 4, 2. And I'm going to get rid of this. We don't need that anymore. And I'm going to put here an ampersand, a percentage sign here. Okay, so this says first num, remainder second num, which means 4, remainder 2. So again, what remainder means, it says, okay, take these two numbers, divide them, so say 4 divided by 2, and tell me what is the rest or the remainder. So in this case here, we're saying 4 divided by 2, we know is equal to 2, which means remainder is going to be what? 0. Why? Well, because 4 divided by 2 is 2, and 2 times 2 is 4, and there's no remainder. Okay, let's go ahead and run this. And we should see 0. Oops, we're running the old. Let's right click here. Say remainder. And there is, result is 0. Okay, now let's try something. Let's say 3. Let's run. Let's see what's going to happen. Ah, now we have 1. Why? Because 4 divided by 3 is 1. But then 1 remains, because 1 times 3 is 3, and we still have 1 to get to 4. Okay? Once we understand this, we will be able to do things like, well, I have a list of number 1 through 10. And I could say, I just want all the numbers that are divisible by 2, or multiples of 2. If something is divisible by 2, that means it's also multiple of 2, right? And you can say, and you can express that by a remainder operator and then display those numbers. And you'll see that all of that in action. So that's the concept of a remainder. So just think of it, whatever it remains from a division operation. So what if we put 8 here? I want you to do, so 8 divided by 3, you'll get 2, because 2 times 3 is 6, and we have 2 left in order to get to our 8. Let's save this and give it a run, and there we go, we have 2. All right, so I'll see you in the next video. So in this video, we're going to learn about incrementing and decrementing a number. Again, remember, as you learn Kotlin, or as you learn any programming language, you'll notice that there are different ways to do the same thing, the one thing. Okay. So in this case here, let's say if we wanted to increment or add a number, or add 1 to a number. Okay. So how would you do that? Increment. We're going to use the sign plus. Okay. I'm going to append the plus to the variable. All right. Let's go ahead and copy all of this. Again, you don't have to do this, but I do just to make sure all is well organized here for me. Kotlin, we're going to say increment. Okay, so we have our increment here. So what we can do with increment is the following. So as you can see here, if we want to add 1 to our first num, we could say, for instance, first num is equal to first num plus 1. If we print this, in fact, we could put this inside of another var inc, okay, like that. So we can just go get rid of this, go to first num plus 1. Okay, so we're going to say inc like that and save. Let's go ahead and run. We should see 9 because first was 8. Let me comment that out, give it a run here. All right, so we should see a 9 at the bottom here as a result, because now we have added 1 to our first num. Of course, the other way we could have done this is the first num plus 1. Okay, just directly adding to our print. Just a choice. I'm going to keep with inc for increment. All right, so that's one way of incrementing. Now I'm going to show you a different way that you can also do the same. So this expression here. So what we can do actually is inside here, we can just say first name. Before that, we just put plus plus. So this means the following. This means first num plus 1. Okay, you just say plus plus first num. If you save and run, we should see a 9. Okay. Now, can we even go ahead and say plus 1 here and see what's going to happen? We should see a 10, because now remember this, all this expression here is this. So what it happens is when we add 1 to first num, so it was 8 at first and then it's 9, and if we add any other number, it's just going to keep adding that number. That's why we have 10 here. Okay, that's for our incrementation. Now, if we want to decrement, we use the minus. So in this case here, what we can do, say var decrement, we're going to say first num minus 1. That's the obvious way. So of course we go decrement here. Let's run. Decrement, we should see 7 because first num was 8, and we say first num minus 1, of course, is 7. Or we could have just gone ahead and done the following. Just say minus minus first num. If we save and run again, look what's going to happen. Now we have 7. I'm going to clean things a little bit here. That way we don't have the clutter of unnecessary information here. So this is decrement. In fact, let me make sure. So we're decrementing, and here we are incrementing. We say plus plus, it's the same as this. So this is a shorter way of doing, and makes our code cleaner and easy to follow. And of course, you can always opt to doing this way, but you will notice we'll probably favor this way more because, again, like I said, it's cleaner and it's easy to follow. Done any programming language such as Java, you'll notice that certain things are very similar to Java, but a little bit better in the sense that Kotlin allows us to condense, allows us to simplify our code. So the whole idea behind Kotlin is that we are simplifying what Java was not able to simplify. So it's a very concise language, and it was by intention, it was intentional. All right. So whenever you have an opportunity to simplify your code, you do it because one is less typing, two is more maintainable. So you'll be able to maintain your code in the long run better. All right. So always go for simplification. Perfect. I'll see you in the next video. Alright, so in this video, we are going to learn how to convert between data types. So between ints to doubles to integers, and so forth. That's a very important aspect of Kotlin because there'll be times when we want to convert things around depending on certain situations. So what I'm going to do here, I'm going to copy all of this and create a new file, Kotlin file class, convert data types. That's what I'm going to call. And I don't need these other files that were open here. And I'm going to get rid of all of these. Convert data types. Let's get rid of all of these as well. Okay, so we have a clean slate here. So let's suppose I have a var. I call this num. I'm going to call this age. And of course, I'm going to explicitly say this age is of type integer. Just like that. It's type integer, and I'm going to give it 31. The beauty of Kotlin is that almost all of our types are also object, and we'll talk about object. But what object in this case means, that means we can access different properties of our variables. Meaning we can say age and say dot, and then we have a lot of things that we see here. It turns out we can actually convert this age integer to string. Now you won't see the difference here. So if I get to string, now this age here is in different format now. We've converted it into a string. If we save this and run, you won't see much difference, but at least the program, we know that our age now was converted to a string. Okay, it's no longer an integer at this point. How can I prove to you that this is already a string? Is if I do the following. If I go and say plus 10 and run, notice what happened. This is very important. What happened here, instead of adding to 31, it just concatenated it. So it looked at it, said, this is a string, and I'm just gonna concatenate or glue together 31 and 2. That's why we have 3110 or 3110. Okay? Now, if I remove this to string, look what's going to happen. Now, the problem that's happened, let's hover over and see. So it says here, infix can correspond to dot qualified age plus blah, 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 nullable receiver age. That means because we said here this can be a null, when we said int exclamation mark is 31. We're saying this can be a null, so it's saying it's not allowed to do this operation here. So if we remove this, then we should be okay. So if we save this and run, we should see 41. Okay, because now we know this age is an integer. Okay, so we're able to actually do addition, because you can't add a string and an integer. That would make no sense. Okay, so what the compiler would think that you're trying to do is thinking that you're trying to put those two variables together, not necessarily perform an addition on those two. Okay, so that's how I was able to prove to you that the moment you say .toString, then all of a sudden this is a different expression that's happening here. The other thing we can do here, you notice if you say to dot and you say to byte, we can actually convert this to a different type called byte, which we didn't talk about. Now let's say dot to double. We save this and give it a run. Now you see, instead of 3, it says 3.0, because we say age dot to double. So now we're converting from different types here. So we can keep going here. Let's say we want to go to float and 3.0. Now you notice there isn't really a difference between the, at least visually speaking, we don't see any difference between 3.0 for double and 3.0 for float. But we know this is a float because we say to float. Okay? And internally, this has an F to the right here to signify that it is indeed a float. Now, this is very useful in cases when, for instance, we say that this var age int is 3, okay? And we here at the bottom, we say blood pressure. I'm just going to give it a double number here. And we say blood pressure is, let's say 89.0, something like that. If for some reason we wanted to take this age here, we want to put this 89 into our age, let's try this. We can say age is equal to blood pressure. We're going to have a problem, right? Because, well, these two types are mismatching. They're not the same. Okay. In fact, we have here this red bulb that signifies that we have an issue. So if you click on this one, it says convert expression to int, right? We have to convert it to an integer because that's what we said it to be previously. So what we can do to solve this problem, we can just go after the blood pressure and say dot, look at this, to int. Now we've solved our problem, because what we did, we do realize that our blood pressure is indeed a double. However, since we want to put inside of our age, we need to convert it into an integer. And when we do that, now we are safe. Okay, so now our blood pressure to int, which now is indeed an integer, okay, is safe to put inside of our age integer. Okay, save this and run. And we should be able to see 89 with no problem. And you will see the implementation of all of these more as we continue in this course. But I just want to give you a little taste of how to convert data types, which is a very, very handy tool. As you can see here, we can always convert things back and forth as we keep creating our programs here. All right? Perfect. Now play around with this concept, and if you have any questions at all, feel free to ask. I'll see you next. In this video, we're going to talk about another kind of operators. In this case, they're going to be conditional operators. Now, we need conditional operators in any programming language because, again, it allows us to branch our code, our statements, our logic. Because the idea behind programming is decision making. So for that to happen, we need a way in which we can harness the power of conditional statements, conditional logic. Okay, so for that, we need the operators. So I'm going to go ahead and create a new copy all of this, create a new one. I'm going to call conditional operators here. Okay, conditional operators. Okay, I'm going to get rid of all of this. Control V, and we don't need any of this. So I'm going to get rid of all of that. And it's going to be here, conditional operators. Okay, so the ones we're going to talk about are less than, greater than, equal, not equal. So these are the conditional operators we're going to be looking into here. Okay, let's create two variables here. Let's get var num. We're going to give it 5 var second we're going to give it 6. Okay, so what we're going to do here is the following. So we're going to do the following. I'm going to say print ln, and we're going to do something very interesting. I'm going to say first greater than second. Okay, let's see what this will output. So right click and run, and says false. So it turns out if we use conditional operators, what we're saying here, first number is greater than second number, this expression here will return a Boolean. Okay, returns a Boolean, which means true or false. Like that. Get one space there. So in this case, because first num is 5, second num is 6, so 5 is not greater than 6. That's why we have false. If we copy this and create a new, the less than, so first num is less than second num, if we save and run, we should see false and true. Okay, because now, indeed, first num is less than second num. Okay, so indeed here we have first num is less than second num, which is not true, Boolean. And there we go, which is not true. Then we have false, and first num is less than second num, so 5 is indeed less than 6, and we got true. Okay, so very simply, so we know that conditional operators, because it invokes a condition, that means it has to return either true or false. And we'll see how to use this when we learn about if statements. Now we've used the less than and greater than. Let's look at the equal, this kind of equal here, double equal. So if we go ahead here and say the following, I'm going to go ahead and comment this out. If we go and say print ln, and I say first num is equal to second num, notice the double equals again here. This is not the assignment equal, just one equal. This is double equal, which means we're making sure, testing if the first num is equal in value to the second num. Okay, let's see what this will print. You should know it's going to say false, right? Because these two numbers are not the same. Okay, now if we were to do the following here, let's copy this and add the exclamation mark, say exclamation equal. What this signifies is not equal. So whenever we have an exclamation mark preceding any variable, or in this case this other operator here, that means not equal. We save this and run, we should see a true for this statement here, because first num is indeed not equal to second num. And the other case here is if we wanted to use the less than or equal, we can go ahead and just change this to less than or equal and see what's this going to output. It says true because first is less than or equal to second. Is that true? Yeah, is indeed less than. So this is less than or equal. Okay. And we copy this and create the next one here. It's greater than or equal. If we save, let's give it a run. What should see? False, right? Because this condition is not met. This condition is not true. So first name is not greater or equal than. This is greater than or equal. Perfect. So now you're able to use these conditional operators here. Less than, greater than, equal, not equal, less than or equal, greater than or equal. This may not seem very useful right now, but once we learn about if statements and loops and so forth, we will put all of this into action, and you'll see how we can use all of them in code. I will see you in the next video. Alright, so in this video here, we're going to use what we learned, the conditional operators we learned here, and add another component, which is the if statements. Okay, so again, the whole idea behind programs is the ability to branch out our code or our statements, right? To do our logic, to say if this condition is met, then we need to do this. If this is not met, then we don't do this, and so forth. So what I'm going to do here, I'm going to copy all of this and create a new file. If statements. There we go. All right, so the first thing we're going to do here, I'm going to keep everything except this. So what I'm going to do here is the following. If statements. To create an if statement, simply we just go ahead and say if, and right away we have here IntelliSense code completion helping us. If we hit enter, then we have this parenthesis here. This is where we put an expression. An expression is essentially the condition we are trying to match. Okay, so we say here if first num is greater than second num, and then we put our curly braces, which means now inside here we can run the logic, the code. We can go ahead and say print ln, and we can say yes. Let's go ahead and get rid of this, and let's run this. So right click and find run if statements. Let's see what's going to happen. Well, nothing is running. Why? Well, because this condition returned false, because first num is not greater than second num. That's why this code here doesn't run. Okay, notice if we change, if we copy this, and let's go ahead and comment this out. Okay, now if we change this to less than second num, if we save and run, we should indeed see yes, because our first num is indeed less than second num. Now you can see the power of using our conditional operators here with our if statement, because now we can do all sort of things. And of course, like I said, conditional operators go hand in hand with if statements, because again, we are finding conditions and saying if this condition is met, then this should happen. Okay? That means we can now here say if it's not right equal to, we want it to say yes. Let's run, and indeed say yes, because these two numbers are not equal. Let's see what else can we do here. Go back. Let's see, less than and equal. Okay, let's say here less than or equal. Let's run and say yes, because first num is less than the second number. Okay, you notice if I change this to 5 and run, this should still be true. Oh yes, because this says less than or equal, so either or, right? If it's less, this should be true, or if it's equal, then this should be also true. Okay, let's put that back. And of course, you can do the greater than or equal, and you save, give it a run, and of course in this case it won't show anything because this code is not run, because again the condition is false. Now the beauty here also is that in our if statement we can add an else statement after our last braces. We can actually add, say, else, and we put the curly braces brackets there, and we can say print ln, and we can just say no. Okay, so what this does is that if this is not met, whatever we set to be run inside here, if it's true, if it's not met, then we're just gonna print whatever else here. In this case, we're gonna print no. So we save this and give it a run. It's going to say no because it failed. This first statement here failed, or at least it gave us a false. Okay, and we want print, and then it goes and runs the else. Now again, the whole idea here, especially with Kotlin, is that we simplify things. Okay, now we know here we have one statement. We only have one statement that needs to be shown. So what we can do to make this simpler is the following. We can go ahead and say if here. We can say first num, in this case, is greater than or equal to second num. Instead of putting braces, because we know there's only one statement that we're reading here, we can just go ahead and say print ln yes. Okay, yes, like that. Okay, and we can say else print ln no, like that. This is the same as what we did previously here. It's all in one line of code because we just don't need to put the curly braces anymore. So if we run this, we should have the same result, but we know that our code is just all in one line. Okay, it's printing no because this turned out to be false. Okay, so this one print is just going to print the else. Okay, very, very neat. See, I like this syntax because it's just one line and it's very easy to understand and to follow. But of course, you're very welcome to use this notation as well. Perfect. So I'll play around with this concept here. Okay, you can change a lot of things. In fact, instead of having integer, we can also have doubles, floats, or strings as well to start doing all this comparison here. All right? All right, perfect. So I'll see you in the next video. In this video, we're going to talk about logical operators. Okay, so logical operators are and, or, and not. Okay, so all of these will be used in conjunction with what we have already learned. So I'm going to go ahead and create a new project here, or new file, Kotlin, and I'm going to call this logical operators. Okay, get rid of all of that. I'm going to copy and paste it in here. I'm going to get rid of all of these. Get rid of all of that. These are going to be logical operators. So for logical operators, like we said, we have and, which we use 2 ampersands. We have or, which we use 2 pipes, so shift backslash like that. Okay, and we have not, which we've seen before. It's just an exclamation mark like that. Let's go ahead and use if statement so we can drive this concept home. Let's go and say if the first num is greater than second num, and we're going to put all of this inside of parentheses because we want this to be just one statement, and we're going to use the and first. Say and, let's give a new var here, say var third num 10, and we're going to say and third num is less than first num. Let's go ahead and put that in parentheses too, because we want these to be one expression and this also to be just one expression like that. So we are now saying the left, what's left, and what's on the right side. If that's the case, we're going to go ahead and say println, say hello. And we're going to say else, we're going to say println, nope, something like that. Before we even think about it, let's go ahead and run it. So right click and run. All right, so it says here nope. Okay, let's go and trace it and see what's going on here. So the first thing, let's just read and try to understand what's going on here. So we say first num is greater than second num. Is that true? Let's see, first num, second num. No, that's not true. So that means this whole expression here turns false. So let's go ahead and say this is false. How about this one here? Third num is less than first num. Third num less than first num? Nope. So this is also false. So now we're saying false and false, right? Okay. So false and false, it's going to give us false, right? Because all we saw here is nope. We didn't see hello because this wouldn't run because we have a false, right? Because this whole expression here turns to be it's false. That's why we have this else nope here running. What this tells us is that if both of them are false, if we are using a logical operator on 2 falses, we get false. Now let's change this to make it positive or to make it true. So first num 5 is indeed less than second num 6. Okay, so now this is true and this continues to be false. Let's see what's going to happen. Let's run. And we get nope again. So it seems if both are false and we run and, we're going to get a false branch here and says nope. If one is true and the other one is false, we still get a nope, which means we still get a negative or a false result, right? That's why this is running. How about if we make this as also true? So now we're going to say third num, which is 10, is indeed greater than the first num. What's going to happen? So this now is true. If we run this, what's going to happen is that we see hello. So for the and, I like to always say both have to be true in order for us to get a true statement, expression. Okay, so both sides operands have to be true in order for the expression to be true, in this case to run our print hello. Now let's move to the or. Now let's change this. Instead of, I'm gonna go ahead and copy this, and I'm gonna comment this out so you have this code. Okay, so now we have a copy. So let's go ahead and see if we can change this to or. So shift pipes like that. Now we have two, so this is or. So we're saying whatever to the left or whatever is to the right. So this has to be true. This is true. Like, let's change this back to make it false. Okay, so first num is 5 is certainly not greater than the second num, which is 6. Okay, so let's run this and see what's going to happen. It turns out we have a false or a true. We ended up with a true statement. That's why this ran. So it turns out for or, only one of the operands or only one side has to be true for the whole expression to be true. Right? So only one side needs to be true for the whole expression to be true. So if both are false, obviously everything is going to be false. Right? Could change this. Oops. And run, we're going to get a false, which means we are going to get nope. Okay, and of course if both are true, and automatically the whole expression will be true. So you can see here and or, so or is the opposite of and, or and is the opposite of or. Right, so let's go ahead and talk about the not. The not is just a negation, which means it negates whatever we have set to be. So if you want to negate or make something opposite of what it is, in this case, if we put an exclamation mark just like that before this expression here, that means this whole thing here is going to be the opposite of what it is. So it's going to go ahead and look at third num, which is 10, and see if it's less than the first num, which is 5. In this case, it's not true, but now it's going to be true because we put the opposite. Because we now said here the opposite of what this is, right? It's negate, it's converting, or it's flipping whatever it is to something the opposite. Okay, so if we run this, so now this is going to be true, and this continues to be false to the left here. So you should expect to see a hello here. So let's go ahead and run. Okay, so we have here an hello. Now if we had also here, we can create a boolean, say is correct. Let's make it actually a boolean explicitly. We can use this correct here. Let's change all of this. In fact, let's make it true. So now we can use that boolean here. And if we go like this, you can see right away it goes and we can do the same. So if this is true, that means now this is going to be the opposite of true, which obviously it's going to be false. So now it's correct, it's going to be false, which means now we have false or false, right? There's two statements here, and we should get a false or a nope in this case, right? So you can see things that we can do now using all of these logical operators in conjunction with conditional operators. We can do a lot of things, right? We can create decisions based on the expressions that we are passing in our if state. What I've shown you here, if, else statements, conditional operators, and logical operators. And we're going to learn about other control flows, but if you put all of this together, that's what computers do, right? Computers are real good about taking logic and making decisions depending on the data that it's been receiving. Okay, so all of this, the if statements, trying to figure out how to branch the logic, right? If this is true and that is not true, then we do this, else we do that, else if, and all this stuff. It's called branching, is what computers do. And most of our programs that we're going to be writing, and as we learn Kotlin, they will be based on this primitive concept, or fundamental concept, really. Now that you've learned these, go ahead and play around with this concept, and I'll see you in the next video. Welcome back. So in this video, I'm going to teach you another control flow here. So we learned about if and else. Now we're going to learn about a new one called when expression. If you know C, C++, or Java, you probably have seen the switch statement. So the when statement in Kotlin is the same as the switch statement in many other languages such as Java, C, and C++. Okay, so what I'm going to do, again, I'm going to go ahead and create a new file, Kotlin file, of course, and I'm going to call here when, just like that. I'm going to say func main args, going to be array of strings, like that. That's our main entry. I'm going to talk about when. First thing we're going to do here, I'm going to create a variable, say var age. It's a type of int, and I'm going to give it a space there. I'm going to give it 19. Okay, so we're going to say this. We're going to say when, there it is, when we're going to pass age. So what are we doing here? We are passing in the age as the starting point for this expression. So that is the expression that we're passing in for a when. What we're going to be doing inside here is to add a few statements inside here that will check whether this age is 19 or anything else. And as this number, so the idea is that as this number changes, we are going to have different things. Okay, so we can switch around. So we can say, for instance, if it's, let's start, if it's 17, right? We put dash greater than sign. Okay, and we want to say print ln, just say 17. Okay, like that. If it's 18, you're going to say like that and say print ln. 18. In fact, we can say line like that. Okay, and if it's 19, we're going to go ahead and say you wanted to print line. Say yep. 19. Now else, we just want something else to happen. We want to say print ln none of the above. Okay, so if we run this, let's save this and run, right click, it says yep, 19. So it went ahead and ran this one here because it checked. It went through, checked 17. Nope, it's not. 18. Nope, it's not. 19. And it says, yep, indeed, age is 19 right now. Now let's go and change age to be equal to 17. What do you suppose is going to happen? Let's run this, and we should see 17. With this one expression, we can check to see different options, right? So we can say, well, if the users enter 17, then we print something pertaining to that 17 key. Enter 18, we want to do something else. If they do 19, they do something else, and so forth. I mean, we can branch this to the end of the world, okay? And we can then have an else that says, well, if none of the above, we can just say none of the above. Okay, so that means if we change here to 16 and run, we should get the none of the above. There we go. Okay. Now we armed with this knowledge, let's create a really fun little application here. So we're going to create an app that will prompt the user to enter a number between a certain range, and if they enter a certain number, we're going to display a random message, okay? So let's go ahead and do the following. I'm going to go ahead and comment this out, okay? Put it at the bottom there, and I'm going to say the following. I'm going to start with, say, print ln, say enter a number between 1 and 10. And then what we're going to say here, we're going to say var, because we want to retrieve that number. We're going to say entered number is equal to read line. Now the read line, we want to make sure that we are reading an integer, because we want them to enter an integer. We're going to say dot to integer, to int, like that. Now we have a problem here. We'd say only safe with exclamation or non-null asserted. So we have to assert this two exclamation marks here to make sure that whatever we're getting from the user is indeed an integer. These two here are not negation. We are not negating. We're not making this the opposite of what it is. We're just saying we want to make sure that whatever we're getting, it's an actual integer. Okay? Say when, okay? And we're going to pass the entered number. So here we're going to say if they entered 1, we want to print to the screen not wrong number, okay? If they enter 2, we want to say print ln getting close. Let me copy this. closer. It's through 4. We want to say println. Alright, you can see it's a fun game here. Say 5. We want to say println. Well, you are lost. Okay, for 6. We want to say bingo. And we can stop here, say else. Println. Sorry, you are way lost. Just like that. So when we run this application, we should see this: enter a number between 1 and 10. And of course, whatever we are entering, we want to make sure we are actually making it to be an integer. And then we use our when expression. So this will go ahead and see whatever they've been entering until they enter the correct one. And then we will check to see what number was entered. So if they enter any number between 1 and 10, we should see a message here. Okay, so let's save and give it a run. And there we go. So let's give it 4, enter. See, it says Okay, let's run again. All right, let's give it 10. Sorry, you're way lost. We'll keep going. Let's run. How about give it a 6? And look at that, it says bingo. We could have used the if else statements, but this is much easier because now we have everything laid out for us, and it's easier to read and easier to put together. You can see now you can create interactive applications here, simpler still, but at least something you can play with. Okay, all right, so go ahead and play around with this concept here. Create a little console game here that will ask the user, prompt the user to do something, and you can display something totally fun or different depending on what they have selected or what they have entered. Okay, and obviously whatever they've entered, we could have, of course, converted it into any other type, to string or to boolean or to whatever else we wanted, depending on what we want to do with that entered value. Okay, so go ahead and explore that. I'll see you next. Hello and welcome back. So in this video, I'm going to show you another side of programming. Yes. They're called loop controls. See, there will be times when we want to repeat certain statements, we want to display them, or we want certain expressions or statements to be repeated in code, right? So if, let's say, if we want to write this here, print wrong number 10 times, right? We could go ahead and write println 10 times, and that would be fine. But what if we want to do automatically? What if we want to do 10, 15, 17, 100 times, 1,000 times? Right? That wouldn't be really a good use of our time. So we need a way of looping through and get those results that we want. Okay, so that's what we're going to learn in this video. So I'm going to go ahead and create a new file here, Kotlin file. I'm going to call this for loop. There we go. And I'm going to go ahead and say fun main, because we need an entry point, args, array, string, and there we go. So we get here, gonna for loop. So let's say we have here println, right? The infamous println. Say hey there. Okay. If we wanted to print hey there about 5 times, we would want to use a loop. In this case, a for loop. Okay. So what we would do to create a for loop is simple. We say for, and there we go. We can just go ahead and say enter, and we have to pass in an expression inside here. Okay, so what do we need to do? We have to create a variable first. Let's call this item. Okay, and next thing we say in, and then we put the range, right? How many times we want to loop through. We're gonna say 1.5. Okay, and then we have our braces signify that whatever's inside is going to print from 1 to 5, so 5 times. All right, so let's copy this and go ahead and put it over there inside. Okay. So if we go save and run this, oops, it's going to run the old one. We don't want that. Let's go ahead and run the for loop like that. And there we go. We can see at the bottom here, we have hey there 5 times. The syntax here is item, and then we say in, right? So this item is just a variable that we can use to say how many times we're looping through. And then we're going to say in 1 through. So this dot dot, just think of it 1 through 5 or through 10 or through 20, like that. So any number we want. Let's go ahead and save this and run and see it go through 10 times. As you can see, we have hey there 10, 20 times. Okay. Now let's go to check out this item here. What is that going to give us? So that will be our iterator. So as we iterate through, this item is being updated with each iteration. So print it out as well. I'm going to say item to see what's really going on. Save and run. Ah, there we go. So it turns out it doesn't start from 0, it starts at 1 because we said here from 1 to 20. Now for one from 0 to 20, we could have said 0 to 20, and then it would include the 1. Now if you're coming from Java, this may be a little bit strange because usually you say int I is equal to 0, I is less than whatever number you want to get to, and then I plus plus. Okay, same concept here, but this is cleaner and easier to really understand, right? So we create a variable, the iteration here, and then in from 0 to 20 or whatever number you want to put there. Okay, you can see the item here goes and updates each time it goes through. At first, because we said from 0, starts at 0, so item is 0 and goes ahead and adds all of that or displays all of that. Okay, so from 0 through 20. Now, the beauty here is the following. Inside, we can start doing a lot of different cool things, right? So we can, for instance, go ahead and say if, because we know about if statements. We can say, well, if item, this number, this iterator here that we have created, if item percentage sign or remainder 2 is equal to 0, like that. Okay, so what are we saying here? If the number is divisible by 2 or multiple of 2, then we want to print something here. Right? We can say, for instance, item is multiple of, in this case, we just go ahead and append item again. Now you can see the power of the remainder. So what we're doing here, let's say if it's 2, 2 divided by 2 is indeed 1. Okay, so there's remainder 0. So 2 will be 2 is, not ID, multiple of 2. Okay, so let's save this and run and see if this works. So all the numbers that are actually going to be showing here are going to be multiples of 2. As you can see, you get 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And the other thing we can do, we can say, well, for all the multiples of 2, we want to print something. We can say we want to print, let's say, fizz, like that. Say else if, right? There's that thing too we can do. We can also do an else if, right? Else if statement. If item ampersand 3 is equal to 0, right? We want to say print ln buzz, like that. So any multiples of 3, we want to print buzz. Multiples of 2, we want to print fizz. All right, let's run. So we should say fizz, buzz, fizz, buzz, fizz, buzz, fizz, buzz. So fizz, fizz, buzz, fizz, 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 buzz, fizz, 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 buzz. Let's go ahead and print here the actual item number here. Let's go ahead and say item, like that. Okay, and run. All right, so fizz 0, fizz 2, buzz 3, okay, fizz 10, fizz, and so forth. Very cool indeed. Using a for loop. In fact, we can go ahead and say to 100 here, right? So we have a bigger range. You can run this. It's going to be a bigger range, obviously, like I said. And look at that. Now we have a lot of fizzes and buzzes and all so forth. This is a very simplified version of things you can do, because now you have all this power. You know about for loops, you know about if statements, now you know about it's else if, you know about remainders. So you can do a lot of intricate things with your code, right? Without having to go and run or write yourself every println or all this logic, but you were able to put inside of a for loop and things are working perfectly. Okay, So can you think of something you can do with this knowledge that you have now with this for loop and also the knowledge of if statements and else if now and so many other things that you've learned? Can you think of something really cool, really fun that you can build? Oh, I bet you do. So go ahead and play with that, okay? Find something, maybe another console app like what we've been building here, where you prompt the user to enter a number, and then maybe create a program just like what we've been doing here, a console program that will allow users to enter a number, and you can figure out if that number is a multiple of 2 or 4 or 5 or 3 and so forth, right? Just play around with this concept. It's pretty fun. It really, really is. And that will solidify what we've been talking about here for the past videos when it comes to Kotlin. Okay, so do those little exercises or think of something that that will keep you engaged as you learn this. That's very, very important. All right? All right, good luck. I'll see you next. Hey, welcome back. So I hope you were able to think of something to build with a for loop and maybe the remainder that we learned, and if statement and if else and so forth. If you did create something really cool here, just go ahead and show us in the forums. We would love to see it. Okay? All right. So next we are going to proceed and talk about while loop. The while loop allows us to say, while this condition is true, then you run this code until this condition is not true, and then it won't run anymore. So what I'm going to do here, I'm going to create a new file. I'm going to call this while loop. Get rid of this, fun, main, args, array, and I'm going to pass here array of strings, of course. Okay, it's our main entry point. This is for while loop. Okay, so for a while loop to work, we have to have a counter. Otherwise, we run into a lot of issues. So we're going to say var counter is equal to, give it 0. Okay, and then we can say while, there it is, while, and just like for loops and other things we've seen, it's the same thing. We need to have an expression here. So we're going to say while counter is less or equal to 5, for instance. Well, we want something to be done, okay? And we are going to say counter plus plus, which means we are incrementing our counter. This is the same as saying counter is equal to counter plus 1. Okay, so we are incrementing our counter at the end here. So what we're going to do here, we're going to say print ln. I'm going to say counting. Okay, and I'm going to pass our counter like that. Okay, so first of all, we say while, and in our expression, we say counter is less or equal than 5. Well, this is true. This will keep going until this is no longer true. And we are incrementing each time we go through. Okay, let's save this and run. And there we go. Let me make this a little bit bigger here. So we can say counting 0, 1, 2, 3, 4, 5. The moment we got 5, we got out of our counter. So I'm going to put here, I'm going to say print ln out of while loop. All right. So let's save this and give it a quick run. You can see it went, the moment it's done, say out of while loop. Okay. Very cool. Now, if we just remove the equal there, just say it's less than 5, let's see what's going to happen. Let's go ahead and run. And you notice when 0, 1, 2, 3, 4. Where is the 5? Well, the reason why, because we say counter is less than 5. So by the time counter is 5, then it's going to be 5. It's less than 5. That's not true. That's why it just goes and prints this out of while loop. So it stops at 4 because obviously 5 is not less than 5. Okay, so depending on if you want to include the last number, we will put equal. Like that. If you remove the equal, so less than or equal, then we would not have that last number, if that makes any sense. Okay? Very cool. Now you can see there's a lot of things we can do with a while loop, okay? Because you can say, while this is true, we can keep going. So that's the basis of a while loop. Okay? Now make sure you have this counter plus plus, otherwise this while loop will never stop and you may crash your computer, okay? So it's important to have this counter plus plus so to iterate through so that we don't run into memory issues or infinite loops as they call them. Okay, All right, perfect. So go ahead and play with this while loop concept, and I'll see you in the next video. Hello, everyone. All right, so in this video, we'll continue and we'll talk about a do-while loop, which essentially is like a while, but a do-while is a little bit, it's a little bit different in syntax and also in the way it operates. So I'm going to go ahead and create a new file here, Kotlin. I'm going to call this do-while loop. Of course, get rid of all of that. I'm going to copy this and paste it in here. We don't need this. And this is going to be do-while loop. Okay, so do-while loop, like I said, is essentially the same, but instead of having a while keyword first, it's actually added at the end. So we're going to say do, say enter, and then at the end we're going to say while. And then we're going to go ahead and copy this, paste it here. Let's delete all of the rest. Okay. Now the beauty of do while is that it at least runs once. Okay. So if you have a certain piece of code that you wanted to make sure that at least runs one time, you use a do while, because as you can see, it doesn't check any condition until the end of this expression here, right? So whatever we write here, we say, hey, and right click. Let's go ahead and run do while. It will at least run. There we go. Now, because I don't have, this is the problem, because I don't have a counter, this is continuing to run infinitely. That's a problem. Okay, so I'm going to stop this execution. I'm going to terminate it. Okay, let me go ahead and add here our counter plus plus. This will ensure that we don't have this infinite loop. Okay, so 2, 4, 5. Hey, 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 hey. Okay, now even if we change here, let's go ahead and put, for instance, 7, right? You can see here we say while counter is less than 5. This shouldn't run if we were just using the old while loop, but you will see that it will run at least once. Hey, there we go. So runs once and then goes here and checks. It says, well, counter is less than 5. Not true. This counter is at some point at 7. Okay, starts at 7 and exits out. All right. So if you have, like, again, if you have a certain amount of code or a certain piece of code that you want it to run at least once, you use do while. If you want more control of what runs, okay, if you want to have that expression before it runs, you use a while loop. Okay, so there's different ways or different situation which we would use. We would choose one over the other. And of course, inside here we can even have other expressions. We can say if. Again, let's change this to at least 1. We can say if counter remainder 3 is equal to 0. Again, if we are finding that all multiples of 3, we can go ahead and say print fizz, something like that. Again, you should remember this syntax, this way of writing an if statement. If we just have one line inside, we don't have to put inside of a curly braces. We can just go and put it. We can just put a print line right in front of our condition here. Okay, so if we go ahead and run this, we should say fizz at least once because we are running from 1 to 5. Okay, if we go ahead and perhaps put here 15 and run again, we should have a few fizzes there. Okay, and we can, if we want, we can say else print len, say buzz. Let's see if we're gonna get a few. Okay, so buzz buzz fizz, buzz buzz fizz. Print line, that way we have it in a new line. There we go. Okay, so that's just one of the other things you can do. Now you've learned how to use a do while loop. Okay, just remember a do while. You want to use do while if you want to make sure that at least this runs once, because as you can see here, we don't have any expression per se, and the expression is actually at the bottom. So it has to run first and then goes and check. All right, perfect. I'll see you in the next video. Alright, so in this video we are going to make a real fun console app here. Okay, so this app is going to be an app that will prompt the user asking how many siblings do I have? And we're going to put some conditions where they won't exit the app until they either say type in a certain number or they get the answer right. Okay, alright, so let's go ahead and create a new project here. I'm going to copy this, I'm going to create a new file. I'm going to call this app how many siblings. Okay. All right, so I'm going to get rid of all of this. The first thing we need to think about here is the logic. So what is it that we're trying to accomplish? Well, like I said earlier, what we're trying to accomplish here is that first the user is prompt with a question. The user has to enter an answer, and the program will do the following. If the answer is incorrect, then the user is prompt with the answer again. Else the application terminates. Okay, and of course we can add another feature. So this is really helpful even when we're building simpler programs, simpler applications such as the one we're going to be building. It's nice to have an idea what is it that we're going to be building. Okay, now once you start building bigger applications, then of course you do this in a more organized way, and you do mock-ups and you write things down and you create a little diagram just to have an idea of what you're trying to build. Okay, so what we're doing here, if we look at this specs documentation here, things that we're supposed to do, it says the user is prompted with a question. That means then we need to have a println that will prompt the user. Now, if the user is being prompted, that means we need an answer. We need to fetch that answer, right? So that means we need to get a read line to get that answer. Okay, and it says if the answer is correct, then the user is prompted with the answer again. Okay, that means there is some sort of logic that keeps going. The application logic will keep running until certain conditions are met. Now, that there should ring a bell, should tell us that we need some sort of a while loop. Okay, so let's do the following here. So what we're going to do, I'm going to put here a while loop. A while loop. Now, I think back, I said, well, do I need a while loop or a do while loop? Because here, I think I want this app to run at least once, right? So I think the best thing to do here would do a do while loop, something like this, okay? Now, one condition is here, what we need to do, we need to add at the top here a var called is true, which is a Boolean type, okay? And we're gonna give it a false to start with, equal false. Okay, assignment here. The idea here is that this do while will keep running until this is true, Boolean here, is no longer false, meaning they have actually answered correctly. Okay? All right, so inside here, what I'm going to do, I'm going to say the following. So what we can do here, we can say is true. That means this will always run until is true, until the answer that we want actually is true. Otherwise, we'll keep prompting the user. So inside here, what we're going to do, we're going to say print line. Okay, we're going to say how many siblings do I have? Or does Paulo have? Okay, and since we are asking a question, now let's go ahead and create a var here called, in fact, we're going to create this var outside here. Say var answer. Okay, it's going to be an integer, and we're going to say is equal to readLine dot to int, because we want to transform whatever we are reading to integer. It looks like he doesn't like it. For safety, we need to put those 2 exclamation marks like that to make sure we are safe to actually get whatever we're getting from the user. So, all right, so there we go. And now inside here, we are going to check the answer that we're getting. Okay, so what we can do, we can say when, because we know now how to use a when expression here. We can say when answer, and inside here we're going to give a few conditions. Now I have 12 siblings, so 13 including myself. So what I'm going to do here, the correct answer, I guess, would be 12. Yes, I do. I realize that I have a lot of siblings. My parents were busy. What can I say? All right, so 12, and then we put that dash greater than, which signifies that we can put a statement here that we want to print or do whatever we need to do. So here I'm going to create actually some sort of a block. So I'm going to create a block that we can add things to it. Okay, so this block here, the first thing we need to do is make sure that is true variable that we created at the top here, which is also being used in this while at the bottom here. We're going to make it what? Be equal to true. And we're going to print ln. Go ahead and put a semicolon there just to signify we have a new one here. In fact, let me go like this. All right, so if it's 12, this is correct, and then I'm going to say you are correct. Okay, and I'm going to go ahead and say else. I'm just going to say print ln incorrect, and I'm going to say try again. Now, because I want to make sure that there is a separation or a new line, I'm going to say \n. So this means go ahead and give me a new line. So skip one line and give me the next line. Okay, so \n, that means new line. When we run this program here, we're going to go through our do while here. And the while will say print ln, how many siblings does Paulo have? And it's going to check the answer, which we know now is whatever we're getting from our user here. Okay, let me clear this. And if it's 12, if they end up saying 12, then we want to make sure that is true boolean, which is controlling, as you can see here, controlling our while, our do while here. It's going to be true. That's the first thing we're going to do. We're going to say print you are correct, something like that, just for aesthetics here. So we're going to print you are correct, and then we're going to set is true to true, and then we'll read this end of the while here and check if it's true, and indeed will be true, and then we are done. Perfect. Let's go ahead and save this and right click here and run. Let's see here. Let's move a few things around this far here. Let's get this answer actually inside here. False. Okay, so here, okay, so we need to change here when answer is, all right, so we put the answer inside of do while because that's where we actually need to retrieve it. Okay, so we'll move a few things around. All right, so this should be okay. Let's save this and right click and run. Oh, there we go. So now we have our answer, or question, I should say. Let's give 10 incorrect. Try again, and you see it goes ahead and asks again, how many siblings does Paulo have? How about 8? Incorrect. Try again. 9. Incorrect. Try again. Oh, 13. That's incorrect. Let's start 12. There we go. You are correct, and it exits. The moment you answer 12, which is indeed the correct number that we set it to be here, we set it to true, this is true, and we exit it, okay? Because this only runs while is true is false. The moment this is not true anymore, in this case we set it to true here, when this is correct, the app exits out. Perfect. So that's a really neat app here that you can actually create yourself, okay? You can adapt this to something else you want. So I would like you to go ahead and try out something similar to this. Just give your own spin and go ahead and share your creations with us. I would like to take a look at the things that you come up with. Okay? Perfect. I'll see you next. All right, welcome back. Welcome, and welcome. So in this video, we are going to talk about functions. So all along, we've been using this main function here, and we never really talked about it. And that was all intentional. So because I wanted to get out of the way the basics of Kotlin. And we are progressing going forward, which means we are learning more advanced topics of the language. Now we're ready to learn about functions. So what a function is an enclosed entity that allows us to write code in this enclosed entity, and then whenever we want to invoke the code, the logic inside of the entity, we just call the function name. So here is an example of a function. So this is our main function, okay? That's our entry point. We create a function by saying fun, right? Not to be confused with fun, but it's fun, that stands for function, and we give it a name. And then we have this parenthesis here, okay? So inside we pass in some parameters. So parameters, we think of parameters as variables or data that we are passing in to be used inside if we wish to do so. Okay, and of course we have those braces here, which signifies this is the body of the function. This is where we add the code that needs to be invoked. All right, so when we say print ln, we're actually calling another function here called println, which we then pass something, in this case a string. And so when we save and run this, that's when we see the hello at the bottom here in our console. As you can see, it says hello. Okay, so that's essentially what's happening here. As you can see, we don't have to know what this function does. We just have to know the name, we call it, and we pass in something, and then it displays something. So this function here, if you right click and say go, say declaration, it will tell you exactly what it does. Look at this. This is the code, the library code that comes with Kotlin, so it shows you exactly how it's implemented. So it's a public inline function, println, we pass in the message. This just says just pass anything in there, okay, any kind of object, and we say system out, and then we system out the message. Okay, and you see this syntax here. If you've done Java, you realize this is a Java syntax. Again, just goes to prove that all of the Kotlin really sits on top of Java, right? Perfect. So whenever in doubt, just right-click on the method or function. You can tell I come from Java. I call the method, same thing, functions, and you go to goto and declaration. Will take you to the actual class or method, in this case, where this is implemented. And you can read and see how they did it. And of course, that's the same thing we have here. Okay, so in this case here, what we are doing, we are saying we are creating a variable args of type array. But this array here, we haven't talked about arrays, and we will soon. This array here is of type string. So this array holds strings. Okay, that's what's happening here. All right, so how do we create our own functions? Well, simply, let's go here at the bottom here. We say fun, just like we did here at the top. And let's say add. We want a function that adds to number. Add, and we want to pass in something. We want to pass, of course, an integer. So we're going to say num1. It's going to be of type int. And what else we want to pass? We want to pass num2. It's also a type int. And then we have our enclosed braces. Sum is equal to num1 plus num2. Now that we have it, we can actually call, because this is the function name, the add. So if we call this and we pass two numbers, because that's our contract here. We said we have two parameters. We have to pass them in order for this to work. So where do we call it? Well, we call it inside of our main, because remember, our main is the main function that first runs when this program executes. So we're going to say add, and you can say there it is. And this is probably the best time I can show you how this works. So you can see the moment we say add, it shows here that we have to pass in a num1, just like what I said, which is a type int, and num2 also type int. Okay, so we say enter. So we say pass 2 and pass 3. Okay, let's see what's going to happen. Let's run this, save this, and right click and run. Nothing is running. What seems to be the problem? Well, the problem here is that inside of our add, we just said var sum, and you can see here, it says here variable sum is never used. That just means we just created it, but we never really did anything with it. No wonder we're not getting anything, right? Because, well, the result is there, but we didn't do anything with it. We print line and just pass sum like that. Now we have used our sum, which means we should see something. Let's run. And it says here 5. And we know better. We can just go ahead and say the following. Sum is, and like that. and run again, we should see sum is 5. That is perfect. So we created a function called add. We said it has to have 2 integers that we pass, and then we take those parameters, okay, parameter 1, parameter 2, and we said, and inside we say sum. We created a variable called sum, and then we added those 2 numbers we passed, and then of course just printed the sum. Okay, very simple. Now look at this. If I were to put this at the bottom here, look how simple this is, right? So we just call add and 2 plus 3, and then we just get the sum is 5. So we were able to take a block of code, block of logic, and abstract it, or meaning create an entity, a function in this case, that does all of that logic, all of that backbone logic that we don't really have to think much about it when we actually use the method or the function. And we just call it, pass it, and we are done. Good. So obviously we can create another method here. Let's copy this. We can say subtract 2 numbers, okay? Say result. It's called res for result. Just semantics here, nothing really different. Okay, now we have subtract. If we copy this, we call it here, and we put 3, 1, and go ahead and run. We're of course going to see 5, but also we're going to see result is 4 because 3, whoops, there we go. Subtract has to be minus there for this to work. All right, let's try again. Run, and there we go. Result is 2. Well, because 3 minus 1 is indeed 2. You see now what's going on here? So we create fun, the name, and we have parentheses here, and inside we are going to we add actual parameters. And obviously we can add as many parameters as we want. Okay, we can go ahead here and say num3, for instance, of type int again. In this case here, what we can do, we can go ahead and say minus, if we wanted, say minus num3, okay, and results. So in this case here, now we have an error because it says, well, no value passed for parameter number 3, which means we have to add something, another parameter here, because we've added 1 more parameter here, right? So now we're going to say 1, for instance. Okay, if we save this and run, we should see a different result, probably 1. There we go. Yes, because 3 minus 1 is 2. 2 minus 1 is indeed 1. That's what we did here. Perfect. Perfect. Perfect, perfect, perfect. All right, so play around with this concept here, and I'll see you in the next video where we continue with this topic here of functions. All right, so let's continue with our function topic here. So we created this function here that we pass in parameters, and then we print a sum, and in this one we print the result, which is the subtraction of numbers. Okay, and then call them, and all is great and fun. Okay, now you notice here one thing here. So these kind of functions here, they don't return anything. Now these functions here are called void. Void means that they don't return a value per se. So in this case, all we're doing here is just print the sum. Okay, if we were not able to print it, then we wouldn't be able to see the results per se. Okay, now if we add some sort of return type, I went ahead and created a new function file here called functions return type. I'm going to go to it, and here I'm going to go ahead and create, actually at the bottom here, I'm going to say fun. I'm going to say multiply, and I'm going to of course pass an integer here. Say num1 type int, num2 as well, also type int, like that. So this multiply here, what it needs to do, well, it's going to multiply these 2 numbers, these 2 parameters that we are passing here. So we're going to go ahead and say var result is equal to num1 times num2, just like that. Now, in order for us to be able to return this result here, we use the return keyword, and we say result. Now we have a problem here. The reason why, if we hover over, it says type mismatch, required unit found int. What is this? Okay, so what happens in Kotlin is the following. all of the void or all of the functions that don't return anything, such as the ones we created here, they don't return anything, right? They return a unit result, which means they just return nothing. Okay, this unit is a type in Kotlin that essentially says it's just a void. Now, in order for us to return something, we need to make sure that the actual function is of a certain type that we want to return. In this case, we want to return an integer, which means this has to be a... And how do we make this multiply function an integer type? Well, simply we put colon like that, and we say int. And you notice the moment we say that, we are then safe. Okay, because we're saying the contract here is that, well, this multiply method function, I'm going back to Java, multiply function is indeed a type integer, which means its return type we can expect is always going to be an integer. Okay, so in order to use a return in a method, in a function, we have to make sure that we have a type attached to that function. Okay, so in this case here, if we go ahead and say multiply, in fact, if we can say print ln, and then inside here we can call our function, right? We can say then multiply, and of course we need to pass, let's say 2 and 3. Okay, if we save this and right click and run, we should indeed see 6. Okay, now look at the difference here. Let's go back to our functions here. The difference here is that this has a unit type, so this is actually something like this in code, right? It's a unit type, which means it's just void, doesn't return any value per se. But since it's void or doesn't return any value, instead of, we don't have to actually say is of unit type. We can just implicitly assume that this indeed is a unit type or void because it doesn't return anything. Okay, so therefore we don't have to put a return key because all we're doing is just print out whatever we the summation of these two numbers. But in this case here we have a return type of int. That's why we can now use a return type. Now here is the beauty. We can do, because we know we are returning an actual integer, right? We can do all sort of things, because now what we can do, we can go ahead and say, for instance, var. You can put the result in a var. We can say multiply or result is equal to multiply, and we pass again 2 and 3. Okay, oops. Now our result has 6, right? Because we know this returns an integer, and now result is an integer, which means if we go here and say fun again, the different functions, in which we say divide, okay, let's say int one this num1, and we're just going to pass one integer here for now, okay, just like that. Let's return this. Let's make this int, right? If we return this integer, so num1, check this out, the beauty here. So all we're doing here, we just call this function divide. We could have called anything, but I'm just calling it divide. And we pass in an integer, so it just goes and takes that integer, nothing special here. We can now, because we know our multiply is returning a result, we can use this divide function here, and we pass a number and we'll return that same number to do whatever we want here. Check this out. We can now say the following. We can say var final result is equal to result divide by divide. And in divide, we pass in, if we wanted to, let's say 2, something like that. And we say print line result, and we pass final result, just like that. Let's save this and run. Let's see what is the result going to be. Result is 3. Let's trace and see what's going on here. So what we did, divide, we pass in one parameter, and then we return that parameter clean, right? We didn't do anything. For our multiply here, of course, we take those two numbers and multiply and send out the integer result. So what we did here in the result, okay, we called our multiply, we passed 2 and 3, so this will return 6. So our result will have 6, and then we created another variable, final result. We then called the 6, this result here, and divided it by 2. So we call this other method here, other function, I should say, and we pass 2. So this returns just 2. So now we have 6 divided by 2, and we say final result. Okay. Now this was a stretch. Obviously, we wouldn't really have to just have a method like this to return a number. We could if we wanted. I just wanted to show you the flexibility that we now have when we have a return type with attached to functions, because now we can just use them as variables, really, right? We created a variable and got that result and put in that variable, and then we created another variable and we got the result we got earlier and divided it and we passed in. So now we have this whole new world of flexibility of things that we can do in our code, and very simplified, because this makes sense. If I said multiply, well, I'm passing 2 and 3, those two numbers be multiplied. That's one of the powers that we have here of functions, especially when you start returning things with those functions. Okay, and of course we are returning numbers here. We could have returned strings as well if we wanted to, right? We could have created another function here, for instance, that says fun get name. For instance, we can say we'll pass name as a string. In this case, if we wanted, we can just say return a type string. Okay, so this method here is of type string, and we say return what? Name, just like that. So now at the top here, we can say println. Check this out. I can even concatenate or put everything inside of a string. I can say my name is, and like that, and I'm gonna say get name. Look at that, and I can even pass then a string of name, Paulo, just like that. Okay, now because we are passing here an actual method, we have the braces, curly braces attached to our $sign. Look at that. So now we save this and run. I should see my name is Paulo. Isn't that great? Look at that. And of course, like we did before, I could have put this get name Paulo here. Oops. Inside of a variable, just like what we did here, and it would have worked as well. All right. I hope you're starting to see the amazing things we can now do. So what I need you to do right now is to create other types of functions here, right? So we have string. I showed you strings. Int. I want you to go and create a boolean, one that returns a boolean, a float, a double, and so forth. So just go ahead and play around with this concept here, and I'll see you in the next video. And as usual, if you have any questions, don't hesitate to ask. I'll see you next. All right, so functions don't always have to have parameters. Okay, we can have functions that are just empty. They don't need always to have parameters, nor do they have to return anything. All right, so let's go back here. I'm going to create a new file. I'm going to call this functions, no parameters. All right, I'm going to get rid of this. Okay, all right, so I'm going to say fun main because we need this. Args, it's going to be array strings like that. All right, so let's go ahead and create a function without a parameter and doesn't return anything. So we're going to say fun hello there, and we are going to say println hello there. Look at this, the simplest form of a function. And of course, we can say here, hello there. Right click and say run. And we should see hello there. Very simple. We don't have parameters, empty parameter, and we don't have a type, right? We're not returning anything. Now, these kind of functions, in many other languages, we call them void. Void, that means it doesn't return anything. Explicitly, of course, as you can see here, it doesn't have necessarily a type. In the background, what this does, what Kotlin does, it actually adds a type called unit, okay? The unit type here, let's go take a look. So right click and go to declaration and see what this unit is. Look at this. It's just very simple public object unit. Okay. So this one, it says the type with only one value, the unit object. This type corresponds to the void type in Java. So this is just a simple empty void type. So you can either add the unit, or if you don't need to, just like that. So it's in this case here, it's inferred, which means is implicitly, the system, the Kotlin system, knows exactly that you are talking about here a unit type function, which returns nothing. And there are times when we just want a function that prints something and doesn't return anything. Okay, so not all functions have to be of a type and have to return something. And case in point here, we have this hello there, which just says hello there. All right, perfect. So I'll see you in the next video. In this video, we're going to talk about variable scope. Okay, what that really means. What is this thing called variable scope? Well, let's try something real simple here. Create a new file. I'm going to call variable scope. Okay, I'm going to get rid of this, that, and that. Okay, fun. Main. I'm going to call this, say, args, array, and string like that. There we go. Now let's try something interesting. Let's create a function here at the bottom, show name, and we're going to pass a string called name. Okay, and of course we're just going to say print ln name, and we pass that name. Very simple. All right, so let's go ahead here and say the following. We're going to say show name. I'm going to pass hello James, like that. This is very, oops, I wanted to run this. And we should see here James. All is good, nothing new. Now let's go ahead and create a variable here. So is equal to my name, and we're going to give it, sorry, var name is equal to Elliot. Now, what if we wanted to be able to access this my name here inside of this show name function? Okay, because if we go inside of our show name and try to say my name, nothing happens. I mean, we can't really access it, right? How do we do that? Now, here is a problem that is caused by scope. Okay, so variables inside of a functions, they are only visible inside of that function. Outside of that function, they are not visible, which means they don't exist. There's no way we can actually access it. Okay? In order for that to happen, in order for us to be able to access this my name variable, we'll have to get it outside of all of our functions, right? So if you put like that, now our my name can be accessed here. So if you say my name, there it is, right? There's my name. Even here also we can say my name. Okay, so we are now able to access this my name because it's now outside scope of one of these methods, or one of these functions here, because now we've declared it outside of all of our functions. Therefore, we're able to access. So this will be some sort of a global variable. And if we were to do it inside here, I'm going to put all like this, var my name. This is local variable, which is only visible inside of this function. Okay, so now we can actually and copy this and paste it in here, save and run. Look what's going to happen. We should see Elliot, right? Even though we said show name is going to be James, it overrides everything because, as you can see now, we're not actually passing a parameter. We are passing, but we're not passing anything. We're just going straight and getting our my name Elliot. Okay, and you will see more the why this can be very useful and important as we start learning more about classes and object-oriented programming with Kotlin. But I just wanted to give you a little taste of how variables lose and gain scope, right? We have local variables and we have global variables. If you want to create a global variable, you have to assign it or create it outside of the function. Okay, and then all of the functions will be able to access it. Now here, you notice we were able to declare it, right? So we said var name is equal to Elliot. If we could have very well just said my name is of type string and just string like that. Of course, we'll have to get rid of that. Okay, and we're going to say it's null for now. All right, so now we can set it anywhere we want. So for instance, here we could have said my name is James. Okay, so that means inside here setting it to be James, or let's give it a different name, Bonnie. Okay, let's save this and run. We should see Bonnie. Okay, so there's different ways we could have done this to make it global. So this first way here, we assigned it. The second way, we just created a variable and then we could assign anywhere else. This may be a little bit confusing, but just think of the scope thing here as whether the variable is accessible inside of one function or whether it's accessible in all other functions. So if you want it to be accessible across all the functions, you just create it outside of all the functions. If you want it to be accessible inside of a function, obviously you make it a local variable. All right, makes sense? All right, I'll see you in the next video. All right, so in this video, we are going to start talking about classes and objects. When we start talking about classes and objects, now we're talking about what we call object-oriented programming, so OOP. Okay, OOP, or object-oriented program, allows us to compartmentalize our code, allows us to create smaller pieces of code called object or classes that interact with other classes, making our applications more flexible, easy to maintain, and scalable. Okay, but let's digress here. Let's talk about the foundation here of object-oriented programming, which is classes. So what is a class? Well, a class is the blueprint of what we call an object. So think of a class as a blueprint of an object. So in order to create objects, we need to have classes. So a class allows us to create some sort of a blueprint. Think of an architect when he wants to build a house or a building. He needs to have a blueprint of what the building is going to be or is going to look like. Okay? So the idea with a blueprint is that you can have a blueprint of a home and then you take that blueprint and give it to a constructor who will then build a house. Okay? So in our case here, a blueprint for an architect is what we call a class. Okay? It's something that we can then take it and create different kinds of homes or objects, but all coming from that one blueprint. So for instance, if we think of a cup, a real world cup, right? A cup that you put coffee and drink or water. Well, a cup has what they call a state, right? So a cup could have properties such as color, thickness, capacity. Those are properties of our cup. Okay? Every cup that you will ever have has to have some of those properties. But also a cup has some sort of behavior. So a cup could break, a cup has a price if you're trying to buy it, a cup has other behaviors that we can attach to it. Okay? So as you can see here, as we talk about a cup, the idea of what a cup is, we divide it into behaviors, into properties and behaviors. Now the beauty of classes or blueprints is that, like I said, you can only have one blueprint to make many other actual objects, right? Meaning in the example that I gave you of an architect, the architect creates one blueprint of a house or a building, and then he could give that blueprint to a constructor, and the constructor can use the same blueprint to create many different houses, but all of them are from that one blueprint. Okay? So in this case, a class will be that blueprint that the architect had created. An object would be an instance of that blueprint. In this case, would be a house. Okay, would be a house 1, house 2, house 3. Doesn't matter. However many houses that are being built using that first blueprint. Okay. So, like we said, a class has to have properties and methods, functions, or behaviors per se. So let's give an example here of a house. A house, being a class, would have properties and functions. Okay. So in this case, the properties of a house would be a price, right? Type of the house. Is it 2-bedroom, 3-bedroom, 2-bath, and so forth. Year built, right? And owner. And of course, we can give many other properties like the color, whether or not it has a big yard, and so forth. Okay, but then we have methods or functions or actions per se that we can implement on those classes, which is number of bathrooms. Right now, we can get how many bathrooms how many bathrooms that house has. We can say get year that the house was built. Okay, so we're implementing actions to that class. Okay, and we can also get the house price. That's the main fundamental idea when we talk about classes and objects. So you need classes in order to create objects, right? And we'll see this in code in a second here. All right, I'll see you in a bit. Now we're ready to implement this class object idea here that we previously talked about. Let's go ahead and create a new file here. I'm going to call this classes. An entry point here. It's going to be main. Like that. Perfect. So we have our main, nothing new here. Give it space. All right, so to create a class, we simply say the following. Usually we create class in different folders, but in this case, we're going to put everything in one file only. All right, so to create a class, we go ahead and say class, the keyword class, and we give it a name. So the name of the class I'm going to call is house. And then we are going to pass what we call a constructor. A constructor is a method or a function that allows us to construct, to initialize the class, okay? In here, we are going to pass a few properties or a few parameters. You notice the syntax is pretty much the same as with when we create functions. But in this case here, we're going to pass in a few properties here, which are, the first one is going to be type. It's going to be a string. And then get price. I'm going to make it double. Say year built. I'm going to make this an integer. Owner, like that. And I'm going to make this a string. Okay, and then we have our braces. So this is how we construct our class. So we say class, house, that's the name of the class, and we pass in some properties. So in this case, we have a type string, price, double, year, and owner string. Perfect. Now that we have our class, it's an empty class, which is okay. In order for us to actually create an object from this class, so an actual object that we can use, we do the following. Instead of our main here, we say var. I'm going to say my house is equal to house. The moment you say house, notice that we need to then pass in a few parameters here so that we can initialize our house. Okay, so the first thing is going to be the type string. We're going to say 3-bedroom house, and the next is going to be the price. It's a double, so we can say, for instance, $23,000. Put that 0 like that, and then we need to pass the year built. Let's say 1978, and the owner, I'm going to say Paulo, just like that. Okay. So now if we'll go ahead and say println, and we say my house, and just go ahead and print out my house object. If you save this and run, and we have this very strange thing here that we have really no idea. It says house at and blah blah blah. What this is saying is that we have our object in memory. So this is just an address in memory where our house object lives. In order for us to access the properties like type, price, and year built in our class, we need to create an initializer. Okay, so what we need to do here, we need to do the following. I'm going to say init. So there is the piece of code we can use. Init, say enter. Here inside, that's where we can say, for instance, println. We can say type, and we pass our type. Okay, so now we have initialize here. So what this does, we're just going to go ahead and print the actual type. Okay, whatever we're passing here, is that we need to find a way in which we can actually intercept or access these values, these properties that we are passing in our constructor here, right? Such as the type, price, year built, and owner. Because as you can see right now, if we can go ahead and say my house and print it out, we just get the address where this house object is created and is stored. So there's no way really we can access these types here. Okay. So that's when we need two things. The first thing, we need to actually have properties, right? So if we go here on top before the init, we can go ahead and say the following. We can say var, we can say type, it's going to be type string, and we can say accepts null, and I'm going to just instantiate it with null at first. And we can say var again, price, it's going to be what? Double. We're gonna go give it null. Say var year built. It's an int. going to give it a null to begin with. Var owner is a string is equal to null, like that. Okay. Now that we have our properties, okay, set already here, what do we need to do inside of our init? That's where we're going to initialize these properties to certain values. Those values are going to be the ones we're going to be passing in when we construct our objects like we did here. Because now when we say my house is equal house and we pass in all of these parameters, so we are constructing our object. So for us to be able to initialize our object, we need then to be able to pass this, to transfer all of these parameters here, properties, into our fields or properties here, right? So what we need to do now is the following. We can get rid of this for now. We're going to go ahead and use this is owner, by the way. So we're going to go ahead and say this dot. Now we're accessing these properties inside here. Okay. So we're going to say this properties dot type. Okay. Now this keyword here is the same thing as house. In fact, when you select this, look at it. Look at that. The house is also selected. Okay. We could very well say house dot type, but since we are inside of this class, we're just going to say this, which means this context here, this class. Okay, so we are accessing the type here. In fact, you can see this dot type, then this changes of color. Okay, so we're setting it to what? We're setting to type. So whatever we're getting, in this case, it's going to be 3 bedrooms, we are setting it to our property here. Okay, and then we go say this dot price. We set it to our price, and we keep going. Say this dot year built to year built. This dot owner to owner. This dot like that. So now we have our initializer initializing. So this one initializes all of our properties. So now here, what we can do the following. We'll be able to access the property. Let's say we want to get the type, right? We can go ahead and say my house dot, and look at that. The moment we say dot, the dot means we want to access properties or functions. In this case, we want to access property, which is the price. What did we say we want to access first? Type. We want to access the type. We can say my house dot type, like that. And if we save and run, look what's going to happen right now. It's going to tell us 3 bedroom house, because that's the type we set it to be when we constructed our object here. Okay. So now this my house is indeed an object. It's no longer a class, because we say my house, that's the variable, is going to be equal. We're assigning the house, right, which is our class house here. And we pass in 3 bedrooms, 23,000, 1978, and Paulo. Now, since we did that, and if you go back to our class, we were able to initialize all of those types here. This that type, and we pass in whatever we are getting from our constructor. Okay, the beauty is that since as we created this house here, again, that's just a class, a blueprint, we can create as many objects off of this class, off of this blueprint as we want. All right, so we can go ahead and say, for instance, var second house is equal to house again, and I'm going to go ahead and pass in here. I'm going to say 6 bedrooms. Okay, 123,000, 2016 money, like that. Okay, so I have the second house here, which I can go ahead and print, say second house dot owner, and should have, let's run this, we should see Bonnie. And if we want to access another one here, we can say dot price, right, and run. We should see $123,000. Of course, we can concatenate here. We can go and say price, like that, and save. If you run, we should see at least price concatenated and $123,000. All right. So that's the idea here. So we are becoming a little bit more flexible in so many ways, because now we were able to create just one class and have an initializer here where we initialize all the properties, and then we are able to create as many objects off of that one class as we want. Okay? And since we're able to access, in this case, our properties, these properties here, type, price, year, build, owner, check this out. We can also do the following. Since we have our my house object here, we can change on the fly. Now I can say my house dot owner is equal to Arthur, like that. Since this my house is this one here, check this out. Look what's going to happen. Because the first one owner was Paolo, now we change to Arthur. If we save this, give it a run, sure enough, now owner is Arthur. And you can see you can do the same thing to other objects you create off of the class. Very, very nice indeed. Again, we have our types, our properties, and our initializer. When we create our class, in this case here, we added a constructor, which we pass all of the properties we want this class to have when it's constructed. Right? So as we construct, we need to pass something to construct it. And inside of the class, we have initializer here, which essentially initializes all of our properties. All right? Perfect. Okay, so go ahead and play around with this concept and add more if you want. Add more properties and initialize them here as well. And go ahead and create as many objects as you would like and print them out and see how things work. All right? Perfect. I'll see you in the next video. So we have our house class here, which is beautiful and wonderful, and we love it. Now, the whole idea of having a class is that we are compartmentalizing our code into sections, smaller building blocks that can connect with other building blocks to create this bigger complex application. That's the whole idea. So we're compartmentalizing our code, making it more extensible. So with that, that means we also have to be aware how the objects are accessing the class's properties. In this case here, I said we were able to say my house.owner, and we set it to something, and then when we say my house.owner, then it will show whatever we set it to, which is fine. That's not a problem at all. But because we want to make sure that the classes are their own entities, right, their own black box where everything happens inside, and the outer world only gets what the class wants to broadcast to the outer world. Okay? So with that in mind, that means we need to be very careful when we start creating, instantiating our classes, our objects, especially what we can and cannot access. So we need getters and setters to be able to set up our classes internally so that when we want to access things outside, we just call these behavior methods or functions that will allow us to access all of the types inside here. Okay, so what I'm trying to say here is the following. If we want to get, for instance, the type of the house, we need to have a getter called getType. So this concept of getters and setters is very prominent in Java. Now, Kotlin is a little bit different when it comes to getters and setters. So they are actually optional in the sense that the whole idea is that you will be able to get and set things using your properties. Okay, but I'm going to show you how to create a getter and setter explicitly. In this case, we're going to say fun as a function. We're going to say get type. Okay, in this case, we're going to create a getter for our type here. So it's a function and its type is string, and then it will return this dot type. Okay, let's click here and see what's in close function, get a string. Oh, there we go. Make sure we have an exclamation mark here to say that it could be a null. Okay. And that's fine. There we go. So now if we save this and we go back to our implementation here, let's get rid of all of this. Well, actually, I'm going to do that. Now we can actually do the following. We can say my house get type, okay, like that. In fact, let me say print ln like that and save, keep it run. We should see the type of my house is going to be, make sure we go like this, run again, and we should see here type 3 bedrooms. All right, so if we need to create our getters and setters, we can actually go ahead and create them, but usually, and create them like that. So I'm going to go create a setter. So we said fun. I'm going to say set type. To set a type, we're going to have to pass here a type of type string, and we're going to say this dot type is equal to type. Okay, so we're passing whatever we're getting to set from set here, and we are setting our tab. And we are passing whatever we're getting from our set method here, function, and we are putting inside of our type. So now, if we go back at the bottom here, implementation, we can start setting things. We can go ahead and say, for instance, myhouse.set type, or I guess set type like that, and we can say 8-bedroom house. Okay, I'm going to run, and it's going to say here the house type now, because we change it here to 8, it's now going to say 8-bedroom house. The thing that it's very important to remember is that with Kotlin, we really don't need to create our getters and setters because it's all done for us. Okay, it all happens in the background here. So this, I just wanted to show you, and you can always do this. That's totally fine. But the idea here is that, as you saw earlier when I was showing you, you can literally go straight and say second house dot and go type, okay, and set it to something. So here we are actually setting type now to something else. Okay, so one of the biggest improvements is that we don't really need to create our own setters. We can if we want, and of course we'll see some cases where we need to do, and there's a little bit of difference in syntaxes, but generally speaking, you just want to set the values whenever you want, as we did before. There's exception, of course, but that's usually the rule of thumb, right? You don't have to create your own setters and getters. Okay, that's the beauty. So in this video, I was able to give you some ideas on how Kotlin creates objects and how you can create objects by our init here, which initializes all of our properties. And if we want to go straight and change our properties, or get and set, we can just go ahead and say get and set the values, or just get the type or price, year build, or owner. And I do realize this can be a little bit strange at first, especially if it's the first time you are learning a programming language, or if you are already a Java programmer. And this may seem a little bit like, well, I'm not quite sure how this is working. Or maybe it's going to be one of those things you realize, I get it. This is much simpler and easier to deal with. All right. Either way, just stick with this and it will all be fine. And I hope you are seeing the value in this. I'll see you next. Alright, welcome back, folks. So in this video, we're going to talk about inheritance in Kotlin. So this concept of inheritance is a very important one in any programming language. Essentially, classes represent objects. So we use classes to create objects. In those objects, we'll have properties and methods and so forth. So classes are these closed entities that have all of the logic, all of the compartments of what an object is ought to be. Kotlin allows inheritance, meaning if we have one class, we can create other classes that inherit from that first class, which means those other children class would take all the properties of the parent's class. An example would be, for instance, we have a class animal here. And animal, of course, has properties of name, number of legs, food, and so forth, and may have also methods that says make noise, okay, animals eat and sleep. So from this parent class here, animal, as we call it, we could have, for instance, a cat class, which we know a cat is also a type of an animal. Cat is an animal, which means a cat could inherit from animal. What that means? Well, that means that all of these properties and methods and functions are then inherited. So the cat will also have all of those. So we can create another class called lion that would inherit from animal, which means lion now would have name, legs, food, and make noise, eat, sleep. And we can keep going. Dog, well, dog is also kind of a type of an animal, so it would also inherit from animal class. So the animal class will be considered the superclass or the parent class, and all of other classes that are inheriting from animal class will be called the children class. Now this is very important because, for one, it allows us to make our code a little bit more flexible and not redundant. Because if you look at this hierarchy here, an animal is more of an abstract idea of what a true animal is, right? So an animal could be a cat, could be a lion, a crocodile, and so forth. And all of those animals, all of these animals, they have a lot of things in common, right? They could have a name, number of legs, and so forth. All those properties. So it would be a waste of space and redundant, right, to not take advantage of those common properties. That's why inheriting from a parent class is considered good practice, because then we are not having to write redundant code. And the code that we write using inheritance will be much more flexible and concise. So let's go ahead and take a look in code. All right, so let's go ahead and put into code this whole concept of inheritance. So what I'm going to do, I'm going to create a new file here. So Kotlin file. I'm going to call this animal. Okay. And what I'm going to do here, let's go ahead and say fun. Create our main entry point here. It's going to be ours of type array, and it's going to be a strings. All right, so we have our main here, nothing new. And now we're going to go ahead and create an animal class here. We're going to say animal. Actually, I'm going to start with class, and we're going to say animal. And notice also all classes start with uppercase. Okay. And right, so we have our animal here. I'm going to create our class. So we have our constructor empty here. Our immediate constructor is empty. So what we're going to do, we can actually create a constructor inside here. So I'm going to say constructor, and we're going to pass a few parameters here. So name, it's going to be a string type. I'm going to give it a color. Also string type, num legs, it's going to be int type. Okay, like that. And because, like we said, we have a primary constructor also here. So the moment you put parentheses here, that means we have a primary constructor. Now, the reason why we're having issues here is because it's saying primary constructor call expected, which means every time we create an actual constructor, we have to say colon, so invoke the primary constructor. You can say this like that. Okay. Now, if we don't have any parameters that we're passing in our primary constructor, we really don't need to have it. So we can just go ahead and say class animal, and then we won't need to have to confirm to primary constructor. Okay, this is also valid. All right, so that means now we have our constructor here, implicit constructor. And here, what we're going to do, we're going to set up our name, color, and legs. Okay, initialize everything. But for that to happen, we need to create a few properties here, or instance variables. I'm going to say var name. It's going to be string type. I'm going to give it a null first. Oops. I'm going to create var color. It's going to be a string type as well, and we can initialize it to null. Var num legs. It's going to be an integer type. I'm going to initialize it to null. Okay, and inside here, inside of our constructor, this is where we initialize all of our properties. So we're going to say this because we want to access the properties from our class here. Okay, so this dot name, I'm going to set to whatever we pass in our constructor, which is going to be name. Again, this dot color is equal to color. This dot num legs is also going to be equal to num legs. All right, so we have now constructed in our secondary constructor here, we are constructing our class. Okay, so we're setting up our properties to accept whatever we are passing in our constructor here. Perfect. Let's go ahead and inside of our main here, instantiate an animal class. We can say var animal is equal to animal, just like that. Of course, we have to go ahead and we're going to go invoke our constructor here. So that means we have to construct our object. We're going to pass in here the name to be dog, for instance, the color to be brown, and number of legs is going to be 4. We would hope that a dog has 4 legs. All right, and just to see our object here, let's go ahead and print, say print line. We're going to go ahead and say this dot name. We're accessing our instance variables here, our properties. Okay, and I'm going to copy this. Color, num legs, like that. Let's go ahead and run this. And there we go. So as you can see here, we have dog brown 4, right? Because the name of our dog is, as we set up here, to be dog, color brown, and number of legs 4. Okay, so we created here object, nothing new, we've done this before. Okay, now let's talk about inheritance here. So like we said, inheritance allows us to inherit from a parent class. So we can take all of the properties of that class and functions as well. So let's go ahead and inherit from our animal. So in Kotlin, in order for us to inherit from that class, we could go ahead and say class. So we're going to create a new class. We're going to call this class lion. And then to say that we inherit or we want to extend to our animal class, we're going to say colon, right? So remember this notation, and we're going to call animal. We're going to say animal here. So this means lion class that we just created is going to extend or inherit animal. Now here's the problem. We have this issue here that says this type is final, so it cannot be inherited from. Well, it turns out when we create classes in Kotlin, all of them are final, meaning they cannot be inherited from. So if we double click here and look at this, click on this red bulb, it says here make animal open. So you click that. The moment you do that, you notice now we have this new keyword preceding the class animal. So it says open class animal, and now we are okay. Now the other issue we have here is that it's saying no value passed for parameter color. The reason why it's asking that is because the moment we say parentheses there, we are trying to invoke a constructor. So in this case here, what we can do, there's a few things we can do, but I'm going to go back here and actually have a primary constructor, which will give us an issue because every other constructor that we created, we also have to make sure that we confirm to the primary, which means we have to say here colon, right, and say this like that. Okay. Now you notice we don't have any problem here. Okay, let's go back and explain what's really happening here. So when we create a class and we put these parentheses here, this is our primary constructor. So any other constructor that we explicitly could create in our class, in this case we said constructor and we pass parameters here, it has to, we have to call the primary constructor here. It's a contract. So anytime we want to create any other constructor, we always have to say colon and call the primary constructor. In this case, this primary constructor is empty, so we can still say this and just put nothing there. If our primary constructor had, for instance, name string like that, we would also have obviously to pass here name like that string. Okay, so we're getting a lot of errors because we didn't do that. So I'm going to remove all of this. All right. Okay, so the same thing when we create a class that inherits from our parent class, we'll have the same here. So we say animal and we invoke our primary constructor. Okay, so this says inherits from animal. And you may also realize right away that this colon here may have different meanings in different circumstances. In this case here, we are also actually saying this constructor inherits from this, which means it takes all of the properties of our primary constructor class. So when we always go and say, for instance, var name or var hello, and we say colon and then we say int, guess what? That's what exactly we're doing. We're saying hello is of type integer. That means hello inherits from integer class or object. Okay? All right, back to what we were talking about. So now that we have our lion class inheriting from animal, what we can do, just to show you something very quick here, I'm going to leave it empty like that. Okay, so what I'm going to do here, I'm going to instantiate or create an object off of this class here, which inherits from lion, from animal. Okay, so I'm going to say var my lion, actually var, I'm going to say var lion is equal to lion like that. Okay, now to prove to you that indeed our lion inherits from animal, which means inherits all of these properties here, look what we can do. We can now, the moment we say lion dot, so we're accessing properties of lion class or object in this case, look what we have. We have num legs, few other functions. Okay, so these are variables or properties. Now you notice also that in our line here we have no properties. So where are these properties coming from? We go dot, num legs, name, color, and so forth. Well, it comes from our animal because we said here we are inheriting from our animal class, which coincidentally has name, color, and num legs as its properties variable. So now I could literally go say lion dot num legs is equal to 4 or 4. say print line num legs like that. And I say lion.legs num legs. If I save this and run, I should see here num legs 4, right? Because we say lion.legs is equal to 4. So we access the num legs property of our lion, which we are inheriting from animals, and we set it to 4. And of course, inside of our lion class here, which inherits from animal, we could create our own variables, okay, our own properties or methods in even constructor, because remember, this is its own class. Lion is indeed its own class. It's just that we're saying we are inheriting from our parent class. All right. In next video, we'll continue with our lion class here. We will add a few more things inside of our lion to show you the power of inheritance. I'll see you next. All right, so in this video, we are going to talk about overloading constructors. We may have touched that concept a little bit, but I'm going to go a little bit deeper in this video. So what that means, I'm going to clear all of this. So what that means is that, as you can see here in our animal class, we have one constructor. In fact, we have two. So we have this primary constructor, which is empty, and we have this secondary constructor, which has a few parameters here. Okay, these parameters we pass, and then inside we set up our properties to take whatever we are passing in our parameters. Okay, and of course we print the name, color, and numbers. Perfect. Let me go ahead and comment all of this out. Okay, put it all at the bottom there. Perfect. So back to our main class here, to our super class or parent class here. Let's go ahead and create another constructor here. Constructor, and I'm going to say this because every constructor has to conform to the parent constructor here, right? We have to call this as in this primary constructor. Okay. Now we have a problem here. The reason being is because overload resolution ambiguity. What this means really is that, well, if you are creating another constructor here, it cannot be or have the same signature as any other constructor that is created. What this means is that anytime we want to create another constructor, it has to be different from the previous constructors, which makes sense. Because if we're creating the same constructor, what is the point? This is very important to remember, and the compiler really wants you to remember that. That's why it gives you this error. Okay, that just tells us that we always have to have different signature, which means we have to have different parameters that we're passing for each constructor that we create. So in this case here, we're going to go and say name, string, and I'm going to pass color, but also type string like that. So now you see the problem is gone. And of course here, I'm going to go ahead and say this dot name is equal to name. This dot color is also equal to color. Okay. And of course, let's go ahead and say print line, second, actually this is third constructor. Let's say this dot name. I think that's enough. That's fine. So then how do we know which constructor is being called? I'm going to minimize this. So I'm going to go ahead and say var animal is equal to animal. The moment we say animal and I open here, you notice we have three options. We have no parameters. We have the constructor here with the one we just created here, which we will need to pass the name and the color. And we have the third one, which we have to pass name, color, and legs. How does the system know which one you chose? Well, it knows which one you chose. If you don't put nothing there, it says, well, you didn't put anything. If we want to go ahead and say, for instance, we pass in a name, okay, we say animal, and we pass in this case, a color, say brown, then obviously we'll know, okay, you want to use this third constructor here. And you can see right away, the moment we use a certain constructor, it goes ahead and gives it a color, and the rest become gray. And the reason why you can give as many constructor as you want is because there are times when you want to instantiate, you want to make sure the object that you're creating, in this case we're creating this animal object, you want to make sure that, for instance, we just want to have the name and the color. And of course, we can still say animal dot number of legs. We can still set it ourselves for. But the basic of this object we want it to use. For instance, in this case, we just want to use the second or the second constructor here, or the third constructor, which has 2 parameters. Okay. If we didn't want to do that, we could have done, of course, the same thing. We could have gone just say var animal is equal to animal, right? Create our object, and we could set everything ourselves. We can say animal dot number of legs. Oh, we already have that. That color, say brown. Animal dot name. We can say lion or something else, something like that. In this case here, what we could do, we could say fun show animal, and here we can say name is this dot name. Let me copy this. Say this dot color, right? This dot number of legs, like that. Now I could say animal dot show animal. We save this and give it a run. And we can say name is lion, name is brown, name is 4. Of course, we could have changed the wording here. Name is, we can say color is, and num legs, like that. Give it a run. We just changed the wording here, nothing big. And we have now name is lion, color is brown, num legs is 4. Okay. So we use a method, we use a function to display what we have set our object to be. In this case here, we set our animal color to be brown, animal.name property to be lion, and number of legs to be 4. And then we just say animal.show name. Okay? And of course, obviously, we could have created another var, another instance of that same object, say var animal2 is equal to animal. In this case, we could have decided that we wanted to use the 3 parameter constructor. We can pass a name here, another animal, okay, color blue, number of legs 6, something like that. And check this out. If we go here and say animal2, right, and then show animal, look what's going to happen. Let me go ahead and comment that out. Let's run this once again. Now we're going to show the animal2, the show animal. Look what's going to happen. So as you can see here, it's calling the constructor, since we're using this constructor now, the second constructor, and we have this prints here. That's why we still see this object here. Okay. So we are printing twice, which is fine. But you can see here that we are indeed say name is another animal, color is blue, num legs is 6. All right. There we go. So again, we could have created as many constructors as we wanted or as we found fit. But each constructor would have to have a different signature or different number of parameters and or different types of parameters. So in all of the constructors would have to be different in order for this to work. All right. Okay, perfect. So I'll see you in the next video. All right, so the next thing we're going to talk about is access modifiers. So as you can see here, all of our variables that we've created so far, they are called public. Right? They're public, which means we can access this variable here from anywhere, any other class. Okay, so in this case here, let's go to our, give it space here. If we go to our cat, which extends animal, we can say super dot, for instance, color, right? The super color, we're saying we are accessing the color of our main class, our parent class here. This is our super. Okay? That's because we're able to do that because it's public. So if we don't have any modifier here preceding the creation of the variable, right? This assumes that it's public. And you can see if you put public, it says redundant visibility modifier because it assumes it's public if you don't put public. All right. So public is default for our variables here or properties. The next one is called private. Private, as the name imply, well, will not be visible outside the class. So if we change this name, for instance, to private, you notice we got a lot of problems right away. Okay, like here, super.name, we are not even able to access it. Why is it so important to hide or to change the access modifier of certain components of our classes? That is important because there are times we need to hide certain variables or certain properties of our classes so that our classes are a little bit more protected from outside world. Because remember, the whole idea of having these classes and creating objects, it's so that we are able to confine all of our logic, all of our functions or methods or actions that are happening inside of our class, our entities, so that the outer world only can access what we want the outer world to access. And by outer world, I mean anything else that it's using the classes that we're creating. For instance, if we wanted to make sure, the absolute sure, that nobody can directly access, for instance, number of legs to our animal, we would say private, like that. Now, number of legs will never be accessed directly from outside of our animal class. The only way for this to be accessed directly from anywhere else is through getters and setters. Okay, so we would have here a method that would say, for instance, function set num legs. Okay, and of course we would pass here num of type int, and we'll say this dot num legs is equal to num legs, or num in this case. So now what we're saying here, we're saying, well, because we set it to private, our num legs, when we set things up or when we want to go outside and set our num legs, we will only be able to set it by using this setter. Okay, which means, so if we go outside here and we want to say, for instance, I'm going to go ahead and comment all of that out. So here I'm going to create a new, say var new animal is equal to new animal. Oh, from Java, it's equal to animal. Our animal, I'm going to pass a few parameters. I'm going to use the second parameter here. So I'm going to put animal for the name and color, say brown. Okay. Now I can say new animal dot. Notice that I don't even see the num legs. I only see set num legs. Okay. I can set the name still. I can set the color, but I cannot set the number of legs directly, right? The only way to do that is through a method or function that I created called set num legs. So if I enter and I just pass 4. Okay. Now if I say new animal and instantiate and show and call the show animal, I should see everything that I want to see, that I'm supposed to see, which is the whole animal property setup. There we go. This third here, it's coming from where? I think I'm gonna go ahead and comment all of these out. That way we don't have an expected. Okay, comment this out here. That was from previous. Let's run again. Again, as you can see, name is animal, color is brown, and num legs is 4. But you notice we actually use the set num legs to set our number of legs because we weren't able to say new animal dot legs or num legs and access the property variables directly. Okay, so those are two main, public and private. And there's also protected. Protected is the same as private, but is also visible in subclasses or kid or children classes, right? So subclasses, which means, so okay, so if I change this to protected, the num legs, if I go to any subclasses or child class of animals, so any class that inherits from animal, such as, let's find one here, cat inherits from animal. Notice inside I can say super dot, and I can access num legs because I changed it to protected. However, if I go back here and change this to private, and I go back inside of super here, inside of our constructor, say super dot, I can no longer see the instance variable or the property numLegs. Okay, so if you want to have a property that is only visible inside of that class, but not visible anywhere else, you will use private. But if you want it to be visible inside of this class, but also other classes, children classes, okay, subclasses, then you would use protected. Okay, protected like that. Get rid of this. All right, perfect. Now you learned about public, private, and protected. All right, so I'll see you in the next video. Kotlin as a language is a very powerful one, and I'm sure by now you are very convinced by that. One of the things that I think it's important to understand about Kotlin is the ability to extend or create extensions from classes that are already built in. Now, imagine you are building your application, you are just using this language, and there's certain functionalities that you can't quite find within the classes that come with Kotlin, within the library classes with Kotlin. So in those cases, instead of creating things from scratch, you can actually use what has already been done and extend or add functionalities to those classes. What I mean by that is the following. Imagine that we're creating a function that will remove the first and the last character of a certain string. So if we actually use this string class, go to string as that, Kotlin, say dot, there's a few functions that we can call. But what we can do now is we can actually create a different class using that extends our string object or our string type by saying fun. Okay, it's going to be of string type, and I'm going to give it a name. So you start by using the class that you want to create extension from. So in this case, string, I'm going to call this remove first and last char or character. Okay, and of course we want to return a string type. Now there's two things we can do here. We can put all of this inside of a function, inside of braces, as you can see that's totally fine. But because Kotlin prides itself for being succinct and very minimalistic, if you will, we can just go ahead and say it's equal, right? So that's the same thing as just putting the braces there as a function. So we can say it's equal to what? Well, we can now say this is called the receiver object. Now the string here, class, that's called the receiver type, the parent class, which is the string here, okay? So we can say this dot, and I can say substring, okay? There's that class there. What I'm going to use is this one here, this method. Okay, so I can pass in the start index, which index we're going to start removing characters from, and the end index. So I say enter. I'm going to pass here 1, and then I'm going to say this again, the receiver object. I'm going to find the length of this object, this string object. Of course, I'm going to say -1. Okay, and of course I forgot to do this because that's indeed our function that we're going to be calling. Now we have extended, if you will, our string object, string class, and added a remove first and last character. Okay, so now if I go to inside of our main here, I can go and say, for instance, val, say let's say full name, already shown as such, and I'm going to say val result, let's say it's equal to, I'm going to say full name, okay, that's a receiver dot, and I'm going to say remove first and last character. You see, now we have access to that because it's the type that we are passing, because it's the same type as the receiver object. Okay, like that. And then I can go ahead and say first characters are, if I spell correctly, characters are, go ahead and pass our result. Okay, so if you go ahead and run this, we should see our result. So the P is gone, and the E for my last name is also gone. Okay, Now you have all this power of things you can do with your code. And this concept here can be used in any case that you find fit. Now, of course, like with anything, it's easy for us to abuse this, but it's available to you, which is amazing because you can do all sort of things. For instance, the other example I can give you here. For instance, let's say we want to use the int to create a function that will add or double a certain number. Well, what we can do is say fun again. It's going to be integer. And the name, we're going to say double number. Okay. It's going to be of type int, of course. And I'm going to go ahead and say, just to make it, to simplify it a little bit, I'm going to go ahead and just to change the syntax of writing this to give you a variety of things you can do. I'm going to say return. What I'm going to return here, I can say return this plus this, right? So that means I can say val number 1, 12. I can say val res is equal to number 1 dot. I can go ahead and say double. Look at that. We have double now. Okay. So results here, I can go ahead and get rid of all of this. In fact, just to simplify, I'm going to just keep it there. I'm going to say res. Go ahead and run. And it should say 24. So now we can actually create little libraries. And say if we are creating an application or a program, creating an application that will always want to use, oh, I don't need to have this, Kotlin. So what I was saying, if we want to be able to create, for instance, a program that will always need us to double the number, we can go ahead and create an extension of the type that we want to use and create a double number method, which every time that it's called upon a certain number, then we can say dot double and it will just return double of that number. So you can see how powerful this concept is. Now what I want you to do is do the same example here and create another extensions for other types. So let's say I tried string here, I did string and I did integer. How about try to do boolean? How about also trying to do a char or a byte or any other types that we have, and play around with this concept. And remember, we can do this with any other class that we create or that is included in our Kotlin library. Perfect, and I'll see you next time. All right, so let's talk about another concept here, which is the nested classes concept. So there are times when you need to nest classes inside of other classes, right? So you have the outer class and you have the inner class or the nested class. So how do we do that? Okay, let's give a very simple example here. Okay, so this is the idea here is to really get your head wrapped around how classes work in Kotlin and so forth. And bear in mind, if you come from a different language such as Java, you will see a lot of similarities in these two languages, and you also see how simplified things tend to be when it comes to Kotlin. Now, if this is your first language to learn, you notice also you're lucky because this is one of the most simplified languages out there, in my opinion. Okay, so let's look at an outer class here. So I'm going to create a class at the top here. I'm going to call this outer. Okay, very simple, nothing big here. I'm going to create an instance variable called val, say my string, string as such. I'm going to give it and say outside nested class. Okay, just a string, and I'm going to create here a nested class. I'm going to say another class again, call this nested class, and I'm going to create a val new string, and I'm going to say inside nested class. I'm going to create a function here, say call inside, and I'm going to give it a value that it will return, which is going to say function call from inside nested class. So this syntax here, we are just saying this function will just print out or return this text. If we wanted to, we could have said something like this. I'm going to go ahead and comment this out. We could have also said fun call inside as a function, and we could have say s out, or if we wanted, we could have made it this type string, which means we'll need to return something like function call from inside, etc. So these two are essentially the same thing. But I like this because the whole idea of Kotlin is to get rid of all of the fluff, if you will. Okay, so you will see me do this is the same thing. If you prefer to do this, then go ahead and do this. But if I like this way here at the bottom, because again, like I said, it's about Kotlin, and the idea of Kotlin is to cut off the fat or to make it less verbose. Okay, cool. So I'm going to go ahead and comment this out just in case you want to have another way of doing this. Okay, there we go. So we have the call inside. Perfect. So to take a look at how it all works inside of our main here, I'm going to go and say print, or I can actually say s out. Look at that. Okay, to simplify here, and I'm going to say outer dot nested class. Okay, call that class. I'm going to go ahead and access the new string variable, this one. Okay, so this will access the member of nested class. So I'll put it here, accessing the member variable of the class. Okay, there we go. So save this. If you run, we should see, hopefully, there we go. Oh, wait a minute. Let me run this one. There we go. So there we go. This is what we see inside the nested class, which is what we did. Next here, what we're going to see, we're going to create an object of a nested class. Right? So here we just went ahead and access the new string from the nested class. Now let's go ahead and create an object here. I'm going to say val nested. Okay, say outer dot nested. Okay, create that object. And then I'm going to say s out, and I'm going to say nested and access the call inside, which is going to, yes, you guessed it, is going to call the inside, the inside method, okay, which is inside of a nested class. So what we've learned here is that from our outer class, we're able to go inside of a nested class and access all of the values and all of the members, as well as all of the methods or all of the functions of our nested class. Very cool. Perfect. I'll see you in the next video. How can we access this m string inside of our nested class? Is it possible? Let's try this. Let's say I want to create a function. Let's say get stuff, and I want to set it to this string here. So m string, and you notice I can't even do that. Okay, in fact, this should be a function, right? Like I said. And notice it's red because it says unresolved reference. This is because in Kotlin, your nested class cannot access members of outside of itself, cannot access members of the outer class. In order for that to happen, we actually have to make a change that will say that this class it's not just a nested class, it is indeed an inner class. The moment you do that, you notice now we are in business. If you remove inner, we are not in business. You add inner, then we are in business. Now in Java, what happens is if you have an inner class or a nested class in this case, it will automatically say, okay, you are an inner class, but automatically. But in Kotlin, you have to specifically say inner class in order for you inside of inner class to be able to access, you can see here, our member variable from our outer class. And you notice now we have a problem here. This also means, let's go ahead and get rid of this or comment this out. So now what we can do to access, to make this work, okay, we can say now, for instance, val outer is equal to outer class like that. So creating an object. And I'm going to say s out. I can say using outer, make it inside of string here. So outer. So using outer object, and then I can of course go ahead and pass in arguments here. I'm going to say outer dot nested class, okay, dot. I can then say either call me or new string, all of that. Okay, so I can access everything. Let's go ahead and say I want the call inside or get stuff. Start with get stuff. And then I can say val inner class. Let's say just inner. And again, I'm going to say outer. Okay, make sure that I'm getting that object access there, and again access the nested class. Okay, so now I can say s out, so using inner object. Okay, I'm going to pass here our inner dot. I can either get stuff, new string, calling inside. Let's say new string as such, or just to continue with the tradition, just get stuff. Okay, so now we're able, because we said this is indeed an inner class, it has to be specific. You have to specify it in a class. Then you notice that inside we can actually access our outer member variable. And then outside in our main, if we want to go ahead and access, for instance, the nested class and the methods, we can just go via the outer class or via the inner class. You notice both of them are able to get stuff. Okay, those are small things, but they're very important to understand, especially when we start developing applications, a little bit more complex application. This is a very important thing to know, because it gets to the point where if you are having an inner class, if you want to create a nested class, what you could do is you could just create a class just like we did, and then you want to access the outer class member, and then you're not able to do it. You have to remember always to put inner, okay? Otherwise, you're not going to be able to access the outer member variable or any other methods or functions that the outer class may have. Okay? Perfect. I'll see you next. Let's talk about companionship. Let's talk about companion objects here. To illustrate the companion objects and why they're so helpful, let's create an object, or let's create a class here. I'm going to call this person. Okay, again, simplicity is king. I'm going to create a function here called fun show name. Okay, and what this is going to do is just going to go ahead and print out, say, s print ln like that, and I'm going to just go ahead and say my name is name. I need to create that member variable at the top here. I'm going to say file name Paulo, just like that. Okay, very simple. So in order for me to be able to call this show name here, I can't say person dot and try to get our either name or show name. Now, in order for us to access that, we would have to do this. We would have to say, for instance, val Paulo, give it a type which is equal to person, like that. Okay, so Paulo is a type of a person. Okay, and then we have that object, and then we can say Paulo dot either name or show name as such. Okay, so once we have that, let's go ahead and give it a run. We're gonna run this one here, and says my name is Paulo and companion object. We don't need this anymore. All right, so there we go. So this is totally fine, but there are times when we want to be able to actually access anything from our class by just invoking the name of the class, because we don't want to go through the process of creating an object and get all of that. So that's where the companion object comes in. So what the companion object does, so in this case, actually do the following. We could say companion. See, there it is already. It says companion object, enter, and there we go. We can take care of this by removing that method and put inside as such. Okay, notice the moment you do that, then we cannot resolve the show name, because now it's inside of our companion object. The beauty here is that the companion object is of type object, and we can actually give it a name if we wanted to. We can, for instance, say name, for the lack of a better name, and that would work. So now we don't need to do this. Now we can just say person dot, look at this, show name. Okay. Now the cool thing here is that the giving the name to our object, companion object, is optional, but it helps if you need to do that. Now we have a problem here of unresolved reference, and you notice that because this is outside, we're having issues, so we would actually get rid of that and put it inside our companion, then we are all good. So save this and give it a run. We should see My name is Paolo. Very nice. So now you know about the companion object. And again, if this is all new to you and maybe it's a little bit awkward for the lack of a better word, don't worry too much. So I want you to go through this, try to understand as much as you can, obviously. But as you evolve as a programmer, as you learn more about this language, this should all make sense. Okay. So what I'm trying to do here is to give you as much information about Kotlin as possible. So if you already have been programming for a while, so you know Java, for instance, or any other object-oriented programming language, then this will make more sense. But if this is your first language and this is like, oh my goodness, I've been looking at classes and all this stuff, it's not really making a lot of sense, do ask questions. And I recommend you go back and rewatch the videos, okay? And then ask me questions. I'm always here to help you understand all you need about Kotlin. Okay? I'll see you next. Let's talk about operator overloading. Let's look at a quick example here. Let's give a val A, give it 3. Val B, I'm going to give it a 4. Okay. So what we can do, let's say print, and we're going to say A plus B, as such. Okay. Save this. Let's go ahead and give it a run. Very good. So 4 plus 3 is indeed 7. Now, what's happening in the background with Kotlin is the following. We're saying print and we're saying A dot, because we know A is of any type, in this case is an integer, and could be different types. We're going to say plus A dot plus. You can see plus can take in a lot of different messages or a lot of different parameters, right? So the plus is what we call overloaded. Okay, so you can see here this plus that captures in an int, a byte, a long, float, double, a short, and double. Okay, so that's what's happening. So what we can do, we can say plus and we're going to pass B in this case, and we'll have the same result. Give it a run. 77, that's not what we want. Let's get rid of this and run again. Should be 7. Okay, so this is what's happening in the background. Of course, we can always use this form to add to number. So either one of these work. So when we do this in the background, this is what's happening. Now, because the way Kotlin is set up, we can also define how operator works for objects by also overloading its corresponding function. So, for example, let's look at the plus or the addition operator, how it works for objects by overloading plus. I'm going to go ahead at the top here. Let's go and create a, actually I could do at the bottom here. Let's go ahead, I'm going to create a class. Let's call this class point. Okay, so point will take in an x, which is going to be a type of int, which is going to be of type int, and let's set it right away 0 so that we don't have issues. Say val y. Int, I'm going to set it to 12. So what are we going to do here at the bottom? I'm going to overload plus function. How do we do that? Where we say operator, we use the operator keyword to say that we are going to be overloading what? An operator, because plus, minus, divide, multiply, those are operators. And I'm going to call, it's going to be a function. We're going to be overriding or overloading the plus. So we're going to pass p of type point, say point, as such, and it's going to be of type point, like that. So we have to return something here. So I'm going to say return we're going to return point object, just like we did here, as such, and we're going to pass x plus p dot x, right? Because the point object has the x value, and then y plus p dot y. So inside here, I'm going to go ahead and comment this out. Inside here, what I can do, I'm going to say val point 1. I'm going to say is equal to point. I'm going to pass, let's say 3, let's say 10, and minus 4. Okay, then val point 2, point, I'm going to pass what? X is going to be, let's see, 3, 8, like that. So we have our 2 points, okay? And of course, those points, now we want to return the plus. Now let's return the sum of these 2 points. Well, we can say var sum is equal to point, right? Because it's going to be point type that's going to be receiving. And we're going to say sum is going to be equal then to point 1 plus point 2. Next, we can say print ln, and we can say the sum is equal, let's put it all in parentheses. What are we going to pass? I'm going to say sum dot x, and then sum dot y, like that. Looks like this sum is redundant. We could say var as such. This would also work. All right, there we go. So we refactor our code a little bit here. So what we did here again is we created a point class which we pass an x and y value, and we initialize those in our constructor here, okay? And then we said overload plus function. So we use the operator, is very important. We use the operator keyword and say plus, and then we pass the point object which has x and y. Okay, of course we have to return a point. So in this case we return a point which is x plus px. So whatever we're passing, if it's 0, it's going to be plus px. If the point x coordinate is 10, it's going to be 0 plus 10. It's going to be 10 for the x coordinate. So then y, whatever we're passing, in this case is 12. P dot y is going to be whatever the point is we're passing. Let's say the point in this case is -4 for y. So 12 minus 4 is 8. You get the point. So here we are returning the summation or the addition of the points. Okay, so let's go ahead and run this real quick. Oh, I forgot to finalize with something like this. Let's run that. And there we go. So the sum is 13 and 4. Let's make sure this, if this is actually makes sense. The sum, 10 plus 3, that's what? 13 minus 4 plus 8, that is 4. That's why we have the sum of those points is 13 and 4. Okay, so we were able here to overload our plus operator to yield to this result that we have here. So my challenge to you is, how would you then overload the minus operator? I'm going to put challenge here. Overload minus operator. And you notice we can do that if you go here, just to see that the same thing can be done as it is done in the background here. So we can say a minus, look at that, or you can say a multiply, divide, for d we say div. Use the same concept that we use here for this plus operator overloading plus function here, and do that. And I would like you to do the same thing with the minus operator. And once you've done that, make sure that you invoke it here as well so we can see the results. That should be fairly easy. Good luck, and I'll see you next time. In this video, we're going to talk about another component of object-oriented programming, which is called interfaces. Okay, so interface classes. What these are classes that have methods without bodies or without content. Now you may ask, why do we need such a class that has methods without implementation, right? The reason why is because there are times when we need to use certain features of a class that can be used anywhere by any class. A good example would be the following. We're going to create a very simple interface class here. We're going to say interface. Okay, that's how we create an interface class. We're going to call this input handler, something like that. And this class here will have no constructor. All right, so we have our interface input handler. So inside here, we're going to create a function. We call this clicked, okay? And we won't have a body to it. Okay, we're not going to add a body. So what this is going to do is the following. If we create a different class here, say class, a normal class, we call this button, and we inherit from input handler, in this case, we're going to have a problem here, right? The problem here, if you hover over, click here, click on this red bulb here, it will say implement members. Okay, so if we click that, we'll have this window happening, and we say okay, and then we'll have this. Get rid of that. And then we'll have this, that's this override fun clicked. And of course we have a to do here, which means we can add whatever we want to add here. Okay. Now, the beauty about this is that this input handler here is an interface or is a class that can be used anywhere by any class that we instantiate, right? Because all of its functionality or all of its implementation only depends on the class that we are using to implement it. Okay, in this case for the button. Okay, so now here what I can do, I can say I want to print ln that says button clicked. Okay, so if we go here and say var my button is equal to button, okay, like that, and I say my button dot clicked, if I save and run, okay, this class, we should see here at the bottom it should say button clicked. We could have created a different class. For instance, we can say class phone, okay, and we can implement, say, input handler, like that. And the moment we do that again, we will have this problem here. It will force us to implement that method, that function. So any class that we create that will inherit input handler, because it's an interface, it will force that class to override and implement that method, that function here, which is clicked. Okay, so you notice here we can go ahead and totally create something totally different here. We can say print ln, we can say phone clicked, save this and create another var here called phone is equal to phone, right? So instantiating that object, and we say phone dot clicked, and we save and run. We should see it's going to show the phone clicked implementation here. The beauty of this is that it allows us to be more flexible. We can have as many functions as we want. For instance, we can say double click, okay, this method there. We can say fun single click, like that. And notice we have a problem here, right? Because we added these two new unimplemented or empty. We added these two functions here. That means we have to implement those or override them. Say like that. Both of them. And this one as well. And implement both of them as well. Okay. And we can add our own implementations, just like we did before. Okay. Print ln. For now, we can just say double click. Here we can say print ln. Single click. All right. And if we wanted to access those override methods, and we could have done the same thing here, right? We can go ahead and save my button. That double click, and it would show double click, and do the same with our phone. You will see interfaces everywhere in Java as well as in Android development. Okay, so that's a very important concept to understand. So just remember, the interface allows us to create empty functions, right? And then any class can inherit from that or implement the interface, and then we'll have to override the methods. It's going to be forced to implement or override the methods or the functions from our interface class. Okay, and it gives us a lot of flexibility because now, well, as you can see here, each class that inherits from input handler, our interface here, can create its own implementation of that function. Okay, that's very powerful because it allows us to create very extensible classes. All right, play around with interfaces, and I'll see you in the next video. All right, so the next thing we're going to look into here is an abstract class. Now, I do realize that I'm throwing a lot at you here. And most of the things that we're talking about as we talk about advanced object-oriented programming in Kotlin, they may not make a lot of sense at this point, and that's okay. I do this on purpose, not to torture you, but it's to give you all of the information that you will need to use or to refer to as we start digging deeper into these concepts, okay? So bear with me here, and if you have any questions, you always know you can come and ask. All right, now we talked about interface classes. Interface classes allow us to implement or inherit everything, allows us to override the methods that we create. Interface classes do have methods or functions that don't have a body. The reason why is because we want to make sure that the implementation is at the class level, okay, or at the children class level, as you saw here. Okay. Now the next concept I'm going to show you is the abstract class. Okay, let's go ahead and create a new file here. So new, I'm going to call abstract class. Now abstract class is very similar to our interface classes that we looked into earlier. Okay, so abstract classes. Now abstract classes, they are not meant to be instantiated, and they also can have a mixture of functions declared with or without an implementation. I know there's a lot of words here and that can be a little bit confused. So just think of an abstract class as something that's not meant to be instantiated. What that means is when we create a class and we go to our main function, right? We say, for instance, var my class, and then we instantiate it, which means we invoke the constructor of the class that we're trying to instantiate it from or create an object from, right? We can say home, for instance, something like that, right? Well, if home was an abstract class, this wouldn't be possible. So let's go ahead and put all this to action. I'm going to create a main entry here. I'm going to call this args. It's going to be array of strings, as you've been doing now. All right, and at the top here, I'm going to say abstract. Okay, that's the keyword we use to create an abstract class. I'm going to say class. I'm going to call this, for instance, graphic object, as an example. Okay. Now this graphic object here, let's think of this graphic object as the object that has all the functions and code that allows us to create, for instance, different graphical objects on the screen, right? Like a rectangle, a line, and a circle. Okay. Now if you think of this graphic object, it's a very abstract concept, right? A graphic object would be, like I said, rectangle, line, circle, triangle, and so many others, right? So it would make sense for us to, anytime that we have a class we are trying to create, to think in those terms, okay? So if we think of a class that all it does in this case is it's a graphic object. In fact, I think I misspelled here. It's a graphic object. It's more of an abstract idea, which means this graphic object here has a lot of functions and methods that we can use to create different kind of objects or graphical objects, such as rectangle, circle, lines, and all so forth, right? So that also means this is a good class for us to make an abstract, because it is indeed an abstract idea, right? A graphic object, it's not necessarily a real graphics or an implementation of a graphical object in the real world, which means now we can go ahead, for instance, and create a function here, say function, that's draw, right? Now, because we wanted to not have an implementation, we have to make it an abstract. So an abstract class will have abstract methods or functions in this case. So what else do we need to do in order to actually create a graphic object? We can say abstract again, and we can say fun resize. That would be another function that we need to create an actual graphic object. But notice also what we can do here. We can actually create an implementation function here, right? That actually has a body. We can go ahead and say, for instance, fun move to, right? So this function here will take, for instance, we can say new x position, okay? It's going to be an integer, and we will take the new y position of type integer as well. And we can go ahead and implement it something. We can go ahead and say, for instance, print ln new X and new Y. Okay, that's fine. We don't need to actually implement everything, but you get the idea. So we have a mixture here because we know that any object created using this graphic object here, this graphic abstract class, will have a move to, because we could make that graphical object, let's say it's a rectangle, to move from X to Y. Okay, so now that we have this abstract idea of a graphic object that can allow us to draw and resize an actual object, we can go ahead and say the following. We can say public, we can say class. Let's say we want to create a circle, right? We can say circle extends, right? Graphic object, like that. And the moment we do that, it said circle must be declared abstract or implement abstract class base method. So if we click this and click here, it says implement members, like that, and look at that. We can implement all of those. You notice here, this is pretty much the same thing that we have when we talked about interfaces, right? We have to override certain methods. So they were very similar. But now we have another problem here. It says here constructor must be initialized. So what we can do here, we can just go ahead and put a call primary parameter like that, and we should be okay. So there we go. So now we have a circle that inherits from graphic object, but we have to implement the draw and the resize. So here I can go ahead and say print ln drawing circle. And here I can say print ln resizing circle. Now, when we go to our main here, if we wanted to instantiate our graphics object here, it wouldn't work. Let's try it. Let's say var graphic object and say graphic object like that. If you look, cannot create an instance of an abstract class, which is why we created an abstract class. We cannot instantiate it because it's an abstract class. However, we can instantiate anything else that inherits from our abstract class, which means now we can say var circle is equal to circle, like that. Okay. Now circle dot, we can call draw, and it will draw our circle. So if we save this and run, we should see says drawing circle. And because we also have this move to that has this implementation here, we can go ahead and say, for instance, circle dot move to, and we can pass 12 and 23, right? And save and run, and it will run the move to. And you can see here, moved to new X and new Y by extending our graphic object, which means we can go ahead and create, for instance, a triangle because it's also a graphic object, right? So we can say class triangle extends graphic object. And of course, we have to give our constructor and make sure that we implement all of those members. Okay. Okay, just like that. It's a print ln drawing triangle, and of course we can say here resizing triangle. Okay, and we go here inside of our main, create a triangle. We can say var triangle is equal to triangle, like that, right? And we say triangle that draw, save and run. We should see the drawing triangle. Okay, drawing triangle. And we can do the same things that we did with our circle. Okay, so anytime you have a class that is more or less an abstract idea, okay, because a graphic object, it's not necessarily an object, right? It has all the methods that allow us to create real concrete object, in this case a circle, triangle, we could have created a line, we could have created a rectangle, so many other shapes. You will see us using a lot of abstract classes that come with Kotlin and the Android framework. That's the reason why I wanted to get you started in these concepts here of abstract and interfaces. Those are very important concepts to really start understanding, and we will touch bases obviously as we progress in our studies here, but I wanted to give you an idea of how all of these work. Now, one exercise I want you to do is to go ahead and get a piece of paper and a pen or pencil and write down all of the, for instance, abstract idea, okay, something that is very abstract, and create a class, an abstract class with abstract functions, and if you want, implemented function as well, and then go ahead and create concrete classes, as we call here. Like circle is an actual concrete class that extends this graphic object abstract class, okay, and then override the draw method and size. So I want you to, for instance, think of a shape class, which is very similar to this. It's a shape, is not a concrete object, because you can't have an object called shape, right? But you can have a shape such as a circle, like we did here, circle, triangle, square, or rectangle, and so many things. So do the same thing as we did here, but use the abstract class shape, okay? All right. Thank you, and I'll see you next. All right, so in this lecture here, we're going to talk about another very important concept called generics. Now, generics can be a little bit confusing at first, but the idea about generics in Kotlin and Java and many other languages is that we are trying now to create classes a little bit more generic in the sense that the types of our classes can be anything that we want them to be. Now, let's start with an example here. I'm going to create a new file, Kotlin. I'm going to call this generics class. Okay, I'm going to go ahead and get rid of that. I'm going to create a fun main args array, and I'm going to say string. So I'll create just a main here. Okay, that's perfect. All right, let's go ahead and create a generic class here. The way we create a generic class is the following. We just say class, and then we, for instance, we're going to say login. That's login class, and then we're going to put inside of angular brackets here, we're going to say T. This T stands for template or type, okay? And then what we're going to do, we're going to say, for instance, name is going to be of type T. We don't know what type T is, and password is also going to be of type T, just like that, okay? And here inside, we can just create an initializer here. We can just go say print ln. I'm going to say name, just going to say it's equal to name, and we're going to say password is password, okay? Nothing complex here. So again, what we're doing here, we're creating a class called login, and we have these angular brackets, and we put T as a template or type that we don't know yet. And of course, the name that we're passing here is going to be of type T, so the same type that we're creating here, and the password also the type T. Now, when we go to our main and we want to instantiate or create an object out of this login here, we can go ahead and say var login is equal to login, like that. So now, in order for this to work, we have to pass in the type this object. In this case, we can say, for instance, string. Right? We want this to be string, and also to instantiate it, we're going to put the name, in this case has to be type string, because remember we said T, right? So all of these types have to be the same. So name is going to be string. I'm going to say John, and the password, I'm going to say John, like that. Okay, this is a generic class because again, it's very generic. So we just say, hey, we're going to create this class. In this case was login class, and we are going to make sure that this login class takes in a certain type. We don't know what type that is. Okay, that's why we put template T or type, just a generic type. And then we pass some parameters here in our constructor of type T and password of type T as well. Okay, now the beauty about generics is that, okay, in this case we said login instantiated, and we say this is going all to be type string. Okay, if we want it, because it's a generic class, we can say var login is equal login2, we can have the same variable name, is equal to login, and check this out, I can change the type to something totally different, right? I can say in like that. And then look at this. Because I changed type to int, right, in our generics, in our Angular brackets, now you notice the name is type int, the password is also type int, which means the contract now is that both of them have to be ints. You see? So it's very malleable. It's very flexible. All right, we can say another one, var login3 is equal to login. And what type we want to do now? We can do Boolean, for instance, like that. And the moment we do that, we pass in something. Look, now name has to be Boolean, password has to also be Boolean. True, false. So now we can use any type to attach to our login class here, object. Any type at all, because we said, well, this login here will just take anything. Whatever type we put here, it's going to be the type that will be the same across the class. And if this is true, that means then nothing will prevent me from doing the following. Say class, create a totally different class, I call person, and then this username is a type of string, and password is a type of also string. See this class here? And I can say init, and I can say here print ln person class. Right, so this is just any type. That's just a person class, so it's a different type. That means then we can still do the same what we did here. So we can go ahead here and say var person. I can say credentials, or let's say user, is equal to login. All right, and then I'm going to pass the person type. And check this out. And then in order for this to work, I can go ahead here. Look at that. Now the name has to have a person type, right? So what I can do actually here, I can instantiate a person class, a var person is equal to person, okay? And pass in here right away Paulo and password Paul. Okay, so once I have that, in fact, let me go back here and add some properties. I'm going to say var username is type string. I'm going to give it a null. And I say var password is also type string. And I'm going to give it a null as well. And inside here, I'm going to initialize. I'm going to say this dot username is equal to username, and this dot password is equal to password. Okay. So now that I have this person and I passed Paulo and the password, I can, and I know I have to pass in here a person type. So this person here is a type person, so it's an object of type person, which I can pass here. And here I can just go ahead and pass person, and of course person 2 as object, because these two are person object. I hope you can see the power of things that we can do with generics. They're very flexible in that we can change the types that we're passing instantly inside of our Angular brackets. And we'll see all of these examples in action as we progress in our studies here. Perfect, so I'll see you in the next video. Alright, welcome back. So in this video, we are going to talk about yet another type of classes or data structure per se. This one is called enum or enumeration. Let me go ahead and create a new class or new file here. Kotlin file. I'm going to call this enum. Just like that. Okay. And as usual, I'm going to go ahead and say, close out of that. Fun main args array. Okay. Oh, entry point here. Okay. So the enum, I'm going to write it here. Enum classes essentially allow us to represent collection of information, but namely fixed or static information. Okay, put this in a new line. There we go. So these classes are very simple in nature. They allow us to create static variables that we can use in our programs. We don't usually need to instantiate them or create objects out of them, which of course, as you know by now, by creating objects, we are taking up some memory space. So whenever we can avoid creating a lot of objects, it's always a good policy. So the way we do this, we say enum class right there, and we give it a name. We're going to call this suits. Suits as in deck of cards. Okay, so usually deck of cards has a few suits. So what we could do here, we can go ahead and say hearts, right, and say spades, comma, diamonds, and clubs. Right? So now we created this enum class. We called it suits. In this case, it will be suits of deck of cards. So as a disclaimer here, I don't play cards, so I don't really know much about cards, but I know that each deck of cards, there are suits. So hearts, spades, diamonds, and clubs. Okay. So now we have our suits enum class, enumeration class here. So we can actually use it inside of our main here. So how do we use it? But before we do that, there's a few things you need to notice here. You notice that all of these items inside here are in caps. And there's a reason for that. So in most programming languages, Kotlin included, any variables types that are supposed to be static, meaning that they don't change, because hearts will always be hearts, spades will always be spades, we tend to write them in caps, all caps. That signifies that they are static, so they don't change. Okay, they're fixed values. So now here inside of our main, we can actually use that class by saying, for instance, we can use our suits class by saying, for instance, var card player, for instance, is equal to suits. See, there it is, dot, and I can access diamonds. So now card player here has suits diamonds. Therefore, if we were building an application, a card player app, right, a card player program here, we could have probably say something like this: if card player is equal to suits diamonds, then we want print line and say you are doing great. Okay, like that. If we go ahead and run this, we should see this message. It says you are doing great. Okay, we could have also said, for instance, var card player 2, for instance, is equal to suits dot clubs. Okay, and we could have said if card player 2 is equal to suits dot clubs, just like that. Could also print something, hello there, things are not so well. Okay, something like that. So this is obviously a very simplistic example on how to use your enums. We could have created another enum class here. For instance, we could say enum again, class, and we're going to say, call it directions. Okay, and we add here north, south, east, west. Okay, we could have said var player direction is equal to directions dot east, right? So if we were to be building a game, we could say if player direction is equal to direction dot east, then we could say something. So print ln, you are going east bound. Okay, let's save this and give it a run. There, you are going eastbound. Anytime you have fixed items or fixed variables that you know the values are always fixed and you want to enumerate them or put them in one class, that way it's easy to access. As you can see here, we always set suits dot diamonds and then we access the actual diamonds element here instead of our suits class, enum class. Okay, so anytime you want that flexibility, you should always use an enum class for that. Okay, as you can see here for directions, because north will never change, will always be north, south would never change, as well as hearts, spades, diamonds, and clubs. Those are set known variables with values. Okay. All right, so a very simplistic approach here again, but nonetheless a powerful one. Okay, play around with this concept and I will see you in the next video. All right, so in this video, we are going to talk about arrays. So what is an array? So think of an array as this rectangle in memory, where inside of each rectangle, we call this container. Okay, we have smaller components here, right? So we have smaller buckets, just like variables, right? So we have variable 1, 2, 3, 4, 5, 6. But the beauty about this container containing smaller slots of variables, smaller slots in memory, is that each container has an index, right? So the first one is going to be index 0, index 1, index 2, 3, 4, 5, 6, 7, and so forth, depending how big this container is. Each container, these slots there, they're called elements. So now we have a container, this huge rectangle here, bigger bucket, and inside we have elements, so the small slots, which are then connected to index. So think of an index as ID for each slot. So if we want items in container or in element 0, that means in index 0, we will then get that element. If we want then what is stored inside of index 1, we will then go and fetch the index 1 and we'll get that element. Okay, so this is the visual representation of what an array is. The beauty of having this data structure called array is that it allows us to organize our data. In this case, this array here could be an array of type integers, so we would have numbers. So inside of element 0 would have 2, element 1 would have 4, and so forth. Everything is well organized throughout the container, throughout the array. And it's easier to fetch the contents inside of the elements or inside of the container by using index point where the slot is and get the value from it. Let's go ahead and see how we create arrays in Kotlin. All right, so let's go ahead and create a new file here. I'm going to call this arrays. Okay, can get rid of all of this, and we don't need any of these other classes open there. All right, so we're going to say fun main args. I'm going to say here array. Oh, what do you know? String, and there we go. Okay, in order for us to create arrays in Kotlin, well, we do the following. We go ahead and say var. Okay, I'm going to call this my array. And I'm going to say it's equal to array, and here we pass int, because those are the types that we're going to be inserting in our array. Now notice something very cool here, okay? And we talked about this when we talk about generics, remember? So generics, we said there were classes that allowed us to be more flexible when it comes to types. So it turns out that an array is actually a generic type, right? Because you see here, there's these angular brackets, and we have to pass the type which this array will expect. Okay, so now for our array, the next thing we need to pass is the size of our array, because remember, if we look at array as a container, it has to have sizes, right? It has to have a size, or how many items will fit in this container. In this case, we're going to create an array of size 5, and then we have to initialize our array. In this case, we're going to initialize it with 2. So we have array of size 5, meaning with 5 slots or 5 containers, and each container will have 2. Okay, if we want to see this, we can go ahead and say print ln, and we can say my array. And if we want to go to a specific container, we create a bracket like that. That signifies an array. Inside, we're going to pass an index. Okay, so the index here, let's say for the first item, it's going to be 0, because arrays start at 0. So the first slot or the first container is always 0. So in this case here, we're saying we're taking our my array and we are accessing index 0. And the way we access, we put inside of square brackets like that. If we save this and give it a run, we should see see 2, because we said for every slot or every container, okay, or every element will have 2 inside of it. So 0, index 0, we have 2. Let's go to index 1, or the second slot. And we're going to run this. We should also see 2. Okay, nothing really special here. Now, you may say, well, how about if I want to iterate through or go through the entire array and show all of the items inside of that array? How would I do that? There's different ways to do this. So we're going to use a for loop. Okay, so for, and there it is, we are going to say element. Okay, we're going to create a variable inside. We're going to say in my array. So we're doing the for loop here. And we're going to say print ln. We can say index is, I'm going to say element, okay, I'm going to say plus item, and we're going to say plus my array, and we pass element like that. Okay, so what are we doing here in this for loop? We created a variable that will hold all of these items inside of our array. So in my array, which means this array here, and we're going to go through. At first time, we're going to say index is element. So if index is 0, it's going to be 0, and items at 0 element is going to be, we're going to access my array, and we're going to pass that element, which is the index. Okay, so at 0, it's going to be 2. So since we don't have a lot different numbers inside of our array, it's just going to show 2. Okay, save this and run. And as you can see, we have item is 2, items 2, items are 2, 2, 2, and so forth. And if we want to change each item at each index in our array, instead of having 2 in all of them, we could have said my array at index 0. We're going to go and give it 10. I'm going to copy this. At index 1, I'm going to give it 1. Okay. And at 2, we're going to give it 3. At 3, I'm going to have 8. At 4, I'm going to give it 100. Why not? Okay, so save this. Now each element inside of our array will have different numbers. Okay, so save and run. And you can see here items 10, 1, 3, 8, and 100. So in this video, we're able to create an array. So we said var my array, so give it any name we want, and we say it's equal to array, and we have to pass in the type because it's a generic. Okay, pass in the type of items we want to have in our array, and right after that we pass the length of our array. So how many items, how many slots we're going to have. In this case, we're going to have 5, and then we initialize with something. We initialize with 2. If we leave it this way, that means every slot will have number 2. Now, if you want to change each slot, we can just go ahead and access the index. So in this case, we use the square brackets, say square brackets, put the index 0, we're going to put 10 and 1, 1, and so forth. And to loop through, we say for loop element in array, okay, and then just print the elements because this element will have all of the items inside of our array. All right. Perfect. So go ahead and play around with this concept here, and I'll see you in the next video. But also, remember, we can create a type of int. That means we can also create a type of a string. We can also create a type of Boolean, type of char, and many, many other types. Okay, so go ahead and do that. So create a new array and change the type. Okay, instead of integer, we can go ahead and put strings or any other type that we have learned. All right, so go ahead and give it a try, and I'll see you in the next video. Now I'm going to show you another way of printing out the actual items inside of a string. So in this case here, we're just printing using objects, right? So printing objects. Okay, because as we print, we're just printing the objects inside of our my array here. So if we want to actually iterate through and take and get our indexes, what we can do here, printing items inside of the array via index. What we can do is the following. We can say for, I'm going to create an index here, say index in, we can say from 0 to, in this case, let's say we have 5, if we put 5 and say print ln, we're going to say my array, and then of course we're going to iterate through our index. Okay, so it's going to show us items inside of our my array by index. Okay, if we save this and run, we're going to have an issue. All right. It says here, array index out of bounds exception 5. So it's still printing these items here because this is from previous, right? So the reason why we're having this problem is the following. We're saying here index in 0 through 5. Well, we do understand that indeed our array here is length or size 5, okay? But the problem here is the following. It goes through 0 through 5. That means it actually shows 6 elements, right? Because it's going to be 0, 1, 2, 3, 4, 5, right? So those are 6, right? Counting with 0. That's why we're getting this array index out of bounds exception, because we don't have 6 elements inside of our array. We actually have 5. And it's easy to think that this is correct because yes, indeed we have 5, but we are not counting with the 0 included, okay? So the way to always make sure that we don't run into this issue here is the following. We could either go say 5 minus 1, okay, which will always remove the last, which will always make sure that we count 0 here, right? Because it's going to take the length, which is 5, and we're going to say minus 1, okay? So remove the last one, and we save this and run, and then we have no problem. As you can see, it goes through. Let me go ahead and comment this out so we don't have that. Let's run real quick here. And we should have indeed 2, 4, 5, 6 items here showing. Okay. So if this works, the best way for us to be safe, because we may end up changing the size here, right, to something else. This is also printing, that's why we're getting that 6. We should get 5. But anyway. Save again and run. We should get 5 items indeed. All right, so there we go, 2, 4, 5. Very accurate now. All right, so now the best way of doing this, because like I said, we could go back again and change the size here, which means we have to come back here and change everything to look good so that we don't run into issues. The best way to do here, because the range here says 0 through the size of our array. That's what we are trying to do here. We want to iterate through the entire array. Well, likely our myArray object here has a method or function called size. So if we say myArray, array, what do we call it? Yes, myArray. Say myArray dot, look at that. Now we have this size, so we can use it. Okay, so now that we have my array size, we're still going to have a problem if we run this because it will get the whole size, which is 5, okay, but not include 0. So we need to go ahead and say minus 1. That way we are going to be safe because the actual size of the entire array, including 0, will be the whole size 5 minus 1 to include all of these items, including 0. Okay, so now save this and run. We should indeed be safe, and it will show us the entirety of all of the items inside of our array. Which means if we go here and decide to change this to 6, right, and add here my array 5 is equal to 1000, save and run, we should not have issues here. We don't have to change anything because it's just going to get the size of the array that we created. So we can add as many, and this will always work, as you can see here. Okay, that's one important distinction between arrays, because it can get a little bit confusing at times. But always remember that. To subtract 1 if you want to include the 0, because then it will get the actual range as opposed to an out of bound exception. All right. Okay, perfect. I'll see you in the next video. The next data structure we're going to look into is called the array list. Okay, you've seen array list before. So an array list is just like an array, but is a little bit more flexible in a sense that it allows us to do a little bit more than plain arrays. All right. Okay, let's go ahead and create a new file here. I'm going to call this array list. And I want you to notice something that I have pointed out earlier here, how everything seems to be an object. If you're coming from Java, you probably started noticing right away. Okay, so I'm going to go ahead and say fun. In fact, let me go ahead and copy all of this so I don't have to type all of that again. And I'm going to delete anything inside here. Okay, perfect. All right, so here we go again. I'm going to talk about array lists this time. So an array list is what I call the improved array. Okay, so an array list allows us to do a lot more than just plain arrays. So how do we create an array list? Well, we say var. I'm going to call this my array list. You can call it whatever you want, and I'm going to go say array list like that. And notice right away, as an array list for Kotlin, we have here in the first, we say enter, we have to pass the type. So it's a generic type again, right? So in this case, we can have an array list of any object that we want. In this case, we just want a string array list. Okay, just like that. So now my array list here object can be used. So we can go ahead and say my array list dot, and look at that. The moment we say dot, we have a few methods we can use, or functions that we can use to access or add things to our array list. Let's use the add. Add just accepts either an element, string type, because we said this accepts strings. And notice we have two flavors here, right? So the first one, we can just add an element. In this case is a type string. Okay, or if we want, we can actually add an index and the element we want to add. So we could say, for instance, index 0, I want to add string Paul, or index 10, I want to add string James. Okay, and you also notice we didn't have to specify the size. That's one of the beauties of array lists. We don't have to specify the size if we don't want to. That means it's very flexible. It can be very big or very small. And you also notice, like I said, now we are able to use method or functions to do things with our array list. In this case, we're using add. Let's go ahead and just add a name here, or a string object. Let's say James, like that. So if you go say print ln array, we can say my array list dot 0 at index 0, right? Let's save this and run, and we should see says array James. In fact, we don't need this array here. We can go ahead and run again, and it says James. Now, because this is the first item that was added, it was added to the first index. And we can keep doing it here. We can say my array.add. I can say, for instance, Paul. And of course, that would be added to inside of the second index. Let's run this. And we should see Paul. So we use the get, and we pass the index. Now, to iterate through, we can go ahead and say for. In this case, I can say names, that's the variable. In my array, I can say print line names, and I can say names, like that. If we save this and give it a run, we should see all of the items inside of our array list. See, names James, names Paul, and of course, because we had this older print line, it also showed Paul at the bottom here. And of course, here we are iterating through objects, okay? And we could have also iterated through actual items inside of our array. So we could have said, for instance, for index, like that, and say in. I could say my array list. I could say 0 through my array list dot get size. See, now we have get size function we can invoke, right? And we can then say print ln. If I can type, okay, there we go, print ln. There we go. And I can say my array list dot get, right? I can pass then an index here, which is in this case index. Okay, so now I'm going to go through, iterate through, and get all the items. Just the same thing we did here, but now I know at least I'm going through index explicitly. Okay, I can say here items like that. Let me go ahead and comment this out so we don't have all of these print lines showing. Let's go ahead and run this. Aha, now we have the same problem here, right? So we need to go back and say -1, so that way we don't have that issue of array index out of bound issue here. Let's run again. And there we go, items James, items Paul, and so forth. And let's we can go ahead and keep adding, say that add, we can say Bonnie here. If we run, we should see Bonnie added. And there we go, there's Bonnie. And because we're talking about array lists, so we have more flexibility, there's other things we can do here. We can say, for instance, my array dot contains, you see there is this method here. We can check if this array list contains a certain string, okay? And if that's the case, we can do something. So we can go ahead and say if my array list that contains Bonnie, I want to go, oops, let's see, Bonnie, I want to print ln, she's beautiful, like that. I'm gonna go ahead and comment this out, give it a run. Right, so it's going to go through our array list and find if there is such thing, or if contains an object, string object, Bonnie, and it will just print she's beautiful. So look, as you can see here, we have she is beautiful. Right? Things that we can do that we weren't really able to do otherwise. So what else can we do with my array list? We can remove, right? We can say, for instance, my array list dot remove. Right? So in this case here, we have different flavors of remove. We have remove all. We can remove all of the elements in our collection, in our array list, or we can remove just an element, right? Or also we can remove at a certain index. So we have to pass an index. Now let's start with remove an element here. So we can pass the actual string we want to remove. In this case, we want to remove James, right? If we save this and let's go ahead and uncomment this line here so we can see that indeed James was removed. If we run, we should see that James was removed. See? Now we don't have James anymore because James was removed. We removed James. The other things we can do here is we can set. Okay, so we can say my array dot add. We can just add an element. We've done this. Or we can just add by passing in the index where we want to add that new element and pass the element, or we can use the set method here. Okay, let's go like that. Set will take an index. Let's say we want to add a new element on index 1, which means Paul. So we say 1, and then we pass what we wanted to add. We say here salmon, like that. Okay. Save this, and if we give a run, we should see salmon instead of Paul. And there we go. There's salmon, right? And Bonnie. Wonderful. All right, so you learned about array lists here, and they're very simple to use, as you can see. So first thing, you have to create a variable, of course, and then just say equals array list, and we have to pass in here the types, right? Remember, we're talking about generics here. This array list is a generic type, which means we can be more flexible. We can pass types, string, integers, booleans, anything you can imagine, even our own object or classes that we create. Okay? And then we can say add. We can add items, we can set, which means we can add elements inside of specific index. Okay, and of course we can check to see if our array list contains a certain object or certain string in this case, and if that's the case, we can do something we want. We can remove items and so forth. Okay, we can also iterate through objects if we want, and we can use this other way of iterating through as well. All right, it's a lot of fun here, so go ahead and play around with this concept, and I'll see you in the next videos. Alright, so in this video we'll continue talking about collections. We talked about array lists, arrays, and now we're going to talk about another collection type called hash map. So a hash map allows us to have a structure that allows us to have key value properties. Okay, so for instance, if we want to have something like this, 1 as the key and the value would be Mary, like that. Okay, so we have a key, 1, and Mary as the value. Or if we wanted to have something like Mary married, okay, something like this. So this would be a dictionary or a key value pair. Okay, so a key and we have a value, right? So that's what a hash map allows us to do. So what I'm going to do here, I'm going to copy all of this and create a new source or a new file, Kotlin. I'm going to call this hash map. All right, I'm going to paste it all in. And as usual, we're going to delete all of this because we're cool like that. And I'm going to make sure here I said hash map. It's called key value pairs. All right, great. So again, how do we create a hash map? Well, we're going to go say var. Let's call this hash map. It's going to be equal to hash map, and you notice right away we actually have a class called hash map. And notice something very cool here. So hash map, we have angular brackets k and comma and then v. What that stands for is that in our angular brackets, in this structure, key value structure we have here, we have key. Well, k is for key and v is for value. That's all. So we go enter, and then here we're going to pass a few things. Now it's going to tell us what keys, what types of values we're going to put for key and for the values. Well, for the key, in this case I can say string, and for value I'm going to also say string. Okay, of course I'm going to make sure that I have there my constructor. Okay, I'm having a problem here. Oh, hash map. There we go. All right. There we go. So we are good now. So with hash map now, we can say hash map dot put. That is the method instead of add. As you can see here, say key is a string type and value is also string because that's what we specified in our angular brackets here. Okay. So let's say we want to say the string is going to be Mary and the key is going to be married. Okay. Hash map that put Paulo, that's the key, and the string is going to be married, or the key I mean. And let's copy this and we can do the same thing here. Let's say John is, I'm gonna say single. Okay, can easily get those values. We could say print ln. We can say then hash map dot get. Right, you see here get, we can pass the key and we pass here, for instance, Mary, and we save this, right click and run. We should see the value for Mary. In this case will be married. And see, it says married. If you wanted to get John, we run this. We should see single. It's very important to realize also is that the moment we say string, when we create our hash map, this is very important because obviously we cannot put an integer here, right? Because we specified that we want strings. Now, here's the trick. If you want this to be any type of object, you can go ahead and say any and any like that. So the any keyword is a Kotlin keyword that means just a very generic object. In this case here, check this out. I can actually put 1 here or 2 or whatever we want, and this will still work because this just says any object, any object. So for key can be any object, for value can also be any object. I don't recommend doing it this way because it's just very generic, but in cases that you need to do so, that's totally fine and works flawlessly with no problem. Okay, so any again, right? But in this case we just want string and string, and right away you see we have a problem here because it's saying that we need to make sure we have a string here. Okay, that was Mary. Now for us to be able to iterate through our map, our hash map, and get all of the items, we can do the following. I'm going to go ahead and do that. I'm going to say for So I'm going to use a key. So I'm going to use the key. So I'm going to go ahead and say k in hash map dot keys. Okay. So now I created this variable k, and I put all of the keys of our map here, hash map, into it, which means now I can say print ln, and I can just print here, say map or hash map dot get, and I'll pass the keys. Which keys? This key here that we have created, just like that. Okay, if we save this and give it a run, we'll get all of the items. Okay, so we have married, single, and married. Okay, so we got all of the values of our keys. Right? So anytime you want to have a key value pair data structure, then you should use a hash map. Okay, because now you can put, for instance, the key and the value. And this can be used in many situations. For instance, if you're building a game and you want to map users with their score, you can very well create a hash map like this, right? So it could be, the key could be the username and the value could be the score. Perfect. So play around with this concept again, and I will see you in the next video. Alright, so up till now, when we talked about the collections such as hash maps, array, and array lists, those are what we call, they are under the collections package, right? It's collections package. Now, up until now, when we talked about all of the collections such as array, array lists, and hash maps, we were talking about, I showed you the general way of creating those, which means there are more towards the Java way of creating those collections such as hash map, array, and array lists. Okay. Now I'm going to show you in this video how to create the same collections such as arrays and hash maps, but in native Kotlin way of doing things. And the other thing I have to tell you, and I'm sure you've probably picked that out already, is that Kotlin is very related to Java. In fact, it runs on top of the JVM, which is Java Virtual Machine. So all of this code is actually translated into Java in the background. Okay. So you can use interchangeably Java and Kotlin together interchangeably. But since we are focusing on Kotlin here, I should also obviously show you how to do the same things strictly in Kotlin. This is still Kotlin, but the syntax, when we say hash map like this, we are borrowing from Java. So I'm going to go ahead and say here Kotlin collections example. Okay. I'm going to go ahead and copy all of this, put it here, and I'm going to go ahead and get rid of all of these as well. Okay, let's start with array. Get rid of all of that. All right, so we now have an empty. Here's how we create an array list in Kotlin. We simply say, we're going to say var my array list, and we say list of. As you can see, there it is. It's called list of, and you can either say the type, pass in the type of list you want to add. In this case, we can put strings, just like that, and then we can go ahead and pass the list. You can say me, James, Bonnie, life, see, whatever you want to do. Okay, and of course the way we access is pretty much the same. We can say print ln. If we pass my array list like that and save and run this, we're able to see me, James, Bonnie, life. Okay, all of them we have here, our array list. Okay, now if we want to go to access a certain item, we can say like that, and we can pass the index. In this case, if we want index 0, so the first item, if we save this and run, we should get me. So essentially we can do the same thing as we did previously. Okay, but you can see now the difference here. We said array list here when we created previously var, and we say array list and we pass the type, and of course then we're able to say my array list that add and so forth. And of course we can still do the same thing, but you notice there's difference now here. Instead of saying array list, we say list of. Okay, just small differences. And obviously because we said this will only take strings, if we try to put 67, now we have a problem because we said this list will only hold strings. The other way we can do this is actually get rid of that. That way, it just assumes you are going to be passing in objects of any type. You notice now we don't have any error here. So we can put any type and we should be good. Okay? So if you want to explicitly say the types you want to accept, you put the angular brackets and put a type. If not, you just remove it altogether and still works. In this case, we're just doing strings here, right? We can still do for loops to iterate through. We can say for items in my array, like that. And we can say print ln. You can say items. And I'm going to say items. Okay, if you save this and run, we should see all of these printed out. And there we go. It's me, James, Bonnie, life. Now, if we wanted to programmatically add something else to my array list here, like this, my array list, and let's say we want to add inside of index 0, a different name, Paul. Now we have an issue here. The problem here is that when it comes to Kotlin, when we talk about list, right, the array list or list collection, we have two options. They can either be mutable, which means they can be mutated, they can be changed, or immutable. That means you cannot change. So the default is immutable, meaning you cannot change this on the fly. You can add as many as you want, but then later you can't change. As you can see here, we are not able to add anything, right? So this, we're going to call this default is always immutable. Now, if we want to make it mutable, guess what? We can actually say in var mutable array or mutable list, okay? And we're going to say this mutable, there we go, you see, mutable list of. And if we want to make it a string, we can then go ahead and say me, day, James, something like that. I'm going to go and clear all of this. Okay. Now, if we just change what are we running here, put it here, so now we are going to be able to run the mutable list. Let me go ahead and get rid of this because it's not possible. Let's go and run right away. We should see me, day, James. Okay, so me, day, James. Now, if you wanted to add something to, for instance, inside of index 0, we can gladly do that. We can easily do that by saying mutable list and say 0 is now equal to Paul. Notice now we have no problem because we said this is now mutable, meaning we can change it if we wanted to. Okay, so let's save this and give it a run. And there we go. Now, index 0, we have Paul. Now, the same way we have this list for array list, we can also do the same with other collections here, which we talked about, was the hash map. Okay, so for hash map here, we're going to go and say, for instance, var my hash map is going to be equal. Now we call this hash map of. It's the same thing as the hash map in the previous video that I showed you, which was more Java based, but this is native Kotlin. But you notice it's the same idea. So hash map here, we can pass the types. In this case, I'm not going to pass any type. But now look what's going to happen here. For hash map, we know is key value pair, right? So we have to have a key and then a value. So we're mapping things here. And we go like this. 1, we say 2, okay? And then we pass the value, say Paulo, for instance. Okay, so now we have the key 1 to Paulo, which means the key is 1 and Paulo is the value. We can keep doing this. 2 to James. Okay, and of course to access, we can say my hash map. If we want .get, right, we can pass the key, say 1 for instance, and that would print, let's say print ln here, like that, and it should print Paulo. Let me go ahead and let's give it a run, and we should see Paulo showing. And there we go, Paulo. Still showing me here because we still had this running here. Not a biggie. Okay. And you probably have guessed we could have done the same as well with array of. So arrays, right? We can say var my array is equal array of. Okay, I can pass here 1, 4, 8, 10. Okay, now we have my array. Let's see. So if I say my array and add on index 0, if I say 2, that 3 works, right? Because now if I go 4 items in my array, print ln, I can go ahead and say items, and say items like that, and run. Should see all of these numbers. And there we go, 3, 4, 8, 10. So one big takeaway here is that when we create our list, array list, in this case it's going to be list of, just remember that the list of is immutable, meaning you can't add anything to it once you have instantiated it. Okay, you will have to create a mutable array list, in this case mutable list of, and then you'll be able to add items. Okay, that's the main takeaway point here. And also in hash maps, the syntax is different now, right? Now we say 1 and say 2, the actual word 2, and we give the value. And we can give as many as we want. Perfect. So again, go ahead and play around with this concept here. And if you have any questions at all, you know what to do. Ask them away. Okay, I'll see you next. All right, welcome back, folks. Welcome back. We're making a lot of progress here. Now, the next thing we're going to be talking about here is a very fun topic in a way that now we are going to be able to do a little bit more. Up till now, we've been doing a lot of studying, a lot of learning the language, trying to make sure that we understand the syntax and how things work with Kotlin. So in this section, this video here, I'm going to start showing you how to write things to file. Because we're talking about devices, right? As we create applications or create programs using Kotlin, we are running these applications on devices, in this case on our computer, okay? Kotlin also has libraries that allow us to do a lot of things, such as writing to file, reading from file, and do all sort of cool things, right? So here what we're going to do, we're going to create a new file here. So file, new, Kotlin class. I'm going to call this write to file. Okay, so we're going to start learning how to write things to file, to our computer here, right, in a text file. Okay, so we're going to say fun main args array string, like that. Okay. So why would we even bother to write to file or write to a text file that it's saved on our hard drive? For instance, if you are building an app that is supposed to save the state of the game, right? So that when people come back to play your game, you want to show them the status of their previous game, like the points, the lives, like the score or the lives and so forth, right? How would we get that information? There's different ways to save information for later use. In the most basic way of saving things would be to write to a text file. Okay, so that's what we're going to be learning here. Now, as an example here, I'm going to create a new function here. You know how to create function now, so I'm going to create fun. I'm going to call this write to file. And this function here will take a string that we want to write, right? So we're going to call this message. It's going to be type string. So to write to file, we need a class that does all of that for us. Likely, we don't have to create that whole class from scratch because, again, like I said, we have classes that come pre-built with Kotlin that we can just invoke those classes and it will do all the work. Okay, so the class we're going to be talking about here is called file writer. So it's a class that has all of the methods or functions that allow us to write to a file. In this case, we're going to write to a .txt or a text file. Okay, so what we're going to do, we're going to say var writer is equal to file writer, and right away you have here, it says here file writer, okay, like that. And you notice this file writer here is actually being borrowed from Java, right? Because let me go back here, say file writer, there we go, it's being taken from Java. Again, going back, remember that Kotlin and Java are brothers and sisters, okay? So there we go. And what we need to do here is that we need to pass the name of the file that we're going to be writing to. In this case, we are going to call this message.txt. So we have message.txt. txt is the extension needed for us to, for the system to know that, okay, it's a text file, a very simple file that we're writing to, okay? So here what we're doing, we're establishing the file to which we are going to be writing to. Okay, so now we have a writer here, we can start writing. Okay, so how do we do that? Well, we say writer.write. Look at that. Okay, there's different flavors here of constructors, but we can just use this one here, which we're going to pass the string. The string we're going to be passing is the message, right? Which is what's being passed via our parameter here. Okay, so our writer, we say that write, and we are writing the message that we're going to be passing. Now, here's the thing. As we do all of this, as the writer goes and creates this message.txt and then goes ahead and writes and does a lot of things in the background, things can go wrong. Okay? So it could be that this message.txt here file was not created in the hard drive, or maybe the file's corrupt. I mean, there's all sort of things that could happen. For that, we have to include these or enclose these into a try and catch exception. Okay, so what we do here is we try. So we're going to enclose this, put all of this inside here. And if we are trying, we need to catch the exception that may happen. So we really haven't talked much about exceptions. So exception is just error handling. Okay, as our programs run, things could happen. Errors happen, and we want to make sure that if we are creating an app, we want to make sure that if something happens, the app fails gracefully. By that, I mean it just doesn't crash and our users using this app get mad. Okay? So it's always important in cases where you're writing or reading files or doing certain network connections and so forth, always put it inside of a try and catch, because this will go ahead and try, as the name implies, go and run this. If it doesn't work out, it's just going to halt and stop, and then call the catch. We'll catch the exception, the error that we're talking about, and then we can do something with it. Okay, so in this case here, we're going to pass EX of type exception. Okay, just a general exception, and we're just going to print ln here, say exception. I'm just going to pass our EX just like that. Okay. All right, so now inside here, this is where we are safe, presumably, of course. My friends, this is all. So we writer.write, write the message, and we're done. But because we're talking about a writer, we need to close this writer here. You can say writer.close. Because this class here does a lot of work in the background, of course, and as it does its work, we need to make sure that once it's done, we give back the resources that we have been taking. It's a very extensive work that's happening in the background, and once we're done, we need to take that memory we've been using, give it back to the system. Of course, in this case, it's just going to be a very small message that we're going to be writing, but in a bigger application, this can take up a lot of memory, and we always want to close this work. Okay, so give it back to our system. Okay, and that's it. So what this means is that we can go to our main here, create a variable called message, and we can say hello world, like that. And then we say write to file, and we have to pass our message, and there is the message. Okay, let's save this and right click and run. We should expect to see a message.txt being created, and inside of it we will have something. And you notice there's nothing here showing because we didn't print out anything, but we should see message.text, and there we go. You can see here it says message.text. If you click on that and look at that, it says hello world. Okay, so we can go back here and change it, say something else, say for instance new message, save and run again. So it's going to run this, add the new message inside of our message.text here, and there we go. See, it says new message. Very nice. Congratulations. So look how simple this was, right? We just have a writer. We create the message.text, the name of the actual text file, and you just say writer, and then we just say writer.write. So we invoke the function write, and we pass the message that we want to write into the file. And then, of course, we close. That's it. Go ahead and play around this concept here and see what you can come up with. Okay, create different files, write different messages, and so forth. All right? Okay, go ahead and do that, and I'll see you in the next video. All right, perfect. So I hope you were able to go through and add new messages and play around with this concept here. So the next thing we're going to do here is the following. You notice something here. As we add strings or message to our message.text, you notice that every time we run, when we change, let's say we put 1 here, save and run, you will notice something. Let's open our message here. You'll see here, we'll change to 1. There we go. There's that 1 there, okay? But what if we want to make sure that each time we add a new message that it's actually appended? So in order for us to be able to append, so each time they add a message or a string, instead of rewriting everything, we want to be able to append it, right? So if we go the first time, it's going to see a new message. Second time we change, it's going to be that new message at the bottom here. For us to be able to do that, we need to actually add a new parameter into this file writer class here, constructor. Okay, so if you go comma, you notice there we have file name, which we already did, right? And now we have the append, which takes a boolean, so either true or false. In this case here, we are going to say true because we want to be able to append. The moment you do that and save, let's go ahead and run. Let's change the message here to something, message 2. Okay, let's just focus in here. So I'm going to run this. I'm going to open our message text. You should see what's going to happen. And there we go. Now we have new message 2. Okay. Now you notice it appends on the same line. If we wanted to make sure that anytime something is appended, it appends on the new line, we can simply add. So here, where we're writing the message, we're going to append like that and put \n. So this signifies go to the new line each time we write a new message. Okay, so it will be appended in a new line. If we save this and go ahead and run, oh, there we go. So now it says message 2. New message 2 is indeed in a new line. So let's go ahead and delete all of this. Save. Go ahead and run again. Maybe say message 3 here. And run. Let's open here. We should see message 3 showing at the bottom here, if all goes well. There we go. So new message 3 is indeed over there. All right, so we have that working. Now, what if we wanted to make this a little bit more dynamic, right? Because right now we have this static message that we add ourselves. We have to type it in and all that. What if we wanted to make sure that each time this message is being added is actually added from a user input, right? So let's go ahead and make this a little bit more dynamic where users can add input here on the console, and then we take that message and we save, right? So what we're going to do here, in fact, we are going to do the following. We're going to go ahead and say print line, say enter a message, like that, and then we're going to say var message in this case. In fact, we're going to just copy this and put it all here instead of just hard-coded message. We're going to go and say read line dot and then toString, just to make sure taking whatever we're getting from our console and make it a string and put it in our message. And then, of course, we write it. Now, the next thing we need to do here, because we're smart developers, we're going to do some validation here because we don't want people to just not put anything inside of our console and we write an empty string here. So what we can do, we can say if, okay, we can say message dot equals, okay, we can use the equals function. We can just say like that is empty, so there's nothing in there. Then we're going to say println, please enter a message. We're going to say else. We're going to just go ahead and put it here. Okay? So if message equals nothing or empty, we're going to say, hey, please enter a message. Else, then we know this message has something. So they've entered something, and we're going to just go ahead and save that message. Write that message, okay? Go back here. I'm going to just go ahead and delete all of this and save that so our file is completely empty. Okay. And let's go ahead and run once again. There we go. Enter message. I'm going to say hello world. The moment I say enter, I go to here. We see hello world there. Very nice. Now check this out. If I run this again, enter message, I can say next message added and enter. We go back. It says here next message added. Okay, so we can continue doing this. Let's go ahead and run it once again. What is next? Enter. And you can see what is next. Very nice. We were able to make this a little bit more interactive to where now we can enter messages and we can retrieve those messages and add them into and write them to file. Now let's run once again and see what happens when we don't enter anything. Right? The moment we do that, it says, please enter a message. Perfect. So we were able to get this to be a little bit more dynamic. All right. So I'll see you in the next video. Now that we're able to write to our text file, well, naturally we need to be able to read from it. So I made a few changes inside of our text message, inside of our message text here. Essentially just I cleared everything and added a new hello world here. Let's go ahead and run again so I can add something else. Are you there? And we should see you were there. There we go. Okay, at least we have two there. All right, so how do we then read from file? Okay, so we're going to create a new function here. Let's call this read file. And we don't have to pass anything because we're just reading something here. Okay, all right, so first thing I'm going to do, remember again, I'm going to put all of this inside of a try. So I'm going to say try catch. Okay, just make sure when things go wrong, this application doesn't just crash. And here we are going to say EX for exception. I'm going to just make an exception type here. I'm going to say print EX.message. Okay, so we're just going to print out a message of whatever issue we end up having. So at the top here, what I'm going to do, I'm going to create a new var. I'm going to say var reader is equal to file reader. Okay, that's what we need. And we need to pass the file that we're reading. In this case, we know it's going to be message.txt. So I'm going to say message.txt. And it has to be exactly as we have specified in our file. And for now, I'm going to create a var read message variable here of type string. And I'm going to make it null for now. And the next thing, I'm going to say var char of type int. So this is going to be a character. Okay, and the reason why we're doing this is because as we read items from our files, as we read all of these, they actually come in as a stream of bytes or stream of little characters. Okay, so byte is another type that allows computers to create streams of messages. Okay, so that's why it's a type of int we're creating here called char. So this will go ahead and capture each character inside of our file here. So now inside here, what I'm going to do, I'm going to say do while. I'm actually going to do the do while. And the while is going to be empty for now. So what we're going to do here is the following. I'm going to go ahead and set char, right? This item here I have at the top. And I'm going to say reader. This reader here because it points to file reader which has our file to read. So it's ready to be read. So we're going to reader.read, just like that. Our char here has the stream of bits, a stream of bytes flowing. Okay, they're not readable, so they're not string, they're not character yet, but they're just bytes. So what we need to do next here is to convert this stream of bytes, of integers, to something that we can work with. In this case, we're going to just convert it to characters, okay, to chars. So we're going to say print, and we're going to say char dot to char, to character. So we're converting these bytes, okay, into character that we can see. And here to finalize our while, we want this to work or to go through while char is not equal to -1, which means while we are not at the end of this file, we will keep going. The moment we get to the end of the file, we'll then stop. That's what we're doing here. because -1 means the end of the file. Okay, perfect. So let's go ahead and call this for now, just to see if things are actually being shown. So for now, what I'm going to do, I'm going to go ahead and comment that out, and I'm going to call read file like that. Okay, let's save this and run and see if we're going to be able to read anything. Okay, so there we go. It says, hello world, are you there? So that's exactly the message that we have here. Now, let's do something here. Notice if we go ahead and say, instead of saying print, we say print line. If we save this and give it a run, this is just something small that I would like to show you. Not a big deal, but just a little distinction. So notice now we have all of our messages showing here, but it's all in the new line. So the print line, as the name implies, it puts everything in a new line. Since these are coming as one character at a time, it indeed goes ahead and print one character each new line. So if we go ahead and put just print, then we're going to be able to print the whole thing in one line, which is exactly what we want. Okay, so that small distinction here there between print and print line. All right, so there we go. We're able to read. All right, and we have write to file. And I have this other method here that I created and I commented out. It will do the same thing, read from file, but it has a different way of doing things. So I'll just keep it here for you to play around with. So we can uncomment this and call this read from file at top. You'll see that it will have the same results. As you can see, there's less code than this read here, but it does the same thing. So as a homework for you, go ahead and try to see if this makes any sense, okay? And figure out what this is doing. Write to file and read from file. Well, now you have a lot of tools that you can use to create pretty cool programs here. All right? Okay, perfect. So I'll see you in the next video. In this video, we're going to build a fun little application, a little program here that will prompt the user with a menu. So 1 to write, 2 to read, 3 to exit the application. Okay, it's just a very simple app here that will a feature that will allow us to solidify what we've learned about reading and writing to files. Okay, so I'm going to go ahead and create a new file here. Kotlin, of course, and it's going to be app read write, like that. Of course, I'm going to go ahead and do the following. I'm going to say fun main args array string. Okay, and I'm going to create a few functions here. Say fun. I'm going to call this menu. Okay, and fun read file write to file. Gonna have message here. It's type string because we already have the same name here. We're gonna say write to file. There we go. And I'm gonna call this fun read from file. Should end up with a problem here. Yes, that's what I thought. Let's just change that so that we don't have issues with the naming. Okay, so there's 3 functions here. So the menu here will just prompt users get information. Okay, so what we're gonna do here is the following. It's gonna say print ln. I'm gonna say, I'm gonna go ahead and open a new line. 1 to write, read, 3, exit. Okay, something like that. Let's go ahead and copy this and call it inside of our main method here to see if things are actually going to work. Let's right click and run. We should see at least this menu displaying there. And there we go. Enter 1, read, 2, enter 1, write, 2, read, and 3, exit. In fact, I don't like this fact that all of them are in separate lines. Let's get rid of this. I think I want them to be in the same line. I think it's better. Okay. Let's run once again. Okay, that's actually much better. So not a lot of spacing. All right, so once that happens, then we're gonna go ahead and say print ln, In fact, now I'm going to give a new line so we have a spacing here. So println, I'm going to say var choice is equal to read line. I'm going to make it to int because we want to make sure that whatever we're getting is going to be an int. And just to make sure here, we're going to put 2 exclamation mark to make sure that null is okay. Okay, there we go. So now we're getting int choice here because if they say 1, it's going to be to write. If say 2, to read, 3, exit. Okay, and now we are going to use the knowledge that we have of when. I'm going to use the when expression here. So we're going to say when. Okay, so when choice, that's what we're going to use to iterate through. So when choice is 1, well, we want to say println, and because we're going to have a statement here, we're going to go ahead and do the following. We're going to say println enter message, and then we're going to create a variable here. And then at top, we're going to create another variable here. We're going to call message. It's going to be type string, and so we're going to say message is equal to read line to string because we want to make sure whatever we're reading is actually string. Once that is done, we are going to call our write to file method function, and we're going to pass the message. Okay, and in case of the read, so number 2 here, we're going to go say in case they have chose 2, we're going to go to following. We're going to do say println. I'm going to just say reading, and we are going to call read from file. In fact, it has to be write to file because we don't want to call that old one like that. All right, and then we'll read from file. In case of they say 3, then we're going to say println exiting, something like that. So if they go ahead and say select 1 or enter 1, we're going to say enter a message. They will enter a message, and we'll take that message and write to file. If they say 2, we're just going to go ahead and print whatever they have entered, whatever we have. Okay. And 3, if they say 3, in this case, we're just going to say exiting. Very easy. So now we have to implement our write to file. Likely we don't have to write everything again. We're just going to go ahead and copy. So let's go read to file here. I'm going to copy this and put here. That's all good. And write to file. I'm going to go get all of that code as well. Okay. And paste in there. Now let's go ahead and change this text file here to something else. Let's say app reader, something like that. And of course, let's make sure we copy the same when we read from file. Otherwise, we're going to end up with a lot of issues. Okay, and we don't need this. All right, perfect. So it looks like we are ready to roll. And notice because we already had that code, we shouldn't be copying code. It's bad programming practice, but in this case that works. Okay, that's fine. Because we had that code already, we just copied and paste and it still would work. We just changed a few things here. So we call app reader the file name where we're going to be writing to. And I think we're ready to go. So now we just have to call this method. In fact, it's already called. So now let's test it out. Let's go ahead and save this and give it a run. Gonna make this bigger. All right, say enter here a choice. I'm going to go ahead and say I want to write, right? Enter message. I'm going to say I love this app. Enter, and there it's done. Okay, let's run once again. 2, and you can see it says I love this app. Okay, let's go and run once again. Let's say I want 1. Enter message. This is a new message. Enter, and we're done. Run. If I want to read again, say 2. Enter, and you can see I love this app, the first message, and this is a new message is reading. Perfect. All right. So we took all of the things that we've learned and we created a very dynamic application, right? So we created a method here, a function. I keep saying method, same thing. A function here that prompts the user, gives the menu, okay, and then inside here we have the choice, reading the line, reading the input from the user, okay, getting that input and make sure it's indeed an integer, and then we have a message here, which message variable, which we then use that to add the message that they have entered, and we use that message and we write to file if that's the case. If the case is that we want to read, we then just call the read from file. If not the case, we just print the exiting. Okay, so very modular, very cool, and I'm sure you can manage to create something way better than this. Okay, and if you do, please share it with us. I would like to see what you come up with. All right, thank you so much, and go play around with this concept, and I'll see you in the next video. All right, welcome back. So in this section here, we are going to start our Android development with Kotlin. I know you've been waiting for this for a while now, and if you made to here, congratulations. You must be really eager to get started. So there are a few things we need to do first. Of course, we need to set up our machine. So the first thing we need to do is to actually download the Android Studio IDE, which is the tool that we're going to be using to create Android apps using Kotlin. Okay, so what we need to do, go to Google and type in Android Studio like that, and we should see a link here, preferably this one that says developer.android.com. That's the Google Android official developer website. So we're going to click there. And if you see this 2.3.2, I'm on a Mac here. If you're on a window, you will see it's going to be a link for the window platform. This is what you see depending on when you start working on Kotlin here. We would need to install a different Android Studio, which is the Android Studio 3.0. Okay, as of the recording of this video here, it's not ready yet, but we can find it as a developer preview. So what we need to do is to actually say, go here, it says preview, click there, and then it will get you here. Okay, to where you can see it says 3.0. I'm going to go ahead and download it, but before I do that, I'm going to take a little look here. Read says here, get early access to the latest features and improvements in AS by downloading this preview version here. The Android Studio preview can run side by side with your stable version, so you can work on the same projects in both versions. So that's really good because I already have the previous version here, which is 2.3.2, okay, which is the stable version. Okay, so go ahead and say download. And of course, we have to accept certain conditions here. Just go ahead and click there and say download, and it should start downloading in no time. It may take a little while depending on your internet speed, but I'll come back when all this is done. In fact, it should probably be done in a second here. Go ahead and follow some instructions here because I want to make sure that I install both the stable version and this version side by side. And if you're on Windows, this is what you're going to do to follow these instructions, if that's the case, right? But most likely, you probably will just download this the first time. All right, so what I'm going to do here, I'm going to just double click, and this will unpack. All right, so it's all unpacked. I can see here, I've got the Android Studio preview. I'm going to just go ahead and put it inside of my applications folder. Go ahead and drag it and put it inside of my applications. There we go. Now if we go to my applications, so now that I have that done, I'm going to control space and find Android Studio preview. I'm going to run that. It should show pretty soon here. In your case, you would just go and find where you installed your application, and this should happen. I'm going to say open anyway. It'll take a few seconds here since it's the first time. There we go. So here, the first thing it says, okay, since I had the previous one, I'm going to just go ahead and use the same previous version's preferences. Okay, I'm going to say okay. And there we go. Now it's going to be starting. I'm going to go ahead and put my... There we go. And it's installing its things here, and it will take a little while since this is the first time. Just be patient and let it do its thing. All right, so this is what happens here. It's just asking me if I want to install Instant Run to allow things to run faster, and they strongly recommend it. I'm gonna go say an update. So now it seems that we are already ready to go. Okay, and in your case, you may have had a pop-up here that says some sort of update. Just click on the update and follow the instructions. It's a good idea, especially in the beginning, to always update whatever they suggest you to do. What's opened here, it's actually an old application of mine, and so we're gonna go ahead and get rid of it. What we need to do, we're actually going to create a new Kotlin Android application. So how you do that? Well, you go at the top here. You can't see, but it says File, and then you say new, and you say create new project. And here we go. So we have here this create new project window, which allows us to create a new project. And at the bottom here is very important. This is the location where you want to add your code, or where you want to your projects to live. Okay, so if you want to change, just click here and it will change. Now at the top here, we have the application name. In this case, we're going to start with Hello Kotlin Android, like that. And the company domain here, you notice it's customary to have a reverse domain name, meaning that you start with com and then you say my domain. In this case, I'm just going to go ahead and say go whole dot, and then you can pass here the name of the app. It's going to say Hello Kotlin Android. Okay. Now here is the target Android devices. This is where we specify which API levels or which Android versions we want to target. Notice one thing that's very important here: the lower you go, okay, the lower you go, the more people you'll be able to target, or the more devices you're going to be able to target. So the higher you go, obviously, the less people you're going to be targeting. However, the higher you go, the more features you also get. I usually try to get at least API 21. That's about 40.5%, which is ideally a good starting point. Now, if your application is very basic and you understand later, as you understand more about the APIs and so forth, you can play around with this. Okay, you can go lower if you would like, but about 20 to 21 is always the best bet. Okay, I'm going to go to 20, 21 like that. Right, and the rest is all good. I'm going to say next. Okay, and now here we have this screen here that gives us different activities, and we'll talk more about activity, but essentially a starting point that we want to start with our app. In this case, we're just going to go ahead and say empty activity, say next. But before we go even farther, let's go back here. There's something I forgot. Actually, here we need to include Kotlin support, obviously, because we are building this Android app using Kotlin. Okay, so we need to check this include Kotlin support. All right, so let's go next. We have that already done. Go next, and of course, let's go ahead and get the empty activity. Okay, say next, and everything is okay here. We're just going to go ahead and say finish. Okay, now you notice that our system here is working, which means it's actually creating our dependencies, all of our project files that we need to start developing applications. And to the left here, you can see we have a few buttons we can click, or tabs. Right, there we go. And what you know. Now we have our Android project here is now ready for us to use. We're going to open this Gradle file here, and we're going to go to build.gradle module app, this one here, not the first one, and we'll learn more about what these files mean. But for now, let's just set things up here. And we're going to go to build.gradle, double click, and this is what you're going to have. So next thing we're going to do, we're actually going to add an extension file here, a new library that will help us quite a bit. So what we're going to do, I want you to go to Google and say Kotlin. Okay, type in Kotlin, and this should pop up, kotlinlang.org. Click on that. All right, so at the bottom here, we should go and find Learn. So we go to Tutorials, and we want to go to Android here, Getting Started with Android Development. Click on that. It tells you all the things you need to know to get started. So essentially what we've done, okay, which is fine, okay, but we're interested in Kotlin Android extensions here, so click on that, and we're going to go here and copy this. Okay, we can say apply canvas and copy this. We're going to go back to our Android Studio, our beautiful Android Studio here, back to our Gradle, and we're going to add here plugin Kotlin extension. The moment you do that, this pops up. It means we have to sync our project again so that these updates are read properly. So say sync now. It takes a few seconds, and then we should be good. All right, so once we have that, I think we're ready to do a quick run here. Okay, so what I'm going to do, in fact, I'm going to go ahead and click on this activity main XML here, and at the bottom I'm going to click on the design because I want to see how things are actually look on the design, and we'll take a look more thoroughly on all of this, so don't worry too much about this. So we have this text view here, as you can see. When this application runs, we should be able to see this hello world here. Now, since this is your first time, you probably won't have an emulator, so a virtual device that will allow you to be able to see this application. Very simply, you can, to create a new virtual device, you see this button here at the top says AVD, so it's Android Virtual Device Manager, so click on that. If this is your first time, which I assume it is, you won't see any of this. Okay, that's totally fine. All you will see is a button in the middle here that says Create Virtual Device. So what do, you go ahead and say Create, and you pick something, you pick one of them here. I would make sure that you're under phone, not where, right? We're just under phone here. Let me pick one, how about Pixel, this one here, okay? And once you pick that one, say Next. Now, you notice here there's a few things. It says here at the top, you see it says O and says download. So these are all downloaded here. Now this O here, it's the newer one that I installed and it's not downloaded yet. So what I'm going to do, I'm going to go ahead and say download. And it says that we should download it because it makes everything faster. So it takes a few seconds. I'm going to go use this Marshmallow API here. Okay, I'm going to say next. And you can name whatever you want. I'm going to say Pixel API just as it is, and I'm going to say finish, right? And you can see there it is. You have your Pixel API here. All right. So I'm going to get out of here. Now, if you go ahead and click at the top here, this play button, green play button, say click, this will happen. So initializing ADB, so all of the devices. So I have a few here. You probably will only have one since we just created one. So I'm going to just use this one here that I always use. You can pick whatever you want depending how many you have. But again, you probably just have one. Just pick the one you have. And I'm going to say OK. And in a few seconds here, we should see this here. It'll take a little while and this will show up, hopefully. It'll take a few seconds since this is the first time. There we go. And what do you know? Hello world. Perfect. So you were able to run your first app, your first Hello World app. All right. And I know this first time it was a lot of work because we had to install and configure things. But from now on, this will be a very fast and quick process for you. So it's going to be very easy. Okay. So congratulations. You are now set to start building Android apps. All right, I can't wait to see you in the next video. All right, so the next thing we're going to do is we're going to talk about Android Studio. When this course was first created, we had Android Studio 2.0 or 2.2, if I'm not mistaken. But now we have Android Studio 3.0.1 as of recording this video, which is in February of 2018. Now, one of the things that you probably have noticed right now is that we must update our software very often. So if there is a new build patch that was released by Google, the owners of Android, then it's only wise for us to go and download the new stable one because they have tested it out and they've added other features that could be very beneficial to us as developers. So that's always a good habit to have. So what I encourage you to do now is to go to developer.android.com. Okay, as you can see at the top here. And what you need to do is navigate to find, in fact, let's go back like this so I can show you exactly how to do this. So you're going to get here to developer.android.com. And what we're going to do, let's go to develop. And then we go to Android Studio as such. Okay, this is where we can find the place where we can download Android Studio. Now, they make it very simple for us to actually download and install Android Studio. So if you don't have Android Studio installed, of course, you go ahead and click here. You're going to have this before you download terms and conditions, and you're going to have to say yes. And of course, you can't quite see here, unfortunately. There is a download Android Studio, which is now active for you to do so. I'm not going to do that because I already have Android Studio. In case you don't have already installed Android Studio, then you, of course, you're going to say download Android Studio, which is at the bottom here. Okay. Now, in cases that you already have Android Studio installed, what you need to do, I'm going to find my Android Studio here. So I already have my Android Studio up to date and installed. Everything looks great, but in case you don't, it's okay. So you go to Android Studio at the top, you say check for updates, just like we did before. And it looks like I have a few updates myself that I need to do. But in your case here, now the updates that I have, because I already have 3.0.1, it's showing me other things that I need to download here. So these are actually from Google repository. So I need to download the Android 6 or Marshmallow, Android 7, and so forth. Right? In your case, if this is what happens to you as well, please just click update now so that you can update whatever they're asking you to update. Okay, so I'm going to go update now. Of course, I want to bore you with the logistics here. I'm just going to stop this video and bring it back once all is done. And again, you may not need to do this. If you do, just follow the instructions as I did here. All right, all is done. I'm going to say finish. Okay, so everything is finished. You may want to restart your IDE, but in this case, I'm not going to restart it. Okay. So this is indeed our Android Studio. And of course, you can go back to Android Studio here, go to check for updates again, and we'll go ahead and look for what else you can update. And it says you already have the latest version of Android Studio installed. To configure automatic updates, you can go to set updates dialog for your IDE preferences and so forth. So always a good idea. And make sure you have 3.0.1 or 3.0.3, whatever you will have to update to when you start this course. Okay. The main point here is to always make sure that you are up to date. That is very important. And again, you notice the way this one looks here. My IDE looks a little bit different from perhaps what you are seeing on yours if you just installed the Android Studio. So to make your Android Studio look like this very nice theme, what you do, you find material theme. To do that, let's go just tap twice on your Shift key like that, and search will appear, and just say plugin. And you should see at the bottom here, we want to go to this plugin here. So plugins, and there we go. This is where indeed what you need to do, you just type in material theme. Now, if you don't have the material theme installed, you will have a button that says install. The reason why I have an install button here is because I already have the theme installed, which makes a lot of sense. So once you have that, just go ahead and say OK and follow the wizard, and you should be set, which means you'll be able to have it look exactly like mine here. And the beauty with that is that you can have all different options that you can use to change your whole IDE the way it looks. So it's pretty nice. Again, it's not a requirement, but I like it because then my code looks like this, right? Very nicely done, beautiful colors, and it's also dark, which is good for the eyes. Also, going back to our develop.android.com, where we can download our Android Studio, I really would advise you to also read more about the things that you can do with Android Studio. It's a very well done IDE, which was built on top of IntelliJ. Hence, it looks exactly like IntelliJ. If you go back to, so if you open IntelliJ, this is IntelliJ, and if you go back and open Android Studio, it looks exactly the same. It's the same IDE, except Android, or the Google developers of Android, they decided to take it and change a little bit, and but using the same base, which is IntelliJ. So that's why they call it an IntelliJ based IDE. Okay, so going back here, I encourage you to go and read more about the features. You can click here, you can see the features, everything you need to build on an Android. There's a lot of things you can learn here. So, and the other thing I will encourage you to do is to look at the user guide to get some ideas on how to use certain things. And we're going to learn all of this anyway, but you know, nevertheless, it's always nice to have different opinion or different view when learning something. That's the beauty of having Android Studio. Now, the other thing that I need to mention here is that developer.android.com should be the website that you will always have handy, because this is essentially where everything Android based is. This is where the Android people who create the Android software, the Android stack, live. This is where they put all of their code. This is where they put all of the features. Everything you need to know about Android, you should be able to find here, because this is the hub of Android. That's why it says developer.android.com. Okay, so it's nice to familiarize yourself with it, because this is where you're going to live for the next months, if not years. Okay, perfect. I'll see you next. So with the stable version of 3.0 and Kotlin, there's a few things that we don't need to do that we used to do. And you will see that in the next video. So this is the update for the next video that you're going to be watching. So there's still valuable material, of course, in the next video, but I want to give this update. That way you have that peace of mind, if you will, so you know exactly what the new things have happened since then. Okay, so I'm going to go ahead and create a new file here, say project from scratch. And here for my application, I'm just going to call this introduction. Okay, you can name whatever you want. For the company domain name, we're just going to use, in fact, you can say build apps with paolo.com, such, and then you find a place where you want to put those projects. So I have this portfolio folder, but you can click here and find other places that you want to put all of your projects. Okay, that's nothing different here. Now, it used to be, this is another thing, it used to be that we would have to put the reversed domain name here. I notice I put Paul. I'm not Paul, I'm Paolo. There we go. So the reverse domain name is what is considered the best practices when creating our company domain for our application. But you notice now we don't have to actually write the reverse one. So we write the correct order, and then here at the bottom says package name is reverse, right? It reverses everything, which is great. And if you want, you can edit there. See, that's small things, but nevertheless, they are helpful. And notice it's already clicked to include Kotlin support here. Okay, that comes with Android Studio 3.0. This is perfect. Say next. Here we are going to select the factors and the minimum SDK. So we are interested in phone and tablet. Now there are different levels of the SDK APIs here, right? So you can see we have KitKat, which is 4.4, Lollipop, Marshmallow, Nougat, and Oreo. We are interested in Oreo, of course, but that is the latest. However, you have to realize that the higher you go in the API, the less people your app is going to be able to target. Okay? So if you click here, you notice now it says here, by targeting API 26 and later, your app will run on less than 1% of devices. And you can click on Help Me Choose. If you click that, it will give you a very nice hierarchy and representing the percentages for each of the levels here, Android platform versions, if you will. Nougat is 25, level 25, API 25 is only 1.5% of people in the whole world who are using this. So the lower we go to 4, the more people we have. So Jelly Bean is about 99.2%, and KitKat is about 90%. And of course, the higher, again, like I said, we go, the less people we can target. So this is going to give you an idea of what to do in terms of, okay, is the features that you're trying to have in your application, are they that much more important than having more people using it? So that's something that you have to decide yourself. So generally speaking, I like to be at least in the middle, right? So let's say Lollipop is really good. Marshmallow is also good, so it's 39.3%. So there it is. But for now, what I'm going to do doesn't matter for now. I'm just going to say Nougat. That's totally fine. I'm going to say next. And I'm going to use this empty activity here. So click on that, say next again, and everything is good here. Just say next, and now our project will be created. Perfect. So we have our project here. It's a Kotlin-based Android application, and we have a lot of things going on here, which we will talk about as we learn more about the IDE and developing Android application. One thing that also has changed with Kotlin, with the stable version of Android Studio as well as Kotlin. So Android Studio now is 3.0.1. It gives us a few other things. Usually what we had to do before we had a stable version 3.0 for that included Kotlin, we had to do a few things in order for us to connect to the button. What I mean by that is the following. Let's go to activity main XML here. So we see we have our visual representation of our application. Okay, that's very nice. We have this hello world text here and so forth. So let's put a button. So let's click here and add a button to the top here. And we have these lines, these constraints that we can actually snap to make it so that the button is constrained according or relative to other objects or other items on the screen. And we will talk more about this, of course. So let's go ahead and double click and we can give this button a name. Let's say, hey there. And because we need a way for us to reference this hey there button in our code in Kotlin here, which you will see in a second, we need to give it an ID. I'm just going to call this button ID as such. Okay, just simplify. And you notice the hello world as a text also has a given default ID, which says TextView. Okay, so things are good here. Now, the thing that we had to do always, in order for us to reference that button, we had to facilitate our work, we had to go to Gradle, go to build that Gradle, this one app here, and then we would have to go and find an extension that we would have to add inside of our dependencies. Okay, right inside here, which will allow us, was an extension that would allow us to then bypass a few things, would allow us to bypass having to instantiate the button object, so this button here and this one, so that we can then do things to that button. Now everything is done automatically for us, meaning the moment we start typing inside of our own create method here, function, we can go ahead and just say button ID. Look, it tells us, it says button ID from activity main XML, which is this button here. So we're now referencing that button, which is what we want, right? So say button ID, and I can just go ahead and notice what happens. So it says import Kotlin X Android synthetic activity main X. So now it's connecting us directly. We don't have to create an object and then referencing it, in this case the button. We can go ahead and call the ID that we named our button directly. Okay, and I can simply say dot set on click. So I have a few options here, but I'm going to get the easiest one here, right? Click the set on click listener and look at that. And now I can also call this ID for our hello text here, which is TextView, to set it to something. So I can say text, look at that, TextView from activity main XML, and tells you here also is a TextView type. Okay, you can say that text. Now, there's two things you can do here. If you're coming from the Java perspective of things, then you are probably used to see dot set text and you pass text. Okay, now this still works, but this defeats the purpose here with what we're trying to do, because Kotlin is supposed to be concise and easy to read and quick, right, in our syntax as well. And you can see this will still work, but if you hover over, it says use property access syntax, which is different. Okay, so although it's going to work, we are going to do it Kotlin way, which is just say dot text and set it to something else. But notice also, if I go dot say text, it says here it's from get text and set text. So the dot text can be used to get text and also set text. Okay, so I want to set, I'm going to say is equal to hey there, clicked, and such. Okay, so now if we save this, go ahead and run, we should be able to run. Now for me, it's going to run because I already have emulators that I've set up before. Now, if you haven't set up the emulator yet, which is the representation of an actual simulated device, so we can actually test our applications, very simple. You see here at the top, we have this AVD manager. That stands for Android Virtual Device Manager, because an emulator is indeed a virtual device. Okay, so if you click on that, then you notice I have a few already done. So you can go to the bottom here that says create virtual device. There we go. So there's different style or different types you can create. You can create actual TV, Wear, phone, and tablet. Let's keep phone, right? So let's say I want to create a Nexus 24, for instance, right? Let's just choose that one. You can create any one you want. Or if you want, you can create a Pixel XL or any type you want. Just pick one, okay? I'm going to pick this one here because I think I already have all those pixels anyway. So I'm going to go ahead and say next. And you notice now we have different releases here, API. So the API 27, I didn't install it, so you can download if you want to, but we're going to keep with Oreo. Okay, that's what we're saying. This device will run Oreo, which is API level 26. You notice here it says we recommend these images because they run the fastest and support Google APIs. Okay, these images is meaning the API level. So I can say next, and then I get to name whatever I want our Android virtual device. I usually like to keep the Nexus 5X 24 API 26, and I can append something like phone or whatever you need to do. And you can change how big you want it to be, but I just leave everything as it is. Okay, I want to make sure it's portrait like that. Now, the other thing I do, just to make sure that I don't have to do next time, you see where it says Show Advanced, right? So click in there. The Show Advanced, you scroll down. You can set up a few things. You can set up how many RAM, random access memory, sexual memory you want to allocate for the phone. So I'll just leave as it is. But what I really want to do here is I want to make sure that the keyboard enable keyboard input. So if it's not, we want to enable it. What this does is once we start building application and you start using this AVD, this emulator, to test out your applications, and that application allows users to actually type in or enter text per se. This will allow us to enable our keyboard as the input, which means as we test, we can actually use our keyboard to write text in our application. So it's very handy. It's not the most important thing, but it's handy because you wouldn't want to be trying to tap the keyboard on the emulator here on the computer by clicking. It's just a lot of work, unnecessary work. So this kind of helps with that. So perfect. So I'm going to go ahead and say finish. It takes a few seconds, and there we go. Now you see, there it is, this Nexus 5X that we created. Right? And of course, you can go ahead and edit it, or from here, you can go ahead and run it. But I'm not going to do it right now because I have already something else running. Right? So this is perfect. So now you have your new virtual device running. All right. So that when that is done, we are ready to run this thing. I'm going to go click run, and notice we have different things now showing. So this Nexus says here available virtual devices. All of these, those are mine. But then it says, and because I already have one running, you could select if you want to run the one we just created, but I'm not going to use that. I'm going to use what I already have running, connected. It says here, connected devices. I'm going to say OK. And there it is. It's been running. That's the reason why you see it there. In your case, it will open it up. It will take a few seconds for it all to actually work. And there we go. Aha. There it is. We have our first application here. Okay, running. So the idea here, if we click hey there, we should be able to then change this to say hey there clicked. Right? Ready? There we go. Hey there clicked. Ah, perfect. Congratulations. I'll see you next time. All right. So you must be very excited because you were able to create your first application here. And I hope you were able to go and create another application of your own and use what we have learned so far. Now, I'm going to go back a little bit to talk a little bit more about what we have here inside of our Android Studio, because I want to make sure that we understand what's going on, or what comprises or what makes up our applications, a project, okay, an Android project. We did touch the basics on the previous videos. I'm going to take one step further to show you around Android Studio, but specifically to show you about this XML deal, all these XML files that we have here. And as I said before, all these XML files are a part of the Android user interface, okay? Everything that has to do with texts or how things are laid out in our application, in our screen, okay? So XML, let's go back to our activity main XML here. We have here our user interface being shown, so we're able to add a few text view, a text view, an EditText, a button, and another text view. Okay, and you notice also we have some constraints added to them. That way, if we change the way the application looks, things still look good. Okay, just like that. Now, this user interface here is represented using XML. So one thing that's important to understand is that in Android, everything that has to do with user interface is created using XML. So in the background, what happens is the Android system goes ahead and inflates, or it takes this XML file and makes it into actual objects such as the button, edit text, and text view. And that's the reason why we have a lot of XML files in our project. So an XML file essentially includes tags. Okay, so you look here at the top, we have this XML version. What are we doing? We're encoding this whole XML into a format called UTF-8. Now, we don't have to talk about it and we don't need to know about it, but it's all included when we create a user interface, okay? And then we have here a tag. So as you can see, it's open tag. So is the angular bracket here. So we open tag, and then we pass a namespace here. So this all comes with Android. It says Android.support, constraint layout, and so forth. Okay, and we have another namespaces here, but then we have this Android and it says layout width. Now we're adding properties to our view here, to our XML view, to our user interface. Okay, we're saying here the layout width of this view, this whole view, whole screen, has to be match parent, which means it will just match the whole parent. The parent meaning the whole screen. Okay. The same also with the height. This here would be, if you close, you notice it closes everything. That means this is the top parent tag or node. Okay, now inside of it, as you can see here, we didn't close it. We are saying now we are going to add things inside of our parent XML. Okay, inside we say open, we open again our tag and we say button, and inside of that button we add a lot of properties. And all these properties, we added them using our palettes here. So all of these widgets that we have, and we'll talk more about those widgets. We're able to drag and drop and set everything up. But the same thing we can do, of course, inside here with our widgets. We can also do them writing code here, writing attributes or properties using XML. In fact, years ago, when I first started in Android, this was the only option. You did not have a drag and drop option. You always, if you wanted to create a button or a text view or any widget, you actually had to come here and do the following. So open, say button. And the beauty also you notice here is that our IntelliSense or code guessing helps us, right? So it knows that you want to create a button, just go enter, and it gives us a template of whatever we want to add. In this case, we can say we want our layout to wrap content. So to kind of have the same size that is allowed to have, okay? Wrap content, you see? So now we can give an ID. The moment you say ID like that, you can select the first one and just give it an ID. So you notice it says @ plus ID. So we are assigning an ID. I can go ahead and say my button, something like that. Okay, and can I also add a text, right? And you notice for the text, we always have to add inside of our strings. But for now, I'm just going to say hello, just for you to just to show you. If we save this and go back to our design, we should see there's that button hello. Okay, and I can do the same thing from here, right? I can click on this and you look to the right here in our properties. I can get all these properties that I've added. It says ID, my button, layout width, wrap content, and I can go ahead and change things from here as well. Okay, I'm going to get rid of this. And of course, I could have done the same thing if I want to add a text view. So you can work both ways. You can go in design and add items. And if you want, you can go back to text view, to text here, text tab, and just add things manually. Okay, you'll notice that as we go through, there are times I just like the flexibility of doing it manually, and I usually do that. That doesn't mean you can't do using the design drag and drop. Okay, those two can be used interchangeably. Very nice. Now you notice at the end here, we are closing our parent node or tag here. Okay, so you notice we have the angular bracket, or the less than, the angular bracket here, the angular sign, and then /, and then we close our constraint layout. So this constraint layout here, we need to talk about, allows us to constrain our widgets, whatever we put in our screen, just to make sure that things are actually going to look decent in different devices and different conditions. Okay, it's a fairly new addition to Android Studio that really helps us create visuals or user interface that will look good in many different devices, and whether the device is rotated and so forth. Okay, and you can see all of that. And of course here, if you want to see the outline, you can go ahead here and create the blueprint, show design in blueprint, for instance. Right, now you have the design. This is how it would look. Let me make it bigger. And I'm going to snap this. That's another thing. So if you look at this icon here, if you tap on that, that snaps the project tab there, giving us more space. Okay, so now you can see we have the design and we have the blueprint. The blueprint is nice because you can see just what you need to see. In this case, you can see the enter your name with all the constraints that we added, and we can see also this edit text and button and so forth. Right, so this is the same what you have to the left, but here it's just the outline, the blueprint. It's easy to work with. And the moment you click on one item that has constraints already, you notice we have this box here that signifies we have all the constraints, right? So if you notice here, if you can delete the constraint if you would like, or you can go ahead and change. For instance, we click on this text view, you can slide left if you want it to be to the left, or all the way to the right, and it still keeps its constraints that we've added. Okay, so I want it to be about 50% like that. If I can get there. There we go. All right. Now these here mean that this constraint is fixed. Okay, if we get rid of that, then we know it's not fixed. If we add it, it's going to be fixed. Okay, being fixed means it will always be the same. All right, so we change that. So this is wrap content, but the sides are all fixed, which means the width will always be the same. Okay, or the constraints to the left and right. And to the top here, we have a lot of buttons. Okay, we will look at them as we go. But this is the main one that says Run App, and we have this icon here. What this means, it's a new addition. This just means that if we are already running the application and we make a few changes, what we can do actually is just click here, and it will quickly run your application to run the code again. Okay, well, that I think I ran. So it's running. I can go ahead and tap there, and quickly makes the changes right away. Okay, it doesn't recompile everything, just makes it way faster. And of course, we have this stop here. So if we click on that, the app will stop. And then we have this debug button here. So it will run and debug the application. And we'll talk about that at a later time. And we have other buttons here that we will be talking about them as we go. But those are the main buttons that we're going to be using quite often. And now to the left, we'll go back here. If we want to see our project again, just click on that. And you notice, like I said, we have this button, this icon here to snap, right? If we need more space, if we go back, right? And that happens also to the right here. So go like that, you snap, and you tap here back, and you got your properties back, all right? Now, the other thing you will notice here is that at the bottom here, we have a few things. And of course, we have here our palette, right? Like I said before, in this palette, we have all of these widgets that we can drag and drop and put in our user interface. I'm going to change it to just one. There we go. All right. And below here, we have the component tree. This component tree has all of the items inside of our user interface, inside of our screen here. It says here constraint layout. That's what it's at the top, right? And inside we have the show name button. We have the text view, entered name, result ID. So that means all these items are inside of our constraint layout. So it just gives you a hierarchy of how things are laid out in our view. In fact, if you go back to text here, you see we have our constraint layout here. So it's just representing all of this in a tree like this. So you can have also a visual idea of what is inside our constraint layout. All right, perfect. So I'll see you in the next video. All right, welcome back, folks. So in this video, I'm going to give you a little tour of the Android Studio tool, IDE, that we're going to be using. So IDE stands for Integrated Development Environment. So you'll hear me talk about IDEs over and over again, or you'll hear people saying, oh, which IDE do you like best, or what IDE do you use? So that's what it is. IDE is just a tool that allows us to build applications. In this case is Android Studio. Okay. All right. So here we go. We have our Android Studio installed. Everything is working perfectly. Obviously, there's a lot of things going on here, and most of them we will learn as we go. But I wanted to show the basics of the tool so that we are off to a good start. All right. So the first thing you notice here is that we have these tabs, this vertical tab. So if you click on the first one, it says project, click on that, you notice that it snaps. Okay, and if you click back, and then it shows this panel here, which has files. Okay, now this file here, the main one says app. Okay, that's our application, so it includes all of the folders and files and dependencies and libraries that constitute our application. So in fact, if you close it, you notice that all of the what was inside is also closed. And of course, we have our Gradle scripts here, and we'll talk more about Gradle, but think of Gradle as a system, underlying system that allows us to do a lot of things with our Android IDE here, our Android Studio, that takes care for building the application in the background so we can actually see the app running on device or on the emulator. Back to our app here, we have this folder called manifest. If you open the manifest here, the manifest has a lot of things, but think of the manifest as the heart of your application, because this is where you define certain configurations for your applications. For instance, you notice here we have this Android icon and then passes in an IC launcher. So this here, what's doing is that we're going to our folders, again, our app folder, we go to Java and takes us to resources here and goes to map and gets one of these icons here. But if you click, you will see these are icons for our application. Okay, this is what users will see when they install our application. So all of that is done inside of our Android manifest. And you notice also we have a label here. This is the name of our application. In fact, when we ran our application, we saw here, let me go ahead and run again. Go ahead and run again this app here. You will see at the top here it says Hello Kotlin Android. Okay, and if you look here, it says Hello Kotlin Android. Now, the reason why is grayed out is because this is just a visual aid. The reality, if you click on it or hover over, you notice there is this @string and then /app name. What is that? Well, what happens is here, whenever we have this we are saying we want to access a folder. So in this case, we're accessing the string folder, which can be found inside of values. So this is the string folders here. If you click on that, you will see we have a string here. We have the XML file and we have a string which has this app name, and then we have the Hello Kotlin Android. Okay, this is what we have set this whole project to be, if you remember when we first started. But all of that, of course, is being called in our manifest. And we have other things as well. But just think of the manifest as the heart of our Android apps. This is where we set everything that we want our application to do and to be. And then right after that, we have this Java folder here. This Java folder has 3 packages, okay? The first pack that we are interested in is the first one here. So we'll open that one, and it has this main activity. Okay, this is a Kotlin file, Kotlin class. If you double click, this is what you're going to see. Okay, so this is our Java code. This is where we write our Kotlin code. Any other Kotlin file or an activity, an activity is essentially just a screen. So this screen here is this activity. Okay. Now, one of the things about Android is that we have everything separated, meaning we have the visual part of the thing and we have the code part of the thing. And of course, we have the resources, which includes the strings and images and so forth. So what happens with Android is that we have the user interface, which is the visual part of things, right? All of this, like the string, the text view here. This is text view. We have the view, the background colors, and so forth. So that's the visual part, okay? And we have the code part, which is this here. So this code part, this Kotlin part here, the classes that we use connect to our visual part of things, if that makes any sense. So if we go back here, you notice that we have activity, main XML, and we have this activity.kotlin here. Let me get rid of all of this because we don't need it right now. So these go hand in hand because what happens is in code, we invoke the XML, which is the user interface. So in the background, what Android does is all of the user interface being anything that users can see and touch, in this case this, we create using XML. Okay, as you can see here. But now we have design mode and we have the text mode. So this is XML code here. Okay, so all of this can also be represented visually. So we can change things here, and you can see things changing as well here, okay? So the idea is that the code, Kotlin, will invoke whatever we have specified inside of our XML, our user interface. So every time we create a new activity, in this case a new screen, usually we'll have the code part of things, right? The Kotlin, and we'll have the XML, which is the user interface. Of course, then we have the res folder here. This res folder has the layouts. Again, that's part of user interface. You can see right away we have this activity main, which is what I've just opened here. And we can add all of other layouts, as many layouts as we want, depending on how complex our app is going to be. Okay, and then we have the mip map. This is where we put our resources such as images, right, for our application. In this case, we have these images here for our icon of the app. Now, the values folder, we have 3 XML files here. We have the colors, which, as you can imagine, this is where we define our colors, so we can then call these colors anywhere else in our application. And we have the strings folder that I've shown you here before, which in this case here, we define the strings that are going to be used in our application. In this case here, this app name, you notice it was used inside of the manifest folder here, right? We said label is going to be @string app name. So it goes and finds this app name here and gets this value and displays it. And we'll see more how to add more strings here that we can then invoke in our code or XML to display it. Okay. And then we have the styles. We'll talk about styles. Styles allow us to stylize or brand our application. You notice here in this style tag here, we have few colors. We have primary color, primary dark, and accent colors. All of these colors, if you look closely, they resemble the colors that you see here. So you have the top and this color, okay? So we can actually create our own styles that we can use for branding. If we want our application to have a certain look, an overall look, the whole application, then we can do all of that here. We can create our own styles. So going back to our main activity, XML activity main here, you notice there's a few things that are very important because we're going to be able to use this design view here to add things into our user interface, into our activity here, okay? But you also notice here we have this tab, vertical tab. You click on this, it hides and opens. So what this is, allows us to see the representation, how things are laid inside of our user interface. So you see here we have a constraint layout. The moment you click that, to the right here we have this properties tab, which is very contextual, meaning if you click, for instance, on this text view here, it will show all the properties pertaining to our text view, which means we can actually change the name, change here, say hello Kotlin Android. Save, look at that. Now we see here we have hello Kotlin Android, and we can make it bigger as well if we want, okay? If we want to change this text size, we can just go here. I usually search here, say size, and there we go. We can click here and say 24, for instance, and there we go. Make it a little bit bigger. Okay, so now we have that. And at the top here, we can minimize or zoom in or zoom out and zoom in to make it bigger for us to see. You can see there. Okay. At the top here, we have a few things. If we wanted, we can create, here we have just this one view. So here we have the telephone view, so you can actually see how it will look on device. If you click here, it will just give you the overview, right? The underlining layout. And if you click here, it will show both, right? So now we have this underlining here, and we have the actual device, how things would look. Okay. Very cool. And now the other main important thing is that we have here palette. If you click on this palette here, we have all these widgets, which means there are user interface widgets that we can use to put inside of our view here, right? We have here buttons, we have toggle button, checkboxes, and so many others that we can use, right? We have plain text views, edit texts. We have many different things we can use here. We also have layouts, right? We can add layouts inside of our user interface. And we'll look into that, of course, as we progress, right? And most importantly, at the top here, we have this play button here. We have a debug button, which we'll talk more about. And we have other things that we're going to be learning as we continue with our development here. Perfect. So go ahead and play around. Go ahead and look through. And the beauty here also is that you can actually drag and drop. If you want a button, for instance, we can drag and drop there. And there it is. If you click on that button again, because if you click on it, you can see now we have in our property here, we can add an ID, we can change the background color, we can do all sort of things. We can change the text. If we wanted to say, click me, like that, you will see it will change to click me. Okay. And so many other things we can do. So we're going to be playing a lot around here, right? Adding widgets into our screens and be on the design side of things or go into text here. And you notice the beauty here is that we have this click me button. If you go to text, we'll see the actual implementation in XML. And we can edit things here as well, right? So for instance, here I can change this click me here to click it now. If you save this, you go back to design, you will see now it says click it now. And of course, I could have done the same thing here as well. Okay. All right. So that is a very quick overview of our Android Studio, which we'll be using to develop Android application using Kotlin. All right. So I'll see you in the next video. All right, so in this video, we are going straight to it. We are going to build a very awesome quick app here, so that way we can get your feet wet. So what I'm going to do here is I'm going to keep using the previous project that we have here, hello Kotlin Android here. And what I'm going to do now is I'm going to delete all of these, okay? Notice also we have this constraint layout. If we go back to text here, you notice we have this constraint layout. It allows us to do a few things. So let's put, for instance, a button here at the top. well, kind of in the middle here. Notice the moment you do that, we have this notice here. Okay, it says this view is not constrained. It only has this design time position, so it will jump 0, 0 unless you add constraints. That means we have to add constraints. That way, when the application is running on devices, it knows exactly where it's supposed to do. So what you can do, if you click on it, you see these circles around it. You can just click on it and drag, and there we go. Now you snapped at the top here. It's going to be 8 dpi from the top. You can move it here, right? And you can do the same to the right, okay? And the same to the left. And of course, if you want, you can do the same to the bottom there, okay? Okay. Now, the other thing that happens is it says hard-coded string button should use add string resource. This means every time we are giving names or we are having to add strings or titles to our buttons or whatever else in our application, we should always go and put all of them inside of our strings. Now, the reason behind that is that later on, if you want to get your application translated into different languages, it's going to be much easier to come here and create a new resource and put the same strings or the same titles or whatever else you're using in your application, as opposed to having to go back to each button and change the name, if that makes any sense. Okay, so in this case here, they're saying that we always have to go to strings here and say string and pass it a name. I'm going to say button name. In fact, I'm going to say underscore here, and then close it. And then inside, I'm going to say, for instance, show name, something like that. Okay, now if you save this, we go back to our main activity, main XML. Inside of our button here, what we can do for text here, we can click in this pick a resource. You notice there it is. So click on that, and we can go and say, you notice here it says button name and show name. So you select that and say okay, and all of a sudden our show name has this show name there. Okay, that's very important. Okay, so now we have our button. Let's go and find a text view. Say text view, it just allows us to put a text on the screen. Okay, so I'm going to say text to search there. So text view, I'm going to go ahead and put it on top here. Okay, and notice it's snapped there. Now what I want to do, I can say I want it to be at the top of our button there. Okay, and I'm going to give a text inside of here. I can just click on here and say add resource, because I want to make sure that I add the text I want to put inside of our text string here, okay? And then I'm going to say it's going to be title, and the resource value is going to be enter your name, something like that, okay? And now you notice it says there, enter your name. Now, if I want to make this a little bigger, what I can do, I can go back here and search, say, size, okay, size, and I can just click here, and I'm wanting it to be 14 SP, like that. How about a little bit bigger? How about 24 SP? There we go. Okay, very cool. Let me put it at the top more here. And if I want, let me make sure that the constraint at the top is also there. Okay, just make sure that this allows us to, whenever it's running, it's always going to be at that position, whether it's landscape or portrait. Good. Right. So now we're going to go and find an edit text here. So I'm going to go ahead here and find this plain text. Okay, I'm going to put right below here in the middle. Okay, so what I'm going to do, I'm going to delete that. I'm going to give it an ID because we need that. I'm going to call this enter name EDT. Okay, these I don't need an ID. And for button here, I'm going to also give an ID because I need a way to reference that ID later in my code, and you will see all of that. Okay, I'm going to say show name button, like that. And it says update usages as well. Yes, because we want to make sure that we update these IDs across our application project here. Perfect. So now we have our name, we have our show name. And this is just text that users can see and read. And this is where a user will be able to enter something, right? That's an edit text, as they call it. Okay, but now we want to change this. It says name. We're going to change it to something else. In fact, we're going to just get rid of all of this text altogether. Okay, and what do we need? We're going to add a hint. So I'm going to go ahead and say hint. I'm going to search, say hint. There it is, hint. And I'm going to go ahead and add a new resource right into our strings because we are cool. I'm going to say hint name, and it's going to be enter your name. Now I know this is redundant because we have already this text view here, but nevertheless it's okay. I just want to show you how to use certain widgets here. Okay, so the idea here is users enter something here. We say show, and then we're going to show the name. Okay. In fact, let's go ahead and add another text there at the bottom. I'm going to make sure I give it an ID. I'm going to say result ID. So now that we have everything set up, we are going to go, I'm going to go to our main activity here. I'm going to get rid of all of this. Now, if you go back to strings, you notice that all of the title and hint name and button name that we added are already added here, which is good. So now I'm ready to go to our main activity here. So click there. Now this main activity here, you'll notice something very interesting here. It says here it's a class, main activity. We know what a class is. And it says here extends or is of type app compact. So it inherits for app compact activity. So this app compact activity is just a class, an Android class that has all the functionalities that we need to run our application. In this case, an activity. Okay, a screen. All right, and then we have this override function here. So we're overriding this onCreate function method that comes from app compact activity. Okay, we're passing a bundle here, and then we are calling the super, and we're setting up whatever we're getting from our bundle here. And don't worry too much about it for now. Now, the important part here is that we are setting the content view. We are saying, well, what is it that we want to show in our window, in our activity? In this case, we're setting to activity main. You notice this activity underscore main is the same activity that we're talking about here. This is what we are saying we all want to pull and show it there. So now that means we need to find a way then to get access of all of these widgets that we added here. And simply what we can do inside here, after we've set the content view, okay, we can go ahead and say, for instance, if we look back here, let's go ahead and look at IDs. Let's say we want to get this enter edit text here. It says enter name edit text. So what we can do, we can say edit enter. See, it says here enter name edit text EDT, right? Edit text.text, right? And what we can do now, we can put that whatever we are getting from our edit text here, we can put that into a variable. So we can say var entered text is equal to enter text, just like that. Okay? And now that we have whatever was entered inside of our edit text, we have put inside of our entered text here, a string, okay? So what we can do now, let's go ahead and get then this button here. So the idea is to get this button clicked, and then we are going to take this edit text, this text here, which has this result ID, and change to whatever we have entered here. Okay, and that's the whole idea here. So what we're going to do, we're going to set up the button here. Button. And right away, the beauty here is that right away we have the show name button ready for us. So we can just use it. Okay? Because again, remember, we were able to get IDs. So we gave IDs, which are now connected to our activity main.xml, which internally is connected to our main activity Kotlin. Because remember again, we said set content view to this. So internally, it knows exactly which buttons we're talking about. So say button, show name button, get a dot set on click listener, just like that. Okay. And we're going to use this second one here because we want the Kotlin, say like that. And we can right away just go ahead and fetch this text view here because this is where we want to set whatever we got from the user. All right. It's not too bad. Okay, so what we're going to do then, we're going to say result, because I think that's what I called it, say result ID dot text, and I'm going to set it to entered text. Just like that. Very simple. So all of this depended on whether or not we were able to get the IDs. So IDs are very important because that's the only way we have to actually get our widgets. Now, if we save this and run, I'm going to use connected device there. Okay. There we go. Says here, enter your name. We have to fix something because this text view here is showing it at the top here. The reason why is because we didn't obey our constraint. So we're going to fix that right now. So I'm going to go ahead and make sure this is always at the bottom here. I'm going to put it there. And I'm going to make it a little bit bigger as well. Okay. And while I'm here, I'm going to put a size. Make sure that the size, no, we have to click on it first. So size, it's going to be about 14. 18 perhaps? Okay, that's fine. All right, let's go give it a run. I'm excited. I can't wait. Say OK. And for me, I'm going to just say use same selection for future launches. So that way I don't have to always say OK. Okay, so now it's running. And look at that. So our text view now is at the bottom here. Okay, so now if we go ahead and say Paulo Dishon and say show, and look at that, it says Paulo Dishon here. And you notice something else, this enter your name is in the middle and this should be here. So something is not right here. So we can fix that. That means we need to make sure that this is snapped to that. Let me put it over there. Okay, so let me snap this there and snap this with that one. Perfect. Let's run again and everything should look perfect. Okay, enter name. Let's say James Bond. Again, do that and say show name and look at that. So it's James Bond. In less than 11 minutes, you were able to create a very simple app using the tools that I've just shown you here, and it's working, right? So here you can go and change to something else. Let's say Bonnie. If you go show, of course we have to, and you see, it says Bonnie. So whatever you add here, show, it's going to say Bonnie add, hello, and so forth. Isn't that great? Well, congratulations, guys. This is a big deal. So you should be very excited. So play around with this concept. And if you have any questions at all, feel free to ask. Okay? All right. Perfect. I'll see you next. All right. So next thing we're going to talk about here is the strings values file here. So the string file, XML file, has the parent node here called resources, and inside we can create strings, which we can then use in our application. As you notice here, we have this app name, right? So that's the application name. So that's the Hello Kotlin Android here. So that's the app name. And we have the button name, which we created earlier. Go back to here, activity main. That's set show name. Okay, so if you go back to strings, you see button name here. So we use this button name to invoke this string here. It's very important to use strings.xml to add all of the text that we're using in our application, because later when you want to say take your application and create a different version in a different language, it's much easier because you can just create another strings.xml and translate all of the text in your application into that language. Okay. All right, so of course here you can go ahead and create your own string. Okay, you can say string, and let's say here I want to say new hint. Of course, I then put what I want to see here. I'm going to say new hint. Okay, and notice the way we name our strings. We usually they are all lowercase with underscore if you have more than one word. Okay. So that's important to remember. So now how do we access this new int? We can go back here to our XML. If we wanted to change this show name here to use our new hint, we can easily go to our property here and see here where it says text. You can see it says add string / button. We can click on that and say add string, and the moment you start typing, you have options here. We can change to new hint like that, and it says new hint. So now we have invoked this new hint from our strings file to be shown here. Very nice. And of course we could have done the same thing anywhere. We could have gone back to our text here, and for instance for the text we could have changed right away here to something new, say new hint, and it will reflect that as well. I'm gonna put it back. So it's very important to use our strings.file to add strings. You also notice that I don't always have to go here and do that manually. We can, obviously, but as you start developing applications, time is money. You notice the other thing you can do, if you look at, for instance, you click on new hint, we go to our properties to the right. If you look here to the right, it says you pick a resource, this icon here. If you click on that, this will happen here. So now it shows all of our resources that we've added, right? So we have new hint, title, Android, and many others that come with Android, right? So you can either add your own by going here, say add resource, it says a new string value, right? Or you can just choose whatever if you have already added. In this case, I'm going to show you how to add your new. So click new, and here the resource name, you can say, for instance, newest item, and resource value, which is the value that you want to show when they call newest item. I can say hello there again. Okay, and you notice file name is going to be inside of our strings.xml. Say OK. The moment you say OK, it says hello there again. But most importantly, you go to strings and you will see there is newest item hello there again. Very, very nice indeed. So you have different ways to do the same things. Okay. Now the next one we're going to talk about is the color here. You notice it's the same theme here, right? Because now it says resources again, and inside we can add different colors. Now, every time you create a project, an Android project, what's going to happen is the Android system creates these colors for you. These colors here are colors that allow our application to be branded per se. If you notice here, we have color primary, which is, you can see here, this little thumbnail gives you the idea of what color this is. So it's kind of light blue, I would say. Okay. So you notice this light blue is actually this nav bar here that we have. Okay. And of course, and the color primary dark is the one at the top here where we have all these icons of our phone notification. Okay. And then we have this color accent. You notice the color accent you can't really see anywhere here in our application, but you can see even in our cursor and the underline of our edit text. So these colors here are actually being used to brand our application. Okay? So every project you create for Android app, this will happen. And of course, obviously you can change to your liking, and you will see us doing that. So these are hexadecimal colors. So you can actually go online and say hex colors, and you will see a list of hexadecimal colors. But the cool thing is this actually is also a color picker. So if you click here on this color thumbnail, you notice we have now this color picker that we can use to pick a color. So if I go ahead and let's say I want to pick this one and say choose, you notice now this hex has changed, so did this thumbnail. We save this application and give it a run, we should see that our color primary is going to be different. And you see, now it's different. Okay? So because we were able to change just in one place, look at that. We changed the whole application. Okay? So if this application here had, let's say, 10 different screens or activities, then all of the screens will now have this color at the top here on their action bar. So this is the power of having everything organized in different compartments. That way we don't have the same color in all different places hard-coded. So when we want to change the whole color, when we want to change the color, we just go to one place and change it, and the effects go through the whole app. All right? Very, very nice. Perfect. And then we have our manifest, Android manifest here. We've talked a little bit about it, but the Android manifest again is the heart of our app. Okay, this is where we add a lot of things that impact how our application works. You can see here again we have this parent tag here called application. So if you close this, it closes everything. All right. Well, at the top of it we have the manifest, which means this is the parent of this whole XML here, right? And inside of it we have this application tag. So obviously this pertains to the whole application. All right, we have this allow backup to be true. Okay, and we have this icon here. So it goes to @mipmap, which means goes to our mipmap folder here, which has all of these icons, and of course displays it. Okay, and as you can see here, we have this icon here. Okay, and then we have the label. Notice if you hover over it, says add string / app name. You guessed it, goes to string and gets this app name here, ID, and shows this one. Okay, and we have here a theme, so it goes to the style folder. The style folder allows us to create styles for our application. Now notice what happened here. In the style folder here, we're using the color primary, and we are passing @color primary. So here we are passing the color from our strings, or I'm sorry, from our colors. All right, that way we can stylize this whole application. So that's a very important component that allows us to brand our applications on the fly. And obviously, as you know, you can create your own styles, and we'll see that at a later time. Now, one point that I want to take home here is the following. You notice that we have all these folders, they all separate, but they all work together. So here we have the Java, it says Java, but it's not Java anymore. We're talking about Kotlin, but under the underlying code is still Java, so it says Java, right? So we have the Kotlin Java code here, the actual logic, okay? And then we have a folder here called res for resources. So inside of resource, we have layout that shows here how our screens are going to look like. Okay, and then we have map for our icons, and then we have values. Inside of map, we have a resource we also have the assets folder or drawables where we can add images and other all sort of things that we can add for our application to use. So everything comes together here in code so that we are able then to have something like this, which is an app. If you start thinking these terms, you realize that an application, literally a lot of different moving parts that come together to make an application. There are a lot of classes that are working together to make an application, and most of them are here. Perfect, perfect. I hope you're able to learn a little bit more about Android Studio, and I do realize I'm repeating certain things here, but the reason why is because I want you to have to start thinking in these terms, to start understanding the Android Studio and the Android ecosystem if this is your first time wrapping your head around this. Okay, so remember there's small components, there are different folders that then we can use in code to put everything together so that we are able to actually create an application that users can use. All right, perfect. So I'll see you next. One of the biggest questions that you find people asking about Android development is the context class. What is the context class? I mean, you've heard probably a few times now the usage of context, and sometimes very confusing to understand what that is. As always, let's look at a quick example here. Let's create a toast. Right? So say toast. I'm going to say make text, and right away you see there in our IDE code completion here it says make test requires a context type, resource ID, and of course a toast.length, which will then let us know how long we want this toast to show the message. Okay, so we need the context, we need the message that we want to show, and then we need to tell it how long we want this message to be shown on the screen. So context. So let's say enter the context here. What we're going to pass, we can say this. And for the message, let's just say hello there. And we're going to just say toast. And the length, just say long. Of course, we're going to show it. Save this, give it a quick run. We should be all good. And there we go. It says hello there. Stay there for a bit, and then it's gone. All right, let's talk about this context part of thing. So the way I like to think of context is I like to think of the context as this class or object per se, this class or object that knows everything about what's going on in our application. So if you think of the context, think about a way in which we can use it, the context, the class, the object, to access anything we want contextually in our project. So let's read this piece of code together. It says toast make text. So what are we saying here? We are accessing our toast class, and then we say, okay, we want to then make the text. Right? So we call the make text method. This make text method knows how to make text. But for it to know how to make text, it needs some sort of context. The context we're going to pass is this, which means, now that you understand about classes and objects, this means, well, this context, which is the main. Okay, so it needs to know what is the context in which I'm going to be able to display this toast, this message. And then after that, it says, well, okay, I now have the context. I have access to anything else I need to construct this message that I need to show. Then what is the message? Well, the message is hello there. Okay, so now I have that information. So I have the context. I know what is it that I'm going to be able to show. But how long do I have to show this message? Well, there is a final static method of length, which is length long. And then, of course, we invoke the show method to show our toast. Notice also, if I went ahead and did this, get application context, you notice there it is. It's just application context. That also could work. Let's run. It still works. So there are different levels of the context. Now, obviously, this application context is bigger, meaning it has a bigger span. Accessing of resources, pointing to other things in our Android application here is broader, if you will. So you want to use the application context sparingly, so you don't use it all the time, because then probably overdo it or run into other issues later as you sparingly use the application context. So that's the reason why we always want to contextualize our context in the sense that we want to use it here, which means in this class here, main class. That's why we usually pass this. Now let's take a look at the definition. Let's go to the holy grail, if you will, which is the developer.android.com, so that we can get used to looking up things. I'm going to go and say context to search, and you're going to have here a lot of results. Let's go to the first one. Okay, so you can see here the context is an abstract class. Of course, extends object. What doesn't in Java? But you also notice here there is what they call the known direct subclass. There's mock context, context wrapper, so many other things. But also see here the known indirect subclasses. Look, all of these. They are all indirect subclasses, which means they can also be used as a direct context. And notice also it says here 40 others. So click here, look at this. Activity, it is indeed a context as well. Activity group, application, it is the base class for maintaining global application state. Again, it is indeed a context, and so forth. Now, if you look at the definition here at the bottom, it says the context is an interface to global information about an application environment. Again, like I said, it just knows, the context knows everything about the application. It knows how to access resources and other Android system features. Does it make sense? So whenever you think of context, just think of this almighty class that allows us to access specific resources inside of our application, contextualizing our application to specific resources. The next time you are in a place where people are trying to figure out what is this thing called context, just explain to them as we explained here, and it should be okay. As you continue developing Android applications, this concept will become more clear and you will learn to appreciate it. All right, perfect. I'll see you next. All right, so we are going to proceed here, and I'm going to create a new project. So I'm going to say File, New project, and this one I'm going to call this Buttons Text View Edit Text. Right, so we're going to talk about buttons, text view, and edit text, which we've looked into when we first created our first app. But I'm going to go one step further in this lecture here. The company domain name here, I'll leave the way it is and make sure we have include Kotlin support. I'm going to say next. API 21, that's all good. I'm going to say next. And of course, I just want this empty activity here. Say next. This is all good, and say finish. And we should have here our new project ready for us to work on. All right, our project is ready. All right, let's go ahead and open our activity main here, and we want the design view, and we have here our hello world, which we don't care much about. We're going to delete that because we're going to start everything from scratch. All right, so notice again in our component tree here we have this constraint layout, which allows us to constrain our widgets as we add them to our screen. Okay, the first thing we're going to look at is we're going to go to our palette here. Okay, and if it's hidden like that, you can just go ahead and click palette and it should show that. And also if our constraint is also hidden here, you can just go ahead and click that and you will see. Okay, so inside of our palette here we have all widgets, text, layouts, containers, and so many other things here. Okay, so in this case here, if you want to search for text view, just say text like that, and you can see here we have our text view. So I'm going to click and drop it right about here. Okay, and right away we have our constraints here. Okay, so if you go ahead and change, if you drag this and try to change the way things are going to look, like that, you notice, let me make this bigger. And I'm going to snap this and snap that and snap that as well. You notice right away that our constraint is working for us because depending on the size and whether we are on portrait or landscape, our text view is indeed in the middle. Okay, let me put it back to portrait like that and make it bigger. Nexus 5. There we go. Okay. Very nice. Let's go back to show our project here. I'm going to resize a few things so we have more space. All right, so we have our text view here. Let's make it a little bit bigger. So what I'm going to do is click on it and just drag it down like that. And you notice it's right about there. Now, if we go to our properties here, we can do a lot of things, right? So we can see here the layout width, the text that it's going to be showing. And if we want to change it to something else, we can actually create a new resource. So add a new string, and we can say here, for instance, title, let's say welcome, just like that. Okay, and you see it says welcome, and it's kind of small, so we can actually change the size of our text. If we wanted to do it here from properties, just go ahead and say size, and it says here text size. If you click here, we can change, for instance, to 18. Okay, get out of there. And if we wanted to change, for instance, make it bold, we could also done the same. We're going to say bold or style rather. Say text. We have to click on it in order for us to be able to see it. Okay, that's very important. So it says here text style, we want bold, and there we go. It's now bold. And you can also text align, right? If you want it to be aligned to start to the left, like that, or if you want like this, or in the middle like that, or indented to the right, and so forth. Okay, so there's a lot of things you can do, change the properties of our text. If we save this, and go ahead and run. Okay. Again, you can also do Control R to run. Will take a few seconds. You notice we have here, it says welcome. Okay, not bad. But now you notice this welcome here is way at the top here. And in our visual representation design here, it's not necessarily at the top here. Well, the reason being is because, as you can see, the constraints that we have are only left, right, and left. There's nothing top, there's nothing at the bottom. If we want this to always be at this place, at this location here, we need to go ahead and click and then drag over there, and then we can drag back here to whatever we want it to be. So now this says it will always be at this distance here from top to where it's supposed to be. If we want to check it out, we can change this again. So drag, and you can see it's always 88 units down. Okay. Go make sure it's big enough. This is very handy. All right. So now if we save this, Control Run, we should see indeed. Look at that. Now it's about 80 units down here. Very cool. So all these properties that we were changing, we can do the same with any other property. Okay, let's go ahead and open our palette here. Let's go ahead and add an edit text. So an edit text allows us to add text. Okay, so it will prompt us for us to type something. We call them edit text, but they've changed the name now. I think now they're just called plain text. Now they're just called text. Okay. So now if I put it here, so notice the first thing that happens, everything you put inside our view, we have these constraints, which is really good, right? So we can move it to the middle there. Let's make this a little bit bigger. So I'll move it to the middle there. We can move it around. I just want it in the middle. And we need to make sure to also snap it. We want it to be always below our welcome. Okay, now if we go ahead and save and run this, let's see what's going to happen. There we go. Okay, and here we can rotate it. You can see it's always there. right? Can rotate this again. Probably can see that. So we have these buttons here that we can use to rotate our application. So we have said here that this name EditText or text will always be below our welcome. Okay, very nice. So we can also change properties here. So name, we can go back here. It says text name. We don't want anything. The text, the EditText, it has another property called hint, right? So this hint allows users to see what is it that they're supposed to enter in this EditText, right? In fact, if you hover over, it says EditText. And I don't know why they say plain text, but I think it's because there are different types of EditText. You'll hear me call this EditText all the time because that's what they're called, but they have different names. In any case, so hint here, to add in hint, we can go and click here. So we want to add in our resource files, in our strings, click that. We're going to say here, hint name, and we're going to say enter your name, just like that. And you can see it's gray and it says enter your name. So we're making good progress here. Next thing we're going to add is going to be a button. We're going to put a button right about in the middle there. And again, we have these constraints that are there, and I want to make sure it's always below here. So I'm going to click and find this constraint, and I'm going to snap there, put it a little bit about 28 like that. That's really good. Now I can also make it longer, right, by dragging. So make sure you click on the button and then go to the corner here. You'll see the cursor changing here into a 90-degree angle, and you can just drag like that. Okay, so button here, it has properties as well. It doesn't have a hint though, so we're going to clear that. And let's say we want to change the background color. We can do that. So click here. Notice now, because there's different things we can change, we have drawable. It just means image. We can add an image. If we want color, we click on color, and we can change to, for instance, accent color. If we do that, say OK, and our button will have an accent color. Very, very nice. And if we want to change the text inside here, the color of the text, we can say text color. We can see here and do the same. It takes a little while for some reason, and I want color white. Okay, so Android brings a lot of different colors here. I'm just going to choose one, that white there, like that, and there it is. And if I want to change it to be bold, I can click that, and I will also have bold. All right, very nice indeed. Of course, I want to change, instead of saying button, I want to give it a title. Or text. What I can do, I can go back here where it says text, right? I can go and change that. And I want to add a new resource, show name. Click that, and now we should see here, for some reason it's not showing show name. Let me go to the text, button string show name. It's not showing. No, not sure why. All right, let's go back to text here. Let me just add here show name once again. Go back. It's not showing for some reason. Oh well. Okay, so what we're going to do here, we're just going to go ahead and say show name like that. Okay, let's change the color to white. All right, and find color. White. Let's see if that was going to work. Oh, there we go. Perfect. So let's save this and give it a run. And we have our app here, right? So you can see we have our welcome, enter your name, and show name. Very nicely done. Okay, so as you can see, it's not really hard to start putting together a very simple application here, right? So the idea in this app is going to be very simple, obviously. We're going to do the same thing. We're going to enter a name, and then we're going to show here at the bottom, welcome and the name you entered. Okay, so we'll do that in the next video. I'll see you in a bit. All right, so now that we have our show name button, enter your name, edit text, and the welcome text view, and it's very handy, right? If you hover over, it tells you exactly what kind of widget this is. Now let's make sure that we actually give IDs. That's very important. Without IDs, we're not going to be able to reference those in our Kotlin code. So I'm going to go ahead and give this button here, show name button. That is EditText. I'm going to enter name ADT like that. I'm going to say yes to make sure that everything is synced up. All right. Next thing we're going to do is actually add another text view here. So let's go ahead and find a text view. If we can't find it, just in fact, it's here. All right, so we have our text view. Let's make it a little bit bigger here. There we go. And we want to make sure that is actually centered. We want to make sure that it actually is always below our show name button here. All right, like that. And I don't want to see this. Let's give it an ID. I'm going to say result txt like that. All right, so all of our widgets now have IDs. Now, before I forget, let's go back to our module here, and I am going to add another plugin here for Kotlin, so that way we can simplify our code. You can say apply plugin extension. I forget what it's called. Let me go and find from the previous. It's this one. I'm just going to go ahead and copy all of this. This will allow us to simplify our coding. All right. So there we go. So Kotlin Android extensions. And we need to sync. All right. Our project is now synced. Perfect. So now we go and open our main activity here. So what we're going to do here is the following. Because we were able to add all those IDs, we can now reference all of these. Okay. So the first thing we're going to reference is this EditText here. So we're going to say here EditText. All right. So it says enter name EDT. And you notice the moment we go enter, this import is added here. Kotlin was actually able to import the classes needed to connect our IDs to our views, widgets. Okay, so now we can just reference the ID and we can say dot text, and we can put this into a string and say var text is equal to that. And next we're going to go and fetch our button here, show name. So what we're going to do is we're going to say show name button. Look at that. It says show name for activity in Kotlin. Very simplified. And we can say dot set on click listener. Okay, we have two options here. We can set the on click listener using the Android native Java, or we can use the Kotlin one. We're going to use the Kotlin because we are in Kotlin here. And there we go. Here inside, what we're going to do is we are going to fetch our text view here, which has this ID result text, right? And then set the text. So we can say text view, right? There we go. For activity dot text, we're going to say is equal to text. Which text? The text here that we got. Now, the thing that we want to do actually is we want to make sure that this text, we want to append something. We want to append a welcome string to whatever we're getting from what the user entered. So we can say here, for instance, we can go ahead and say welcome. Okay. So now it will be appended. So it's going to say welcome Paulo if that's the name that we enter or text that we entered. If we save this and run, all right, so moment of truth here. I'm going to go ahead and say Paulo Deshone. Oops, and says welcome Paulo Deshone. So it seems like I've added actually to the top one, which is not what I want. Okay, let us go back here and make sure. So result, that's what it is. Oh, why am I getting this one? I want this one, result text. Okay, I think the IDs are not right. Because I said text view, right? There we go. Result text. This is one that I want. All right. Save this and give a quick run here. Okay, apply the changes. Go to show. It says welcome. Now, you notice it says just welcome, but then there's nothing else to that. Okay. It says here, if you have offers, do not concatenate text displayed with set text. What this means is that what we can do, in fact, we can just go ahead and say here plus text. Okay, this way I think this should work and run. and now it says welcome Paulo Duchon. Okay. And the other thing we can do here, just to make things a little bit interactive, is we can put an if statement here. We can say if text that is empty, right? If this text we're receiving is empty, we can go ahead and just say result text.text, and we're going to just pass here something like enter name. Okay, and we can say else. We're going to copy this and just pass it all here. Okay, very simplified. So if text is empty, we're going to say result enter name, right? We're going to pass this name. Else, we're just going to go ahead and just get whatever we got and append welcome. Okay, so I'm going to save this and run. All right, say James Bond. It's going to work. Welcome, James Bond. If I delete everything and say, it says here, enter name. Very cool indeed. I just want to showcase here how simple it is to create an application or to code even with Kotlin. If you've done Java and Android before, you will notice that this is way simplified than we used to do with Java, which is still possible. We can still do the Java way here because Kotlin and Java are like brothers, okay? So they can coexist together, right? But look how simple this is, right? Because we were able to get the IDs, right? And we added this Kotlin Android extension here, it abstracted everything for us to where we were able just to go and find the IDs and then perform the operations that we want. Very, very easily indeed. Okay. Again, this is a very simplified application, but I wanted to repeat it so that you have a better grasp on how to create a very simple app using Android Studio with Kotlin here. Okay. All right. So I'll see you in the next video. In this video, we are going to build another app. This app is going to be really fun to build because it will allow us to figure out what would our weight be on different planet. In this case, we're going to start with the planet Mars. All right. So the idea is the user will be able to enter their weight on Earth, and then the app will be able to figure out what would their weight be on that planet. Okay. In this case, we're going to start with Mars. All right, so let's go ahead and do it real quick here. As you notice, I was able to go and create a new project, and make sure that once you create the new project, you go down to build at Gradle and you add this Kotlin Android extensions here. Very important, so that way we don't have to type a lot of code to get things to work. Okay. For now, it's okay. We just go and add this Kotlin Android extension just like it is right now. What I usually do, I just copy from previous projects. So go ahead and copy these from previous projects and just paste it inside of our build Gradle module app. Not the first one, this one here. Okay. And once you've done that, make sure to sync and wait a few seconds. All right, so we're back here. Let's go to our main XML here. Of course, as we will always do, we're going to get rid of our hello world here. So what we're going to do, we're going to go ahead and put a text view at the top here. Okay, let's find a text view. This right here. Put right there. Okay, there we go. Close that one down so we have more space. All right, let's give a few constraints here. I want to make sure this is always at the top like that and in the middle. And then let's make this a little bit bigger like this. Okay, it's going to be our title. Let's give it a text. Let's click here and create our own text string here. And we're going to say weight title. And for text, we're going to say, what's your weight on Mars? Just like that. And there we go. So you notice it's too small. Let's make this, extend this a little bit there. Perhaps like this. All right. So the text is really small. So let's go ahead and find a way to change that. Let's say text size. In fact, we're also going to change the style to bold, and size, we're going to make it 14 perhaps. No, that was it. Let's say 18. Very nice. And while we're here, let's go ahead and text align it to center like that. So it puts all in the middle of the screen. Okay, so we have our title there. The next thing we're going to add is EditText. So I'm going to go ahead and get one of these and put here. And I want to make sure that this actually expands all the way to the right and left. So I click on it and go back to our properties editor here, where it says layout width, wrap content. I'm going to change this to match constraint, so it goes all the way from left to right. That looks good. And I'm going to give it a hint text. Let's go and find a hint. Say hint. There we go. And the text we're going to create. I'm going to say here new string. And the source name is going to be hint weight. Whoops. I have to actually give it. Where is hint weight? I need to actually give a value. What we can do is we can go back to our res folder, go to values, and we're going to add ourselves. Go to string, and you notice there's nothing here. We are going to actually write ourselves because I closed it too early. And inside we're going to say enter your weight. Okay, save this. Go back here. Let's go ahead and get rid of say text. We're going to get rid of this name here. We don't need that. And once you do that, you notice it says here enter your weight. Okay, very nicely done. And then at the bottom we're going to go ahead and put a button just right about here. We're going to make this button extended a little bit. Let's change this text. I'm going to say show weight. Let's say show weight, like that. And why don't we change the background color? We want this one here. Let's go to color. I'm going to change to this color primary here. We could have gone and created our own colors, but let's just use what we have here. That's good. Let's change the text inside. Change the color of the text. Let's go ahead. I like say text color here, and we're going to change this to color. Going to make it white like that. Okay, so now you see it says show weight. Now let's go ahead and snap a few constraints here. We want it to be always at the bottom, and this one too. We want to make sure that it's always about there in our application there. Okay, so these are our constraints. Next thing we're going to do here, we're going to put a text view for our result. Okay, well, I'm here. Let's go ahead and snap that over there. Very nicely done. We'll do this until it becomes a second nature for you. All right, so we have text here. Let's make it a little bigger and bold first. I want to put it centered. And let's make it about 18. That looks good. That's not too bad, not too bad. And while we're here, we're going to go ahead and give IDs, because remember, those are very important so that we are able to invoke those in our code, in our Kotlin code. So this is going to be result text view ID. Okay, and let's get rid of this text view text there. We don't want that. We're just going to remove that. And for our show weight, we're going to say show weight button ID. I'm going to say yes. And for our enter your weight, we're going to say EditText enter weight ID, like that. And this says update usage as well. This just means that we need to update all the references within our project. Just always say yes. That's good. All right, so we have our IDs. We don't need to give an ID for our title here because we're not going to reference it in code anyway, so we don't need that. All right, so let's go ahead and save this and run our app. So click in this run button here. And of course, it will show right away connected devices. In this case, I've been running this emulator here. So just go ahead and say OK. Okay, so we have a problem here. It says Android dimensions wrap content fill parent 22. All right, let's see what the problem may be. Maybe it's this here. Let's go back to wrap content. Perhaps that would work. I'll put this in the middle like that. Save and give a run. See if that's gonna solve our problem. It's running. All right, there we go. We have our app running. Okay. If you end up having issues running when you change things and errors like those happen, I usually go to build, right, and just say rebuild the project or clean project. Okay, and usually that solves the problem. All right. All right. So likely our application now is running. Of course, it's not going to do anything because we haven't done anything with the code yet. In the next video, we are going to write the code that will allow us to enter our weight and then show weight, and we'll show here at the bottom our weight on Mars. Okay, perfect. I'll see you in a bit. All right, so we'll continue here with our application, and what we're going to do now is look into the code part of things, which is fun. All right, so let's go ahead and take a look. I'm going to stop this and go to main activity KT for Kotlin, and we have our main activity here. Set content view function being called, where we pass our layout, okay, which is the activity main, which is what we have here. So essentially all of this is being called now. Okay, now this whole process again is going to be simplified because we were able to add this Kotlin Android extensions here. All right, so now this is going to be way easier for us to directly access those IDs and fetch those widgets. Okay, if we didn't have that, we would have to do it the other way. Right? Okay, so let's go ahead and fetch our weight, enter weight, edit text. So what we're going to do, we're going to create a var here, and it's going to be weight. It's going to be, now we're going to go ahead and say enter weight, right? This is our ID dot text. And you can see here that text, it says it's from get text. Because Kotlin is so amazing, we'll use the same variable here to get and set text. Okay, so now here in this case, we are getting it and put inside of our weight. Okay, and next, what are we going to do? What else are we going to do? We're going to go ahead and get our button here. Okay, so I'm going to put get our button. Our button was button show weight button, and we're going to set on click listener. So we're going to say dot to access our set on click listener, and notice again we have two ways we could have done this, but we're going to use the first one like that. And once we do that, now we have our set on click listener, and inside here this is where we are going to show our calculations to get weight on Mars. Okay, but because we are smarter than this, we are actually going to create a function here outside. I'm going to call this calculate weight, like that. Okay, now this function here will have a few parameters, because in order for us to calculate weight, in this case we just need to get the weight on Earth, which is what we are getting here. Okay, so I'm going to go ahead and say user weight, and I want it to be a double because users can actually add a double, something like 89.78. Okay, so we need to allow for those numbers. So here is where we're going to actually create a logic to calculate our weight. So I went ahead and looked online, okay, did a little research and found some information about calculating our weights on different planets. Okay, so this website here is livescience.com, and to calculate a person's weight, you have to multiply the mass of the person, so the person's mass, times the surface gravity. Okay, so mass in this case, our mass, because we're on Earth, is going to be our weight on Earth. So to get the weight on a different planet, we have to multiply our mass by the surface gravity. So in this case here, they even say, let's say if you are 150 pounds on Earth, which is 68 kilograms, okay, you would weigh about 351 pounds on Jupiter, which is 159 kilograms. Okay, so you just take your Earth weight and you multiply by these numbers here depending. So in our case for now, we're going to do Mars. So we know Mars is 0.38. That's the surface gravity. So we're going to use that information for ourselves here. So we're going to use that information. Now, what are we going to do here? We're going to create a variable outside here. I'm going to call this variable val, because this variable is not going to change. So it's going to be val. I'm going to call this Mars gravity, like that, is of type float, and I'm going to give it a value of 0.38, and of course I'm going to give it F there. Okay, so our Mars gravity is 0.38. Okay, so these now I'm putting outside here because I will be able to access it everywhere in our class here. Now inside of our calculate weight here, we're passing our weight, which is a double, okay? But what we need to think about here is that this function here is just a void function, which means it's not returning anything. Let's make it so that it return a double. So we're going to say colon double like that. So now we have to return something. For now, I'm going to put return 0.0 so that we don't get an error. So remember again, it's a function name. We pass in a user weight, which is a type, which has a type of double. And then we're saying here, this function here has to return a number. In this case, it's going to return a double. So what we can do now here, we can do the following. We can say var result is equal to user weight. All right, what we are receiving here, I'm going to say times, that asterisk for times, multiplying. What are we going to multiply by? We're going to multiply by Mars gravity, like that. Now we can then return result. Okay? Because we're talking about Kotlin, and the whole idea behind Kotlin is to simplify our code and make things easier to read and easier to maintain, we could have just gone and done this. Just cut this and put like that, and get rid of all of that altogether. So now look at this. Calculate weight is a very small and very concise function, right? We're just returning user weight times Mars gravity. Okay, that means now when we call this method or this function inside here, we will be able to then add this value to our text view. All right, so now that we have our calculate weight done, so what we're going to do here is the following. We're going to go ahead and create a variable. I'm going to call this var weight, okay, because we want to be able to get our entered weight from ID, right? So we're going back here and get this weight here. If you hover over again, you should see the ID, enter weight ID. So we're accessing whatever we are getting from our edit text. So we're going to say dot text. So now we have our weight, whatever we're getting from our edit text. And next thing we're going to do is to access our button, because we want to be able to, when they click on this show weight, to then display the weight on Mars. So we're going to go ahead and say show weight button ID, that one there. And you can see it says for activity in Kotlin. We can say dot set on click listener. So we're going to get the first option there. And there we go. So inside here, this is where we are going to call our calculate weight. Okay. So what we're going to do here, we're going to say var, we're going to create a variable called the result, and we are going to set it to the calculate weight. And notice the calculate weight returns a double. That's why we can do this. Now we have to pass in a user weight, whatever the user entered for their weight. In this case, it's going to be weight, because that's what we've entered here. Now the problem here is the following. It says required a double and found editable. What this means is that when we get our weight here, when we say enter weight ID.text, going back here, we're getting from our edit text, the type that is shown, it's an edit text, or editable type as they call it, okay? So it's not necessarily a text or a string yet. So what are we going to do? We're going to convert here. First, we're going to convert to string. So if we go dot to string, okay, we still have a problem because now it says require double found string. So we're getting closer. So before we were just this editable object, so the edit text, now we are string. So the next thing we're going to do, we're going to continue say dot to double. Okay, so now our weight, we went from just being an editable, what do we got here, and we transformed it into a string. And then we went farther and made it a double, because that's what's required in order for us to calculate the weight. Okay, so now our result here has the result we are looking for. So if we go back to activity here, we have this text view here, and its ID is result text view ID. So we can say here result, there we go, text view ID. We can set text like that. We want it to be equal to result like that. But we're going to have a problem again because result again is a double. And the text view here, they receive text views or text, it says your char sequence, same thing as text or strings. Well, what we can do, we can either click here and see what they suggest and says add to string. Indeed, select that and we are done. With just a few lines of code, we were able to get our app. Now let's go ahead and save this and run and test before I celebrate here. Okay, let's go ahead and run. And it's running. I'm going to go see. All right, so what's your weight on Mars? So let's say, just to make sure that we are correct, what I'm going to do here is I'm going to follow what they say. So he said if you weigh 150 pounds on Earth, you would weigh 351 Jupiter and about 26 on Mars. So we should receive 26 if I put 150 pounds. This is how we know whether we are off or not. So 150 and 57, which is exactly what they said here, 57 pounds. Okay, so our app is indeed working, right? So we can put any other, let's say if I am 230 pounds on Earth, and then on Mars, I'm going to be 87.4 or 0.40 pounds. Okay, what if we wanted to append or add a string here that says you weigh this much on Mars? We can do here, just simply, we can go ahead and say the following. Say you weigh, like that. We save and run. In fact, let's add another one here. Say plus on Mars. That's probably better. Let's run. Okay, let's start with 150. Show you weigh 157 on Mars. So you notice we have a problem here. Our text is cutting off at the bottom here. That's simply something we can solve real quick. So if you go to our text view here, and we can drag it a little bit down here to make it so that it's larger, like that. Hit save and give it another run. We should be able to say 130. And now you see it looks good. So you weigh 49.4 on Mars. Very nice indeed. All right, so play around with this concept here. You can see you can quickly create a very simple but powerful application, right? As you can see here, we were able to grab our weight, right, from our EditText and put it inside of a variable, and then we invoked our show weight button ID, and we just said set on click listener. Okay. Again, if you come from my previous courses on Android development using Java, you'll see there's a huge difference here in terms of code. Because in Java, you would have to do a little bit more work to get the same results. So that's the beauty of Kotlin. So we said set on click listener, and we create a result variable, and then we got the calculated weight, right? This method here, because returns actually a number, in this case a double, and we put inside of our result. And then we called the result text view ID, and we set it text to our result. Very simple. All right. Okay. I'll see you in the next video. In this video, we're going to talk about a new widget called checkbox. Okay. I went ahead and created a new project. I call this checkbox, and I urge you to do the same. And make sure that, again, we add these Kotlin Android extensions here. Okay. If you don't add this again, it's going to be hard to follow what I'm doing. Okay. This just allows us to make our code as simple as possible. Okay, so add this inside of our app module here, build that Gradle, and we should be good. Make sure to sync as well. All right. Okay, so in our project here, of course, I'm going to design, and I'm going to get rid of all this. We don't need that. So what we're going to do here is to go to palettes. If you don't have that open already, let me just give a space here. So click that, and let's find our checkbox. So checkbox, as the name implies, allows users to tap and select certain options that they want or choices. Okay, so we can put here, we're going to get a few checkboxes here. Add a new one, and let's put a third one here, just like that. All right, it's a little bit bigger so you can see. Let me go ahead and make sure that they are all constrained. These want to be at the bottom of each other, like that. Like that. I'm going to move it down here, down there, move it all of it like that. Okay, maybe this a little bit down here. Okay, so we have our checkboxes. So checkboxes, again, are used when you want to allow users to pick or choose a certain option. For instance, this checkbox here could have a different title because now the default says checkbox. We can change that text there. So if you go back here, we're going to say veggies. Okay, and the next one we're going to say meat. And of course, you remember we shouldn't do it this way. We have to put all of this inside of our strings. But for this example here, I'll give you a pass. You can just go ahead and do this. Okay, just hard code everything. And you can see we have this warning here, yeah, to use string resources. All right, and this will be fruits. If you go back, you should see the names have changed. Let me go ahead and align to the left like that. If I wanted, I can make it all to have the same size. Just to align things, I know. There we go. Okay. This one has to be a little bit... there we go. I think that should be good. Perfect. So we have here first option, veggies, meat, and fruit. Let's go ahead and change the IDs. So we're going to say this one's going to be check veggies. Okay. And say yes. And this one's going to be check meat. Say yes. And the last one here is going to be check fruit. And say and enter. Like that. So now all of them have IDs, which means we'll be able then to access all of them in code. The next thing we're going to do here, and I haven't shown you this, we're going to add an onClick method inside of our text here. So if you go back to text, anywhere here, we can go ahead and say onClick. You notice there is this onClick here. So this onClick here will be a method or function that we're going to use to fetch the event, okay, when users tap on the screen or they check or uncheck our checkboxes. So we're going to give it a name. We're going to call this onCheckBoxClicked, and we're going to copy all of this and add to other checkboxes as well. Okay, and we'll create this method or function in a minute here. All right, let me copy this. All right, so now go to main activity here. What we're going to do, we are going to create a function, right? Say fun. And we're going to call this onCheckBoxClicked. And the thing that we need to do here is we have to pass a view. Because remember, all of these widgets are views. Okay, so everything in Android, everything that you can put on screen is an actual view. So think of a view as this parent class, which all of other widgets inherit from. So a button is a view, a checkbox is a view, any other widget inherits from a view. Okay, so naturally, in order for our method to work here, our function to work, we have to pass in a view. So what we're going to do, we're going to say view is going to be of view type, Android view like that. Okay, so now we have our onCheckBoxClicked, which has the same name as what we have inserted inside of our checkboxes, the onClick. Now, just to show you that this actually works, so I'm going to show you the log class. The log class allows us to log, as you see at the bottom here, we have this log cat. If you tap and click on that, then this console shows up here. So what's happening here is that as we run our applications while we're developing our apps, whatever's happening in the background of our app is logged here. Okay, which means we can actually log messages into this logcat console here, so we can see how things are working in our application. So it's very handy. Now to invoke our log, we say log, because that's a log class, and right away you have our log Android util. Say enter and say dot. There are a few types of logs. We have D logs for debug, we have E for errors, and so many. Okay, but you notice something in common here. For any method that we're going to use in our log class, we have to pass a tag, which is a type of string, and of course a message, which is also a type of a string. Okay, so if we go like that, and usually what I do, I say checks like that, and for the message, say checkbox clicked like that. Okay, very simply, let's save this and give it a run. And you can see, like I said, because our logcat is open, you see all of these different things, all of these logs being shown here. It says installing APKs. So installing our app, I'm gonna go ahead and open it. And there we go. There is our application. So we got veggies, meat, and fruit. Now I want you to keep your eyes, let me put this perhaps to the right, to the left here. Just keep your eyes around here, okay? So I'm gonna tap this. It says D, checks, checkbox clicked, and G, checkbox clicked. So each time I tap, I click or check, this happens. So now we were able to log our event here on our checkbox clicked. So we know this is working. We don't need that. In fact, I'm just going to go ahead and comment that out because we know we have about 3 checkboxes here. We need a way to control all of them. So to check which one was checked, no pun intended. Okay. So what we're going to do here, we're going to create a variable called isChecked, which essentially will hold whether a checkbox was checked or not. And remember, this view here that we're passing is actually going to be these views here, such veggies, meat, fruit. Even though we call them widgets, they are still views. Okay, they inherit from our view class. So what we can do, we're going to say var. I'm going to call this isChecked, and I'm going to make sure that this is a boolean. Okay, and I'm going to say is equal to view, right? The view that we're passing here, which depending on the case, it's going to be all of these 2-3 views here, and say dot is checked. Now we have a problem here because it says is checked. It's not being recognized because this view here is just a simple view. It still doesn't know what kind of view we're specifically talking about. So what we need to do, we need to make sure that our compiler knows that, well, this view is not just any type of view, is indeed a checkbox view. So what we're going to do, we are going to cast. Okay, casting essentially means, well, we know that this object, a certain object, is of this type, right? But we want it to be this other type because we want to be able to work with it. That's what casting means. So the way we cast object here in Kotlin, we just say, in this case, we're going to cast our view to be a checkbox. We're going to say view as checkbox, like that. You notice right away here we were saying cast our view as a checkbox object or type or view. Okay, remember again, this view here could be anything, could be a button, could be just the whole screen, right? So now we are specifying we want this view here to actually be of type checkbox because we want to access all the properties of a checkbox. You notice right away our view now we can access is checked because a checkbox has this boolean variable called isChecked, which returns true or false depending whether it's checked or not. So next, what we're going to do here, once we have that, so once we have that, we can do the following. We can use a when. Okay. Now, if you're coming from other languages, Java or any other language, this is same as switch. So we're going to say when. Okay. Now we need a value that we can check, that we can actually use to check, right? So in this case, what we're going to do, we're going to just check, say view dot ID, okay? Because each view, in fact, if you go back to our main XML here, notice each view, so veggies, we gave an ID. So check veggies, meat, and fruit, check fruit. So now we're saying, well, because we have those IDs, we're going to then go through and check and see which checkbox we are checking. So let's go through all the IDs. Now, how do we access all those IDs here? To access anything in Android, IDs and resources and everything, we use this class called R. The R stands for resources class, okay? R. In fact, you look at here, when we say set content, we access R. We say R dot, then we can go to layout, which means we are going to open this folder here, layout, and inside of layout, we go to activity main. Okay, so R is very important. You will see that happening, being used all the time. It's just a class resource file class that allows us to access resources. Okay, so to access our resource ID, in this case, we can say R dot, right? In fact, you do that, you see all of these things you can access. We want the ID, so we say ID dot. What ID we want? Well, we want the veggies, for instance, check veggies ID, and we got that one. So we're saying if in case they have tapped the r.id check veggies, we want something to happen. In this case, we just want to say, we're going to check if it's checked. Again, remember this is checked here is a Boolean. We're checking if this check view or this check ID here, this veggies is checked. We want to do something with it. So we're going to say if this check is checked, that Boolean. So if it's true or not. If it's true, we just want to go ahead and say log d. I'm going to say veggies, and we're going to say is checked. Okay. In case of r.id dot, I think we said check fruit, we're going to say if, I'm going to check again, is checked, right? We want to say log.d, this is what? Fruit. And we want just to display, say something like is also checked. r.id again, we want check meat. If is checked, we are going to say log.d, this is meat, and we're going to say is checked, like that. All right. Very simple here, nothing too complicated. Okay, we're just checking if the ID that we just tapped, if the item or the checkbox is checked, we're just going to say veggies. Okay, we can also put here say else, means in other case, if it's not checked, right, we can just copy this, and I'm going to say here veggies not checked. Can copy all of this because it's going to be the same everywhere else. Oops. Else, this is what meat, fruit, not checked, and meat, no checked. Okay, so save this. And notice we don't have to call our function anywhere because we already said here that it's being called from directly from here. Okay, so now if we run this, all right, let's go open, clear all of this. Now pay attention here. You'll see things happening. All right, so if I go and click on veggies, you see it says veggies is checked, meat is checked, fruit is checked. If I uncheck fruit is not checked. If I uncheck meat, no checked, right? I should say meat, no checked there. And veggies, you see veggies not checked. All right. Very nice indeed. So you can see now we can do a lot of things with our checkboxes. We can check whether they're checked or not. If they're checked, we can do something. If not, we can do something else. Right? Very, very, very nice indeed. Okay. And of course, if you don't like this style of having everything in one line, you can break it up and put everything in different lines. But I like this because it just makes sense, because now we know that veggies will run this entire code here and fruit will run this and so forth. Okay. All right, so I'll see you in the next video. All right, so now that we know a little bit more about other widgets, specifically about our check boxes, let's go back to our wait app here that we built before and work on it. So we're gonna improve upon it, okay? So what we're gonna do here is we are going to add a few elements inside of our user interface here. Namely, you may have guessed, we're gonna add a few options or a few checkboxes, okay? So what we're gonna do here, instead of saying on Mars, we're gonna change this to be more generic. So we're gonna go back to our text values text here. Instead of Mars, we're just gonna say on dot like that, and then go back, you see it says what's your weight on, which means then at the bottom here we are going to put at least 3 check boxes. So I'm going to go ahead and select all of these and move down for a bit like that, and then here, right about here, I'm going to put let's go and find a few checkboxes. I'm going to put a checkbox right about here. Checkbox to the right there. And one more checkbox about there. So I'm going to go ahead and make sure that these checkboxes are actually going to be always below our title here. Let me make this bigger so you can see. Like that. Perfect. Now, if we want to see a different view, we can very easily change so you can see in a bare bones view, and we can just get rid of that altogether if we want, or just have that both, or we can just have one like that. All right, so now we have our checkbox here. Now we can go back and open properties so we can change options here. But before we do that, let's go make sure also that we know it's always below our edit text at the bottom here. Say Control Z. Sometimes it's tricky to see, but nevertheless. All right, so there we go. Okay, so for our first checkbox, we're gonna call this Mars checkbox. For our second one, we're going to call this, and in fact, let's change the text to Mars. Let's go ahead and actually create a resource file. Mars, I'm going to call Mars like that. So it says Mar. For second one is going to be Venus checkbox. And let's change the title or the text to reflect that. Venus. And last but not least, well, let me make sure that all of this is actually okay. This one is going to be what do we want? Let's say Jupiter. Oops, yeah, let's say Jupiter checkbox. And say text. We're going to change to Jupiter. I think that's how we spell it. Perfect. Let's make sure we are at least aligned and put it in the middle of the screen. So that's the middle. Means I'm going to put this right about here. Okay, that's fine. All right, let's go ahead and save this and give it a run to see how things are looking. All right, let's take a look, and there we go. Things are not looking that great because we forgot to add another constraint here, but which we'll do in a second. All right, so at least we see Venus, Jupiter, and Mars. Let's go ahead and change this then to make sure that at least it will always be to the right and give. All right, saved and run. This looks decent, looks good. Okay, perfect. Now that we're ready, let's go back to our main activity here. So the idea here is for us to be able to fetch all of these checkboxes. Okay, just like what we did before in the previous video when we started looking into checkboxes. Previously, what we ended up doing was we added hard-coded here the onClick event, the onClick function that is to be called for each checkbox, right? Instead of checkbox, we said onClick, and then we went into our main activity, and then of course we created that onClick function. Although that works, but you notice it's very limiting. It's limiting because, as you see here, if we had, for instance, about 20 of checkboxes, we'll have to go and add 20 onClick, right? Which is okay, but it's not very flexible. I'm going to show you the other way in code. So when we go to our main activity here, you notice at the top here it says class main, and it extends app compact activity, which is this class that gives us all these functionalities on create, so we can actually run our application. Now, the beauty about that is that we can also add another interface. In this case, we want to go and get the onClick listener interface. So what we say, we just put comma and say on, And the moment you write that, you notice there's a lot of different interfaces that we can use. In fact, you see it's an interface because there is an I to the left, right? Here you can see this says an I. So what we want the on-click listener view. So say enter. The moment you do that, then you will see there's an error here. What this does is that this class needs to implement certain abstract members. So if you click, you'll see this red bulb, click on that and say implement members. The moment you do that, you will have this. Okay, so now we have this contract, which means we have to implement this on-click if we want to use the on-click interface. So say, okay, now you notice we have this on-click function. Okay, so this on-click function here, you notice it takes in a view of any type, okay, which is very handy because then we can attach any view we want. We want to attach our checkboxes, but if we had buttons, we could have done the same too. Okay. So it's more flexible now. Now I don't like it to be at the top here. I'm gonna put it somewhere here. Okay, very nicely. So we can get rid of this. That's totally fine. Okay, so what we're going to be doing now is the following. Before we go any further, of course, let's go ahead and get a few more surface gravities here. Let's go back to I'm gonna go back here. So we said we want Venus, I believe. We said we have Mars, Venus, and Jupiter. We already have Mars, so let's go ahead and get Jupiter. So I'm going to go ahead here and say val. Again, we're doing val because these are static or immutable or variables that don't change. Okay, I'm going to say Venus gravity. It happens to be, according to our website here, it happens to be 0.91. And then val. We want Jupiter. Which happens to be 2.34, like that. Okay, so those are the values we're going to be using depending on which item was checked. Inside of our on-click here, because we know this view here is of type view, so any type of view. So we want to make sure that this view is an actual checkbox, right? So we're going to do some casting here, so converting one object to the other. What do? We say view, we say v, right? Because this is what's being passed there. We can say as checkbox. Next, we're going to say var is checked. Okay, so this is going to be a Boolean type. We don't have to specify it, but I'm specifying it. I'm going to say is equal to, then I'm going to say v dot is checked. Okay, so it's checked now is either true or false. All right. Then I'm going to use a when statement here. Okay, inside I'm going to pass, I'm going to say v, because remember this v again is of type checkbox right now. It's not just a general view. So I'm going to say v dot ID. So I'm getting each ID from our checkboxes here. Okay, all these three checkboxes. And then what I'm going to do here, I'm going to go ahead through all of the options. Okay, so I'm going to say r.id. Again, I'm accessing the resource files. ID dot, I think we said Mars checkbox. If that's the case, I'm going to check. I'm going to say if, again, is checked. If it's true, I'm going to just go ahead for now and say log. Say log. I want the Android utility log. Say dot d. I'm going to say set up Mars. Mars, like that. Okay. And I'm going to say r.id.Venus checkbox. And I'm going to say if is checked. Okay, I'm going to do the same here for simplicity for now. I'm going to say log dot d set up Venus. Let's say Venus like that. And r.id dot Jupiter, I think. Yep, there we go. Again, we are accessing all of the IDs from our view here, from our interface. Okay. If is checked, I'm going to say log.d. I'm going to pass, this is going to be Jupiter set up Jupiter like that. And Jupyter. Okay. Of course, we'll do more than that in a second here. I need to close that. Now, let's go ahead and give it a quick run here to see if things actually are working. All right, there we go. Let's see. Let's open our logcat here. Okay, just pay attention at the bottom here. We should be able to see stuff. I'm going to go Venus. And as you can see, we don't see anything in our log here. What might that be? Now, the reason why this is not working, or we're not seeing anything here at the bottom, even though we added the code, right, that goes through and sees which ID is being clicked, and if it's clicked or checked, we then are supposed to see a log. The reason why is because, well, because now we are actually using an override on click method or function in this case here, we need to register our checkboxes so that our system knows exactly that, okay, these are able to receive on-click events. Okay? So how do we do that? Well, we have to access all of these and set them up. How do you set them up? You simply do the following. In this case, let's start with Mars. Say Mars, checkbox, say dot, say set on click listener. There it is. Okay, just say enter. In this case, all we're gonna pass is this. What does this mean? This means, well, this class here. Because, well, this is the class that also inherits or is using this interface here of on-click listener. So we're saying just pass myself here, main activity, and we are set. Right, so we are registering our click listener. Okay, and we have to do the same to others as well. So Venus checkbox, that's set on click listener, and pass this. Let's finally do Jupyter. That's set on click listener, and pass this as well. So now if you save this and give it a run, we should be able to see what we're expecting. Go ahead and open logcat. Clear it. All right, let's go and see if this is true. Click and you see Mars. Click and Venus is set up and Jupyter is also set up. And of course, if we uncheck, nothing happens because we haven't added the else statement. So in this video, we were able to put together the user interface, at least to add onto your wait on app here. So we added 3 checkboxes, and we were able to set them up in such a way that it's easier for us to add as many as we want. Okay, so we set on click listeners to our checkboxes, and we have this on click, which is an override method that is implemented on click listener here interface. Okay, perfect. So I'll see you in the next video where we'll continue working on this app. All right, so now that we know that our checkboxes are all set, it's time to start thinking on how we're going to add all of this new functionality. So the idea here is to make sure when they run the application, they can check which planet they want to see, what would their weight be. And remember, when it comes to building application or even programming, there's always different ways you can do things. We know that we can, if it's checked, we can do something. In this case, we're just saying set up Mars. We're just logging that to the console, so we were able to see that things were actually working. But what we really want to do is to be able, if they say, if Mars is checked, we want to make sure that we calculate the Mars weight. Okay? Same thing, if Venus is checked, we want to make sure that that also happens. Same goes to Jupyter. All right, we are going to rearrange a few things here just to make things a little bit easier. Our calculate weight here, as you can see, it returns a double. Okay, so it worked fine when we just had to get one weight. In this case, we have 3 options. So I think the best way to do this, I will just get rid of the return type, which means we won't return anything. So now what we can do, we can just put this, say, result here. Okay, so result var result. Now it's going to be whatever we are getting from our users, right? So the weight, and then we're multiplying it by our, in this case, Mars gravity. So what we're going to do here, we are going to use this calculate weight, and we're going to move the sum of these items here. In fact, we're going to move all of the text this one here. I'm going to put it here. So what I'm going to do here, I'm going to just comment this out. So that way you have this code if you would like to use it this way. Okay. So I'm going to redo everything inside of our calculate weight here. So what I'm going to do here, let's go ahead and fetch our weight or our enter weight here. So inside here, because we are getting the weight from our user, okay, now we don't return anything, so we are actually going to calculate our result. Now let's think a little bit more further here. So the idea here is to make sure that depending on which item was selected, we are going to be able to show the weight on that planet. So it would make sense then for our calculate weight here to make it to do a little bit more work than what we have right now. We have this user weight parameter, which of course is going to be the weight they have entered. Okay. So the next parameter we're going to pass, because we want to be able to use inside of onClick here, right? This onClick checkbox. So what we're going to do here is we are going to add another parameter here. This parameter is going to be a checkbox, because then we will be able to call inside here, and then we're going to pass this checkbox, and we can check to make sure that we are selecting the correct one, if that makes any sense. So what I'm saying here, we're going to say checkbox, right? It's going to be of type checkbox. So now we're passing two parameters, a double and a checkbox type. Now inside here, since now we have our checkbox type, what we will do is do the following. First of all, we're going to say var result, because we're going to be changing a few things here. I'm going to just make it a double, just like that. And now we just can use it. Okay. And next, what we're going to do is we are going to use another when expression here, because we want to be able to check again for the ID of the box, because that's what we are passing here. So we're going to say when, okay, checkbox.id, and we're going to give pretty much do the same thing we did here, but we are going to implement something here. So this result here, depending on which case we have selected, it will obviously have different result, right? So if it's Mars, of course, we're going to use the Mars gravity. If it's Jupiter, we have to use Jupiter, and if it's another planet, we also have to account for that. Okay. So what we're going to do here, we're going to say, in case that we are talking about r.id.mars checkbox, we're just going to go ahead and do the following, and I'm going to say result. In fact, I'm going to copy this. In this case, the result is going to be user weight, whatever they entered, with Mars gravity. Okay, that's nothing new there. In the case where r.id is Venus, okay, we want to do result is going to be something totally different. In this case, result is going to be user weight again, but instead of multiplying it by Mars, we're going to multiply it by Venus gravity, which we have created at the top here, this variable. Okay. And in the last case here, id.Jupiter, we want result to be equal to user weight again times Jupiter gravity. Just to be safe, so we have now, for depending on which case, we are setting our result to be something. But just for safety, we are going to add an else here. In case of none of those are selected for some reason, what we want to do, we're just going to say result is always equal to weight times the Mars gravity. Okay, just a very precautious move here. Okay. And once we've gone through all of that, we are going to do the following. We're going to say result text ID, right? Our ID where we add our result, which we went ahead and commented out here. Now we're going to set it to something. Well, we're going to set it to the text to say weight is, and we're going to pass our result. Okay. Now this calculate weight here is ready to be called inside of our onClick, right? Because remember, we're passing the user weight. We're also passing an object of type checkbox, which is exactly what we need in order for this to work inside of our onClick here, right? Because we have this view here, which is of type checkbox. Okay. That just means now instead of having this log here, we can actually call our calculate here. Say copy this, If you call here, now we're going to pass the parameters. The first one is going to be user weight. Okay, so what we're going to do to simplify things here, I'm going to call get this var here, which is the text view that gets our weight, and I'm just going to put it here. Okay, so now we have this weight here, so enter weight ID, we get the text of our weight, okay, the value, and we're going to pass it here. Well, but this is a text, so we need to say to string, but we need a double, so I'm going to say dot to double like that. Okay, and then we need another parameter, which is a checkbox. Well, which checkbox? We're just going to pass a v. Right, this v here is our checkbox. So going back here, what are we doing? Once we get that checkbox, we check for the ID. Just essentially the same thing we did here. It may seem a little bit confusing here, but what are we doing here? It's very simple, right? So we are calling the calculate weight, which passes our double user weight, whatever they entered, and then we're passing the checkbox here. Okay, so it comes here. So when this onClick runs, it goes ahead and check if it's Mars checked. Well, if that's the case, if it's checked, it's true, it calls the calculate weight because it's checked, right? And the calculate weight takes in the weight. We have to make it a double because it comes in as a string, and then the actual checkbox. So that way we know checked right now is Mars checkbox. Then we're going to show the correct results. So we're going to multiply the user weight times Mars. If it's Venus, we're going to do the same, but now we're going to change to Venus gravity. And if it's Jupiter, we're going to make sure we multiply by Jupiter. Okay, and then of course we just say weight is and pass in the result into our result text view. Okay, so we only have one here, Mars. So let's see if this is going to work. All right, so we have that there. Let's give 150 and tap Mars. And the moment we do that, notice we didn't have to go and say show weight because we say here, right? When we call the calculate weight, it calculates right away. It just goes ahead and fetches the result text view and say text is equal weight is that. Okay. If you go show weight, nothing really happens, which is fine. So let's do the same thing with others. So I'm going to copy this and paste it in here. And do the same here as well. Let's save this and run. Let's see how this works. Now, if we say 150, say Mars, you see it says weight is 57. Let's put a space here. Let's run once again. Just being picky here. All right, so say 150. And because we want to make sure we actually correct, it says here, so for 150 pounds, 351 on Jupiter. Let's go to Jupiter like that, 351. Good, so it's working. If we go to Venus, it's 136. Okay. If you go back to Mars, it says 57. All right. Very nicely done. So it's working. There's a few things we need to do to clean things up a little bit here, but hey, nevertheless, this is actually working. Okay, I do understand this may have been a little bit of logic crash here. You may feel a little bit overwhelmed, but it's okay. That's very normal. Just remember to ask questions if you have them. And the more you look into this code, you read through and try to really pinpoint, you will see that it's not that bad. And of course, there's other ways you could have done this. And we will clean this up in the next videos. Okay, all right. I'll see you next. Hello, folks. Welcome back. Now, our application here is looking pretty good, right? So if you run this and we put, for instance, 123 and we go Venus, says weight is 111.93 in Venus, okay? But you notice something here. If we go ahead and run this app again and we accidentally go ahead and do that, you notice that our app stops, so it crashes. The reason is because the moment we check a checkbox, what happens is we are calling the calculate weight. Well, the calculate weight here takes in the user weight, which is what users have entered, right? So the reason why it's crashing is because At this point, if you just go ahead and touch or check any checkbox, the user weight is null, so there's nothing in there. Okay, that's why it's crashing. So to fix that, we are going to do something different. So to fix that, inside of our onClick here, right, this is the method or function that's called when we check a box. Okay, so inside of the if statement here, what we're going to do, we're going to add an and, right, because we want to make sure that if it's checked and something, in this case, and the enter your weight edit text here is not empty, only then are we able to show the result to do the calculations, because that's very important. We want to make sure that this is not empty. All right, so what we're going to do here is inside of our if statement, where we're checking if it's checked, right, we want to also make sure we're going to say and, so 2 ampersands there. We're going to say and a very handy class called TextUtils. Now, TextUtils is a class that comes with Android that allows us to check if a certain item is empty or a certain string is empty or not. So we're going to say text. See, there is here TextUtils. It's just a class. We're going to say enter dot, and there is a method there or a function that is empty. Okay, so we're going to say is empty, and then we pass in the string that we want to check whether it's empty or not. In this case, we want to pass in our enter weight edit text, which is the edit text that collects information from the user, in this case their weight, right? We're going to get the text and we're going to make it to string to make sure it's a string. Okay, so we're checking if it's checked, and it has to also be make sure that this is not empty. But in this case here, to make it not empty, right, so we're going to go put exclamation mark at the beginning like that. Okay, so we're saying not empty. So if this is not empty, whatever we're passing inside, and is checked is true, only then we are going to display or make the calculations. Okay, so let's go ahead and bring this down here. That way we have the space, everything is spaced correctly. So I'm going to do the same to others. So I'm going to get all of this, copy and put it here, and I'm going to bring this back here just for space reasons here. Paste in there and bring the body here. Okay, very cool. So now if we save this and run, we should notice that our app is behaving better than before. All right, so let's check it out. If you go just like that, when it's empty, nothing is happening. At least now the app won't crash, which is good. So now we can go ahead and enter something here. Go like this. Let's make our text view a little bit bigger here, because we're having another issue that we didn't account for. Let's go and make it really large, because I want to see what the problem is. Let's run once again. Okay, let's go this and say 123. There we go. Okay, one Venus, Jupiter. All right, now the next thing we need to do here is trying to figure out how do we then change depending on what we have selected. In this case, the weight should be for Jupiter, but we don't really know if this is for Jupiter or if it's this for Venus or for Mars. Okay, we know as we go, right? If we go like this, right, we can see now it's probably Venus. But how about add, say, weight is this and then on Venus or on Mars, whichever planet was checked. Let's go ahead and fix that. All right, so here we need to go to our calculate weight here, but this is where we are actually calculating and displaying the text. What we can do here is the following. We can go ahead and put all of this inside of brackets because we want to add more than just that. So what we can do here, put this like that. So what are we going to do? We are going to get this and put inside here. So now we know that in case is Mars, we're going to say weight is that result, and we're going to say on Mars like that. Okay, so we're going to go ahead and copy this, do the same here. Okay, we're going to say this is going to be on Venus, I believe. Yeah. And of course, we're going to do the same here as well. this is Jupyter. Okay, like that. Let's go save this and give it a run. Okay, it should be running. Let's give 189 on Mars, and weight is all of this on Mars. Okay, we change to Venus, that's our weight. On Jupiter, that's our weight. We go back to Venus, go back to Mars, and we have all of that. Now it says here our weight is 71.82000001 on Mars, so it's giving us a very large decimal point here. How do we need to fix that, which means we need to make sure that the numbers that we get, they are 2 decimal points instead of all of these decimal points. Let's go ahead and fix that. So in order to do that, I did some research and to find out how we can accomplish that in Kotlin. And this is a good time to let you in a really small, in a really awesome secret here. The secret is, ready? The secret is, whenever you're stuck, whenever you need help, whenever you don't know how to do something in any language, well, what you do is you do some research. Okay, in this case, I just typed in on Google. There's this site called Stack Overflow. Stack Overflow is a site where developers and people who are learning to develop, they go to ask questions, not only to ask technical questions, right? It's a very, very big site and one of the most used websites, okay, for developers. And they have other topics as well. But in our case here, so I went ahead and looked for formatting in Kotlin strings templates. So I said how to, essentially I just Googled how to format or how to round numbers in Kotlin. And this is what I find. Okay, it says here, unfortunately, there's no built-in support for formatting in string templates yet. As workaround, you can use something like this. Okay, so there is a function we can use to do that. Okay, let's go ahead and copy this. And what are we going to do? Okay, is create something around here. So here, what's happening here is that they're extending this double, and we say double that format, and we're passing in an integer, okay? And whatever we pass in here, we take it and then we invoke the Java format, and we pass certain parameters here, okay? In this case, we're passing whatever we are passing inside here, and we are formatting it, all right? So we have to pass in, and you can see at the bottom here, it says in order to use that, we say, for instance, pi, and then we say pi.format. Okay, we're formatting and we pass how many digital decimal places we want. In this case, they want 2, then this is what's going to happen. Okay, let's test it out and see if that works. So what we need to do here is go back to our result. I'm going to say result dot format. Look at that. Now we are using this format here. So format, and we are going to pass, in this case, 2. Okay, going to do the same for all of them. Like that. And like that as well. So let's see if this works. Let's save this. Let's make sure it was Mars, 189 Mars. Okay, let's run again. See if this works. Okay, let's put 189 Mars and look at that. Now it says 71.82 on Mars instead of 71.82 and 0.00001. Okay, so we go to Venus, and indeed that is also working. All right, and Jupiter as well. Very cool. So now no matter what, it will always give us 2 decimal points. Wonderful. That is great indeed. So we are making a lot of progress, and additions here was that we went ahead and we extended this double here. So this is one thing you can do in Kotlin, right? You can take a class and you can extend or add your own functionalities to it. We haven't talked about that yet, but you can see here how this just worked. Okay. And the next thing you notice here, which is not really ideal, is that as we start checking, right? Now it says Jupiter, all of the others are also checked. So what are we going to do here to prevent from this to happen, right? So to prevent from this to happen, what we're going to do here, let's go inside of our onClick, right, function method here. Let's make this so we're able to see better, we can add another statement here. So what we're going to be doing is that if Mars is checked, we want to make sure that anything else is unchecked. Okay, so what we can do here, we can say, for instance, Venus checkbox that is checked. We're going to make it say is false. Now we want to uncheck it, so we're going to do the same with Jupiter. That is checked. We're going to say false as well. Okay, and we're going to do the same to the others as well. But we have to make sure that the logic is correct here, because now in this case here, we want to exclude Venus, because in this case it's checked, right? We're going to get the Mars checked box that is checked. We're going to make it false, and we're going to do Jupiter that is checked is also false. All right, let's keep going here. I'm going to do the same to this one here. In this case, now we're going to go Mars and Venus. So we're going to go Mars that is checked is false, and Venus that is checked is also false, just like that. Okay, so let's go ahead and give it a run and see if this is going to work. It should. All right, there we go. So let's go ahead and give it 123, for instance. Go Mars. Of course, it says that's fine. And the moment we go to Venus, look, now Mars is unchecked, right? Which is nice, because now we know we are talking about Venus. Okay, and go Jupiter, and that happens again. If we go back to Mars, give 46, go back, and so forth. Okay, now you notice here we don't really need this show weight anymore, because it's just there, so no, it's not doing anything. So we can go ahead and get rid of it if we wish to do so, or we can just leave it there. Okay, but in a production application, an application that you're going to be sending out to users, of course you wouldn't have a button that's not doing anything anymore. Okay, perfect. So now our app is behaving like we want. Okay, if we put another number here, notice numbers are changing accordingly. All right, very, 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 very nice indeed. So we are now done with our What's Your Weight app. Of course, there's a lot of improvements you can do. I'll leave that up to you as an exercise. One of the things that I would like you to do is to make sure that the checkboxes are all invisible until they enter something here. If you would like, go ahead and add more things to this application here. Okay, make it your own. You can add more options here, right? If you want to add other planets, just go to the website that I showed you or find it online and add as many planets as you want to add. Okay, so they can either say Venus, Jupiter, Pluto, and many others as well. Okay, all right, congratulations, and I will see you in the next video. All right, so as we discussed before, an image view, and you notice a very recurring theme here, right? It says here image view, right? That means an image view is also a view. So that's one of the things I want you to remember as you progress in this course or in any Android course, is that everything in Android is a view. Okay, like I said, the view class is at the top as the parent class. So any other widget, all these widgets here, they actually inherit one way or the other from our view class. So if we say this is a view, right, these image views are views, right, that means then there's other things we can do to them. In fact, you can see to the right here, when we click, we have these properties. So there's so many properties that we can change, right? And these properties here are also accessible in code when we go to main activity here. Everything we see here visually can be represented or accessed via code. Okay, that's the whole idea behind developing applications using the Android framework. So now that we have our views here, image views, we can actually give them IDs and call this, this is going to be dog image view. Of course, this needs to update our XML reference, right? Remember that Java R file that I told you about is the resource file that needs to be updated constantly to make sure we're then able to access these IDs in code. So always say yes, and we go to cat. I'm gonna let's call this cat image view, enter, and we're good. Okay, so now if we go to our main activity here in our code, I'm gonna leave this there so you can see. So here in our code, we can then access those. We can then access these widgets, these image views here. So we can say var image var cat image is equal to, I'm going to say image cat image view, right? Like that. I can say var dog image is equal to dog image view, just like that. All right, so now I have access to cat and dog image view. Let's go ahead and change a few properties of our cat image view here. Okay, let's say cat image view dot and see what we can do. The moment we say dot, then we have a lot of methods. Let's see, we can set a color filter there as a method. Let's in turn we have to pass in an integer of type color, or a color of type integer. Okay, let's try that. We're going to say color. So there's a class in Java, in our Android, called color that gives us the basic color. So color dot, and let's give, for instance, a blue, just like that. Let's see what this does. So when we run the application, our cat image view, so our cat image view here will have this set color filter to blue. Let's see what that does. Give a run. Look at that. Look at that, right? So now we've changed the color filter to blue. Okay. What if we want to change, for instance, the dog image and say dot set color filter, and we say color dot cyan, like that. Save and run. Let's see, and look at that. Now it has this cyan filter. Okay, so we are able to then access a lot of properties of our image. On top of that, we can also do things like the following. We can actually, because we know it's a view, we can say cat image, for instance, dot set on click listener, right? So anything that we can put on screen, we can actually make that thing, we can actually make that item to listen to click events, right? Let's use the click listener that we get from Kotlin. In this case, I want to say, for instance, on click, I want to change cat image that I want to clear color filter. And once that is done, let me go ahead and put a new line there. Once that is done, I want to say cat image that set filter to something else. In this case, we're going to use a different version of set color filter, which in this case here, we pass in the color and we have the mode here. Let's try that one out. I have no idea what that it's going to do, but because we are cool, we're going to try it. So it's going to say color first. Can I say green this time? And then for mode, we're going to say Porter Duff, whatever that is, dot mode dot darken, something like that. Again, I have no idea what this is going to do, but let's see. Let's save that and run. So when we click on the cat image, we're going to clear whatever we have set previously here. Okay. And then we're going to change it to green, and then we have this Porter Duff mode to darken. Whatever that is, let's see. All right, so where's our cat? It's got to be this one. Tap and look at that. Wow. Look at that. Okay. So we can do all sort of things with our images, with our image views if we wanted to. You can see now you can do a lot of things. For instance, you can create an app that takes a picture, so it allows users to go and take a picture of something, and then they can have different filters on a picture. In fact, I'm sure you've seen apps that allow you to change the filters of your photos. This is how they do it. Okay? Very easy. It's not a big deal, right? You can do this. Okay, let's see here. Let's say cat image again. What else can we do? That set color filter. I can also set a background color. Okay, I'm going to so say color again. That I'm going to set it to magenta and see what's going to happen. Tap. And it probably set the background color to that, but we can't quite see there. Let me go ahead and clear all these just to see. In fact, I'm going to keep that because I want to clear. Let's go ahead and run. And click, and you can see now the magenta is showing. The reason why we weren't seeing before is because we were first setting the color to green and then the mode to darken. So it was overriding whatever we setting before, after. And obviously we can do the same with our cat image as with our dog image. So now you know how to use the image view widget and then perform a few actions onto those images. Okay, perfect. Great. So go ahead and play around with this concept here, and I will see you in the next video. In this video, we're going to work with image views. Yes, so an image view will allow us to put images inside of our app. Okay, so I'm going to go ahead and create a new project here. So File, New Project, and I'm going to call this Image Views or Image View App. Okay, maybe change this to Image View App as well. I'm going to say next, API 21, that's fine. Say next, and we want the empty activity, and say next, and finish. I'm going to go ahead and create our new project here. Let me show you something quick here. So we've always added inside of our build Gradle mobile app, we always added the Kotlin Android extension here. Let me show you why we do that. Okay, so I'm going to go to our app XML here, go to design. Let me put this up here so you can see everything. And what I'm going to do, actually, I'm going to delete that. Let's put a button here. I'm going to give it an ID. In fact, let's just keep button as the ID. I just want to show you something real quick. All right, so we're going to go to main activity here. So now we are going to access our button here so we can do stuff with it. Okay. When we add our Kotlin Android extension here, it abstracts out a lot of work that we would have to do otherwise. So what I mean by that is that now, in order for us to access our button here, we would have to do the following. We would have to say var, and you give a name a button. We're going to say it's equal to. Notice the moment we say button, nothing really happens, right? Because it's saying, I don't know what button is. I don't know what ID that is. So in this case here, we actually have to say find view by ID like that. And they say r.id.button. Okay. And then we can say button dot set on click view listener. And then we can pass here new on click listener like that. And then we can go ahead and do what we want to do. For instance, if we also wanted to add a text view, let's go real quick, find a text here. So we're right about there. Make sure we put a constraint here. That way it's always there. And we're going to keep the ID as a text view. That's no problem. Just want to show you here something. And here, in order for us to access our text view here, we'll have to, let's try to say text view, and nothing happens, right? Because we can't access directly our text view using ID because, again, we don't have our Kotlin Android extensions added here as a plugin, which allows us to simplify our code, right? So that means, again, we have to go back here, say var text view, and say equals to find view by ID, and then say r.id dot and find our text view. Right, this one here. But notice something here. If we go ahead and say text view and we want to set a text, there's no way to do that. Right? I can't even, let's say, set text, and I don't get anything. Well, the reason why is because as we set our views by find view by ID, what are we doing here? Well, this find view by ID method here, function, what it does is just finds a view. So there's no way we can know whether this text view here is a button, is it a text view, is it an edit text. So all it's doing is just getting a view. So that means here we actually have to say as text view Android widget. So we are saying now this, whatever we're getting from our find view by ID, we want to make sure that we are saying it is actually a text view, okay, which is this kind of text view here. Only then when we do as, so we are casting here, only then will we be able to actually say .set text or text like that. Okay, we can say is equal to hello. Okay, so if we save this and run, we should be able to have this, get this to work. Okay, so let's see, tap and says hello. Now the same thing goes with this button here, although it's working because it's looking at it as just a view. But notice something, if I want to change certain properties of this button here, let's go here and say button dot, we can set on a click, we can do all of these things. Let's say I want to change the text. See, now I don't know set, it won't let us do anything. Why? Because it knows is just a view. And the reason why we're able to set on click listeners, because again, this is just a view. So anything that we can put on the screen, we can actually make it, we can set the on click listener to it. But anything else we want to do as a button, we can't, because as I said again, this is just, this find view by ID, it just returns an ID, a view. As it says here, it just returns a general view. It's up to us to make sure we say as a button, Android widget button. Then the compiler will know, oh, okay, so you're talking about a view, not just a general view, but a view of type button. Now check this out. If I said button, if I want to change the text, look at this. I can change the text, right? Or the title of the button. So I can say is equal to show. If we save this and run, we are going to be able to see now it's changed to show. Everything else still works. Okay. Now, this is not wrong by any means. You can go ahead and do this if you don't find, if you don't want to always having to add the Kotlin Android extensions. That's totally fine. In fact, this is valid. As you can see, it all works. But you notice that there's a little bit more code than otherwise, right? So if I go back here and change and add, I'm going to put here copy, and it's going to be extensions, right? Like that, and sync. I think it's extensions like that. Let's save this. I'm gonna go ahead and clean. All right, so now we added the extensions. Check this out. We go back here. I'm gonna do the same thing we did here, but differently. Look at this. Now, in order for us to get the button, I can just go and say button. Look at that. Now we have what we always have been doing, which is we can access straight ahead using our IDs. So if you go enter, and notice the moment you do enter, this is imported here, right? Automatically. So it's Kotlin in the background is taking all of these IDs, all this find by ID, and abstract all of that out for us. So now we don't have to do all of this. We can just access our button this way. And I can go ahead and start set, and I can say dot set on click listener, and I can take this Kotlin version there because this is the version we used. We can still use it, obviously, but we can go ahead and just use that one. And look at that. This is the same thing as we did here, but now with less code. So here I can just go ahead and say text view again using the first option, Kotlin, and I say dot text is equal to hello. So we only use one line of code as opposed to all 1, 2, 3, 4, 5 lines of code. You see now the difference here? Okay, perfect. So again, if you rather do this, that's totally fine. And that's why I'm showing you this option here. You can do that. But in this course, I'm going to just keep using this form because it's concise, it's cleaner, it's faster, and we don't have to type a lot of things. Okay. All right, perfect. So I'm going to get rid of all of this because I just wanted to show you the differences here. In fact, I'm just going to go ahead and comment this out. And of course, we can remove all of this. All right, so onto our app. So the first thing we're going to do, I'm going to get rid of all of this, right? Image views. So an image view, as the name implies, is a widget that allows us to add images to our screen. We're going to go to images like that, and we have image button, image view, and video view. So let's start with image view. So we can go ahead and put it right there. And the moment you drop it there, it assumes that you want to add an image, which is so true. But before we do that, I'm going to go ahead and get a few images from my computer, and I'm going to copy and put inside of our res here, inside of our meep map. Okay, so I'm going to copy, I'm going to paste it in there. And the moment you do that, this choose destination directly shows there. Okay, there's different resolutions we can add our images. Okay, so we're just going to keep with the medium there. That's fine. Say OK and say OK. And right away, you see here icon LG dog. Okay, now that means if we go back to adding an image view here, we'll see now it's there. You can see it. It's icon LG dog. Click on that, and that's very cute puppy. Say OK, and we have our puppy. So we have our image view. Okay, if you wanted to add another one, let's add a few constraints here to make sure we are constrained. I'm gonna constrain to the top. All right, let's go ahead and add another one here at the bottom. I'm gonna copy another one and put inside here map. So paste, right click to paste it in like that, and we have the same thing. We're saying OK, and OK is fine. Now we have a dog. Okay, we're gonna do the same thing, drag and drop, and I'm gonna go ahead and get the the cat. All right, very nice indeed. And now we have a dog and a cat. We save this and go ahead and run. We should be able to see, hopefully, the dog and the cat. And there you have it. So we have here a dog and a cat. So in this video, you were able to add. In the next video, I'm going to show you a few properties of our image views here. Okay, I'll see you in a bit. All right, so now that you have a lot of knowledge about image views, let's go ahead and put things to test here. We're going to make another awesome app. This app will be a fun app that will allow us to set the filter of our image. Okay, so it's going to be really great because it's going to be a randomly generated all of these different filters for our image. Okay, so we're going to go ahead and create a new app, a new file. That's a file, new project, and this is going to be image filter app. Okay, make sure we have including Kotlin support here. Say next and next, and of course we want the blank activity or empty activity, and we're gonna just finish up like that, and that will be created in a second here. All right, and there we go. We have our app. All right, so we have our activity here. And back to design here. All right, so the first thing I'm going to do, I'm going to get rid of the hello world text view here. That seems to be something we do constantly. And what I'm going to do, I'm going to go and find an image real quick here. All right, so let me see. I'm going to copy this awesome cat image into our resource file here. I'm going to put it inside of our meep map. Control V. I'm going to put it around there. Cat JPEG, and there we go. So we have our cat image here. So double click, and we have this cute kitty there. Right? That's what we're going to be using. So I'm going to go ahead and get an image view here. Go images. I'm going to find image view, and I'm going to put right there. And let's go and get that cat. There we go. Oh, very cute. Now I want to align it so that is make it as big as possible. Okay, so we have everything here. I'm going to call this cat image view. There we go. And then I'm going to put a text view. And you notice also we have our palettes. They're all organized by their type. So for text, we have all this text. For layouts, we have all these layouts here, which we haven't really talked about yet. And containers and so forth. Okay, so now we want text. We're going to tap here and text view. I'm going to just put a title here that I would say, again, I want to make sure this is below, always below our image there. And I'm going to go ahead and make it center. say align. I want it to be center like that. And I also want to make sure that the, okay, and I want to change the text to a new resource here. Its name is going to be, let's give it title. And it's going to be tap me. Okay, make it bigger. I'm going to change go size. Maybe 18. Okay, that looks good. Perfect. So this will just show them here that says, hey, tap me, which means they will be able to tap the cat and then something should happen. Now that we have that, we can go back to our main activity here and we can set up our image here. Okay, so we're going to go to main activity, and the first thing we're going to do here, before I do that, I'm going to go to my Gradle again. I'm going to add my plugin here, right? To make sure that I can take advantage extensions, fully advantage of Kotlin here. Oops. Kotlin Android extensions. I always get it wrong. Try again. And there we go. All right, so now we can use our extensions there. Perfect. Which means now I can just go ahead and say image view. See, it says cat image view there. I can set on click listener. And then here I can do what I need to do with our cat image view. The idea is to, as users tap on the cat, we want to randomly generate a filter for our cat, just like what we did previously, okay? So as they tap, it's going to generate a different filter and also a different Porter Duff mode. Just to make sure things are working correctly, we want, in this case, let's go ahead and say cat image view dot set color filter. I'm going to just go and say color dot cyan for now. We just want to see how this is working. We should see here pretty soon. Oh, there we go. So we have our cat. If you tap and this happens. So the set color filter, it's cyan. Okay. Okay, so at least we know things are working. Perfect. Now you notice here, this color filter here, let's go back and get rid of this. The moment I go color filter like that, look at that. So we have an option here, of course. We have a few constructors that we can call. So we have a few parameters we can pass. We can pass the color, okay, just what we just passed, and we can pass also the Porter Duff mode. Now, I want you to pay attention to something here. The color is a type of integer, is an integer type, which means colors in Android are set as integers. Now, this piece of information is very important because the idea here is to create an array of all possible colors that we want to add and then invoke those colors through that array. In this case here, we need to know the type of our colors. So that way we can create our array accordingly. So now what we can do at the top here, we can go ahead and say var. We're not going to change this variable here. We're going to call this colors array. Okay, this is going to be array of, I'm just going to say pass elements here. So I'm going to go ahead and say color dot black, and then I'm going to add another one, color dot cyan. Why not? Color, oops, dot blue, color dot green, color dot dark gray, and we can keep adding. Okay, so now we have our colors here, which means inside of here, what I can do, I can just say colors array and square brackets, right? That because we're talking about an array, we need square brackets to access the index, right? So this will be the first index. So index 0, 1, 2, 3, and 4. Okay, so in this case, let's say I want black. I can put 0 here. If you go ahead and save this and run, we should have a black background. Tap and look, pitch black. Our next task is to create a random number. Okay, so luckily we already have a random number generator class that we can use. For that, I'm going to go ahead and make a function here. I'm going to call get random. Okay, and I'm going to pass array size. It's going to be of type int, and I want to return an integer. Okay, so essentially I'm going to pass an array size, and then I'm going to return an integer. You will see in a second here. Let's put 1 for now so we don't get an error. All right, so to get this random number here, we are going to do the following. I'm going to say var, create a rand instantiation here, so random from Java util. Okay, so now we've instantiated the random object here. And next we are going to do the following. We're going to say var random num is equal to rand, so our object random here, dot next int. Okay, and what we're going to pass here, we're going to just pass the array size. What this does is that it goes ahead and create a random number between 0 and the size of, or the number we pass here. In this case, it's going to be the size of our array. And then we are going to return our random number. This way it's easier. We can just call random number and pass the size, okay, the range per se, and then we are going to get a random number. Now, to make sure that this actually works, let's go here and say print line, okay, and we're going to say get random. I'm going to pass 4, so it's going to be 0 to 4. Let's see if that's going to work. So each time we tap on the cat, we should see in our log hat here a random number being generated. Let's run this. Okay, let's tap. Let's make sure we look at there, and you see 3. Right? Let's go back here. So keep your eyes down here. Okay, tap again, 0, tap again, 0 again. And notice this random generation is not very accurate, so it repeats itself sometimes, but it's okay. So our random numbers are being generated. Very cool indeed. So with that piece of information now, we can do really awesome things, right? Because we have our random number being generated properly. So here we can just go ahead, instead of passing the hard-coded index, we can actually pass a random index, right? So we can say get random. Of course, we have to pass the size, but now the smarter way to do this, instead of putting our own size, we can just go ahead and say colors array dot size. So this will return an integer, which is the size of this array. So if we change the size of this array, this will not have to change anything here. It will automatically fetch that size of the array. Okay, so now we're going to be able to get different filters, colors filters, each time we run this app, or each time we tap on the image view. Okay, so tap, 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 and keep tapping. All right. So it's going through all of these colors that we have set. Okay, so keep tapping, tapping, and go through like that. Okay, so to explain exactly what's happening here, so each time we tap, it goes and fetch the colors array, which is this one here. And instead of us passing hard-coded index number, we call our get array or get random function we created, which then we pass the range, right? In this case, it's going to be the size of our array. So we say colors array, that's size, right? So we're passing in, we're saying we want this range of random numbers being generated. They're going to be from 0 inclusive to the size of our array. All right. So the first time it goes around, let's say the get random got 0, it goes and gets this black color and passes it in here, which passes in inside of our set color filter. Okay, so it keeps doing that. That's why it keeps changing. Like I said, the generator is not the best, but at least because it repeats itself, but at least we know it's getting randomly. Okay, perfect. So the next thing we need to do, we can actually pass the duff, the porter duff mode here. We can say porter duff dot mode dot, let's say overlay. Save this and run again. Oops, something is not right. There we go. Get rid of that. Let's run. Let's try. There we go. Look at that. Ooh, that's kind of cool. Look at that. Ah, yes. Oh my goodness. Do I love this? I do. Look at that. So you can see these filters are so cool. I'm so excited now. All right. So the same idea. Okay. All right. So you have to forgive me here. This gets me so excited because the same idea, the same things you see on all these big applications such as Facebook or Instagram, we have those filters. Guess what they do? This is exactly what they do. Okay? Fundamentally, that's exactly what they do, right? You can change the color or the filters of your image. Look at that. Isn't that great? So now two things are happening here, folks. Two things are happening here. So now we are getting the random color from our array for our set color filter, right? And we are also adding the Porter Duff that mode we set to be overlay. We could have set it to something else. Let's try that. Let's say instead of overlay, we want what else? What is this add? I have no idea. Let's check it out and see if it's something we'll be interested in. Okay, let's tap. Look at that. It's making a little bit of change. Ah, this is so cool. This is so cool. I'm so excited. So in a matter of minutes, we're able to get a very functioning application that randomly gets the color that we're inserting into our set color filter. And on top of that, we are actually setting the Porter Duff mode and changing. If we want to, we can change back to whatever else we want here. Let's see, DST at top, whatever that is. Let's save this and run. Right? So we're doing all these things in very few lines of code. Right? So it looks like this one doesn't do much. Let's change back to overlay and run. And look at that. So we're overlaying through. Oh my goodness. Very, 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 very nice indeed. Okay, so of course, if you wanted to do this more, you can add as many colors as you want here. Okay, all you have to do is just say color dot, what else we have in gray? We have gray. No, we don't. Okay, you can just go and say color dot red, color dot transparent. I think I saw that. We can go ahead and get another one, color dot white. Okay, we can save and run. Let's try again. Tap. Look at that. So now we have that red overlay happening there. Very nice. Very cool. All right. Yes, exciting times, folks. Perfect. So you were able to create yet another app here using the knowledge that you've learned. Okay, so play around. As you can see here, there's a lot of things you can do here, right? You can create, extend this application here to do more things. One of the things I would ask you to do is, let's go ahead and click on the Porter Duff here, right click. We want to know what exactly the implementation of this class. Go to, and go to declaration. I know you can't quite see there, but just go to declaration and you can see the actual declaration of this awesome class. You notice something here that all of the modes, this is the modes, right? So we saw those clear. I think the one we're using is the overlay, right? So there are all these modes you can play with. Okay, so you can actually go ahead here at the top and say, for instance, val Porter modes and make an array of all those modes. So we can say array of, like that, and just pass, for instance, Porter Duff.mode.overlay as the first one, and say Porter Duff.mode. We want that one, and say Porter, look at this, mode, we want darken, and we can keep adding all of those and do the same thing as we did with our get random here, right? So all we do, because we know we're putting inside of this Porter array, check this out. Right here, we can just go ahead and do the following. This is great. We can say Porter modes, right? And inside of, because we know it's an array, so we can just go ahead and say get random, right? And inside I'm going to just pass Porter mode dot size, like that. Now both of them are getting random overlays and colors, right? So save this. Let's give it a run. I ended up doing it for you, but this is fun. Okay, let's see what's going to happen, folks. So tap, ooh, black, tap again, ooh, tap. So everything is being randomly generated. Look at that. Right? Some of them are better than others. And that one is white, transparent. Of course, that would happen as well. And look at that. So everything now is being randomly generated. How cool is that? All right, I'll stop here because I'm going crazy here. I'm just too excited for you, things that you can do with this. And there you have it, folks. There you have it. A cool application that you can take it and run with it and do amazing, amazing, amazing things with it. And I hope you do. If you do, please don't forget to take screenshots and post in our forums so I can take a look and congratulate you. All right, thank you, and I'll see you in the next video. All right, let's keep going here. So in this video, I'm going to show you another fun app. This app will feature a new widget, which is image button. Okay, so let's go ahead and create a new here. So new file, new project. And we're going to call this random background color. Random background, that's enough. Okay, so random BG, that's fine. Next, of course we want the empty. Say next again and finish. Now our app is being created, or rather our project. We have there our project. I'm going to go ahead and close the old one. All right, so we have our project here ready to go. I'm going to go ahead and do this. You've seen this before. Extensions. And I'm going to sync. Take a few seconds here. It's all synced up and I am ready to go. So we'll go back to our activity main here. Let's talk about what we are trying to accomplish here. So this application, we are going to feature another widget here. It's going to be a image view, but in this case, it's going to be image button view. So an image button view, as the name implies, allows us to actually add images to our buttons, which is really cool. So I do have already a few buttons, a button that I'm going to copy and put inside of a res folder here. I'm going to go meet map, just say v, and that's fine there. It's called round B. And if you go here, you see there's round B. Double click. This is our background image that we're going to be using. Perfect. So the idea here is that we're going to put that image button here. And then when users click, we are going to randomly generate a background color. Okay. Fun. So kind of similar to what we've done before, but in this case, we are introducing the image button here. So that way, you know how to use it. Okay. And you'll notice that most of all these widgets, in fact, they're very easy to use. So they follow the same sort of pattern, right? You create the widget and then you connect to our Kotlin file, to our main activity, right? Using their ID, and then you perform actions, right? Set on click or set a text and so forth. So very, very simple routine actions that we can do. Let's delete this. What we're going to do here, we're actually going to use a button here, and we're going to change a few properties so that we can have a background. Okay, so we're going to add a button here. Okay, we could have used an image button here, right? Very easily. However, let me delete this. If we use the image button, which is fine, if you drop it there, we will be able then to use the image round that we added, no problem. But the image button doesn't allow us to change the text because it assumes you are using just an image which would have a text inside it that says, for instance, tap me or do something, right? So it won't allow us to add, for instance, a text property, which makes sense, all right? So if we had a button that we already had something written inside, we could have used an image button. It would have been the same thing, okay? But we're going to go back and use our image, our button here, because it allows us to add an image as a background, which we'll do in a second here, but also gives us the button or the text property here that we can change. In this case, I'm going to say here, put a resource. Let's say tap. Oops. It's going to be tap and then tap like that. Enter, and there we go. Okay. So we're going to go and change to bold the text, and we want it to be center, which is already. And the next thing we are going to change is the background image. So if you go to background here. We can click there, and now you can see we go to drawables and we can add our round B here. Go like that, and look at that. Now we have our button with a background. Okay. Now let's change this tab to a different color. In fact, let's also give an ID. I'm gonna say tab button like that. Let's go and change the text color. We want it to be color. Let's give it a white like that. And there we go. Perfect. So now let's save this and let's go to our main activity here and see if we can access it. So we're going to say, I think we call tab button. There we go. Tab button. That's set on click. And there we go. What's new? All right. So this is where we are going to fetch this whole background of our view and then give it a different color. Because we understand in order for us to fetch anything, we need to make sure that we get the view ID. Okay. So if we go back to our text here, you notice our view comprises of this entire tag here. This is our view. Now, how do we access this view then? This parent view here, which is this whole view. Okay? The best way to do that is we can add, say, Android here, ID like that, and pass in an ID. I'm going to call this main view like that. Now we have an ID. Now that we have that main view ID, guess what? If we go back here, we can actually say main view. Look at this. I love this. There we go. Now we have main view for activity. Ah, I just love this, folks. Okay, so I can say main view dot, and look at this. I can actually go and access set background color, which in turn, if you should remember this, we can pass in a color of type int. Let's try put color dot magenta, for instance. If you run this app and click on the button, we should see the background turning into a different color, precisely magenta. Ready? Tap. Look at that. We have magenta. Yes. Yes, yes, indeed. So this is working. But the idea here, again, is to make sure that randomly we generate the colors. That way, each time the button is tapped, then the whole color changes. The whole background changes, okay, randomly. Well, we've done this before, so can you manage that? So what I'm going to do here, I'm actually going to go ahead and get some functions that we already did here, which is this function, the get random from previous project, right? Because we just want to get a different a random number. And at the top here, what I'm going to do, I am going to create an array. So I'm going to say var, again, color array. It's going to be equal to array of, right? And we're going to go ahead and pass a few colors here. And I know these colors are all int, right? So we're going to say color dot black, color dot white, color dot transparent, color dot red, color gray, and I'll keep going here until I'm tired, or you are tired, whichever comes first. Cyan, color light gray, color magenta, color, do I have yellow? Look at this, color, I think orange, you can just stop there. And you can add, as you know, as many colors as you want. All right. So now here, you probably guessed, instead of hard coding our colors, because we want this to be randomly generated, say colors array, and we know it's an array. That way we can use our square brackets, okay? And we can pass our get random, which in turn we will pass the colors array dot size. Very simple, right? Again, we created a color array here, which comprises of a lot of colors. And then our set background here, we are passing in our color array. And we're passing inside of each index, instead of hard coding those indexes, we're just passing the get random. Okay, and this get random also in turn requires an integer, in this case of array size, because we need, when we get random, we need to find a range in which we want to get random from. All right, so the range is going to be the size of our array, period. That's done. Run. And tap. Look at that. We are randomly generating all of those awesome colors. Okay? Keep in mind, all these things that we are doing, all these awesome small apps that we're creating, is something that I want to spike some sort of inspiration for you. Every time I teach you something new, we create a new app, I want you to keep thinking of things that you want to create yourself. That's the whole point of all this, right? You want to learn something to apply to something else in your life, right? So can you think of other things you can do with this randomly generating and manipulating and creating images and colors in the background? Sure, of course you can. There's so many things you can do. Okay? Very nicely done, folks. Very nicely done. And thank you so much. Go ahead and keep playing with this concept here, and I will see you in the next video. All right, so in this video, we are going to talk about layouts. As you can see here, if you go to our palettes, in our palettes we have all widgets, text, layouts, container, and so many. So layouts, that's a very important topic because we will be using a lot of different types of layouts, mainly linear, relative layout, table views, and so forth. And I just want to introduce to you a few of them so you have an idea what they do and when to use them. Okay, so I'm going to go ahead and create a new project here. I'm going to call just layouts, Android, like that. And we're going to say next and finish. All right, I don't need this anymore. Now we have our new project. Let's go to our activity main here and go to design. I'm going to close down our left panel there so we have more space. And I'm going to close down my right here. So now we have a lot of space in here. Great. All right, so as we say here, as I said before, we have our palettes and we have our layouts. Let's click on our layouts tab here, and we have our constraint layout. So it's a type of layout that allows us to do things such as if we trying to get something inside here, you notice it constrains right away. Okay, and if we open our right tab here, properties, we see that we have these constraints we can add, right? So we can go ahead and click here, and of course add our constraint as needed. Okay. So it's a really good tool. It's one that they recommend us use. In fact, they recommend to use it constantly to where every time we create a project, it's present there. We have no choice. But of course, we do have a choice. We can get rid of it. The layout that I'm going to talk about here is, the first one is going to be the linear layout. Okay, so let me go get rid of all of these things here. Okay, we have a linear layout. The next thing I'm going to do, I'm going to make sure this component tree here is actually showing. So as we add other layouts or widgets, we will see as a tree here, hierarchy. Let's go ahead and get this linear layout and put it in the middle here and see what's going to happen. The moment you do that, you notice a few things happen, and then we have this runtime notification that says this view is not constrained horizontally. At runtime, it will jump to the left unless you add horizontal constraint, which means we just have to click on it and find these and go like that. So snap to the left and right, and if we want, of course, we can snap also to the bottom, whatever we want to do. Let me put it in the middle like that. Okay, you can snap there too. So we have all 4 constraints. Okay, so you notice this is gone now. And says this linear layout view is useless, no children. This just means, well, if we add a linear layout, that means we have to put children inside. So if you go to text here, you notice now we have our linear layout, which is inside our constraints, which is exactly what we have here, right? We have constraint, and inside of it, we have our linear layout. Now let's put a few widgets inside of a linear layout. Let's go ahead and get this one and put there. Let's get another one and put there. And the moment you do that, you notice something really interesting happened. Let's put another one so you can see. Let's put another one there and look at that. So every time we add any widget, what happened is linear layout, it linearly lays out our items. The reason why we are linearly laying out horizontally is because the one linear layout that we added is the horizontal one here, as it says here. So it tells us that if we want to make sure that whatever we are adding into our screen here is laid out linearly and horizontally in this case, then we would obviously use the linear layout horizontal. Just like that. If we go back here, okay, you can see now the linear layout is the parent, which means inside of it, that's where we added text views. And you notice here we have this orientation property, it says horizontal, and if we want, we can change from here to vertical. Save this, go back to design, look what's going to happen. Now they are horizontally laid out. Let's say if we want to add a button. See, the button's there. Let's add another button. They will keep adding everything vertically now. If we go back and change this to horizontally, go, and you can see we have everything there. Now, the reason why everything is hidden is because now we ran out of space, and that's why we only see 2 buttons here. Now, if we delete this, you can start seeing other things from the right as you delete, and you have all of them there. So every time you want to have something that is either horizontally or vertically, linearly laid out, then obviously you would use a linear layout. And you can change that, all the properties in code as well. And of course, from here too, you can go ahead and say, for instance, background. You can go and add color, accent color like that. If you say, if you go back here, you can see now our whole linear layout has indeed changed color. And notice, again, we put inside of our linear layout. We did not put inside of our constraint layout. So if you want to change the whole view layout color, you can say background color, and we can go ahead and say that one, for instance. And then you notice the difference here. Now we have the whole screen taking that color. When we create our project, the first thing that it's added to our project is this constraint layout. It's a very good idea to always have the parent as a constraint layout, but there are times where we don't need to have the constraint layout. Okay, so we can remove it, go here to text, and what we can do, for instance, we can go ahead and start removing all of this, and we can go ahead and say linear layout like that, and you notice now everything is linear layout. Right? Because now we've changed it to linear layout. But the moment you do that, you notice you lose the capability of the constraint. Now we have no way of constraining our items here. We've gained here the ability to either change to horizontal or vertical by clicking on these buttons here. Now we have to go back here and change properties automatically. Now you notice we have a problem here. Because we have a parent of linear layout, we have an issue here that says, well, we probably shouldn't have a linear layout inside of a linear layout. I mean, you can, but it just makes no sense per se, okay, which is fine for now because I'm just showing you how things work here. So we can change our parent of the whole view. We can change from constraint to a linear layout if need be. In this case, we just don't need it. It's constraints. Get to constraints layout like that, and we're back to constraint. The moment you do that, you go back and look, we now have our constraints, which means we will be able now to see our constraints again. Very cool. So that is linear layout. Okay, perfect. I'll see you in the next video. Okay, so now I'm going to show you the relative layout. Now, the moment we go back here and change our main node here to relative layout, save and go back to our design, look at this. Looks like everything has disappeared, all the buttons. What happened is, because it's a relative layout, so everything is relative, they are now all stacked together. As you can see here, we still have button 4 and 5. Okay, they're there, but they're just on top of one another. Okay, so let's go back to our XML here. Let's go ahead and play around with some properties here. There is a way that we can align things relative to another items or another widgets. For instance, if we wanted to align this button 4 somewhere to the right of button 5, we can do that. relative layout allows us to do so because it's more flexible. It's a more flexible layout that was designed for that. And most of the times you probably want to use a relative layout, and then if you want to put something inside of that relative layout would be a linear layout. If you want to have that sort of flexibility that you can get from a relative layout, very linear layout rules that we can get from a linear layout. Okay, so what we can do here, we can do the following. We can go ahead down here, our second button, we can go and say something to right of. Okay, so we have here a few properties. It says layout to end of, layout to left of, layout to right of. Okay, let's start with to end of and see what happens here. Now here, the layout to end of requires an ID of the layout that we want to be to the end of. Okay, in this case here, we are just going to say at ID / and then we're going to pass the button 5 ID. Notice the difference here. At the top here, we have at plus ID. When we have this, we are assigning an ID to this button. In this case here, we're not assigning an ID, we are assigning the other item that we're going to be to the end of. And of course, as you have it over here, it says to support older versions than API 17, you should also add Android layout to right of, okay, which I'll show you. But for now, we have to do it so that we don't have this error. So say layout to right of, and we're going to pass the same ID, which is 5. Now that error went away. You know, in fact, let's just get rid of this altogether because we don't need this. Will do all the job for us. Save this, go back and look at that. Right away, we were able to push the second button to the right. Let's give different names to these buttons. Let's say enter, and this one I'm gonna just say login, so that we can see the differences here. Look at that, wonderful. The other thing we can do, if you don't want to do the layout, we can say, for instance, to left of, keep enter. So login is gonna be first and the enter last. So login left, enter right. Okay, that happened, but look what happened here. What happened, you can see this sort of, let's make this bigger. You can see here, there is the button, but because the main button was to the left, to the end of where our screen begins, it just got squished over there. Okay, if we had this button to other side, we would have seen it. Okay, but let's go ahead and say Control Z, so we change back to what we had before. So we're back here. And there we go. Now, to see that working, I'm going to move both of them to the middle, and then we're going to try it again. So what I'm going to do now, I'm going to move the enter to the middle of the screen. Okay, now check this out. So if I go here and I say, so what I'm doing here, so now I have this layout centered horizontal. What this will do, it takes a boolean, let's say true. If we save this, it's going to center it horizontally, okay, on the screen. Look at this. Okay, there it is. It's centered horizontally. Now, if we go back and do what we were intending to do, which is to move this login to the left, let's say to left. Let's see if that's going to work this time. Save. We should see login first. And there we go. You see login now is here first. Now, notice something very interesting here. Because the enter, the first button here, which is this one here, we said it has to be center horizontal to be true, and really is center horizontal true, because you can see now this dotted line is going all the way down, which means it's really centered here. Now if we want to go ahead and center it vertically in the middle, all right, we can do the same. We can certainly do that. So just change this to center vertical to true. Look what's going to happen. Save and enter now is there. Okay, because now is centered vertically. Because we got rid of the center horizontally, it's not going to be right in the middle here. But now check this out. If we go back here and say center horizontal to true as well, look at that. We have it being here. Perfect. As you can see here, there's the login as we specified, still to the left of the enter button. Now you can see with a relative layout, you can do a lot of things. You can manipulate things to be where you want them to be in relation to the screen, and most importantly, in relation to other widgets that you have around. Now, what if we want to make sure that certain items are where they are in relation to the whole screen. Okay, let's say if we want to make sure that this login here is at the bottom of the screen in relation to the screen. Okay, so what we can do, we can go back to this button here. Let's get rid of the layout there. Yeah, let's keep it that way. I think that's fine. So let's say if we wanted to get this login here to align with the bottom, okay, to be aligned with the bottom of our enter button here. So what we can do, we can go back here, say enter, say bottom, says layout align bottom. If you say enter, and let's add the button 5 and save, look what you're going to see. Now their bottoms are aligned as we specified. What if we got rid of this to left alignment here? Let's just get rid of that for now and save. What's going to happen? Well, so now we got rid of that dependency here, but we still are aligned with our enter button. Very cool indeed. Let's put it back. Now what if we wanted to add another text view? Let's go ahead and add a text view here. Say text view. I'm going to wrap content and give an ID, of course. I'm going to call this my text, txt. Let's give it a text. Say text view. Save this. Okay, there it is. By default, it goes to the top left. Let's say if we want to take this text view and I'll move it to the middle of the screen. What do we do? What can we do about that? Well, we can say center horizontal to be true. So now you see it's over there in the middle. Now let's say if we wanted to actually move this all the way to the bottom of the screen, what do we do? Well, turns out there is another property we can use. We can say bottom, so layout align parent bottom. So if you go like this and say true, it's going to align at the bottom with this bottom here, right? So moved all the way down here. Very nice. Getting the hang of it. Now let's say if we wanted to actually move this to the right of our enter button here. Okay, so what can we do? Let's get rid of all of these. Well, what we can do the same as we did before. We can say to left of, we're going to pass an ID of button 5. Save this. Let's see what's going to happen. Whoops, I said to left. To left. Okay, so it's going to be to the left of that button, which is not what we really want. Let's go ahead and say to the right here. Save. Look at that. Now you see it's aligned to the right. It's not side by side. Those are two different things, right? We just want it to align with the button 5, which is the enter here. Now, if we say we want it to be side by side with our enter button, we could do just what we did with login. We can go ahead and say the following: align bottom ID 5. Save. And look at that. Now it's aligned to the bottom of ID 5. Very nicely done. Very nicely done. So as you can see, there's a lot of things you can do, a lot of properties you can go ahead and play around with. Of course, all of this can be done by dragging and dropping, but there will be times when you want to do it yourself, going back to the code part of things and do it yourself. And this is how you would do it. Okay? And remember, in this case here, we don't have a constraint layout. We are just straight going to the relative layout and other layouts. Okay, so that's the difference here. All right, so I'll see you in the next video. All right, so in this video, we're going to talk about table row as another layout type. Okay, so what we're going to do, we're going to go to our layout here. I'm going to say new. I'm going to say layout resource file, and we're going to call this table layout. And the root element, let's say relative layout, because that's the one that we prefer. There we go. Now we have our view, designed view here, very nicely. Okay, we have relative layout. Okay, so what do we need to do? Let's go back to open our text here and align things so they look decently fine. Okay, so what we're going to do here, we are going to add a table layout. Well, what we can do, let's go back to our relative here. Let's find table layout here. That's table layout. So as you can see, our table layout, there's two things. There's table layout and there's also a table row. So now you would imagine that if we are using a table layout, we will need to use a table row to supplement it inside. Okay, so table row is part of table layout, but you have to include it. So the table layout is just a layout that we can add a table row. In fact, we should add a table row because that wouldn't make any sense if we didn't. All right. Okay, so we're going to drag this table layout inside our layout, relative layout there. And you notice right away we have our table layout there. And it even added a few table rows to start with. Okay, let's go back here and you can see we have a few table rows inside of our table layout. Let's give a background to our table layout here. Say background, give it color. Let's give the color that we've been given here. We're going to go ahead and get rid of a few of these. We just need one for now. So we have a table row. So a row, the table row is essentially allows us to organize items in a row. Okay. Now, what if we want to add items inside of our table row? What we're going to do, we can actually change this to something different. We are actually going to go and do this like that so that we are going to add items inside of this row. That's where we are going to put items. So let's go ahead and put a text view. Okay, and this text view, we're going to start constructing it. Let's give a text that says first name. Okay, and then let's go give it a width layout to be wrap content with let's say height layout to be also wrap content. Okay, go save this and look what's going to happen, and look at that, we have that. Now I don't like this color that we added because now it merges with everything. Let's change this color here to something. In fact, let's just keep it white. Why not? Okay, there we go. There you go, to first name. Now let's go ahead and give the color to the row here. That way we can actually start seeing the difference. Say background, give a color of about dark. Let's see what's going to look like. There we go. Let's change the text color here because we need to make sure that we can see. Let's go and give a color accent. Why not? That's what we have right now. There we go. There we go. There we go. That looks good. Now, what if we wanted to give it a little padding to make sure that it looks better? Okay, let's padding because everything is to the left and top. Let's just give it a general padding. How would we do that? We go back to our text here. Now, if we want to give a general padding to the entire table view, of course, we're going to go to the table view node here, and we're going to just say padding. Now, notice we can give a top, left, bottom padding. Now, if you just say padding, it's going to give a general padding. Okay. Now, we're just going to give a 15 dB padding. Go back, you see now we have a general padding of the entire row. Now if we want the inside of this row, we need to also go inside of our table row and give a padding that way. We can say padding here, let's say give 12 dB. If you save, now look at that, it looks really nice, right? So we have this nice looking row. So now that we have this row, let's add another text view inside of this row. Now remember, this is a row, which means things will be stacked to the left and right. Okay, it's gonna be last name. That's same accent color. That's good. Look at that. Now we have a problem here because we have an issue where everything is to the left. So we need to give a little padding here so we can differentiate first from last name. Okay, how do we do that? Well, we can go ahead here in our second text view. We can go ahead and say left padding, so padding left, you can just give it 10 dB. Save this and run, and you can see that. And the last one we can add here, so we can add as many as we want, but we're just going to add 3. So let's copy this, and this one is going to be age. And everything is good. And we look, and there we go. How about giving more padding? That way we have a better looking. Let's give it 20. How about 20 dB? All right, that started looking very good. So now we have our table row here, which is inside our table layout, which is inside of our relative layout. Okay, and of course we can add more rows into our table layout. How would we do that? Well, we could simply go here, see this table row here, we can copy this entire table row. And let's put here comment. This is how you do to add a comment inside of our XML file. You put less than exclamation mark dash dash, and then you finalize like that. So here we can say second row. You paste that, and what we can do, let's go ahead and change to add the actual values. We can go ahead and say, for instance, name is Bonnie, last name is Kaylee, and age, let's say 25, forever 25. Now we have a really nice user interface of our table layout here, which contains all those table rows. Okay, that's very cool. And you can see the usability, or when could you use the table rows in many cases. I usually use table rows to when I want to make sure that all of the items that I am aligning are on the same row, for instance, right? Here I gave you an example of TextView, but you could have added any other widget inside there if you want them to be aligned in a row. Okay, so there's a lot of things you can do, and the thing about table rows or table layout is that they really organize your items in a very nice, predictable way on the screen. Okay, as you can see here, if we wanted to give a little space from the top here, we can say give it a margin, say margin layout, margin top here. We can give it 12 dp, for instance. And you can see there is a margin added. Okay, and we can keep going and having as many table rows as we need. And as you can see, things are very nicely organized. Okay, perfect. I'll see you next. All right, so in this video, we will talk about scroll view. So there will be times when you want to display a lot of information, more information than you can put on the screen here. That's when we use a scroll view. So let's go ahead and get rid of all of this stuff we've been working on earlier, and we'll just be left with our relative layout here. Okay, so inside here we're going to add a scroll view. So I'm going to go ahead and start typing. So say scroll view, there it is. That's our layout. And for this, for the width, I'm gonna say match parent, right? Because I want to make sure that it's as big as the parent. Okay. For the height, for now, I'm going to give it about 120 dp. Now let's give it a background color. That way we can see where things are at. And there we go. You can right away see that's our scroll view. Okay. Now let's go ahead and do something here. Inside of our scroll view, we are going to add a text view. If you add a text view, I'm going to say wrap content. Okay. Give a text value of some sort. I'm going to go and just put a lot of gibberish there. That's perfect. And I'm going to go ahead and put a button. Wrap content. Let's go ahead and give it a text of button. That's fine. And let's make sure that since we're here, let's go ahead and put it below our text view here, so we can see. Perfect. Let's save this and take a look, and there we go. So we have our scroll view and has some text in it. Now let's go ahead and run this so we can see in action in our emulator here. There we go. So you can see it's there. I'm gonna zoom it in a little bit more. Right, let's zoom it in there. So good. It's looking good. It's there. Okay, but you can see the power of what a scroll view really does, because in order for this to actually show the scrolling, we have to have more text than we have the space to host it, which means we have to do something here. One, we can add more text. Right, we go to text view, we can add more text, or we can make the height a little bit more small. So what we're going to do, we're going to just say like that, dp. Okay, and go back. So now it's very small. Let's go ahead and do a quick run there, and there we go. So now if you look closely, it's very small, but now if you just click and start dragging, you will see, okay, you can put as many. Let's go ahead and put more text and make this a little bigger. Let's say 45, and we'll keep putting a lot of text like that. And do a quick one again, and there we go. So now you can see, look at that. Okay, so now you're able to scroll up and down, so you're able to see what else is below. As you can see, that's a very handy tool, because then it allows us to add items that will otherwise wouldn't fit on our device, on our physical device, for them to see the data or the information we're trying to portray. Okay, so now you know how to use scroll views. All right, so I'll see you in the next video. All right, so in this video, we'll start talking about styling our buttons or our views, and our applications in general. So Android allows us to style our widgets to brand our applications per se. Okay, so let's say if we want our entire application to have certain look, or text views to have a certain font or sizes and etc. We can do that. Of course, we can do that directly inside of, for instance, if we have this text view here, we can go ahead and style it the way we want, which is fine. But if we want to make sure that this style that we want for every text view or header text view is the same all across, we can then use a style file where we can put all of our styles. That way we can just invoke those styles. If we say style, the moment there's a lot of different styles that come pre-baked with our Android SDK here, okay? But we can also access our own styles, okay, which we will create very soon here. For instance, if we want to access the Android style, we start by saying @Android. So we can say @Android and start type this style text appearance. Let's see what that will look like. And there we go. There's hello world. I don't see there was a lot of change. But if we want to, maybe there's another one. Let's say text appearance widget, something like that. Let's save that and see. As you can see, it's not showing well because the color is different. So let's change the color of our background here. That way we're able to see. Let's say background, see, like that. Save this, and you can see over there. Okay, so those are styles that they come with our Android. So if you want to access styles that come with the Android namespace, then you say @Android. So how do you create a new style? So we are going to open our values folder here under resources. We'll find the folder called styles. So you double click that, and this is what you're gonna have. Okay, I already went ahead and started a new style here. So I say style. In fact, let's go ahead and type here with you. So I can say style, and you have to pass in a name. In this case, let's call this custom style, just a different name so that we don't have name issues here. And inside of this style block, we have to add the items that we want to itemize or style. Okay, so we're going to say item. So in this case, let's say if you want the text size to be equal to be, let's say, 34 dp. Okay, now we have added this text size to be 34 dp to our custom style. Okay, let's say if we want to change the font family, we can say again item. We can say font family. Okay, and then we put here, for instance, we can put cursive or serif, monospace, casual. Let's start with cursive, for instance. Let's see what that does. Let's save this. Now that we have this style here called custom, we can now invoke inside of our activity here, our text view, so that this text view uses the new style. So we say style like that, and now we're going to say and we're going to start typing in our style name. We're going to say custom. You see, now there's two there because we created two. We are going to use this custom style, the first one there. So now, if you save and go back here, look at that. Now we have hello world, just like that. Okay, it's cursive and it looks great. Okay, if we want to go back and add a few more things, let's say we want to change the text color. So we say text color like that. Let's see CDE. Let's click on this so we can actually change ourselves. Let's go to a better color perhaps. How about that? Save this, go back to our design, and we can see it changed there to that beautiful color. Of course, you can add as many styles, as many items as you prefer for this custom style or the other one. Okay, so let's keep adding a few more things. We'll just say item. Let's say we want to, you can see all of these things that we can do. Get rid of this. So we don't need that anymore. Okay. Now let's look at the top here. At the top, we see this base application theme. Well, this base application theme came with our Android. Okay, this is something that was pre-baked when we created this project here. So what's happening here? Now this style here is named app theme. And of course it's inheriting, so it's getting functions and properties from the theme app compact, light, dark action bar. Okay, and of course there's some items that are customized below here. So for instance, the color primary color, okay, we go back to our colors here, we can see all of these colors that were created by our Android Studio that are being used in our style here. So what this is an app theme, which means you can create a theme that can be used on your entire application. So how do we then create a style such as this and make it so that the whole application abides to it? Well, let's open our manifest file here. So enter manifest, and you'll see right here, it says app theme. Say add style, so it goes to the style folder and finds the app theme, which is this here. Okay, and takes all of these colors into consideration. Now let's learn what are these colors really are. Okay, so when it comes to designing Android applications, we have at least three main colors. We have accent color, we have primary dark color, and we have the primary color. So now let's do a little experiment here. I'm going to run this application. Okay, there we go. I'm going to change the background because we don't want that color. It's one of the primary colors and we want that. Let's go get rid of that. Okay, much better. Okay, so I'm going to go ahead in our styles here that were defined before, and I'm going to start changing colors so we can see what they mean or what they represent. I'm going to go to colors, and for the primary, I'm going to change it to this dark color here. So let's look, make sure that we can see here. So I'm going to change to this dark color. Let's choose, and I'm going to run it one more time real quick. Let's see. Okay, so now we know that our primary color is going to be of this action bar at the top here. Okay, because we just changed it, and then we see the change right there. So let's see what is this second or the primary dark color. What does that do? Let's change this to that other color, different one. So you choose, and let's see, and voila. So the top bar, that is the color primary dark. And then what would be the color accent? Okay, let's see. So the color accent, you're not able to see anything right now as we change it because the color accent is used for user interface control, such as checkboxes and text fields. So to see that, let's go ahead and find a checkbox. That would work as well. Checkbox, and put it right in the middle here. Perfect. So we got a checkbox here. Let's save this and give it a run. So our checkbox, let's check it. Look at that. See that color? That is exactly the same color as the color we said set our color accent to be. Okay, so those are the three variables that we need to take into consideration when we create our application. This style, this application, three different primary colors that we've just changed. So each application, as you build application, those are the three main colors that you need to make sure you include or understand, so that way when you create your application, those applications look like Android application. They look like the material designed application, as they call it. Okay, so it's a new style of design that allows us to have very clean visual applications and easy to navigate. And the beauty of all of these themes and ways in which we can create applications that have at least three basic colors to be used is that we have in our Android developer Android develop.android.com design, we have this. We have all of the things that we need to know, all of the colors that we need to know to create good material design applications, right? So you can see there's animation, there's material design style. Let's go ahead and click on the style. Now we can see here, they give us the color palettes that go together that we can use for our applications, right? If you look, for instance, on theme, you can see there's different themes here. Okay, so you can have all of these colors that you can use. So if you're using a dark color for one, then this is going to be the darker, a little bit less darker, and the three, a little bit less darker, and so forth. So these are the colors that go together as a theme when you create your application, okay? And you can, of course, download that theme and look at the colors and design your applications around that way. Okay, in your own time, you can go ahead and read more about designing applications. And as we learn more about Android, we obviously going to come back to this material design paradigm that we are given here for Android development. So, for instance, here we have this secondary color. It says the accent is pink, and of course, you have a few other fallback that you can use. Okay. And for primary colors, it says when using a primary color in your palette, this color should be the most widely used across all screens and components. So this will allow us to have a consistent view user interface throughout your application. Look how beautiful this application looks. You see? And of course, here you have all sort of hex codes, color codes that you can use to create your application. If you want to use, for instance, if you want to brand your application with this orange color, all of these different shades of orange in your application. Okay, that's very, very handy. Again, you just go to developer.android.com and go find the design tab here, and you should see all of these resources that you can go to look at how to really create amazing designs and that follow this material design for Android. The same way we did this custom style here, we can obviously do the same thing for our theme style. So we can say style, again, custom theme. And now the next thing we can do, we can actually inherit or have a parent class or a parent theme that we are using in conjunction with our custom theme. So that way we are basing off a theme that is already created for us if we want that. So we can say parent. And we can go ahead and say, for instance, theme. We can go and say day, night, dark, compact if we want it. Why not? Let's just try that one. Perfect. Now, without changing anything, if we save this, let's go back and open it so you can see. So we had this dark background here. So if we save this and go and change, go to our Android manifest and change here where it says app style, and instead of app theme, we can go and say custom theme and give it a quick run. Let's see if something's going to change. And there we go. And you can see now it changed because now it used to have that color. Now we have a darker color at the top as well. Okay, because we chose here in our style, it's just going to be the day, night, dark action bar, not a light anymore. Okay, so inside here we can go ahead and create a few items. We can say, for instance, the color primary. We can change to something else now. Let's say at color. Now this accent, it comes from the colors that the Android Studio generated for us. Let's go ahead and create a new palette of color here. Well, since we already know where to find a better colors or colors that will go together, let's go ahead and use, for instance, this red one. So let's use this as the primary one. Let's copy, paste there. Perfect. So we have that. So, and we are going to use, let's go ahead and use that one there for dark. Okay. And for our accent, we're just going to use that one. Why not? Okay. Let's do that. Save that. And now if we just go ahead and copy all of this, because the names are all the same anyway, we can just go like that and save and do a little quick run again here. Look at that. Our entire application has changed. And even the checkbox, when we Click checkbox, you see the color is different. Just because we change our theme, now this whole application, if we were to go and create new activities or new items or new views, they would all look like this, okay? These basic theme colors would still remain the same because it's an overall, it's a global scope, which means the entire application will have this branding, okay, this color. So it's a very powerful thing to do or to know, because now as you can see, just because we change the colors, now the application looks totally different. Okay, it's way branded and it looks good, it's coherent. So of course we can put a lot of different things here. We can, if we wanted, we can have said, for instance, that this item, we can say text size. Okay, we wanted the text, all the text size to be 34 or let's say 56 dp. Okay, so now all of the text, if we save this and give a quick run, you will notice anything that is part of the UI controls, like a checkbox and buttons, will take the size that we specified, which is going to be 56 dp. Now the hello world is still not going to take that. The reason being is because we have already specified for our text view style to be custom. Now if we got rid of this, let's run once again, look at that. Now hello world, because we didn't specify anything for the text view. Okay, since we just said here in our styles that we want the whole application to have text size to be 56 dp, and look at what happened. So everything that we put in our application now has 56 dp size. All right, very good, very good. We'll talk more about this as we start building more applications in the future, but I just want to give you an introduction to stylizing themes as well as user interface components such as text views and so forth. Okay, perfect. So I'll see you in the next video. One of the things that we need to fully understand as we learn more about Android development is the class called context class. So if we look at the documentation, as you can see here, we go to developer.android.com and we can look at context, right? Search and hit enter. And you will see right away we have here context. Go click on that. So context class is an abstract class, okay? And you look here at the bottom, it says known indirect subclasses. So all of these other classes that you can see here are the implementation of this context abstract class. So an abstract class, just think of an abstract class, a class that is a model class, okay? A class that we can't instantiate it. It's a model class that we can use other classes to actually implement functionality of that class, if that makes any sense, okay? Now notice something very interesting here. It says here, activity is one of those classes that are indirectly connected to our context parent abstract class. Okay, and there's 48 more. Click on that, we'll see there's a lot of others. Action bar activity, okay, activity itself, activity group, app compact activity, application class is part of our context, and so many others. Okay, and you look here, if you go back at the top, let's see what it says. It says an abstract class whose implementation is provided by the Android system. Right there, it tells us if the implementation is provided by the Android system, that means this class here, the implemented classes, have a lot of power. That means they allow us to access the application-specific resources and classes, as well as calling application level operations, as you can see here. What that means is that you can use any context implementation of that class, in this case activity, activity group, application, and many others, to access the core functionalities and operations of the Android application, of the Android realm, if you will. Okay, and this is the reason why when we are creating our applications, you've seen, for instance, if we want to create a toast message, we have to pass in our context. And usually it's the context, depending on the level, we usually pass in the activity context. Okay. So let's go ahead and look at an example here. Let's go ahead and go back to our tip calculator task here, and we're gonna go inside of our onCreate method here. Okay, so let's go ahead and create a toast message here. I'm gonna instantiate a toast class. We're gonna say toast dot, and look right away when you say dot, try to access certain methods there of our class toast. which in this case is make text, we have here, it says here, it has to pass in a context, and then the resources ID. So in this case, you can just put in your string, and then of course there's some other thing we need to pass in for this to work, which is the length that you're going to show this toast. Okay, but let's focus here. So if we go enter here, and then it shows again, we have to pass in a context. So now we have to pass in this powerful class object that knows everything about everything in this application. Okay, so we are giving a context. If you go back to what the context word really means, what is the context of this toast in this case is main activity, this application here, this activity, which is main activity. That is why we are able to pass in either just this, okay, and we're gonna go ahead and pass, say hello. We're gonna finish this with toast, and then we're gonna say long, of course we have to show. Okay, now this means this class, which means our activity, which when we go back and look at our context abstract class here, it says here an activity of any form, right? Anything that has activity attached to it is part of our context. That's why we are able to just pass this, or we can go ahead and say main.this, the same thing. We are saying that's our context. Okay, that's why this works. So if we save this and run, you've seen it before, we should see this hello message happening. There we go, hello here. Okay, takes a few seconds and then goes away. Now you notice that the other thing we can do too, because we said here the context that has to be passed in here has to equate to the context abstract. It has to be part, or has to be one of those implementation of our abstract class context, right? The parent of all parents. So that means then there are other ways to access our context. We can go ahead and use this method called get base context, and you can see here it says context. That means it's an implementation of the context class. So this would work too. Let's save again, run. We should see hello showing with no problem. There we go, hello. Okay, and we can keep going. We can find other ways in which we can grab that context. Let's go ahead and say get application, right, is of a type application. You notice that there. So it's another level of implementation here. Okay, so if we go like this as a method, let's see if that's going to work. Save, let's run. There we go. It works. It says get application. That would be our context. That is part of our context abstract class. All right. Now notice within the get application, we can actually extend our search. We can go deeper and actually go and get the base context if we want to be a little more specific, or get application context. Either way, depending on where you're using this context, okay, all of these are valid. We're not going to go into the details, but I'm just trying to give you an idea why is this context class, abstract class, and their implementations are so important. So now you're able to understand why is this context so important. Now, look at this. The other thing we can do, because we understand now that the context is the almighty powerful way for us to access the resources, to access certain operation that are part of the global essence of what this application is. Okay, that means with the get application or the context, we can access all of this app, as you can see to the left here. Right, we can access manifest, we can access the package name, class, we can access a lot of things, the drawables, layouts, values, whatever we want, because which means we can go ahead and go do the following. We can say, for instance, a log.v. Let's use a tag. That is a tag that we created earlier. And for message, let's go and do something nice. Let's say get application context dot get. The moment you say get application context dot, you can access, look at this, you can access the package name of this entire application. You can access the package resource path. You can get strings, whatever string you want to get from our application, right? Like this one here, for instance, you can go to get string, for instance, you can say dot, and r dot strings dot, look at that. We right away went able to go and access our strings values here. And we can say, for instance, we want just to get the app name like that and save, run. We're going to be able to see in a log here, tip calculator test, which is exactly the name, if you see at the top, of this application that we just created. So there's a lot of things that you can access, you can get from our application context. And of course, we could have done the same thing. We could have just said, for instance, instead of using the get application context, we could have just said main activity dot this dot, look at that. You can go the same thing. So we are able to access the same methods that we were able to access earlier with the get application. In fact, we can go ahead and get application context and go from there as well. Or you can straight go and say get string and do that. Okay, you can get local class name, get calling package, get package name, just a lot of different things you can do. You can even access, obviously, our methods in this from our main activity, this context here, which is our main activity, right? You can get the on create, calculate, which is the method we create, calculate button as the button that we created, and all of these other things that we can do. Look at that, okay? So now you have all this power that allows you to access things in your application, which we will see as we progress in our studies here. If you want to really understand Android development and really have a good grasp to where you were able to explain to anybody, or when you go to do job interviews, you need to really understand what an activity is. You need to understand what context is. You need to understand how the whole Android layer works. Like, what is Android, right? As we talked about earlier. So those are the main things that you have to really understand, because those are some of the most important tools that you have to understand in order to become a good developer. Knowing how to program, it's mechanics, so you can learn that, right? The syntax and all that. But understanding the framework it's a different thing and a different beast on its own, and you can do it. Okay? All right. So I'll see you in the next video. So the next thing we need to talk about is debugging. Debugging in any programming language is the process of finding errors. The process of finding errors and fixing them. As you can imagine, as we write programs or as we write applications, things could go wrong, not just syntax-wise, but also the code that we write may or can end up with some logical errors. Okay, so it's very important to learn a few things about debugging or about finding those errors and figure out a way to fix them. Right? So Android Studio, our IDE here, has a few tools that we can use to finding errors and try to figure out how our applications are behaving. I have this project we've been working on, and it has an empty main activity, as you can see here. So what I'm going to do inside, I'm going to create a function. Okay, I'm going to say fun add function here. We'll have a few parameters, in this case just two. So I'm going to say first num, like that. It's going to be type of integer, and second num, it's going to be also an int. It's not going to return anything, so we don't have to do anything there, right? We don't have to pass a type that we're going to be returning. We're going to say just print ln. We're going to say sum is, and we're going to append this sum. Okay, I'm going to say first num plus second num, like that. Very simple. And what we're going to do, we're going to just call add, and we're going to pass 10 and 12. Very simple, nothing extravagant here. You've seen this before. Very simple. Okay, we're going to go ahead and run this, but notice what we're going to do here. What I'm going to do is also remember that we don't have anything attaching. We're not attaching to our user interface here because we are going to use our debug console at the bottom here. Okay, so this doesn't matter. So when we run our apps, we usually just run by clicking on this green play button here, right? Now, in order for us, for instance, to see what's really going on, I'm going to show you something what we call breakpoint. A breakpoint, essentially, if we go to the side here, close to where our lines are, and just click, you notice there's this red icon, red button, circular button that shows up here, okay? And what this means is that now, it says here line 12, suspend thread, meaning once we execute this app, okay, it will stop here. So this is our breakpoint. We want to the app to halt here so that we can analyze and see what's really happening here. Okay, now in order for this to work, we are going to use this button here. We're not going to play normal. We're going to run this app by using the debug mode here. Okay, in fact, you can see that looks like a bug, and then there is that play. I'm going to play it, click on that and say okay. And there you go. The moment you do that, the app runs, and of course it calls on create and goes ahead and calls the add method. And you notice there's a lot of things that are happening here. Okay, so at the bottom here, you notice it says debugger. Okay, that means we are in debug mode. And there's a lot of things happening here. But one thing you notice is that it says here on create and 12. Okay, this 12 means we have a breakpoint on line 12, which is exactly true. The app, when it ran, it went and stopped here because we put a breakpoint here. Now, in order for us to go through, step over to go through and see the execution of this method function, what we need to do, we go over here at the top. We got to go to the second one, which says step into. So we're going to be stepping inside of this function here and see what's really happening. So if you click that, and you right away see variables here. Right, in this window here, and you say here it says add, it's a function, okay, and to the right we have variables. But then you have this keyword here, okay, which then says equal main activity and add 467.5. This add is just a place in memory, okay, but this, again, we've talked about this means this main activity, which means this class. Okay, now if you open, then you have a lot of other variables inside of it and functions and many other things. Okay, most of them are functions that we're not very interested in them right now, but this shows you everything stripped down, even the title of our project. Remember here, if you look at the top, it says layouts Android and says here layouts Android. So essentially it's getting this, which means this activity or this class here is getting everything that makes up this class, which means also include these views and everything else. Okay, that's why we have all of this, and that's why we have this drop down. So we can close it. But what we're interested in here is this first num. Okay, if you click on that, so first num is telling you now what's happening here is just it's telling us that first num has value 10 and second num here has value 12. If we keep going step over, now you notice it went inside our print line, and cool, look at this. It even tells us the numbers here. So it says first num is 10, second num is 12. Okay, so this is live. Okay, so what we did here, we stopped the execution so that we can have that control and see step by step what's happening. So this is very useful if you have a big app and you don't know where a problem is or where the error is. So you can do that until you find where the problem is. So this is of course a very simplistic example, but you can see now the power here. So we can keep going. And look at that. Once that happened, right, we got off our system here, right? It went ahead and opened the other execution, which is the println here. It says now, it went and says the next thing was called was builder.append. Now this class here comes from our system. It's not a class that we created, okay? But the power here, again, is that it tells you exactly, you can see the variables here, it tells you exactly what's happening. So we went to this object here, so builder.append. This is what's happening here. So the builder now has the object which says sum is 22, right? Sum is 22. Okay, if we look at the builder string here, this is the representation of these values that we are adding here. Okay, so it goes really deep and you can see a lot of great, awesome things here. All right, so if we keep going, it goes, so it says here, once that's happening, we go to say flash and makes it true, and then we keep going, and we can keep going, and we can keep going, and keep going. So it's telling us exactly what's happening in the background of our application as we run it. All right. And of course, once we're done, we can go ahead and stop here. We can get rid of this. And if we want to get rid of our breakpoint, we can tap there, and it's done. Now the app can run normally. While we're here, you notice also at the bottom here, we have this to do here. You may have asked, what is this to do? Well, this to do, as the name implies, is something we can actually annotate in our code. For instance, if we're writing code and get to a point where we need to leave or we need to postpone whatever we're writing, we can just go / and put to do like that. And the moment the IDE finds that to do, it adds at the bottom here. So look at that. Now if you open, it tells you exactly main activity line 12. Say for instance, write a new function, something like that. And we can add more to do. You can say write 2 more functions. And we can keep doing like that. So this, what happens now, we can go and open a new file and work on something else. And then when we come back, we can always find here, go back here, say, hey, I wonder what else am I supposed to do? Go here to do and say, oh, I see in my main activity, I have a few to-dos here, right? It tells you exactly things that you can do, things that you're supposed to go and do, right? Like this. So it's a very handy tool that you'll find me use all the time. And I encourage you to do so as you build your applications or write your code. Always give yourself a reminder, per se, of things that you're supposed to do. Okay, that's very handy. So now you have some ideas on how to use breakpoints and debugger, and also how to write to-dos. That way you can remind yourself or others who will be maybe working on this app with you, on an application with you, that there are certain things that need to be done. All right, perfect. I'll see you in the next video.